kilometer of
actually,
water.
Sunshine, it's your argument. You
It's a
should
good
not
start
be
right
able
there.
to back it.
Yeah. By the way, this is stuff that you brought up. We're just holding you accountable to the things
and I have backed up everything that I've said.
No,
Not
you
really.
haven't.
Not
Your
really.
laser can't make it through 1 kilometer of water on fucking Earth. So don't ever tell me it can make it through 93 million miles of space stuff.
What's the max range again we asked you for? While you're Googling what beam diversity is?
So here's a laser, for example, that was developed in 2017 that has a maximum radius if shot from outside of the atmosphere. So that would be space. Why are you laughing? Do you know? You can look through a telescope and see the solar. You know you can see the space station, right? But anyways, so if shot with no atmospheric stuff in the way, it can reach up to, let's see,
This ought to be
30
great.
light years.
Yeah, classic.
30 light years.
Fucking classic, bro.
Yeah.
What about? You said it was on the ground, dude. So what about that? You know.
Well,
7 light years. Let's use a bit of logic
so I'm going to say something now.
Yeah, I love when they say
No,
that.
you're not.
Let's use some logic here. 7 light years away. Who the fuck sat at the other end of it to confirm that?
Yeah,
guys,
bro.
I'm going to turn the laser on now. Set your stopwatch. Tick. Let's see. Hasn't got here yet. Hasn't got here. Fuck it, I'll go make a cup of coffee. You just watch that for a minute, will ya? Pour me coffee, come back. Has it come out yet? No, good. Watch it still going, though.
It was the same. Dude, I'll tell you, I got the answer, man. The same guy that was the advanced camera crew for Apollo that watched Neil Armstrong come down the ladder. The same guy. He went to where the laser was going to hit before it got there.
Is that the same dude they left there when they flew back?
Yeah. He's still up there. That's why he got a head start.
Bill the camera.
Yo, man. Legend. You've been using that one for the last week or so. That shit.
How do you shoot a laser at fireball or a sunball or whatever? How are you shooting it? Getting an energy ball reading from an energy line? That's weird.
Yeah, I mean that's.
How do you do that on Earth? Bet you that laser's not even good on Earth for 10 miles.
The computer is what is used to calculate the distances because the computer is able to read when the laser has, hit something or stopped.
The computer calculates it?
Based on light, based on readings of light.
No, the human makes the computer. No, the human puts the numbers in the computer.
He's claiming that the photons talk to each other and tells it when it hits something.
They don't talk to each other, but they have reactions that can be directly observed.
Relays the message back to the computer, and the computer says, aha. It's like an AI, a face comes up and it talks.
I don't know why you're questioning this when you're sitting on Discord talking to me who's on the other side of the planet, perhaps from you.
That's got nothing to do with what you're saying.
The thing that you and I are doing right now is direct evidence that the exact thing you just made fun of is possible. You are so beyond retarded.
You're a little retarded, bro.
Cable guy, slow down.
The internet don't work through satellites. Dude, what are you even talking about?
Well, it's pretty bad, Indio, because he said earlier, well, I know the sun goes under my feet because there's people I can call in other countries. Come on, dude. If this was a book where you connect the dots, bro, you're trying to connect dots that are not even in the same book, my guy. Come on, dude. Crazy.
Shoot your laser to the ISS and see how far it is compared to the airplane, and then shoot your laser at a fire that we know is 30 miles away, and then see what it says, because we'll know how far it is, and then shoot it at one that's 50, like on Earth first, and then shoot it through a little bit of water, just like a kilometer of water.
Okay, if it can hit something 39 light years away, you're going to have to wait 39 years for the signal to bounce back, bro.
I did not say 39 light years. I don't know where the fuck you got that.
Yeah.
I said 3.
Light years.
I said
93
3.
million light years.
I said
what's
3.
the difference? So they detected the bounce back from 3 light years away.
Yeah.
Yeah. So when they shot the laser 6 years ago.
Yeah, that's what that would imply.
When they bounce it off of?
The sun, the thing we've been talking about.
the sun isn't 3 light years away. The sun's supposed to be 93 million miles away. That should be a 16-minute round trip.
No,
So,
yeah. Sorry. I misunderstood the question. I thought you were asking about the sun. No, yeah.
So your argument is they bounced the laser off the sun?
They say in this article that they were directly trying to measure a black hole, and they hit they hit another solar body, and it was detected at 3, and that just happens to be the longest that they've ever done. But they were trying to measure something else.
Yeah, that's a cool story. But you just said they bounced a laser off the sun?
Well, when they were measuring the sun, yes. That would be the separate question.
That's bullshit.
No.
Yeah, I'm going to tell you why it's bullshit. They're going to have to look at the sun to see the laser, because that's where the laser bounce is coming from, right? It's coming from where the sun is?
No, the computer does that because humans are not able for obvious reasons.
What do you mean the computer does that? The computer does what?
The computer has an internal reading of how far the laser it's generating is going and whether or not it hits something.
Okay. Look,
the same way that all of our computers right now are doing that.
That's not how that works, dude. You're just making shit up. So
okay,
they would have to watch.
It's not an argument, sure. Sounds like I'm the one answering all the questions with detail, and you just go,
No, you're not letting me finish, dude. So it's really simple. To know how far a laser went, you shoot the laser, and then you time, using the constant speed of light, you time how long it takes the laser to bounce back to you. Then you divide it by 2, and then you have the distance. Now, if you're looking at the sun, the laser isn't bright enough to see against the background of the sun. The sun would be considered noise. It will be
the computer doesn't need to see with eyeballs. That's the point of the computer doing it, because it's better than a human.
Limitation is still a signal to noise ratio limitation. Okay?
Can you provide a source for that?
That there's a signal to noise ratio
I've provided
limitation?
4 sources now. Can you provide a source for what you just said about lasers? Go ahead.
That there's a signal to noise ratio? Okay.
And also you gave a calculation where you were dividing by 2. Can you give that as well?
Okay. Well, we can just do real simple. We got the inverse square law. Right?
No. You made a claim about dividing by 2. Can you give me a source for that?
Well, common sense says you divide by 2. Distance over distance
right
back.
Now. You're like a legit retard? Bro.
Yeah.
Okay. If the speed of light, let's say the sun's 300,000 meters away. You shoot the laser, and then you get the return signal back 2 seconds. You go, the constant speed of light, it's 300 meters per second. So that means if it takes 2 seconds to get the bounce, 300,000 meters there, 300,000 meters back. How far is it away? I don't know. It's complicated. You gotta be a legit fucking retard, dude.
It is complicated, which is why the computer does it.
I was being facetious, dude. I wasn't being serious.
Okay.
If light travels at 300 meters per second, and I shoot a laser and I get the reflection 2 seconds later, how far away is that object?
I don't know. I'm not a computer that does that.
This is simple mathematics, dude, that you should have learned in 3rd grade.
I'm not going to answer any more of your questions until you provide a source.
You'll do what you're told.
The speed of light? You want a source for the speed of light?
Wait for a source.
You want a source for the speed of light?
Sorry, India, what's the question?
I'm asking if he wants a source for what the speed of light is.
No, I want a source for your claim that the...
So he doesn't want it, India. So what's next? Listen, bro, we'll be asking the questions tonight.
No, he doesn't want the speed of light. He doesn't want to know how to measure it, how to calculate it.
I want it. Yeah. I just want it, dude. I don't know why I do this. Why do I try to get? I don't know why I try to get through the retarded people. I really don't.
Bros,
you're legit low. You're mad low IQ, dude. I hate to tell you that, dude. You got like an 85 or 90 IQ.
Room temperature, bro. Like very low room temperature. Shit's crazy. Honestly, India, you want to put it in the chat for?
It's really simple. You can go on Google, right, and you can look up how much power in watts does the sun deliver to the Earth, and then you Google what's the most powerful laser that they shoot into space. And then you can calculate the inverse square law. Then you can get the distance, 186 million miles. You can do the calculation of how much power it's going to lose over that distance. Never mind how much power you're going to lose from the reflection, and never mind the fact that what you see the sun is the photosphere, and there's nothing to even fucking bounce off of in the first place, because you don't see the solar surface. That's the photosphere. Yeah, did you know that you don't actually see the sun, solar surface?
You don't own a lab coat, do you, Indio?
The point is that when that bounces back, it isn't going to be greater than the 1,400 watts per square meter that the solar radiation is. So that means the sun is going to blast out whatever frickin' laser you saw, whatever laser you shot. Because the sun has a complete spectrum. So it doesn't matter. You can't pick it out by wavelength. You can't be like, we're going to use a specific wavelength and then we'll see that wavelength because the sun doesn't emit it. Nope, the sun emits every fucking wavelength. So that ain't going to work. So go ahead. Do you understand a fucking word of anything I said?
Yeah. Makes sense.
Do you need to Google?
The only problem is I want a source.
Okay, the inverse. I'll give you a list. Inverse square law, constant of the speed of light, claimed distance of the sun, how much power is emitted by the sun at the surface of the Earth per meter. Right? You can go on any calculator and type in. It'll say, "What's the source of the laser?" Put it in. What's the distance? Put it in. So you need the.
Are you gonna post a source, or are you gonna keep yapping?
Yeah, dude. No, I'm not doing your homework for you, dude.
Okay. Because then I'm done listening to you.
This is basic shit.
Yeah, it's not gonna happen.
Look, post the source. You're gonna have to read it, right? Okay.
Yeah.
I really want to post the inverse square law. Okay, I guess I have to post the inverse square law. This is child's level, dude.
I would also like a source that the light from the laser is disrupted by the sun.
I didn't say that. I said it would be drowned out. Okay,
yeah,
so say I got a candle.
Sure. Can you post that?
So genius, say I got a candle and I take 1,000-watt fucking floodlight. And I put the candle in the line of sight of the floodlight. Can you see the candle flame?
No.
There's no fucking. Of course not. So the sun is brighter than the fucking laser, dumb fuck. So you can't see the laser.
We don't need, right, but again, it's being measured by a computer, not a human's eyeballs.
That doesn't matter.
That's the difference that you won't address. The computer can detect how far it's going.
No, it doesn't need to. Shit up. You're making shit up, dude. You're making shit up. I told you how.
Okay, well, that's not an argument to anything that I said.
Okay,
I can just put my hands in my ears and go la 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 too.
Post your source.
Not what happened.
It doesn't matter.
Post your citation then. Post your citation.
I've already posted and explained how lasers work. I'm done doing that. I'm still waiting on your citation. I'm still waiting on your citation. I posted 5 already.
Let's see. Scientists measure the diameter of the sun. That's not a laser.
I'm still waiting on your citation. I am done posting citations until I get one from one of you guys.
No, you didn't post a citation.
I have already posted 2.
But they don't back what you claimed, dude. There's a citation about the sun. Yeah, fine.
I have already posted citations. You have not. It is your turn now.
I have to post the inverse square law. Seriously. Okay.
He's gone into a montage or a mantra.
Yeah, so I'm gonna post 5 different sources.
Listen,
I can't.
You guys are just mad that there are people out there smart.
There's no you guys, bro. You are getting cooked 6 ways to Sunday right now.
It's inverse square law. Okay. Distance of the sun. It's multi-level. Multi-level shit right now. Astronomical unit. Look, the distance to the sun, inverse square law. You can calculate, if you have a source, how much power you lose over 93 million miles. And then it has to bounce back off the sun and come back to Earth. So whatever power it was when it got to the sun, It's going to lose that same amount of power when it comes back. And it's going to have to be brighter than the sun when it gets back to the Earth, which you admitted.
You know, I am actually reading.
So you read Andrew Square Law?
Well, so I'll read that next, but one thing that I am reading right now is that apparently we actually did not bounce the lasers off the sun. So they lied.
Yeah, no shit.
They lied or you lied, bro? Because you were dead ass serious about that.
Hold on, CB. He was only passing information on, which is the same shit we were all taught at schools.
Who is they? Who is they? Who lied to you?
Well, the other article that I read said that we actually bounced it off the sun, but this is posted by NASA, and they're claiming that they measured the sun by bouncing it off of our own atmosphere and then doing some kind of math. I don't know. I don't understand it.
Doesn't make sense to me.
Doing some kind of math. You know, a lot of balls.
Yeah, no, it does. This makes way less sense.
Yeah, no fucking shit, bro.
But I will say I'm not an expert, so it's very possible that I'm just too uneducated to understand.
We know that.
That's the point. You don't even know how telescopes work.
We have PhDs, or dude, getting his PhD in astrophysics that's in here regularly. Okay. This ain't the low hanging fruit, bro. Okay, I know you saw Flat Earth up there in the title, and you're like, oh, that's where the low-hanging fruit is. No, that's in one of the other channels. Made a big fucking error.
Bro, you know what shout out to you for being like somewhat humble about it, but bro, you were reading that shit off dead ass. You were so
yeah, because it seemed legit.
He said, well, yeah. I mean, maybe you need to this should be a reflection of your entire belief in the globe in general.
Actually,
the fact
CB, I've got a better idea. How about I get the link for the home server for him so the young chap can log in there and go and check some information.
You said, wait a minute, maybe
can I ask you guys a question?
You got a small glimpse, a small, tiny taste of the thing that we...
By the way, the internet doesn't work through satellites, bro. It's worldwide from undersea fiber optic cables.
Hooked. Shout out to you, bro. Honestly, this is probably not the glimpse into reality, the taste of truth. But, man, it was a chance. The fact that you realized that was wrong, even though you were dead fucking serious about it.
I want to hear his question, though. What's your question, buddy? Here, what's your question?
Well, yeah, so my question is, what is your guys' explanation for, the fact that it's day some places and night some other places?
Okay, the sun moves.
Just to be clear. Right, but like, why does it go completely dark?
Because the air is not actually transparent. It's not transparent at long distances.
Air is blocking it when it gets too far away?
Yes, you got it.
Right, but then, so if I'm standing on the beach and I'm looking out at the horizon and the sun is setting, from my POV, which you guys, you guys like to tout a lot about the whole direct observation stuff. So from my direct observation of that, it's not backing up away from me. It's going down.
No, it's not.
When things back up away from you and they're above your head, they converge at the horizon. It's called the vanishing point. So, but that's not the important part. Take an art class. So the very fact you said that you can look at the sun on the horizon proves my point. Because you can't look at the sun when it's at solar noon, but you can look directly at the sun when it's on the horizon because it has to go through air that's immensely thicker. Right? That air absorbs the light, and you can look directly at it. And when the sun goes far enough away, it gets dark. Right? And we have this thing called twilight, right? We got nautical twilight, astronomical twilight, civil twilight. It isn't like the Terminator line that you think is on the moon, right? Phases of the moon, that there's a fucking line that just cuts the fucking ball in half. We don't experience anything like that. It gets darker slowly. It don't just shut off because of a rotating Earth.
I don't know. That makes less sense to me than the globe. I don't know. That doesn't make sense.
Cool, bro. A lot of things make sense.
So twilight, which we observe to exist, don't make sense to you. Sorry. I mean, what do you want me to say?
Your explanation doesn't make sense.
Well, here, let me try one.
It does make sense because you said that you can look at the sun directly when it's setting. But if you look at it at noon, you'll burn your fucking eyes out. Why is that?
Because it's like visible.
Why are you burning your eyes out when you're looking at it on the horizon?
Huh?
Why can you look directly at the sun when it's on the horizon, but you can't look at it at noon? There's a reason.
Huh. You know, I never thought of that. I don't know.
It's because the air's thicker. You know, in 400 meters of water down, it's completely black. It's blacker than the blackest night. And that's because the water absorbs the light. But we're talking about thousands of miles. So if the sun is 2,000 miles away from you, the light has to travel through 2,000 miles of air. Can't reach you. There's fucking dust, particles, fucking clouds, storms, all sorts of shit in the way. I'm sure that you have been like on a day where a storm, like a dust storm rolls in and all the street lights come on and it becomes completely black in the dead of the day. The air is full of shit, dude. So there's lots of stuff in the air. And the longer the optical path the light has to travel through air, the more the air absorbs the light and the less light reaches you. So it does make sense. It's not as cool, I guess, as a rotating ball Earth. Fucking Matrix, dude. I love that cartoon, Matrix. That's a fucking great cartoon.
Yeah, it's clever, isn't it? I named that one Muppet Vision because that's what Oakley always says.
I put that on X, dude, when they're like, sunsets are impossible.
So where do you guys think all these scientists went so wrong?
Which ones?
Name one, bro.
Look,
I mean,
first of
all the ones who claim to have measured or like been able to measure it. Like, are they all lying, or are they convinced by like faulty metrics?
No. So you just think there's a bunch of scientists out there that went and measured this shit? There ain't. You know how we know? We talked to them. Some of us in here, we've talked to like thousands of people, man.
Well, someone's got to be lying because I read an article that said that they measured it.
Yeah,
what did they do to measure it?
There's people that lie and say they do measure it like weirdos.
Well,
like
NASA said that they measured it, so someone's lying.
What did they measure it with?
They said they measured it with a laser. Remember with the laser?
All right, you want to know something? Listen.
They measured what with a laser?
The distance between us and the sun. But then, I realized it didn't make sense whenever they explained how they did it. But, I mean, like, whether or not it makes sense to me, I mean, if they didn't do it, no matter how they did it, they must be lying.
So on Uranus opens it every day or every fucking other day to let gas out. They say all sorts of shit. NASA says that there's a fucking star that's doing 70,000 rotations per second. They said it rains diamonds on fucking Jupiter. They say all sorts of shit.
So then they must be lying.
Well, I mean, saying NASA's lying, there's like lots of employees at NASA. I don't know who the PR guy is. The PR guy's lying. Whoever fucking told them that out of their media department, yeah, they were lying. The media department guy probably don't even know either. The thing is, lying, you have to know what the truth is and then tell the opposite. Saying NASA's lying, there's 40,000 people at NASA, there's some dude sweeping the floor, there's some dude freaking cooking in the cafeteria.
Well, I'm talking about the people that are claiming to have done the calculations and reported the data. That's what I'm talking about.
What data?
The data that they claim to have measured using lasers bouncing it.
Well, I have to see the data.
Well, go check the links. I mean, I can send you the NASA link if you want.
There's data in the link?
Well, the data that they claim, yeah.
Or is it just like a link to a web page where they said they did it?
Well, yeah. So that's my point. Is like if NASA's posting that they did this, that they measured this, and these are their findings.
We say NASA. You gotta just stop saying
and they in
NASA.
fact did not, then they're lying. And it's not just the janitor that's lying. It's someone who is claiming to have access to these measurements and knowledge, which would have to be someone pretty high up.
Yeah, and who's going to call them out?
Well, I don't know. Probably no one, but...
Yeah, exactly. They have no accountability. They literally fucking blew people up in the space shuttle, dude. And nobody was held accountable for that shit.
And how could you be the only person with access to a measurement? That doesn't make any sense. Like you're the only guy that can touch a ruler. Come on now.
Think about that.
Guy. Have you seen the image of Pluto, the dog from Mickey Mouse?
Oh yeah, there's that too. God, Jesus Christ.
Yeah. On the surface of Pluto, on the half surface of Pluto.
Uranus smells like fudge. Pluto looks like Pluto. Dude.
Yeah.
Your laser's more powerful than the sun.
That's just like Santa Claus for fucking adults.
Exactly.
They say all sorts of shit.
People do claim to do goofy stuff, but that doesn't mean that's what they're doing. There's a guy named Dr. Bob. He's like a anti-flat earther, and he runs around saying he took a microwave apart in his garage and put together something. Then he says he shoots the sun and gets the distance. And he said he gets the exact numbers they get. Exact.
Look, NASA has one job. Yeah, that's just one job. Their job is to ultimately, their actual job is to lobby Congress to give them more money. They have to do this maybe they'll pass like a 1-year budget, 3-year budget, whatever their budget process is, when they get rolled out, their job is to go to Congress and get more money. How do they do that? They have to claim they can do fantastic things.
Yep.
No one in Congress or none of their staffers is going to fucking check. They're not going to look up and see if NASA bounced lasers off the sun. Did they really do that? Let's go check. The thing is, they have to go up and they have to testify, and they go, and it's not anybody with any direct knowledge of it, right? It's some administrator at NASA. He was told, "Hey, your dudes bounced the laser off the sun," and he goes and he reports that we bounced the laser off the sun. We need more money because now we want to bounce the laser off fucking whatever, right? So. It's just a boondoggle, man. It's just one more government fucking grift.
And guys, am I wrong or right when I say the videos which we saw on YouTube from people who used a filter to make shots, videos from the sun? They showed that the sun is rotating around the horizontal axis and not the vertical axis, right?
Yeah,
because you see it's rotating clockwise, and then just like the moon, wobbling. It's wobbling. Because of the sunspots, you can see it's not rotating as they show us in movies and in NASA around the vertical axis.
Which way are they? Yeah, which way do they got to shoot it? How come they're not shooting it horizontally to the sun?
And you know Dollar. How is he called? The old man Dollar? Something Dollar?
Eric Dollar, yeah.
Dollar?
Yeah.
Yeah, Dollar. Do you remember? He said they cannot see the stars and the sun in the supposed not existing space. That's why when the balloons go up high enough in the atmosphere, the sun's disappeared. He said because you cannot see the light. One could see a light only when there is an object which reflects the light. That's another thing.
Yeah. So I don't know why you guys are talking about the distance of the sun. Probably Eric Dawson. He's right. You guys led from that, I'm imagining. But the sun.
I forgot. What was his first question when he came? I forgot it.
I don't know.
They always digress. Sorry for interrupting.
It always ends up in some shit. So the distance of the sun. Okay, let's just deal with that. The problems with it. Normally on Earth, if we wanted to know the distance of something by just looking at it, what we would do is we would establish the parallax angle, just like stereoscopic vision. We got two eyes, and with our two eyes, we can guesstimate how far something is away. But you can measure this precisely by, if you know the baseline distance between two cameras, or you can use one little camera and just move it to the other location. If you know that baseline distance and you know the angles relative to that baseline, you can try it. You can get the distance to an object. Now, this doesn't work with the sun because the sun doesn't have any parallax. So if you could do this, you can go to as far apart as you want on Earth. I'm explaining this to the globe guy here. So you can go as far apart as you want on Earth and measure your parallax angle, and there isn't one. The angle 0. And this is true for all the celestial bodies. Now, they construct the distance from a bunch of theories, not from observation. They don't do
Nathan and Riley talked about it. Yeah, they assumed the size of Mercury is the same size of the Earth, and they assumed that they have calculated the size of the Earth. Yeah, I remember that. Sorry for interrupting.
It's just the size of Venus. And the guy that did this, Christian Huygens, he used numerology to base his assumption that Venus was the same size as Earth.
Yeah.
So, and he didn't this is how the measurement was, so-called measurement, whatever you want to call it.
Yeah, but as you said, as Denmark said, and that was something which I wanted to say even earlier. That's not a measurement. That's a calculation. It is based on assumptions.
Yeah, so it's based upon the assumed size and distance of Venus. So they watch Venus transit the sun, and they go, hey, it takes this long, so if Venus is this size and this far away, it must have this orbit, okay? And if it has this
then
orbit...
you will have to know, but then you will have to know even the distance of Venus to the sun.
I know. It's just problems all over the place. That's what I'm trying to explain to this guy. So they time it, and then they try to get a distance from this timing, right? But the thing is, where'd you get the radius of the Earth from in the first place?
Yeah, that's it.
Oh, the radius of the Earth is based upon the distance of the sun. So it's a bunch of circular logic.
Yeah. That is what Nathan and Riley discussed a couple of years ago. I remember that.
Yeah, we measured the circumference of the Earth. Well, how'd you do that? Well, we assumed the sun was very far away with parallel rays.
Yeah.
Well, how'd you measure the distance of the sun? Well, we used the radius. What the fuck, dude? That's circular logic.
Yeah. I remember.
And the funny thing is, if Globe Guy was why do you think all these scientists are wrong? We can talk to scientists. They ain't even know what we're talking about. They ain't gonna know this is how it was done. They don't know any of this stuff, right? They're just like you. They went to school. They were told the Earth is a globe, and they left it at that. They don't know about Eratosthenes other than the most basic shit. They don't know how they measure the distance of the sun in any way. They'll have to go Google it just like you. So don't be embarrassed that you had to Google it, because we could have a PhD in physics in here. He'd have to Google it too. They don't know any of this crap because we've talked to them.
Yeah.
What they'll say, we know the magic science guy fallacy. They'll point their finger and say, all right, that's not my field, but somebody else must have done it. Okay, fine. We'll go find that person. Hey, did you do this? I didn't do it. It must be somebody else. And it's always passing the buck, right? Just passing the buck to another person forever. We can't find the guy that did the measurement. I've been looking for 8 years now. Who's the guy? Where is this guy? Where's the magic science guy?
Yeah, but nevertheless, you don't have to be a rocket scientist to understand the English language and the difference in the English language between measurement and calculation. But he didn't like to acknowledge that. I mean, you don't have to be a rocket scientist, right? That is just simple English language. Measurement means something you measure, and you can only measure something which you can touch, or you can measure the ground when you count your feet, how many feet you have on the ground. And do you see what I mean? He didn't want to acknowledge. I mean, he sounded at the end like he was waking up when he realized that the one article and the other source, they differed from each other, and he said they lied in the first one. But it's very difficult. They always come with the idea that, yeah, flat earthers are so stupid and that they cannot actually find something here which is based on science. Although they are the ones who struggle in denying, for example, the black swan. Refraction brings the horizon up, and it's not geometric, and you have now 3 horizons. But still, they cite the boat going behind the geometric horizon.
Look, I want to see someone use refraction. I don't care what you do to make a curved surface look flat, dude. Ain't never seen it.
Refraction, but actually, refraction cannot bring the horizon higher behind the oil rigs. Actually, refraction will cause what we see in one of the footage where someone has filmed the shore on the other side, the time lapse of the entire day, and you see that the water is rising and dropping, and the shore from the other side is disappearing behind the water, and then the water is dropping. But that is just the weather condition. So that is what refraction does. It doesn't bring something from behind the bulge of the water. Stupid.
It also don't make a curved surface look flat. I mean, even if it brought the horizon up, I could say, hey, yeah, cool, it brings the horizon up. Yeah, but it's also
exactly.
hold on, but it's also bringing up all the water in front of the horizon at the same time and making that water look flat. Right? So you got to have just the right amount of refraction. So there's this amount of curve at 3 miles, has to have just the right amount of refraction so that the 3 mile refraction compensates and makes it even with the 2 mile refraction that compensates and make it easy for the 1 mile. You know what I mean? It has to be perfect all the way to make it look flat, which is ridiculous, preposterous, would never happen.
And I want to point something. I don't know. You said something. I don't know what was it. No, I forgot it. But reminded me of something else. I would like to lead you the way in a couple of sentences. What do you think? Which distance is larger? The distance when I'm standing on the shore, the distance between me and the horizon when I'm looking vertical to the horizon, or the horizon, the entire horizon from the left and right, which is perceived by my eye. Which distance? In which way the eye covers a larger distance?
Oh,
you get what I mean?
It would be the left to right. Yeah, I know exactly what you're saying. Because of perspective, it would be the left to right. So, like, your left to right view would be like fucking 20 miles.
Right. Thank you. Yeah, thank you. Okay, so if a boat goes behind the bulge of the water, then if you have one boat on the left side in the perception of your eye, and the other one on the left side, there should be a bulge. They should not be able to see each other. Go under the bulge of the water from their point of view, right?
Oh, a water hill?
As you say, that's what. Did you get what I mean?
Yeah,
bro.
I know exactly what you're saying. We should, you know what we should do?
Yeah, that's why.
We should take
that's
a
why.
buoy.
That's why we flat earthers. Sorry, that's why we flat earthers. I just want to come to the point. That's why we flat earthers when we say the horizon looks flat. I mean, as you said, that should be 20 miles. We should also see a curve on the left side. The left side should be. Do you understand what I mean? Sorry, pardon me.
I got a
Pardon my.
question.
You know what I was thinking, dude? Like, we should do this experiment, right?
I do got a
So
question.
we have a buoy in the ocean, and we take 4 boats. One, each boat is north, south, east, west, and they all go away at the same speed, right? They're all going like say 5 knots. They should all disappear from each other's viewpoint at the same time. So, right, the boat going north should be able to see the east and west boat and the south boat, and the other 3 boats should disappear at the exact same time if they're all going the same speed away from the center point, because there's supposed to be a hell of water, right? It's supposed to be a big fucking, basically a bubble, and they would all lose sight of each other because it's all. Well, I guess you lose sight of the south boat first, right, and then the other 2.
Yeah, I got a question.
Yeah, yeah. Okay, go ahead.
How do
Yeah,
you? So you guys are flat earthers, right?
You're a genius, bro.
So how do you explain eclipses, seasons, tides, stars?
Are you reading a list?
No, I'm just. Them are all things that have to do with the Earth being.
Classic, bro.
Well, I'm just asking for them to explain it.
Okay.
How do you explain eclipses?
You're the one who needs to explain eclipses, not us.
Exactly.
Okay, so something. How do you think that eclipses, the time eclipse happens? How do you think that's predicted?
Probably with how the moon's rotation is across when it orbits around the Earth to when it's lined up with the sun.
Nope.
That's exactly how it's explained.
No, it's not. That's not how it's predicted. In fact, that doesn't work.
It does.
Yeah, you're just saying it does.
Well, that's how an eclipse happens.
Yeah, no, that's the story.
Go on.
So eclipses, and they've been predicted since 2000 BC, before the globe. They use something called a solar cycle, and that tells you when eclipses happen. They happen on a cycle over and over and over again. That's how we know when they happen. They don't use a heliocentric. If you use a heliocentric model and you try to model Earth, Moon, Sun in a 3D model, it doesn't accurately predict eclipse times.
All right. Well, you're trying to explain.
So you need to explain it because your heliocentric model don't even predict that shit.
So can I say something to you?
Yeah, you're going to just ignore what I say and change the subject, but go ahead.
I'm going to say you trying to tell me how to explain eclipse happens doesn't actually tell me that they don't happen, which would have to be due to a global Earth, because certain people on Earth don't see it.
No, that's your claim, dude.
Well, that's just the truth.
No, your claims aren't the truth, dude.
So if the Earth was flat, everybody should be seeing the eclipse at the same time.
No, that's nonsense. That's nonsense.
That makes perfect sense.
No, that's nonsense.
That's a perfect sense. The Earth was flat.
Yeah, if you don't know how vision works, yeah, that makes perfect sense if you have Muppet vision.
That a global Earth would cause eclipses to happen on certain sides of the Earth.
Why do things get smaller as they? Well, here's a better one. When I go to railroad tracks and I look at them, why do the railroad tracks, even though they're parallel, why do they come together to a point?
When you say parallel, what are they parallel to?
Each other.
Okay.
Railroad tracks are parallel to each other.
Mm-hmm.
Do they look that way?
Like, what do you mean?
If you go stand under some railroad tracks, don't they look like they come to a point?
If they're going straight.
At the horizon, right? They converge at the horizon.
Yes, the distance you
That's
go.
what they look like. Okay? Well, the sky does the same thing. What's above you comes down to the horizon, and the ground rises up to the horizon. It's called the vanishing point.
Mm-hmm.
Okay? That's why you can't see to the other side of the world. Perspective. Not because it's a ball.
It's called geolinear foreshortening. It's the technical term.
It's not geolinear foreshortening. What the fuck are you talking about, dude?
That's what
question.
No, the technical term is linear perspective. It's a subset of projective geometry. So the 3D world is projected onto a 2D surface, like your eye, a camera lens, film, something like that. So when it's projected, right, it's only projected in angles. And the farther away something is subtends a smaller angle. So if you have railroad tracks, even though the railroad tracks are 4 feet, when they're close to you, that's one angle, but when they're far away, that angle diminishes and diminishes and diminishes and diminishes. But they're still 4 feet away from each other.
How is it projected on 2D?
It's projected onto a 2D surface.
You just said distance. That would have to do with 3D.
Dude.
If you're clocking distance.
Dude, don't do it. Don't try it. Okay?
Just being honest with you, man.
No, you're not. You're trying to be deceptive.
You haven't been honest since you joined, bro.
Okay? I said bro. The 3D world vision is the 3D world projected. Perspective is the 3D world being projected onto a 2D surface. The 2D surface in this case is your retina. The retina of your eye, the inside smooth surface of your eyeball.
Yeah.
It comes through the lens. That what's outside the lens gets flipped, and then it's projected onto. You can actually look in somebody's eye, and you can see what they're looking at projected onto the inside of their eye. How they discovered it. But anyway, then your brain inverts the image back to the way it is. So the point is that that's what perspective is. The 3D world gets projected onto a 2D surface. That's why it's a subset of projective geometry, because it's a projection.
Indio, may I ask Jodab something?
I'm learning.
Yeah.
Okay, Jodab, would you please? Jodab, just a question. Would you explain to us the reason of the lunar eclipse?
Yeah, I would like to know. You can explain to me how eclipses don't happen, but just because you can like.
No one said they don't happen. Nobody said they don't happen.
Okay,
one word. Straw man and you freaking loser. No, we're not going to listen to dishonest motherfuckers. We didn't say they don't happen. Nobody ever said that. We did not imply it.
Misunderstanding.
No, it's a misunderstanding. You're a piece of shit.
Jodab, just tell us
this is the second time you said it.
I know it is.
Gegenschein. Look up the Gegenschein. That's how it works.
Okay, you can be muted too. I'd rather talk to no one than liars.
Just tell us how the lunar eclipse happens, how the lunar eclipse, according to the heliocentric center.
Berserk, why are you asking him? He has no fucking clue, bro. He just tried to tell us, he's like, that's exactly how eclipses happen. And he debunked it in 3 seconds.
Yeah.
I didn't even bring up the Salanurian eclipse or anything like that. It could have got a lot worse.
Yes, me too. But it's easier because on the lunar eclipse, supposedly, as the heliocentric model tells us, it happens because the Earth goes between the moon and the sun, right? I wanted to lead him to the point where I could ask why we cannot perceive the S factor when you throw a shadow on a sphere.
He's gonna have no idea what that is, bro.
High IQ Berserk, bro. You gotta read the
know that. Yeah, bro.
You know what I mean. You know what I mean because the shadow.
I know exactly what you're talking about. Yeah, I know exactly what you're talking about.
Because when you throw a shadow on a stair with steps, and then the steps would break the shadow.
Okay, I'll ask him about it. I'll ask him about it. So check this out. So you think that the shadow in a lunar eclipse, right? That's the shadow of the Earth projected onto a sphere of moon, right?
Yeah.
Okay. Now, you realize that spheres only cast round shadows on flat surfaces, right?
Yeah.
Ooh.
So it couldn't project a round shadow onto a curved surface. Because when that shadow crosses the center line, it would make an S. It would be S-shaped because the moon would be curving one way and the other way. Right? So when the shadow crosses over the center line of the moon, that shadow is going to curve the other way. So it would form an S shape. Has anybody ever observed this?
I'm new to it. I'm confused. So, do you guys believe in?
Facts, I believe
when you say a flat Earth, like what type of like shape would the Earth be? Like a flat surface?
We don't believe in a shape.
Here we go, bro.
It's not a shape.
What would you say it is?
Okay, we don't think the Earth is a disc in space. See, when you think about like how reality the universe is, right? You think of. I'll just give it to you. You incorporate, probably without knowing it, because they just teach you in school, like that's the fact, the Copernican principle. That Earth is not unique. That it's just like everything else, right? It doesn't have. It's not unique from anything else in the universe, right? You think that. So you take. Well, do you think Earth is a planet?
Yeah, I would say.
Okay, so. Then that means it wouldn't be unique, right?
I mean, it's unique enough to host life. It's pretty rare.
But I mean, unique.
You asked about the shape,
only thing. When I say unique, I mean absolutely unique. Whereas there's nothing else like it. Not. It shares similar things with other things, dude. There's no similarities. I'm saying zero similarities to anything else.
Yeah.
See, that's called the Copernican principle. That when you think that the Earth has no unique place in the universe, so that idea is incorporated into your worldview. So when you think about reality, you think Earth is not special, and it's inside a giant vacuum floating around, orbiting, spinning, all this shit. Right? When I say, hey, picture the Earth in your mind, what do you see? You imagine seeing the Earth from some third-person viewpoint.
Yeah.
A viewpoint you've never had.
Yeah, like photos you see online. I see what you mean, yeah.
Yeah, third person, like a third-person shooter, right? Top down, you're looking down on everything. But nobody has ever seen it from that point of view. We see the world from a first-person point of view.
Do you believe in like space travel then?
No, let's try to get to your questions as you ask.
No, I'm trying to be very basic. Like
I know, I understand.
I'm not saying. Listen, I'm laying a broad foundation, dude. So like, you don't come and have to ask another question. So I'm laying a broad foundation. So when you say, "What's the shape of the Earth?" that implies that the Earth is inside some giant space, right?
Yeah.
Okay, we don't think that. We don't think the Earth is in outer space. We don't think the Earth is in a giant vacuum. We don't think the Earth is a third disk from the sun. We don't think any of that shit. Okay, Earth is synonymous with universe.
So it's on thing. It's on separate thing.
It's everything.
It is the thing. That's the thing.
There's nothing else.
Nothing else. Okay, I get it. All right.
You look at the stars, you see points of light. There's no land in the sky, bro.
So I do.
You can apply the same thing to a human.
India, man.
I'm stealing all your shit, brother.
I don't mean to sound...
you also have to pay royalties, man. Come on, man.
I don't mean to sound like I'm very naive and like to this whole thing, but so when you say that, let's say 1,000 years ago, like was that something that's always been? Has it been something that's?
What do you mean?
Well, you say that it's its own thing, like we're anonymous to the universe.
No. Let me just jump in here real quick.
Go ahead.
What is the shape of the universe?
The universe?
Mm-hmm.
I don't think it has a shape.
Oh, well, has that been like a thing for like thousands of years, or have people always thought that?
From what we know, that it's ever expanding, which means it doesn't have a definite shape.
Here we go. We don't know that, bro. The point is, it's like, yeah, cause.
Yeah, it's like I just think it's funny that these guys say, "Well, it's expanding," so I don't have to answer that question because it's in motion or something. It's crazy to me. If the Earth was a sphere and it was expanding, would it still be a sphere? I mean, Jesus Christ, man! Like,
I don't think the Earth's expanding.
Oh my God!
Okay. Anyway, it was kind of a joke, but the point is, not everything has an idealized shape anyway. If I said, "Hey, what's the shape of a rock?" you couldn't tell me what the shape of a rock is. Because rocks have all different shapes. They're irregular, right? All you can say, it's irregular. But we don't think the Earth is inside something. So asking what shape it is has no meaning.
I got you. No, see it. So then,
because it's like, where's the boundary? Well, if you step outside that boundary, you're outside of reality, dude. Like you're like that. It's like meaningless. It's like going outside of the simulation. If you were like a simulation theorist, right? Say you thought you were in a simulation. There is no outside the simulation. Like there is no out there because you're a computer program. The out of the simulation doesn't exist.
Bullshit.
Do you guys believe in cause and effect?
Here we go, bro.
Well, I don't know your guys' whole basis, so it all comes down to certain things. Like you say one thing, then I wonder about the other.
Bro thinks if you know the cause and effect, you know everything. That's not true.
What does this have to do with?
I'm just wondering if you think that the Earth's its own thing. What do you think the cause of that is? Just always been like.
I know this statement, this debate before.
Here we go, bro. You wanna?
Created.
Yeah,
there's only two choices, right? There's only two choices: created or not created.
Yeah.
I can't think of a scenario where a flat Earth would be
so when
an
you say not created, you mean always been.
No, I don't mean always been.
It's not
look, the time period is important.
Mm-hmm.
How did it get here? Why does it exist? It has to be created by a mind.
Mm-hmm.
Okay, so there is no natural processes that would lead to a flat Earth universe. At least none that I haven't heard any hypothesis of how it happened through naturalistic, materialistic causes.
So,
Are you a bigger banger, bro? Are you a big bang, bro?
So then, would you, with all this,
let's not answer that, I guess. Do you believe in the Big Bang, dude?
Oh, I'm not too. I mean, I'm a religious man.
I don't want to interrupt nobody, but I just put my head. I apologize. And
No, I'm a religious man. I find it just easy to live by it. Not really too many.
I'm going to scream into my mic. I don't want to interrupt nobody while I interrupt everybody. Fucking people, dude. It's so funny.
Well, I don't mean to sound like naive with the whole thing, but I'm just. If you say, do you think that people like our higher ups are lying to us, or do you think that they're misunderstood? Because that's how it's always been.
I think my thing is 99.99999% of people don't know, and they believe it's a goal because that's what they were taught.
Yep.
And do you think the people that found that out, if you believe that they found it out,
we're right here.
Were lying? Well, no, I'm saying the people who are wrong. Were they Are they lying to us and they know, or they're actually confused?
No, they don't know. Like the only people I can say, hey, these people, this group of people is definitely lying, would be the Apollo astronauts, because they're the only ones.
You don't think they went to the moon?
Well, it's not just that. I mean, it's way beyond that. That's just the tip of the iceberg. But the point is that those people, they're the only people that have ever claimed to see the entire Earth as a ball. Right? So the people in the ISS, they would only see 3% of the Earth's surface. So they couldn't definitively say Earth is a ball because they don't see enough of the Earth.
Yeah.
The only people that have seen the Earth, who even would have seen, to have firsthand primary knowledge that the Earth is a ball, is the Apollo astronauts. So they would be lying. Everybody else, other than that group of people, those 27 people, they're believers.
Yeah.
Like, they can't be lying. It's impossible because they don't know anything from which to lie.
Yeah.
Because you have to know the truth, right?
Mm-hmm.
I mean, you can lie. You could believe something and say, I don't believe that, right?
Yeah.
But that would be different. You still don't know anything. You're still in the same situation where you're saying you don't believe something that you believe, but that doesn't bring you to any point of knowledge, right?
Yeah.
So, the Apollo astronauts claim they have knowledge.
How many other countries have been to the moon?
Zero.
Zero, dude.
Well, what they tell us is what I meant to say. My bad.
Well, I mean, the Nazis did. They got an alien moon base up there, right?
Well, I know probability isn't like an argument that's fair, but would you I find it kind of hard to believe that all these other countries that have been to the moon, they're all working together and
I got this one. Just rewind the clock. Just 3 years ago, and everyone was moving in lockstep. So this argument that this country should have called out this country. Did they do that just recently? No, they didn't. Really. Yeah, I didn't think so. It's a one world. What?
Yeah,
he doesn't know. One world.
Good.
All right, bro. Just don't worry about it.
Whatever. They're all a bunch of frenemies. Let's put it that way.
Never heard one more government.
You know what a frenemy is? That's what they are. They're frenemies. They're enemies in public, but behind closed door, they're friends.
Yeah.
It's like that chick, right? It's like, you know, you got these, right? So it's like, you know, why is a fat chick like a moped? You don't want your friends to see you riding either one of them. Right? So it's the same thing, right? In public, they don't want I don't fucking talk to those fucking Russians. They're fucking a bunch of goddamn fascists or communists or whatever I hate today is, and they pretend that they don't like them. Like even now, they're like, we sanctioned the shit out of Russia. They're just still buying mad shit from them. Like, what are you talking about? It's a bullshit. It's a game. There's one thing, and you have to agree on this. There's like almost no doubt of this, is that there's one thing all governments have in common as a goal, and that is control of their domestic population.
Yeah,
they have their interests align in that regard. United States the government wants to control their population. Russia wants to control their population. Britain wants to control their population. Zambia wants to control their population. So they all agree on that. It's to control their domestic population. And they always tell each other, don't get involved in the domestic politics of other countries. Just don't do that. You get involved in their international politics, that's fine. But that's a domestic politics. And hold on, because there's one more point that I got to drive home. So we have the laws of land warfare, right? Human rights conventions. They only apply to when you're attacking another country. They don't apply to your own country. So using biological, nuclear, or chemical weapons on your domestic population is not a war crime. Did you know that?
No.
It's only a war crime when you do it to a foreign country.
Damn.
Yeah. Think about that. So when they say, Assad gassed his own people, what came of that? Not a fucking thing, because there's nothing they can do about it. Because when they passed the laws of land warfare back in the 1930s, they specifically said, oh, no, we can gas our guys. We can gas our citizens.
So do you think that them lying to the population about the Earth?
Who's lying? But that's the thing. Who's lying?
What you're saying, yeah. I'm not too sure. I'm just saying. But do you think that if that hypothetical,
I look at it from the necessary.
They're lying for control of us? Like, I don't see how them lying about all.
Most people just believe it, dude. They're not lying.
So they're not lying.
Most people just believe it. It's a tradition. Like, look, dude. Say you don't believe in. Let's say you didn't believe in religion. You're a fucking atheist. I said to you, and I said Jesus is God. What do you think? All the government officials are lying? Because we live in a Western Christian tradition. Most of the people are going to believe Jesus is God in this tradition. Right? They don't believe it because they go to church or read the Bible or anything like that. It's just a tradition. So their parents went to church, their grandparents went to church, their great-grandparents went to church. So they consider themselves Christians. They don't do anything that's Christian, but they consider themselves that. The point is, like, are they lying? No, they believe Jesus is God. But they don't like there's nothing to it, though. They only believe it because they were told that by their parents and their teachers or whatever. So a lot of people just believe the Earth's a globe because they were told it. They weren't taught it. They were just told it. You go to kindergarten, there's a globe in the corner of the classroom. They say, Earth's a globe. First thing they teach you, Christopher Columbus, right? Christopher Columbus proved the Earth was round when he sailed from fucking Spain. Nobody believed him. He was trying to get to India. Or it's some bullshit, right? So they have their whole bullshit story. It's like one of the very first things they teach you in school. Like the very first things. They teach you that before they teach you the alphabet.
Well, do you not think that happened?
Hell no.
What, Christopher Columbus?
if we were to sail from where he was and do the exact same thing he did, would we be at a different spot or would we be in India?
Christopher Columbus was lost.
So yeah, I understand, but let's just say you
was lost. He'd have tapped end up in the Gulf Stream and end up in Cuba.
So let's just say we sailed from where he did what he actually wanted to do, and he went, west, and then he landed in India. Do you think that we land in India, or do you think we land in the United States?
What?
Yeah.
Well, to
he could have never landed, and he would have had to sail around South America, right?
Do you think he was just lost? And
no, he was lost. They have his logs, and they've recreated his route, and they've recreated the instrumentation and astronomical navigation techniques he used. And basically, they found out that you doing what he did, you'd be off by 15 miles per day.
Oh shit!
Yeah, so that's a lot when your journey's fucking 4 months. You're way the fuck off. You don't know where you are. So the point is that he was lost. He almost starved to death in fucking Cuba. He had to, whatever. The story is the story. The point is that this is one of the first things they teach you. It's just a Western tradition. Believe me, if you go to school in India, this isn't the first thing they're teaching you. You go to school in China, this isn't the first thing they're teaching you. Or Afghanistan, or fucking, this is a Western tradition. And because we're Westerners, we think that everybody thinks this.
I feel like I believe there's globes.
Who discovered the globe? Who came up with the idea to discover the globe? Who figured it out, right? In the story. Right, Greeks. The Greeks figured it out. The Greeks are Westerners. Who carried it along a little farther? Ptolemy. Who carried along a little farther than that? Copernicus. He's Italian. Who carried a little further than that? Galileo. He's Italian. Who carried a little farther than that? Kepler. He's fucking Norwegian or fucking whatever he is. Then who carried it further? Newton. He's fucking British. Right? So it's a Western tradition. The whole idea is a Western tradition. Now, in China, they were flat earthers into the fucking 20th century.
Oh,
the 20th century, dude. So the beginning of the 1900s, until the Jesuits displaced the emperor, and this is a historical fact. This isn't me saying it's a Jesuit conspiracy. They did it. They subverted the emperor. They took over China. That's the way it is. Okay, but the thing is, until they were taken over, they were flat earthers. The population of China, Southeast Asia.
Yeah.
Until the West basically took over the governments of those countries. So the way the globe is actually spread is by the barrel of a gun. We have fucking cannons and you don't. It's literally it. You got bows and arrows. We have fucking cannons and gunpowder.
Yeah. So
who are your leaders? Who are your knowledge keepers? We're going to kill them first. We're going to try to rewrite your entire fucking history.
Yeah.
This is the way the real world works. I mean, if you just figure this out now, I mean,
I'm just trying to figure out how you guys explain all of like the universe's ways, like the whole
just
stars.
Explain the universe.
I'm just
explain the whole universe, bro.
You gotta realize, even
I'm not actually explaining the universe. I'm just like with just how let's just say you look up in the sky, as time goes, you don't see the star, and then you do see the star, that type of thing.
Maybe they're moving.
Or what's your way of things are moving?
Yeah, everything's just the way you see it. The sun moves, not the earth. The sky moves, not the earth. The moon moves, not the earth. The earth looks flat because it is flat. You don't have to imagine it being a ball too big to see. It's just the way it is. So it is the way it appears to be.
But it has to be flat.
Yeah, facts.
It looks flat. That's not like, listen, but don't get confused of me saying, oh, it looks flat. That's proof it's flat. It's not proof it's flat, but it's a good piece of evidence on what it actually is. You don't look at something and go, that looks flat, it must be curved.
Mm-hmm.
Right? That would be fucking dumb. It's like it would say, hey, looking flat is evidence of it being curved. That would be stupid. Like, looking flat is evidence of it being flat. Okay? So if someone says, hey, dude, it's actually not flat,
well,
you're a little ant on a giant beach ball, that's fine. You can say that. Now, bring the evidence, right? You bring the evidence that my visual perception is an illusion.
You guys say it moves, but it doesn't just move. It explains itself. Like, the way it moves is proves for flat
Explanations ain't
Earth.
worth a shit, dude. I can explain why the fucking Bruce Banner turns into the Hulk.
I'm just saying, like, the way the Earth moves explains why you see stars at certain times.
It doesn't move. That's the thing.
The sky moves. The sky.
The sky moves.
Yes.
So would the sun move?
Yeah.
You see
Is
that?
what that's what we
It's the
see.
moon Earth. So why do you think the Earth doesn't move?
Why would it?
Because we don't perceive it to move. I mean, there's other reasons, like there's experiments which demonstrate the Earth does not move.
So
Wait, hold a minute. Why are you? First of all, why are you comparing the Earth to the sun and moon? Name one single resemblance. Oh wait. Yeah, cooked, bro. There's no reason to start comparing the Earth to the sun and the moon. That's crazy. Yes, they move. No, the Earth doesn't move. Very
So
simple.
you believe the sun and moon move, right?
No, that's what you observe.
Well, that's what he just said.
Well, it's not a belief that we have to offer you. It's just
It's
what
not
you
a
see.
belief. That's what you see, dude.
So do you think are they orbiting the Earth?
Orbiting?
Yeah.
Like
What do you
going
mean by
around.
orbit?
Listen, dude.
You mean are they orbiting the Earth?
Listen, dude. We're
Not the way you're thinking of it.
Okay, this is what you don't understand. We're strict empiricists.
Yeah.
We go by what the actual observational or experimental evidence is. Nobody has ever, in the history of mankind, ever observed an orbit of anything ever.
Well, I mean,
Ever.
it's
Not
night
once.
and day.
That's not an orbit,
That's not
dude.
you observing an orbit. And observing an orbit would be seeing something go around another thing in a circle or an
How would you guys explain night and day?
Okay, so listen.
Not from orbits,
Okay,
bro.
hold on, dude. Did you hear what I said? Did you hear what I said? Did you hear what I said?
Go on.
Observation of an orbit will be watching one body go completely around another body. You're going to get banned from the server. It was a bad idea, Hannah.
Wait, what happened?
Okay, yeah. What happened? Same thing that always happens. Right when you're about to make a point, you overtalk me, then someone comes in and interjects. Shit happens all day, every day. Anyway, it's this common thing. We know what you guys do. Anyway, the point is that nobody's ever observed an orbit. Observing an orbit would be to see one body go around another body completely.
Mm-hmm.
Has anybody ever observed that?
Not me.
Has anybody been outside the Earth and the Moon, right, and seen the Moon go around the Earth?
Hell no.
Yeah, that answer is no. Okay. No one's ever seen an orbit. Orbits are completely conceptual. From the viewpoint that we have on Earth, we don't see the planets orbit the sun. We don't see the fucking moons orbit Jupiter. We don't see any orbits. At best, we could say we see something. We see, moons go in front of something, but we never see the quote unquote other side of the orbit.
Yeah.
Because luckily for them, or unlucky for them, you don't see them on the other side. You only see them on this side. So the point is that no one's ever observed an orbit. So you're asking us, does the moon orbit the sun? We're empiricists. We're going by what we actually observed, not the explanation, right? So the explanation always needs the evidence to back the explanation, right? So you say, hey, explain this. I go, okay, I can explain it. But the thing is, do I have the evidence to back the explanation?
I would say
and the thing with the globe is, you'll give me a lot of stories about the globe, a lot of explanations. There's millions of them. A bunch of ad hoc hypothesis, Band-Aids, freaking duct tape, all sorts of shit to hold together. But there's no evidence for the fucking bullshit. That's the thing. There's no evidence. Shadow of the Earth and the Moon. What's the evidence of the shadow? Oh, what's the evidence of the shadow? Oh, what else would it be? That's not evidence of the shadow, though. It's not positive evidence. That's incredulity. That you can't think of something else, so it must be what you think it is. Which is logically flawed, obviously. Okay, we go by what we like. Okay, we go by, hey, it is I can trust my own eyes. It is the way it appears. And if someone comes along and proves that it isn't the way it appears, I'll accept that evidence. But I'm not going to accept the story that somehow I'm fucking hallucinating that the Earth looks flat.
So you think you're right, right?
Is that what you heard?
Here we go. Asking a question.
What?
Why would I know? There's no evidence to the contrary.
And do you have evidence against it? Everything else that makes you think that they're wrong to make you think you're right, or do you have evidence for yourself?
Yeah, the Earth looks flat.
Oh,
are you not listening? Okay. Experientially, you only ever get experience a flat and motionless Earth. Someone wants to come around and say, "Hey, it's not flat; it's a ball. It's curving on the surface." Fine, present the evidence. If I say it's moving, fine, present the evidence. Don't tell me a story.
Well, I'm trying to ask you to explain your evidence.
I go with evidence.
Happen.
Huh?
I'm asking you to explain why you think we see stars at a certain time, why day and night happens. I'm asking you to explain it through your...
Because the sun moves.
We already answered that.
And I get it. So
I don't know if he was here. I don't know if he was here when the other guy. The sun moves away from where you are.
All right.
And then when it moves far enough away, sunlight, the air's not actually transparent. It has to go through air. When it's far enough away, it gets dimmer and dimmer, right? Twilight, dimmer and dimmer, and the sun's too far away. The light can't penetrate all that air to light up where you are.
Do you believe the Earth rotates?
No.
Hell no.
The sun moves. The Earth don't rotate.
Earth doesn't move at all, bro.
All right. And you think the Earth is flat as like a 2D type of flat? Like just
Lord, here we go, bro.
Yeah,
again, this isn't explained.
No, nothing. 2D is a concept. It does not exist in reality.
I'm asking you to explain how the Earth is laid out. You could say it's not real, but you look at a flat object, you look at your screen right now, that's a shape. So I'm asking you to explain what the shape is.
You're responding. We already answered this, brother. Hold on.
To loop back to the beginning, bro.
Yeah, I gotta address this. You respawned just now. We talked about the universe, remember? And you were like, well, I don't know what shape that is.
Well, I know
you probably also you probably don't also think of the universe as some sort of object, as if there's like,
compared to an object in the vacuum.
Hold on. We told you that the Earth, flat Earth, is not an object in a vacuum.
Mm-hmm.
So you're going back to trying to compare
then what is
to an object in a vacuum. Hold on, slow down. We've already answered you. It's more like the universe, which you don't know what shape it is because you're inside of it. You can't phase out of the universe to say what shape it is.
Okay, you're inside of the Earth too. Do you know what shape the Earth is? No, because you're not sure of the shape exactly. Okay.
Doesn't have anything to do. What?
Shut your ass up, man.
Bro, is this guy retarded?
Well, I mean, don't you guys think that your guys' points that you're making are kind of a little bit? What is it? What's the word?
You and I have the same exact worldview.
I know. Do you not understand the points? Evade questions that go against you compared to actually explaining them.
It's not strong against
you. You guys try to say the Earth is its own, but there's no evidence to explain why the Earth its own.
Why is there? It's no different than the universe, dude. You didn't need any.
Do you have evidence to the contrary?
I have evidence that there's a sun, there's a moon.
So
you're not saying there's no sun or moon.
And now what I'm saying is, with the way the moon and sun works, it explains that the Earth is indeed not flat.
Okay,
that has no.
First of all,
it has
the way it works is not an explanation. No, it's not perfect math. You're just making shit up. You don't know any of the math. You don't know what any of the data is. You don't know how any of those shit's predicted. Don't even try it, dude.
Well, then how do you think it's predicted without saying that it's on?
Look, it's not what I think, dude. I'm not going by what I think. That's just the way it is. So, the way the sun, sunrise, sunset, solar noon, angle of the sun, azimuth, elevation, the way that's predicted is not with a globe. So that's not with a globe either. They use something called the equation of time. So they assume that you're a point in space, in that it only tells you where the sun is relative to the celestial equator. The celestial equator is an imaginary line in the fucking sky. And where that is above the horizon, and you could do a calculation, if you know the time and date, where the sun will be relative to that. And it'll tell you the time the sun rises, the time the sun sets, the direction. right? Azimuth, elevation of the sun, all that shit, any time of day. But there's no globe in the mathematics. None at all. The mathematics isn't you on the surface of a globe looking at the sun.
So then, on the surface of the Earth, you have China, you have the U.S. You're seeing.
Here we go.
Yeah, no, just ignore what I said.
I heard everything you said, but what you're saying is
the
don't address
sun
it.
moves, the way the sun moves.
Yeah.
I am addressing it right now. But the way
the sun's
sun
moving?
moves,
Wait, the sun's moving?
the sun definitely does.
Oh,
move.
that doesn't go with your model, sir.
But you think you're spinning.
Yeah, you thought that you said the Earth moves, dude.
Yeah, the Earth moves, sun moves, it all moves.
Oh,
but with the way the Earth spins,
dude, you're confused, bro. You are
well, no, with
confused.
the way the Earth spins.
Wait, which is it?
Okay, well,
I'm asking you. Like, this is my point that I'm trying to get to.
You sound confused, though.
If it's a flat surface and you think the Earth's not moving, so it's obviously the sun that's causing the day and night, right?
Yeah.
Yeah, you see the sun moving.
So
Yeah,
the way the Earth is, well, you guys don't believe in the shape of the Earth, but how would you explain
the shape of the Earth?
Well, you guys just said Earth is in its shape. That's what I tried to address. Then you guys didn't really answer the shape of the Earth.
Because it doesn't have a shape. It's meaningless. It's a meaningless question.
So why do you think it's meaningless? What's your evidence to back to the
What shape is the universe? What shape does the universe do?
Listen, that's the third respawn to the same infinite regression fallacy, which is what you're trying to do, and we're not letting you.
All right. Well, you asked me what's the shape of the universe. Look at your room right now. There's so much empty space. That's what the universe is. Now look at an object inside of your fucking room.
No, so my room is in the universe.
Yes, that's exactly how that works.
My room would be in the universe.
So what shape is the universe?
Look at your room. Look at your PC that's in it. Think of the PC as a planet. Now think of the space that fills it as the
that's
universe.
within.
We don't need to think of it.
Okay. Are you done
You're
talking?
a retard, bro.
Yeah, so you're spazzing because your infinite regression fallacy is failing. Your gotcha's failing. So there's something called the embedding space. The room would be the embedding space. So my laptop, my computer desk, they're inside the embedding space. The universe in your cosmology is the embedding space for planets, stars, galaxies, black holes, nebulas, and all that shit. The universe. The Earth is not embedded in a space. There is no embedding space for the Earth. The Earth is the embedding space. Everything is within that. Got it?
It's within the Earth.
Yes. Within its space.
By the way, this is the third time we've covered this. So
yeah, I know.
It's
you just need to pay attention better.
I'm very much paying attention. So
you're not.
I know.
You respond.
I can understand. So you're saying within. I'm still not understanding. Within.
I know.
Everything is within the Earth.
You don't. Okay, let me ask you what's outside the universe.
The sun.
Is the
outside
the universe?
No,
so
that's
not
in
outside the whole universe. That's not what I'm saying.
Is it embedded in our?
All right. So when you say outside the universe is. And it's it's its own. Like there's no outside of the universe.
That's what flat Earth is.
That's what we're trying to tell you.
We're trying to tell you. We've been trying to tell you that this entire fucking time, bro. Come on, dude. Did it just click? Holy smokes!
I still don't. You guys haven't. Really
you understand.
You guys haven't explained.
Yeah, you do.
Much of your point why things happen. You guys do
try to play pretend. Yeah, try to play pretend. You can try to play pretend, dude. You understand?
I'm not playing pretend. No,
yeah.
So you're just low IQ. Got it.
No, he's playing pretend, dude. It's the third time.
Pretend.
Yeah, pretend. You came in with that infinite. Listen, I've done this many times. You came in with your infinite regression fallacy. Gotcha. It failed. We have to keep pretending.
So disproving makes you correct, right?
Well, this is a well-known paradox. It's called Zeno's paradox. It's been known about for 2,000 years.
Ooh.
Well, I'm just saying, do you think this
you actually can't prove with geometry, math, or logic whether reality is bounded or unbounded.
Mm-hmm.
Yeah, so because of this thing, like if you use mathematics or geometry or whatever, said, hey, I want to go to the boundary of the universe. And I'm going to go halfway there. And then I go halfway again, halfway again, halfway again. You're never going to get there.
Yeah.
So that proves that not only motion is impossible, but that there's no boundary. It's a paradox. And that's what you're doing. You're trying to get the answer to a paradox using an infinite regression fallacy. Because if I said, hey, the edge of the Earth is a million miles that way, you're going to go, oh, it's after that. Oh, that's inside fucking water, and that goes for another 2 million miles. Oh, it's after that. Oh, and you're just going to do this continually. That's why you guys think you get a free pass by saying, well, the universe is expanding. Now I don't have to answer the infinite regression fallacy because it's moving. Somehow the boundary's moving, so that magically makes it all go away. No, it don't make it magically all go away, bro.
Right. And to be fair, there's an article that says we asked 5 experts if the universe is infinite or not, and they don't all agree. So it's not like a written fact that it's expanding or whatever. It's something you just believe.
Nobody knows what nobody knows what the edge of reality is. I'm sorry to break your heart, but that's the fact. Nobody knows.
Or the shape. That's the important part here. The shape.
Or the shape
when you
of
say,
it.
When you say, oh, that's a meaningless question. No, it's not. It's to help you reveal the question you keep asking. Hold on. Why are you talking to me? To help you reveal that the question you keep asking over and over itself is a meaningless question. I'm giving you the answer. The flat Earth is the universe, which has unknown boundaries, and the shape is not really known either. How could you know that?
You need the boundaries to know the shape.
This is not very difficult to understand. Our worldviews are no different. If you believe in the universe, well, then you kind of think the same way. You don't know where the boundaries are. You don't know what shape that universe is. Period. So, what's your problem here again?
I think
it's like asking what time was it. It's like asking what time was it before time started.
Yeah.
Right.
Yeah.
Like it's a meaningless question. It doesn't mean anything. You're asking us, hey, if we take this space and we go outside of it, what space is that? Like, dude, it don't make any sense. It doesn't. It's a meaningless. You're asking like, what's the space outside of space? But you have the Copernican principle embedded in you. That's the thing. You don't even realize it, right? That they've embedded this into your brain. So you have this paradigm from which you judge all things. You're judging this question. You're saying the Earth is not unique. It's just like everything else. So if it's just like everything else, that's be embedded in a larger space because it's just another object. That's it's just like my phone or my fucking laptop or that ball in the sky. They're just all the same thing. They're just a bunch of objects, and that's how you think about it.
Right.
But that's not how it is.
Right. You also probably don't think
there's no indication that the Earth is like anything else at all.
You brought up your room, right? And then the object inside the room. Is there an object inside of anywhere that you could pick up and say, this represents the universe? Probably not, right? Okay, great. That's how flat Earth is. There's really no object to say, oh, this is like flat Earth. There's no way to represent the entirety of reality, number one, because you can't phase outside of it and then look back at it and say, oh, okay, well, it's shaped like this giant blob here or whatever. Does that make sense?
Yeah.
You're in it. You can't leave it. Or how would you be able to say what shape it is?
Good point.
I feel like we covered this pretty thoroughly. We just need to make sure this is clear so we can move on, please. This is like, all right.
I'm not the most intellectual, man. I'm pretty basis on everything.
All right.
Kind of just go from what I hear, what I see.
Have you?
Well, if you went by what you see, then you'd be a flat earther.
Well, from the knowledge I've been told, that explains what I see is why it is. That's what I meant to say.
That makes sense.
I don't know, man. I mean, I was in your boat about an hour ago, but now I don't know.
Why is this guy holding his nose when he speaks?
Sounds like Squidward.
I think it's just natural nerdiness, but hey, I could be wrong. Like natural geek vibes, but hey, what do I know? We talked to him earlier, Jedi. Hey, maybe you could take a crack at him. Pause.
You're all right. I haven't had my coffee yet, so give me a minute.
Yeah, honestly, you might need one for this one, dude. Nah, Pop Smoke here is really chill, though. I think pretty chill. It's giving bass chill vibes. Wait, is that his name? Pop something? Wait, who are we talking to?
Joe Easy.
Sorry, I didn't catch. Who is it in the panel?
You talking about me?
Oh, yeah, it's Pop Smoke. All right, I was right.
That's
All right, W. All right, so what's your next question, bro? Let's keep cooking.
I don't know, man.
I mean, you got some legends in the panel here.
Shut down.
Yeah, facts.
So do you think that there's like with everything, there's like what's the word?
A grand conspiracy, everyone's lying.
Not like a grand conspiracy. I mean like a consistency with how everything is, like with matter, space, volume, all of this, or do you think that it's specifically unique to just the Earth?
There is just Earth. Didn't we just cover this, bro?
What do you mean there's just the Earth? We see other things, so it's not just the Earth.
Oh, okay, you just you just respond again.
Yeah,
I don't get it. I still don't get it. Like it's.
I know. I know because you've been educated a certain way, dude, and we were all educated the same way. You think about everything. You have a paradigm from which you judge everything. So you think when you look up in the sky, you see the heavens. You think all that works the same way as it does on the Earth, right? Everything's just the same. There's one universal physics. It's been the same all the way in the past, retroactively, and it's going to be the same all the way in the future. Never changes. What's on the Earth, like the rules on the Earth happen in the sky, everything's the same.
Mm-hmm.
We know for a fact that's not true. For a fact. So on Earth, when you
so
look
what
at an
about
object,
the fact that the moon has craters? And we can see that.
We'll get to you in a second.
Yeah. So take a image of a crater, flip it upside down, and it becomes a dome. Yeah. So image of a crater, it's pareidolia, buddy. Anyway, you see Jesus Christ in toast too. I mean, fuck, dude.
Mm-hmm.
And you can sell it on eBay.
What about the
people were
rovers?
doing that.
Well, guy, we'll get to you in a second.
What rovers? Fucking rovers. Astronauts on the moon.
Well, here, let me just say this real quick. Here's what you can't do, Pop Smoke. You can't take the solar system and the universe as is. Yeah, bro. Who else?
Okay.
Yes.
That's not
Come
my
on,
name.
Cardi.
I'm confused.
It's all right, dude. You know he doesn't like nickname guys, so we'll just call him his real name.
Okay.
Babe, you got a fucking
you get started
rapper
rapping 21
picture. Yeah, man.
That's Playboy Cardi, dude.
You don't know who Pop Smoke is, nigga?
I know who Pop Smoke is, so that's Cardi. That's not Pop Smoke.
All right, we'll just move on. So what you can't do is take the solar system as it's presented and then put a flat thing in there and then ask questions like, well, so is everything consistent? Like, how comes there's just like one flat thing and then all these other balls and stuff? We've been trying to tell you that it doesn't work like that. It's more like the universe itself. There's nothing outside of the universe. So when you're like, well, the sun's outside, not really. You don't know what the sun is to say where it is or how it is or why it is. You don't know what stars are. You don't know what the moon is either. So you just be careful about comparing the solar system and then putting a flat thing in there because that's what you keep responding and keep doing over and over. Sure.
What do you mean I don't know what the moon is?
Okay, tell us what the moon is. Watch this.
Is it land in the sky?
Yeah.
Yeah, it's definitely a solid surface in the sky that rotates around the Earth.
And how do you know that?
Let me think.
Because you got told.
Probably it. I know. What you asked me again? Sorry. How I know it rotates around?
How do you know? You don't see it rotate. You don't see the moon rotate. You don't see it orbit.
Well, I feel like with the eclipses, maybe explains.
You feel like merch.
Merch.
Nah.
I feel happy today.
How do you just answer the question? How do you know? How do you know?
Maybe tides. There we go. Maybe that explains it. As the moon is farther away as we turn, the water rises and the water.
You know, if we have problems with this guy before like this, we're asking him questions and he's not answering the questions.
Well, you just asked me to explain it. I said tides.
Yeah, tides. I'm asking you how you know what the moon is.
Wait, what the moon is? He asked me, how do I know the road?
Yeah, how do you know the moon's a solid? How do you know the moon's a solid freaking rock?
Well, I know that how gravitation works, and I know that mass allows gravitation. So I would
know how gravitation.
Well, it explains itself. Yeah.
Well, no, that actually does not answer his question because things that are not solid are also claimed to be affected by gravity. So theoretically, even under the globe Earth model and all the physics that go along with it, the moon could, be affected by gravity and also be like not a solid surface. So that does not answer the question.
Let's ask it more simply. What is the moon?
Yeah. How did we determine the composition of the moon? How do we know it's not green cheese or petrified wood?
Do that.
Yeah, so this is not an easy question to answer because you can't actually tell.
What do you think that
the correct answer is that you don't
explain
know?
It?
Don't ask me what I think it is, dude.
Well, I'm just saying,
I'm agnostic, man.
Well,
I'll say
tides,
I don't know.
I mean, as the Earth.
Okay, tides. Tides.
And then the gravitational pull between the moon and the Earth.
I know. Okay, I know you're telling me the common wrong story. It's not even wrong within the globe paradigm because tides are supposed to be caused by like a hydraulic action that's correlated to the moon, but not directly caused by the moon. I actually posted a video from PBS Spacetime that's titled "What Physics Teachers Get Wrong About the Tides." Tides correlate with the moon, but they don't. But they're not caused by the moon.
Mm-hmm.
If you model tides, they have a model for tides. There's like 27 variables in it. The moon is only one of them. The sun is another one of them.
Yeah.
And if the moon was just pulling on the water, right, where would high tide be? It'd be directly under the moon, right? And then there'd be a big bump that followed the moon around. But that's not how it is. Some places have 2 tides a day. Some places have 3 tides a day. Some places have 4 times a day. In England, the tide will vary. Like in England, like the tide will be at 6:00 a.m. It'll be high tide in one part of the English coast, and that frickin' 11 hours later, that's when it's high tide over there. So, did the moon how is the moon pulling on only part of England and not the other?
Some places don't have any tides at all, even when the moon's directly above.
Yeah, and then there's that problem, right? There's fucking almost no tides in the Mediterranean, no tides in the frickin' in the vast majority of the ocean. There's no tides.
It's primarily a coastal
lakes. We have no tides in lakes. What?
Ooh.
No tides in the Black Sea, no tides in the Caribbean Sea, no tides in the Caspian Sea. As Injo pointed out, not in the Mediterranean Sea. It's primarily a coastal phenomenon. It doesn't happen out a distance from land. Yeah.
Damn.
Dude, this is the question for me. I actually don't know. Do tides correlate to the mass body of water, or does it?
No,
like if there's a massive body, like he said, lakes. Like since it's a smaller body, would they not have tides?
Well, if they're being pulled by gravity, right?
Mm.
Is the gravity different in a lake?
No, it shouldn't be.
There you go. So L tides, bro.
The point is, the globe's been around, getting constantly massaged for about 500 years, and it's massaged. It's massaged all over the place, right? So any observation that falsifies the globe, they immediately stick a Band-Aid on it. Right. Okay. So I'll give you an example. Eclipses, because you brought it up. So I'm going to use this as an example. So there's an eclipse called the Selenelian eclipse, or also called the impossible eclipse. So what happens is the sun and the moon are both above the horizon, and the so-called quote unquote shadow of the Earth is somehow cast on the moon, even though the sun and the moon are above the horizon. So think about this for a second. The light source is above your head. The moon is above your head. But the thing that's casting the shadow is below your feet. Now, how does that work? Can't work. That's why they call it an impossible eclipse. Now, they've known about this since the time of the Roman Empire. So they came up with, nearly immediately, an ad hoc hypothesis just to prevent that model from being falsified. They didn't want it to be falsified because they like it. They like it for all sorts of reasons. mainly aesthetic and metaphysical, because they consider sphere is the most perfect shape, so they prefer that form to every other form, right? It fits their metaphysics. See, a lot of people just think, the globe was just a scientific discovery, and that's all it was, just a bunch of, highly ethical scientists investigating the natural world, and they discovered the Earth was a globe. That story is utter bullshit. They had a metaphysical worldview, right? So things like theories called like the harmony of the spheres, which was a Pythagorean theory. They thought the spheres were like musical notes.
Yeah.
So and because sphere has the property of being equidistant to the center, they considered it the most perfect shape. So not only does Plato, Pythagoras say that this is why they thought the Earth was a sphere, but also Copernicus himself, which is thousands of years later, he says the same thing. And he came up with the heliocentric model. So his hypothesis wasn't based upon what we would consider scientific reasoning. It was based upon philosophical reasoning, which they didn't have a problem with. Only now do we have a problem with philosophical reasoning. Back then, they didn't have a problem with it. We have a problem with it now. So when people take their idea of the way science works now, and they retroactively say scientists in the past thought the same way, and this is how they came up with it. And that's not the case. It's not the case at all.
So I'm about to ask a really stupid question.
Facts.
Just be ready. So this is just really there's probably some reason for you guys to just counteract it, but just like, let's say I'm sitting where I'm at right now, right? And I just flew west, kept flying west.
Here we go, bro.
So, no, I know. I haven't got the reason for this. That's why I'm asking. And then let's just say in my worldview, I'd land. If I kept going, I would be able to get back to where I am just going that one direction. Now, how would that be explained? Well, I'm sure it's probably happened. People have flown around the Earth.
No airplane can fly 25,000 miles.
Well, I mean,
it didn't happen.
There's been people who've flown west, stopped somewhere, kept flying. So I mean, let's just say
the point
flying west. Back where I am. How would that be explained on a flight?
Let me steel man your question. If I fly in a straight line in one direction, how do I end up back at where I started?
If it's a sphere.
Yeah, but that's your question, right?
Well, that's mine. Yeah, that's.
Yeah, but
I believe that would happen.
Yeah, I know you believe that, but you can't actually even fly in a straight line.
What do you mean?
It's not possible.
Well, I'm saying I'm flying in one direction. Doesn't it have to be a straight line?
Yeah. So one direction.
Yeah.
West. What is west? What is west?
What do you mean? What is west?
Yeah. What is west?
It would be just
west from New York and west from London. Do you think that would be a straight line?
No.
Yeah. So this is a common thing, right? So if I had a compass, right?
Yeah.
And I had a big magnet in the North Pole.
Mm.
The compass would always point at that magnet. Even though I take the compass and I'm going to follow the west heading, right? And I'm going to, I always got west, it's dead in front of me, and I keep going. I'm going 90 degrees from where the compass says north, right? I'm going west. I'm going to end up going in a circle on a flat surface.
So you're trying to so you're saying that the plane's flying, it's not flying in one direction, it's flying in a path.
You're flying in a circle. Itself. Yeah, okay. You're flying in a circle. It's like going out your front door, walking around your house and going in the front door around. You go out the front door, take a left, walk around your house.
Yeah, has to go back in the front door.
You're going in a circle. So the difference between circumnavigation on a globe versus circumnavigation on a flat Earth, we think you're turning with a very slight turn, right? So you're turning like if you're going west, you're turning to the right, and if you're going east, you're turning to the left. But that arc of that circle is so small, it's imperceptible. But that's not how planes actually fly in real life, because in real life, we have flight routes, or what's called international flight routes. So planes flying like these flight corridors, they don't just fly around wherever the fuck they feel like, right? They actually have restricted airspace. They have to fly in corridors. So no one has ever did a circumnavigation. Anyway, the point is, circumnavigation on a flat Earth is a left to right turn, whereas on a globe, you think you're flipping upside down. Right? You think you're circle, because you are doing a circle, right? Yeah. You're doing a circle, you're flipping upside down and then coming back up the other side. Either way, it's a circle. The only difference is you think you're flipping upside down, we think we're turning left to right.
Yeah, and to be fair, your question kind of involves like a GTA hypothetical where you get in a plane, you just free roam. You understand, like, there are perms in this world. When you want to drive a car, you need a license, and you got to follow the path, the road, the highway. Same thing applies with planes and stuff. So your question kind of works on paper, but it doesn't really work in reality. Just want to throw that in there.
Yeah, I get the whole, like, how it wouldn't make sense, but, like, in a hypothetical, like, it still would apply. Outside,
yeah.
You know what I'm saying? Like, no, I mean, like, let's say I didn't fly, like, I could just magically fly left in a
magic
direction. Yeah, well, I'm just saying, but like,
good. You'd have to navigate curvature then. That means you'd have to rotate around the ball. You yourself have to rotate 360 degrees if you were to come back from where you started. See, we understand that aeroplanes don't fly like this. Aeroplanes maintain and fly horizontal parallel with the ground below. The pitch data of the aircraft shows that the aircraft maintains a horizontal path, so doesn't rotate underneath themselves and then back up the other side as if they were on a ball. So no aircraft navigates a curved surface. Aircrafts use the surface of the Earth as a horizontal plane.
Damn.
So, if you look in the chat real quick, you'll see what we're talking about.
How do I get open chat? 1 second. Oh, like the main chat?
If you go up top to the of the VC, you'll see a little bubble that says open chat.
Oh, shit.
Little chat bubble.
Oh, I see it.
Yeah. So this person just took a freaking printed an AE map, took a magnet, stuck it in the center, and just is moving the compass around. Right. So it'll always point north. You're moving around in a circle. Even though if you're just looking down, following your compass heading, you'll be going east or west. And there's no way to even test. Yeah, and there's no way to test the claim that going in a straight line. It's like impossible to even test.
So I'm looking. Yeah, I see that photo, but like, let's just say I'm in the center, right?
Yeah.
Well, at the magnetic point. If you're at the magnetic point, then you're going to have issues. Your circle is going to get wider and wider and wider as you go east or west around that point.
I'm just looking at it. So I couldn't be in the center. What do you mean? Like, so let's say I'm in the center of that point, right?
What? At magnetic north.
On the photo.
Choking on my own spit.
So, like, could I, if I would just to walk, you see like the little 30, the line with 30?
Yeah, there ain't no north-south circumnavigation.
So I couldn't, let's just say I walked on that line.
Yeah, I'm telling you, that's north-south. There is no north-south circumnavigation.
And let's say I kept walking till the end of that point, where the outside of it is.
Well, you'd be Jesus Christ, because you'd be walking on water.
Well, let's say I took a boat.
He's asking us what he would see, even though we haven't done this. So we wouldn't be able to tell you what you'd see.
So no one's done it?
If you were to go in a hypothetical straight line, then potentially you would reach what?
So what's your reasoning why I couldn't do it? And why no one could?
Hopefully fear and common sense.
The common sense I couldn't get on a boat and cross that line?
The Southern Ocean is the roughest ocean in the world. They literally call it the Screaming 60s because the winds are so fast.
I get what you're saying. Like 30, couldn't
we're
do
talking
it,
like 30-foot fucking swells. Yeah, hypothetical. Go. Why be hypothetical? Go die. I don't care. Go die.
Well, I'm just asking you to explain what I'd see if I did.
We can't answer that question.
I can't answer that, dude.
Do you think that's kind of needed?
No.
For what? For what?
Isn't that kind of the whole basis of your argument that you should be?
No.
You shouldn't be. Well, you shouldn't be seeing anything there, right?
No, look, dude. We have one argument alone, and it's the only argument you need to know. It ain't about the sun, stars, moon, eclipses, or any other that shit. Really simple. Can you have a ball that doesn't have a curving surface?
No.
Okay.
There you go.
All we need, measurable curvature, as in drop over distance. That's it. That'll be the end of flat Earth. Because it eliminates. Listen, they measured curve, can't be flat. Measure no curve, can't be a ball. It's really simple. Yeah. Makes a true dichotomy. There's like you don't even need to get into the other shit.
Thanks.
Necessary condition for a ball, curving surface, and because we have the benefit of the most of the Earth's surface being water, we don't have to. We know like what the water's doing in one place, it's doing in all the other places. So if the water's not curving, then the Earth can't be a ball, right? Can't have like a ball with infinite flat spots, right? So we can just measure the surface of water and see if that's curving, and guess what? It's not.
It's not.
That is literally our only argument. That is it. That's our proof too. So it's really simple. I mean, it is really simple. So people don't want to simplify it because they've been taught their entire lives that, they've been taught kind of like a cognitive dissonance thing about the globe is like, well, if you don't believe it's a globe, you're stupid. Well, here's the details of the globe. Well, I don't understand it because I'm not a scientist, right? So they think only super smart people can figure it out. But on the other hand, if you don't believe it, you're stupid. So apparently you're stupid if you don't believe the super smart scientists that figure it out. So it's really a fucking shell game when it comes to that shit. The point is that the question isn't a scientific question. When you say Earth is a globe, or anybody says that, they're making a claim about the geometry of the Earth, the figure of the Earth. They're saying it's this shape, right? It's not science. Carpenters, they measure shapes all the time. They're not scientists, right? So measuring the shape of the Earth is not science, but they want you to believe it's science, okay? Because they know they can't measure it. So do you want to know what they do? They go, well, there's this thing called gravity, which is science. Well, it would be science if that wasn't such a weak hypothesis. But let's assume it's a strong, well laid out theory. Let's just pretend that. And they say, well, we have this gravity thing, and it forms things into balls, and that's why the Earth is a ball. We can't measure the ball, but we'll just say we can measure this phenomenon, and the phenomenon has a consequence of a ball. We just can't prove the ball part. This is the actual state of affairs. We have people coming here all the time. They'll argue gravity for fucking 10 hours, dude. Not even knowing why they're arguing it. Because they don't have any evidence of the curve. They're arguing gravity. Arguing gravity is they're saying, I don't have any evidence of curvature.
Alex.
Drink the coffee, Jedi. It'll make you feel better.
Yeah, could you get your coffee yet?
Yeah, I'm thinking about making a second one. I'm already done with this.
Might need to get a third cup, man. After we're cooking right now, boy.
I got like a C4 fucking ultimate in the fridge, dude. I'm about to drink that shit. It's like 300 milligrams of caffeine.
Don't drink that shit, man. Don't drink the C4, dude.
Yo, 2 days ago, I drink like probably equivalent of probably like 5 or 6 cups of coffee a day.
God damn.
On a bad day, it'll be like 4. And when I say bad, I mean that's the least amount. 2 days ago, I didn't drink any coffee all day, dude. I'm like, why do I feel like shit, dude? I didn't drink anything with caffeine in it, nothing. So I went from like a daily dose of like 1,500 milligrams of caffeine daily to nothing. I'm like, man, why do I feel tired? Yeah, it took me to like 6 o'clock at night to figure out why I felt tired.
Speaking of tired, but honestly, if y'all need to go to bed, this is your okay to go to sleep. Because Jedi got his coffee and he's gonna cook, so.
Dude, I'm up.
It sounds like you're up, dude, but I am I'm not up.
Has Robert come back in recently?
Oh God, please no. No.
Good.
All right, CB, dude, pass out, man.
All right, bro. All right, I needed the permission first, but
yeah, you relieved the duty.
All right. No, this has been a great freaking panel. Honestly, I saw you run Defin earlier, so shout out to you for popping off and cooking.
Yeah, I was wasting my time watching the fucking anime. I shouldn't have wasted my time watching.
Honestly, no time is wasted watching anime. You take that back right now?
No, just fucking. It's like a series, so I watched like fucking 8 episodes for a shitty ending, dude. I hate that. Dude, I swear to God, because they want to make another. Obviously, they want to make like another fucking series, right? So the ending just sucks, dude.
Sometimes it'd be like that, bro.
What the hell is it called? Paradox or something?
Oh,
I think that was the name. It was on Netflix. It was like an AI. It was like an AI type shit. The art wasn't too great. The story was okay, but then the ending, they like. Look, if you're gonna do the whole thing on story, then you got to have a good ending. Because I could take a bad story if the art's good, or if the violence is gratuitous. The gratuitous violence goes a long way with me, especially with anime. If it's fucking totally over the top, ultra violent, hardcore ultra violence, I'll fucking do. It could be the worst story in the world. I'll still watch it.
I better watch you some Attack on Titan, bro.
Yeah, I've seen some of that.
Oh, okay.
I mean, I watched like 80s, 90s anime, dude, and some of that was like straight out of Japan. They don't pull no punches, dude. Like when dude gets cut with a sword, like the whole room turns red and shit, blood spurting everywhere.
Yeah. Damn. Well, this is the reason why people end up staying up till 5 a.m., 7 a.m. Even Chad is talking about we're having a good time. This is why we like to do this. So shout out to you guys in the panel that really keep this flame lit and drives the traffic, keeps the content going. So shout out to you guys, man. This is why we're here when we should be sleeping. So
let's give I'm gonna bounce off too because there ain't no blowers here. Shout out Helio, dude, if you're listening.
Yeah, facts. Big shout out Helio.
I hope you're keeping well, Helio.
Mm-hmm. All right, well, one of you Aussies take over, man. Clock in.
Matrix will be shouting at people soon. It'll be fine.
All right, man. Well, enjoy that coffee and W panel, W Indio, W Jedi. W those Globers, kind of. That Pop Smoke guy was alright. Kind of.
L Globe.
L Globe, bro. L Globe guy. L Gravity. You know, the usual. Alright, guys. Let's have a good night.
All right,
CV
peace.
out. Yeah.
See you later, guys. Take care.
Peace.
Silence? Mic check. Yeah, I can hear you, bro.
Bro, why is it so quiet in here? What are you guys doing? Hello? Is this like the AFK chat?
I've got a question. Anyone around?
Yeah, what's up, Fry?
Wait, so what's your opinion on gases having weight? Do gases have weight? Is that a thing?
Gases have mass, right? So they do have mass in a way, but they have kinetic energy. There's other guys who can explain it better. But basically, it does have a mass, but it doesn't behave like it has a weight to it. So it expands in all directions. Gas molecules bounce indefinitely off the walls of the container or other gas molecules. So there's no weight, there's no gravity, there's no attraction between the two molecules or the walls of the container. So they just bounce around indefinitely up and down, around in all directions. So you can imagine a gas molecule can come out of a plant, tree, go up, hit bump into a few other gas molecules on the way, hit the container, and come back down. And then maybe hit the ground, hit a few more things along the way down, and then might hit the ground and then bounce back up or bounce in another direction, but indefinitely.
Okay, so I have a question here. If you take like a helium balloon, it most definitely goes up, correct? What would
it goes down to vacuum, right?
Sorry, what?
What were you going to say?
Yeah, that's what I'm asking. Like, how do you explain that?
It's just lighter than the air around it, the surrounding medium.
It is less dense than the air we breathe.
Yeah. And a brick is more dense, so it falls. A helium balloon is lighter, so it rises. Depending on the medium.
So it's got to do with density, basically, correct?
Relative density.
Yeah, relative. Like an oxygen balloon, for example, would be more dense than air, so it would fall down.
Well, a balloon just blown up with, just with your mouth, even if it's just the air inside is the same pressure. Well, the actual outer rubber, whatever, of the balloon will weigh it down.
Yeah.
Same in a vacuum chamber. If you have a helium balloon in a vacuum chamber, it'll fall, but the gas inside the helium balloon will continue to press outwards in all directions.
Wait. So a helium balloon in a vacuum chamber falls down?
So it falls down because of the weight of the actual balloon, the physical balloon that's holding the gas. But the gas inside, the helium inside the balloon is still pressing out in all directions. That's not falling and dropping as well. That's still all bouncing around in all directions. So even in the vacuum chamber, it doesn't affect it. There's no weight at all in gas. Even in the vacuum chamber, just still keeps bouncing around.
Yeah, okay.
Well, I mean, if you have a balloon in a vacuum chamber, that's what I mean. It's going to bounce around inside the balloon, inside the vacuum chamber. That makes sense.
Right.
Do you think if gravity affected gas, the helium would just sink and the balloon would flatten out or something? It doesn't.
So if gravity exists, what should happen to the helium balloon?
Well, you'd think if the helium had weight, then it would flatten out on the bottom. Sort of rest at the bottom, the gas.
I think so. Like in a vacuum chamber, you mean?
Yeah. If it had weight, so you put a balloon with water in it, and you put it into whatever, you put it into any chamber, you put it on the ground, it's going to go spread out. It's not going to But yeah, it doesn't. It just stays bouncing around, not affected by weight at all, even in vacuum chamber.
Is there like a citation or like a video for this? I would like to check this.
I don't have one, but I'm sure there is one. Globers like to use it as a proof against, as a proof of gravity, but it's just not evidence of gas not being affected by gravity at all.
Oh, someone's done a video on it. Will helium balloons float or sink in a vacuum chamber?
Yeah.
You want me to link it?
They don't sink because of gravity. They sink because of the balloon itself has weight, has bonded molecules.
All right, the balloon. Yeah, the balloon would have weight.
Hmm.
The balloon itself would have weight, correct?
Yeah.
Right.
Without the balloon, you just have a helium chamber.
Honestly, like it doesn't even look like the balloon's going down. Wait, is this even a vacuum chamber? Okay, I see.
But we know gas expands in all directions. You know, you open a gas canister, the gas is going to go out in all directions. It's not going to go down like, what do you call it? Dry ice. You know, dry ice kind of has a bit of a weight to it and it goes down. It's not like that. It goes out in all directions.
Okay, so wait, but it can't go in all directions. Like if you just release helium gas in the air, wouldn't it just go up?
It all goes out in all directions.
But it won't go down, it will just go up.
Well, it's not every single molecule is going to go directly up. They're going to bounce into each other and go in all directions. But generally up.
Like 90% of it would go up, correct?
Well, in a balloon it will, when it's all together, but if you release it into the atmosphere, it's going to all mix together with the atmosphere.
Gas don't go, they expand to fill the container. And the collisions that happen afterwards is the next question. It's not like it falls down. Maybe a gas particle collides and then it goes in a downward direction, but gravity is not... does gravity not doing anything to gas? Gas just expands to fill the container.
Yeah, it doesn't have a weight. It doesn't have weight. It has kinetic energy, which is something completely different.
But you said it has density, correct? How can it
density? Mass. It's considered to have a mass, like it's a thing.
Right.
Yes, but it doesn't have any weight. It's kinetic energy.
What's weight? Wait, what's weight? What do you mean by weight?
Well, weight like bonded solids that have a weight. 10 grams, 20 grams, whatever. Yeah, like water or anything.
So
rock, wood, dirt, whatever. Solid.
Does air have weight? I mean,
no.
Okay, so air doesn't have weight.
Just explained it. No, it doesn't have weight.
Water has weight. Okay.
Yeah. It's all bonded. Sticks together, has weight. You can weigh it. Put it on the scale and weigh it.
Right.
Can you weigh a burp? Nope.
Like, when you say weight, isn't it just mass?
Matter?
Matter, yeah. Yep.
Well, yeah, stuff.
Matter not have
whatever.
weight?
Yeah, matter has weight, like solids, bonded molecules, and they have weight, but gas is unbonded. It's kinetic energy, so it doesn't have weight.
The weight just goes away.
Sorry?
Let's say it's like a liquid. And
it's a liquid. If gas forms a liquid, then it's going to have weight.
So some gases, you compress them so much that they become, some of the inside the gas becomes the liquidy. I think that's in scuba diving. I think it's pump it in so much that some of it liquefies.
I think those are called
not all of it.
fluid.
Superfluid. Oh, it's a whole other thing altogether. Superfluids. It's sort of. We're talking about air,
Never
not
mind. That
superfluids.
is mistake. That was mistake.
Yeah. So worth looking at superfluids. Interesting as.
Yep, go on YouTube and look up helium superfluid. First video that pops up, absolutely amazing. It literally like sinks through the glass that it's in. It's has like zero viscosity. Yeah, it sinks through the glass beaker that it's sitting in. It's dripping out the bottom. Apparently, it can like climb up walls and stuff. And if it goes into motion, it just never stops. It just keeps moving forever. Crazy stuff.
Crazy.
I think it's if you get helium gas less than 4 Kelvin, and it turns into a liquid. And if you get it below 2, or I think no, below 3 or 2.8 Kelvin, it turns into superfluid. Crazy videos about it on YouTube.
But just to answer Tibbs, yeah, the gas in a propane tank is still expanding in all directions inside the tank. So you're going to get, so there's going to be pressure on the entire, all the walls up, down, side, and bottom as well. So when you put it on a scale, it's reading the gas pressure hitting the bottom. It's hitting all of them. It's hitting everything in the container, spreading out in all directions in the container. When you put on the scales, it's reading the gas particles bouncing on the bottom of the container. So it gives you a reading of weight on the scale. But still, it's not weight, like it's not, gravity does not affect it at all. Gas doesn't form puddles on the ground. Spans in all directions.
Things will only sink, Tibbs, if you displace them, right? So if something gets displaced, then it will reseek equilibrium. But once it reseeks equilibrium, right, when it comes to gas particles, right, on a microscopic level, they're still moving in all directions and have a directional bias, and they move in straight lines between collisions. Just a cool quote about gas particles. Then I'll post this definition of gas particle movement.
Well, Tibbs double the pressure. So the amount of substance in a contained volume. So if you don't mind. So when we say that gases have weight because you put them in a container, you must
You're cutting off, Jedi.
understand that the reason why you've put them in the container
Did it drop? Yep.
Yeah, he'll probably reconnect in a second. I thought he was just roboting for me.
So am I coming through clearer now? Can you all hear me? Can Tips hear me? Was everyone talking about what gas does? Is that the conversation? I see a couple of citations posted by Anti-Globe. And I think Daz was talking earlier, talking to Tips about how gas moves and shit.
Yep, you're coming through crystal clear now, which is great. Yeah, I think Fry was asking Daz if gas has weight.
Yes. Okay. So, no. So we have to remember that weight is a pressure downwards and only downwards. Gases don't act like this. They have infinite degrees of possible motion. They can go in any direction and do not have a bias. The only thing that changes gas behavior or its directional path is a physical interaction, usually with another gas molecule, something solid, or the walls of its container. So you have to understand that gases expand indefinitely in all directions. Weight's just a directional downwards. So when you put like a rock on the floor or you fill a container with gas, and because there's now more substance in this space, there is more ability for it to press downwards because you have lots of collisions with a body of gas inside a contained environment. We have to remember, though, that we're containing the gas for a specific reason, primarily to stop the expansion of gas, right? It's hard to do that unless you've got a physical container, which is the primary problem that we've got within the globe model. There's no physical boundary stopping the gas expansion into the volume of space that we're said to reside in. So no, gases don't have weight. They have within mathematical formula, and when we look at how molecules and electrons and protons, we got things like atomic weight. It's the amount of electrons and stuff around that atom. We have that stuff, and different gases have a different amount of those type of substance. We can talk about molar mass. Again, that's more of a, it's not necessarily the thing that everybody says that mass is. They have different conceptual ideas. The primary word being that they're all conceptual. The gases don't have that type of weight where they just press down.
Wait, okay, so Jada, I have a question. So, like, you're saying weight is a downward force, something like that?
I'm talking about this direction downwards that some matter takes, so solid matter, liquid matter, gases, they all have different directionality about them because the energy that they hold. So solid objects, yeah, they'll go downwards depending on the density of their environment. In gases, solid things appear to go downwards at all points. Depending on the surrounding area that they're in, whether you've got, say, mud under it, the rock will continually sink until it reaches a density layer that it can't go down further through. Liquids that permeate substance, that evaporates, turns to gas, gas fills space. It's just the way things work. Why there isn't up and down, no flat earther is going to be able to tell you. It's the idea that we've got this story about gravity that makes everything go down. That's not been scientifically proven, especially with gases. Gases don't act in this way. When they trick us that all things go down, they don't. Gas expands. Doesn't have weight. You can contain gas, and the amount of substance in that space will act on the environment. Yeah, it will cause pressure on things. If we didn't have gas pressure, we wouldn't have liquid water. We wouldn't exist, but we wouldn't have biology. We wouldn't have liquid water also. It all needs containment. The energy to keep heat in, that needs like gas and liquids and solids to permeate through, to disperse, entropy over time, right? So all of these things to exist in the way that we experience them, it needs containment. All the energy and everything else will leave. Wouldn't have started. We wouldn't have achieved pressure. We wouldn't be having this conversation. That's what these laws of thermodynamics describe. And without the limitation of the environment wouldn't exist. Why would CO2 as a gas pull from dry ice? It's relative density. So this substance is denser and has less energy than the other substance that already exists around it. So when you introduce it from your container into the environment, it acts like this way. There's lots of different gases that when you do this act differently. Helium being the primary example, that goes straight up at a phenomenal speed. So it's density that causes these things to go up and down. Why up and down, though? We don't know. It's just, it is what it is. All we observe and all that we measure, taken from a horizontal stationary plane, and they go up and down. Gas expands into space.
So is density and weight like the same thing, or are they like different phenomena?
Density of what? So density of substance, solid, liquid, or gas. If we're talking about gases, then to talk about density, then we're going to need.
You're saying gas operates differently than liquids and solids?
Yeah, it's at infinite degrees of motion.
Right.
Solids don't have infinite degrees of motion, like I'm pointing out. Liquids don't have infinite degrees of motion, right? Gases do. So gas expansion into space. If there is an available volume for gas to fill, gas will fill it because nothing is stopping it from doing so.
So here's my question. If there's like a vacuum chamber and you release any gas, like oxygen, helium, whatever, wouldn't it just consolidate down, like at the bottom?
No, if you have a vacuum chamber and then you put gas into the vacuum chamber, you will have a container of gas. Because the gas fills space. You have a contained environment with just gas in. The gas will fill it infinite degrees of motion. Depending on the energy and the system, it will depend on how much pressure you have. Pressure is defined as the amount of collisions with the walls of its container. Depending on the energy of the individual gas molecule, like heat makes it move faster.
I think so that would happen in a balloon, because a balloon's tendency is to
So
become
exactly,
smaller.
gases take the shape of their container. So you've got a balloon with gas that wants to expand omnidirectional in that balloon, pressing equally on the insides of that container. Yeah. Depending on the gas, it will sink or it will rise, depending on the pressure outside and within. And the energy
but balloon's not a container. A balloon's just like,
a balloon's what? It's a container of gas that's stopping the expansion.
No, a container would be like a solid metal chamber, or like a
or a container stopping a gas expansion, like a balloon or a tire.
I don't even know if a tire is a good example. It might be.
Sorry. Isn't one of the primary things about tires is that they contain gas pressure, and you can put more gas into this finite space and cause more pressure. It's nice to have
anything that deflates.
Like seriously, dude. You're saying a balloon's not a container?
I mean, by container, I mean like a solid container that doesn't deflate once there's nothing in it.
Yeah, we have permeability because we put different gases. Helium's very, very small, like I spoke about the amount of atoms that a helium atom has, electrons and protons and so on. The rubber is very thin. Eventually, over time, the helium will escape. It will deflate. Yeah. But it's still a container. It becomes open, then the gas leaves. Was closed and then becomes open. You notice what happens when it becomes open, right? The gas leaves.
In a balloon?
Yeah. Yep. We're talking about the pressure within the system, that after a while, because the balloon has become open, has become stretched, and the gas is so small, then it leaves, doesn't it? Again, this is just proving the example of gas behavior. If there is available volume for the gas to fill, if there is high pressure in one space and low pressure in another space, the gas will want to fill that space, because it can do, because it has infinite degrees of motion. Lots of collisions.
Here's my proposal. Like, if you release gas in like a solid metal chamber, let's say that's a vacuum. It's a vacuum chamber, and if it like consolidates at the bottom of the chamber,
consolidate bottom. It's not going to do that.
Like, let's say you release helium inside this square, like cube chamber, and all the helium settles to the bottom.
Then we'll be sucking the things out from the bottom at all times. We don't.
Sorry?
Gas doesn't behave like this. If there is an available volume, it's not going to clump up in one corner.
Yeah, like water. Like, you just pour water in a chamber, it just goes to the bottom, just like that.
Water into a vacuum chamber? No. If you have no atmospheric or gas pressure on the water, water will turn to gas. It will bubble.
Really?
Yes. When you put ice in a vacuum, it will sublimate, not turn to water, turn straight to gas.
I mean, maybe some other liquid, maybe not water, but it just think like, you know what I mean. Like, if you put like, let's say, any gas. I mean, I don't know. Maybe someone might have done it. Maybe it's not done. But I think
you can drop something that's very cold, like liquid hydrogen, into a vacuum. It will sublimate, turn to gas.
Liquid hydrogen is probably a liquid, right? It's probably not a gas.
Yeah, we're just talking about how energy moves. This is why the second law of dynamics and entropy are always the standard that we hold to this, because this is how stuff acts. Gas moves in all directions. It doesn't have weight. It doesn't press only downwards. If there's available volume space to fill, it will fill it because of the degrees of motion and the kinetic energy that the gas has. It's just going to go into the space, dude. It's a law of nature.
See.
As soon as you apply the gas into the vacuum, it's not a vacuum either. Container of gas, like Jedi was saying. As you can see in the chat, canister on the right is a vacuum.
Oh, is it?
I'm glad you reminded me of my. I was going to bring this up because you brought up a really big, thick steel container. So the highest vacuum we can pull here on Earth is, I think, it's about -6. Maybe it's -8 now. So it's a long time ago since I looked properly into this. But ultimately, these high-pressure, large vacuums, like several feet of concrete reinforced with steel and several feet of concrete again, they suck out the gas reaching, let's say, -6. Over time, 2 weeks later,
Yeah, I have to drop. Sorry, I'm getting a call, Jada. You can continue. I just have to drop for a call.
Yeah, no worries, man. But I'll tell everybody else when I finish. Over time, the gas still that's outside starts to enter the space of the vacuum chamber. So the vacuum lessens over time because the gas still managed to get through the steel, still managed to get through the reinforced concrete into that space. Because gas is always pressing in all directions, and it's going to fill space if it can, because it's so fucking small. The pressure behind it's always going to expand it into that space. So yeah, gas fills space, even in vacuums. Well, I'll tell Fry that later, if I remember.
I think Tibbs had another question in the chat there. Why is it that dense gases get some sort of directionality when placed in a less dense?
Why? Because one... Alright, so if we're talking about two gases, one goes up, one goes down. Why is the energy of one different to the energy of other that makes it go in this directionality? One of them being heat. If we're talking about density, we're still going to have to talk about pressure and how we achieve it. Density is the amount of substance in that space, right? And the energy within it, hot, cold, whatever it is. Different types of gas have different atomic structures. Some have more, some have less. Depending on the atomic structure, we will class this as a denser gas because it fills more space. So it's about the amount of space, it's about the amount of energy. But why things go up and down is because of relative density. When we act upon these systems, they will do this or they will do that. When we take a container of sulfur hexafluoride or dry ice to a concert, we understand that because it is denser, because we keep it cold, then it will stay closer to the floor. Wait, what?
Keep going, Jedi.
Yeah.
Mike.
So over time, the gas, which is increasing in entropy, will continue to disperse into the space. There will not be any left in 5-10 minutes if you don't keep pumping that gas into that space. But to talk about this, you need a contained environment because you're already applying this substance into pre-existing gas pressure. Isn't it wonderful what we can do with the pre-existing gas pressure? We're talking about how you achieve pressure in the first place. The only way that you achieve pressure is the container. No container, the gas expands into the available volume. It's just what happens.
If you increase the heat of a liquid, it will also increase its general pressure because it will try harder to press out against its container. Like steam expands, like I forget with how much psi out from being water to being its mist form. You know what I mean?
Mm-hmm. This is because the energy in the individual gas molecule, it has more kinetic energy now. It's going to move faster, so it's going to have more collisions with the environment around it, the walls of its container. All right, so more pressure, more collisions.
Yeah. Are we having like a physics argument? I just jumped into the random voice chats. I don't know what to talk. Is this actually flat Earth stuff?
Yeah, so it's a physics argument in relation to how we work and operate and how nature works and operates in the physical natural world. So when applied to laws of nature, what we can physically do when applied to the laws of nature. we understand that we cannot achieve gas pressure without a container because of the laws of entropy. This means that the vacuum of space that we are told that is physically uncontained from our gas pressure couldn't exist because we wouldn't have achieved pressure and the gas would have fucked off.
That doesn't even... They understand the idea of a gravity well, right? Like, I'm not...
Yes, I understand the mathematical reification of the gravity well, yeah.
I don't know.
I know.
Is this like, do people actually think the Earth is flat, or did they actually...
Yeah, bro.
Yeah.
I'm pretty sure it's 90% trolls. I don't know why you even think it's flat. I guess not even a religion thing.
No, most of the people here from 24/7 know that the Earth is measured to be flat.
Oh, so it's like a game.
No, it's a direct measurement of the surface of the Earth, and how those measurements are applied to reality.
What's with the logic on this pair of clown shoes?
He just stumbled in here and doesn't understand what's going on.
If you want to see if your planet looks like, look at every other planet, and then you don't even have to like leave or do math. Just get a telescope.
Yeah, my ceiling fan doesn't look like my floor, sir.
What about the floor?
My ceiling fan doesn't look like my floor. You're trying to equate viewing celestial bodies to the surface of the Earth, and it doesn't compute, sir.
You can't look at other things and say that that's what you are. You have to look at what you are and compare yourself to those other things. What are you talking about? Do you think that if you go to the woods or to a forest and you see a squirrel in a tree eating nuts, that you're a squirrel in a tree eating nuts? Is that what you think? Think you're a banana when you look at a banana? What the fuck?
No, but I can see what other bananas look like if I look at a bunch of bananas.
Sorry, other planets. You haven't determined it. Sorry.
If you see what a bunch of other people's insides look like. Like, you can get general consensus of what things are by examining other models or cutting open another. Like, if you want to see how an electronic thingy works, you'll often go and take an old one or whatever and take it apart and then look at it. And look at this, the chips, these are the thingies.
Yeah, but you're looking at that thing, and that's what that thing is. And you're trying to compare it to the floor that you're standing on. It's like, seriously, Grasshopper, you got one eye on the future and one eye on the present. How are you going to know where you're going if you're not focused here? Started talking about how fucking computers work. We're talking about the surface of the Earth. You're talking about other planets. You haven't determined that this is a planet yet to compare it to those things. If you're going to say that the Earth could be like those things, you would have to measure the surface of the Earth to determine if it was like those things. Those things are spheres, so the Earth should have curvature over distance if it was like one of those things. The Earth doesn't measure curvature over distance. We measure the Earth flat, so measurably not like those things. We also don't measure any movement to the Earth. Those things in the sky appear to move. So measurably not like those things. The Earth is measured to be horizontal and stationary, not like those things in the sky.
You can see the roundness of an Earth outside of a spy plane, though. I'm not sure what you guys have done, or if you've ever seen like Virgin Galactic, or if you've ever seen, yeah. Like, have you ever been on a ship, and you get up towards the top, and your binoculars, and you look, and you can see the horizon, you know what I mean? How do you explain the horizon line thing if you don't believe there's a curvature to the surface?
Explain the horizon, I can define it for you. Horizon, no horizontal line. I can define it for you. So the horizon is the horizontal line observed by the observer where the surface of the Earth appears to meet the sky at distance. Horizontal being zero rate of slope. All horizontals are parallel to the plane of the horizon. All verticals perpendicular 90 degrees to the horizon. So it's horizontal. That's how I explain it, we define it. We also use that horizontal for building and relativity and height and depth and your orientation. You are standing up at 90 degrees perpendicular to the surface. Your brain and your vestibular system are made to do this. So, yeah, it's horizontal, dude.
I don't.
If it's horizontal, then it can't be curved. There'd be a contradiction. Curvature is a rate of change of slope. The horizon has zero rate of change of slope. So not curving like a sphere would. Horizontal. You understand what horizontal is, right? Like what your mum spent most of her life being.
Okay.
I mean, come on, dude. I'm trying to get some kind of something out of you now. You know what horizontal is, right?
Answering your very direct question.
I'm using. I know.
Come on, Brando. Brando, are you broken? Your battery's slowing down or something?
I'm probably. So, what's the question again? Horizontal?
Yeah, you know what horizontal is, right?
Yeah.
Cool. So that's what the horizon is. So all horizontals are parallel. You know what parallel is, right?
Yeah, I know what parallel is.
Good. So all horizontals are parallel to the plane of the horizon. The horizon being the limit of vision of an observer across a plane around 360 degrees. The plane of the horizon is the interior of that circle, a horizontal circular plane based on the observer's observation, his limited observation across the surface of the Earth until it appears to meet the sky.
Yeah, I know what the horizon line is. You don't have to define. I don't think if you were standing as flat, the curvature wouldn't be. You wouldn't have a horizon line like you do, like we do.
Sorry.
And it wouldn't change upon your elevation.
Sorry, if you're to have a horizon in the way that you claim it to be, then it would be a physical Earth curve horizon based on the observer's eye height in feet or meters, dependent on the radius of the ball. We're told the radius of the ball, 3,959 miles. So based on your height of eye, that calculation is 1.225 multiplied by the square root of that observer's eye height in feet, which gives you a horizon if your eyes are 6 foot off the floor at the beach with your feet in the water, so 6 foot above sea level, a horizon at 2.8 miles. It's around up to 3. So that would be the physical curvature of the Earth where boats and buildings would be obstructed from view. However, we observe a horizon well in extent of this distance at 10, 15, 20 miles, depending on the eye height of the observer up to 1,000 miles, even if we change the wavelength of light from visible to the infrared. We do not see an Earth curve at 1.225 times the square root of the observer's eye height in feet. So your curvature doesn't exist. I've defined the horizon. Horizontal.
I mean, Jedi, you did the favor of defining it for him after he.
Yeah, I know.
I mean, he didn't know it. And then he went from rinsing and repeating and asking what it is again, not understanding what it is, saying it doesn't compute to a globe that he was lasering. Yeah, it's defined as a horizon. Maybe he needs to focus a little bit, put that straw down, focus on other lines, straight lines.
I don't know. I'm pretty sure the Earth is round. If it isn't, I don't really care. 'Cause I'm not like, doesn't really matter. But it seems, I don't know.
Don't matter, doesn't care yet. He's here. Yeah, he came here to mock flat earthers, I'm sure. And
It's just like a thing to like look into science or something. That's one thing I always thought was just like a giant like conspiracy by Bill Nye and his little gang to get children.
You're in the wrong category. This isn't science. These are measurements. Can't be refuted. Measurements. Horizon, flat, straight line. Horizontal. Not science.
Because you can just look and see the Earth is rounded, and it doesn't change depending upon where you go, really. So I don't really. There's all these different
look
maps.
and see a horizon. Whether you look and see curvature, sir, is that what you see? Or do you see a horizon like you brought it up? Almost say crevizen, ain't that some shit? Yeah, so it's a horizon. That's what you see.
Yeah, you see the edge of where you see the roundness of the Earth at the skyline.
Okay, you can't be helped. Have a good day.
Yeah, a horizon isn't something that happens, right? It's not like something that's exclusive to a globe, right? You would have to have a horizon at a specific distance if the Earth was a globe. When we go out and long distance observations and laser tests, you can see magnitudes further, and you would be able to see the horizon magnitudes. Right? So you can absolutely have a horizon on a flat plane. Right? Look at any video game. Right? Video games are created on flat maps. So near any ocean in a video game, you have a horizon, right? Because a horizon is actually a product of perspective, right? Everything converges into what's called a vanishing point, right? And a horizon line is a straight line between vanishing points. And that's how it's taught in architecture manuals, right? Art, advanced art courses, right? That's what a horizon is. When you're looking at the horizon over a large body of water, you also have weather conditions to take into consideration. That's why we call the horizon an apparent location, right? Because it shifts around due to varying temperature gradients and things like that, humidity, all kinds of different things. Okay, so yeah, you can absolutely have a horizon on a flat plane. What we're doing is going out and testing the globe, right? And if the Earth is a globe, you have to have a specific amount of drop over distance, right? Curvature over distance, which is a larger amount because most people haven't looked into it. So if you look into it, you'll see that you should have 66 foot of drop or curvature over 10 miles, right? And we can go out and set up a camera or a laser just off the surface of the water, and we can zoom in and we can see, like, for example, objects on the other side of a 10-mile lake, when the objects should be hidden behind the curvature of the Earth by a huge amount. We have all of these demonstrations, right? Practical, repeatable demonstrations that we can present. We've got tons of evidence, tons of laser tests as well over huge bodies of water.
Oh.
And we're not claiming to know the shape of the Earth. We're not claiming that it's like some disk in space or something like that. Like you might have seen some pictures or something of like a flat disk in space, right? That's just propaganda, bullshit, nonsense that no flat earthers are claiming. Right? We're not claiming to know the shape of the Earth. We're testing the Earth. When we test the Earth, You can't find any curvature. And then when we look to the globe side, we're like, all right, well, prove, who in all of history measured the curvature of the Earth? Validated there's such a thing as a geometric horizon, right? Validated there's drop over distance. And you look into it, you're not going to find anything, right? You're going to find calculations based off assumptions. That's what you'll find.
You found calculations based on flat Earth measurements.
Yeah, that too.
Yeah, it's a very interesting argument, mate. But we're not going to bore you unless you want the answers to the questions. But for all intents and purposes, the Earth is measured flat. The globe comes after flat Earth measurements.
My back. I'm listening. I'm just half awake still, to be honest. I'm not trying to be disrespectful or anything. I just because I don't. We have satellites and shit, and we have dudes who've been up to space. So I just find it weird. There's any uncertainty at all as the thing because we can literally see. Also, I can't even post. I can't post
you have
the
to
image.
Get to level,
I have an image.
You have to get to level 3. Hold on, look, you said something before about the Blue Origin and the Virgin Galactic. I just wanted to really quickly touch on. Right, so you probably know who the astrophysicist Neil deGrasse Tyson is, right? He's a globe earther, obviously. He's a scientist. Everyone knows who he is, right? He came out after those trips and he said he did the calculations. Sorry.
The globe earther.
Yeah, he's a globe earther. He believes the Earth is a globe, but he even says, right, you wouldn't be able to see the curvature of the Earth from that height. So there was also a trained astronaut on the Blue Origin flight, right? Went up to 350,000 feet, and she said she was disappointed she didn't get to see the curvature of the Earth. Apparently, they didn't go high enough. Yeah, you can't see the curvature of the Earth from these heights that quote-unquote civilians can get to, right? You can go up on a plane, right? You're not going to see any curvature from a plane.
You can in the Pearl Land too. We usually have some of the more. Where's the? I gotta put it in the general chat. Let's see if I have a chat. I don't know why these voice chats, side chats, are gay. I won't let me put anything in there, image wise. There's the Pearl Land 2
be in the server for. You have to be in the server for. You have to get up past level 3 and post images.
Oh, fuck. Okay.
Just let me look.
Basically,
you can post a plane or something like that if you want, but you need to know what type of camera they're using, what type of lens they're using, and then you need to learn how lenses work. Right? Because you'll find in most of these cases, through a plane window, for example, you've got curved glass, thick, round, curved glass. So you've got to take that into consideration, and then you've got to take the camera lens into consideration. Right, so a camera lens, right, any type of wide-angle camera lens will distort straight lines. So it could look like there's curvature, but usually in this footage, you'll see as the camera pans around, right, what looks like curvature will distort, right? And if the camera pans enough, you'll see the curvature curving the wrong way, right? It'll go from concave to convex to straight. And that's just a product of most camera lenses. So yeah, it's not proof of Earth curvature, because when you send up a camera, right, like a rectilinear lens, right, that's a type of lens that basically eliminates distortion of straight lines as mostly eliminates that distortion, right? So when we send up a camera on a weather balloon to 120,000 feet, we can't see any curvature at all. Flat.
My internet's bad. Give me a minute. Oh, fuck. Hello? Hello?
Oh.
My internet dropped. Hello? Can you hear me?
Hey, man.
So, Rando, you are back. What we're doing? What's going on?
I don't know. I'm trying to fix my current phone thingy. It should be fine. I was gonna show you guys Erland 2 glider. It's a pretty cool glider. They fly it over this mountain range in South America. There's a constant updraft, and they use this uplifting air, this warm rising air off the mountains to get up to like 100,000 feet. It's one of the highest flying gliders ever. It's really cool to see. And they have pictures here. If you look up, it's PERLAN space 2. It's one of the coolest like civilian things because you can actually go and take rides on it too. At least they have for a little while for like funding stuff. Where you could go take a glider right up to the edge of space. It is really cool. And flying at 90,000 feet in a glider, or just riding off of like the rising air currents, is really neat. But you can see up at 90,000 feet, you can see the roundness of things pretty directly.
Did you hear One second, Rando. Did you hear everything I just said to you? I'm going to go about the lenses, right? About Neil deGrasse Tyson, about the astronaut on the Virgin Galactic from 350,000 feet that said she couldn't see the curvature of the Earth. She was disappointed. Right, Neil deGrasse Tyson coming out after that saying he did the calculations. You wouldn't be able to see the curvature of the Earth from 350,000 feet. And then I was explaining how camera lenses work and what type of lens is being used is very important and what wide-angle lenses do. Straight lines, two lines in general.
Where's the paper for that or the news article for that? Because there's pictures where you can see the roundness with the Virgin Galactic ride.
Again, it's going to depend on the lenses that you use. So it's like you're not listening to what's being said. So would you say that we can make predictions based on mathematical and geometric principles? Like how much curvature we should see based on the distance and the size of the object we're looking at? Based on those mathematical things, we have to go further than 1,000 miles above the surface of the Earth to see the curvature of the Earth. We're not high enough to see the curvature of the Earth. The curvature of the Earth that we think that we see is produced primarily through the lenses that we use, GoPro cameras. There have been multiple observations of curvature, multiple observations of horizontal, in some instances both at the same time. So mathematically, geometrically, we're not high enough. Everything else is just lenses.
I don't think that's...
It's mathematical and geometric principles I'm talking about. You don't agree with math?
Well, you can just see pictures, though.
Sorry?
Virgin Galactic sells not pictures, sells rides. Trying to see, it's like, I don't really think that there's much...
Rando, with the Virgin Galactic, right? If you go through the video, you'll see the horizon. It looks like it's curved, right? And then as soon as the camera pans a little bit, all of a sudden the Earth will be curving the wrong way, right? I've got screenshots of it. Post one in the side chat. You'll see it's drastically Earth curving the wrong way, right? Because of the lens.
Because we have dudes that fly around the Earth.
Fly around the Earth.
Yeah,
so
like F-72.
Yeah, you brought up the glider earlier, and I was sitting here just smiling to myself because everything from this point is just going to prove a flat Earth, even when you said gaining altitude. So you understand that airplanes fly horizontally, right? With the pitch of the nose about 1 to 3 degrees above that horizontal to maintain horizontal flight at speed. So airplanes work, right? They fly horizontally, don't they?
Yeah.
Yeah. So they fly horizontally, maintaining altitude which is parallel to the surface below. So if the plane is flying horizontal, what's the surface below?
Well, you fly a fixed distance because of air traffic control. If you're flying at 10,000 feet, and then all of a sudden you try to fly at like 11,000 or 12,000, you're going to get in trouble.
Okay.
You're supposed to try and maintain a certain distance from the ground.
I'll ask you again because you're not answering the question.
What?
If the aircraft is flying horizontal, maintaining altitude and parallel with the surface below, what is the surface below? Is it horizontal or is it curved?
You're not when you fly, you don't go AGL for your altitude though.
Altitude.
You go medium sea level for
sea level. So if the aircraft is flying at 500 miles an hour for 2 hours, maintaining horizontal and parallel to the surface below at say 10,000 feet, what is the surface below? Is it horizontal or is it curved?
You can take a string and put it on a pin and have it go around a circle if it's...
That's lovely. I'm talking about an aircraft which is maintaining horizontal flight, which is parallel to the surface below. What's the surface below if the aircraft is flying horizontal?
The way you're doing it, that doesn't work because your relative distance to the average sea level is not something that changes because the relative sea level is relative to the center of the Earth. So you could draw to the center of the Earth.
Relative sea level is the horizontal frame of reference that we get elevation, altitude, and depth from. So we're talking about above the surface of the Earth. If the aircraft is flying parallel to the surface below and maintaining horizontal flight with pitch above horizontal at speed, what is the surface below? Is it horizontal or is it curved? You have to remember this. If the surface of the Earth was curved and the aircraft was maintaining horizontal, its altitude would change with increasing distance. The surface of the Earth, because it was curved, would diverge away with distance from that horizontal line. So what's the surface below the horizontal flying aircraft? It's interesting you don't want to answer. It's a very simple question.
No, it should be still curved. The thing is, you can't use that to decide because the distance, the elevation is still it's referencing relative to the center of the Earth going outward. Because you can't use, I can show you pictures, but I can't do
32,000 feet. Is that above the surface of, the core of the Earth, is it? That's above the surface, means being that
to the center of the planet. You could draw outward a line from the center of a circle, and then have the plane go around the circle and make another circle around the first circle. And the elevation or the distance between the two circles could be the same all the way around. You know what I mean? I know what you're trying to say, but the way you're looking at it's wrong. You can't use elevation as a way to exclude, because you could have them be at two relative, you can have the same relative distance at various points. Like a sphere around X point. because the elevations, all elevation comes off of a distance from the center of the Earth, because everything stands off the absolute core, and it goes out, and then there's like the sea level, which is what we all use for industry and this and that. But if you could still have a fixed elevation and go around a sphere. You could have a sphere that is formed like 1 inch away from another sphere around it. You know, you basically just put a circle around the circle, and then you have the same distance or elevation from the first circle be the same all the way around.
Do you understand what a tangent is?
Tangent? Isn't that a math thing? What does that have to do with this?
Because the tangents are horizontal planes that meet the surface of a curve at one point. What I'm trying to describe to you is this problem. Something that is horizontal, that's supposed to be maintaining its distance above a surface, and that surface that is curved. The aircraft is taking the horizontal plane. The surface of the Earth is the curved thing below it. It's a geometric claim. Aircraft's navigation doesn't work like this. Aircrafts maintain altitude whilst flying horizontally. A certain distance above mean sea level, that's water. Water being the horizontal reference datum. Remember we were talking about the horizon earlier? Yeah, the plane of the horizon, mean sea level. So maintaining that horizontal with the horizontal surface below. The surface of the Earth is horizontal. We practically use it as such. There's no curvature involved with the surface of the Earth, dude. If there was, then the aircraft would have to change in pitch to rotate around the surface of that curve, like you would describe when you had your pen in your bit of string. It would have to rotate like the hands on a clock, 360 degrees, if it was to complete a circumference. That change in pitch is not measured in any device within the aircraft. The aircraft maintains horizontal, parallel to the surface below, which is horizontal.
They use altimeters to get elevation, and then you do corrections off of that.
It's no corrections. What you're talking about, the correction would be a change of pitch.
If you're going fast enough, you can.
If you're going faster,
the MiG-31s, I think it was.
Increase the rate of pitch correction.
Yeah, there are certain places.
Yeah, because you're moving faster over a surface, it's going to move faster beneath you, and the curve is going to be more if you do not change your pitch. It's a problem. You're not helping yourself there.
No, there is more of a there are certain planes that could theoretically punch themselves into orbit if they didn't. If it wasn't for the fact that dollars damage.
You want to orbit again, which is a change in pitch, 360 degrees rotation around the center point that you drew with a string. Pitch data proves that aircrafts and things in the sky don't do this motion.
There's altitude corrections.
Yeah, altitude being height above mean sea level. Mean sea level being the horizontal reference frame. Horizontal water. Water's horizontal, dude.
You could see, in the International Space Station in low gravity, if you have water droplets, they make spheres, they don't make flat discs.
Then, not in the vacuum of space. When you turn on the TV and watch them do things with CGI and augmented reality. That's not what happened.
You don't believe in the International Space Station?
No, I don't believe in the vacuum of space. And that you can do things in the vacuum of space. Because the vacuum of space cannot be real. It breaks fundamental laws of nature. Nature wouldn't operate in the way that it does if there was a vacuum up there. I don't want
just before you move forward on that topic, I just wanted to point out the screenshot that I said I was going to take in the side chat for you, Rando, just so you can see. Right, the Earth looks like it's curving the wrong way. This proves that wide-angle lens. Right, so just have a look at that photo. I'll hand it back over to Jedi. He's doing awesome. But just wanted to point that out.
Somebody else should talk to him maybe about space. I've spoken for too long. unless he's got a question about it, that somebody else can answer it for a bit before I get annoyed that he's not getting it and have to take him to school about it, and then his brain will melt. Yeah, the vacuum space isn't real, Sunshine. We can tell you why if you want.
But we have like laser spectrometers, and there's nothing there we'd be able to detect. We wouldn't detect anything in the gaps, or we would detect things in the gaps.
Sorry. We?
NASA, the various universities, the various science institutions, the various laser labs all across the world.
So not you.
What?
So not we, not you, they. They have, you haven't. Not we. You understand? It's English. You speak English, right?
Yeah.
They have, you haven't. Okay. Are you a critical thinker?
I guess. I just these dudes always brain dead because they're just bored on the internet.
Yeah. I don't know, dude. Maybe you need to understand this when you're more awake and sprightly instead of falling asleep.
No, the reason why gas acts the way it does and why most things act the way they do is because matter gets attracted to matter, then it gets scrunched down.
No, it's not true.
It's a gas in space.
It's not true.
You can drop an apple or whatever. The idea that matter is intrinsically drawn to itself should be pretty straightforward. That's why things kind of stick together in clusters.
Okay. Do you understand the second law of thermodynamics?
I don't remember what the laws of thermodynamics are off the top of my hand. All I know is you can't reach one state without transitioning between every state in between, like temperature or form-wise, like the Plato thing or the different.
You
can't increase from 0 degrees, so they're going through 0 to 1 to 99 to whatever. I'm not saying all the numbers, but I know how thermodynamics works as the gist, but I don't remember like those specific specific rules. What is this?
You understand you understand what entropy is, right?
Yeah, everything seeks to balance.
Yeah. Energy spreads out over time. Now, understanding this very simple law of nature, we understand that the available space, the vacuum space, can't exist from our uncontained thermodynamic system. To have the thermodynamic system that we have, we must have a fixed volume. Fixed being contained. One reason for that is the gas is here. The gas is under pressure. Gas requires physical containment to achieve pressure. Pressure is defined within the word press. It needs to press by the collisions with the walls of its container dependent on the amount of substance and energy within that system. No container, no pressure. Gas doesn't act in the way that you just said it did, where all things clump together. Gas has the power of indefinite expansion, has infinite degrees of motion. It can travel in any direction. Pardon?
It still will try to expand because the particles bounce around freely, but they still fall towards other particles.
No falling. Right, gases have no directional bias when you say fall. Gases act like this. They travel constant, random, straight line motion. The randomness comes in with the physical interactions, the collisions it has with other gas molecules, physical bodies, the walls of its container. That's pressure collisions. Without the container, no pressure. The gas will continue to expand into an available volume.
You don't need a container for pressure. Like if you go to the ocean, the floor, there's like you're not in a cup, you're in just a giant puddle, right? And if you go above even a giant ocean.
Hello, dude. I'm taking my time, speaking slowly because I want you to understand this. I know you're talking about at the bottom of the sea. We're talking about gas behavior. Its power of indefinite expansion, 360 degrees, omnidirectionally, expansion. Right? Energy doesn't have any directional bias apart from following the laws of entropy. A change over time where the system would try to equilibrate with its surrounding environment. Heat, for example, would dissipate over time unless there's no more energy put into the system. Gas pressure moves into lower pressure environments because of the amount of collisions in one space compared to another. The amount of volume that the gas can fill, the gas will fill it. Laws of entropy, dude. These are expressed in experimental validated formula. Boyle's law, Avogadro's law, Gay-Lussac's law. The experiments that give us the ideal gas equation, PV equals nRT. P and V being the amount of substance in the defined volume. The P being the pressure, the collisions on that container, defined by the volume, the amount of space. No volume, no container, no pressure. The gas continues to expand. It's the law of nature. So to have a vacuum up there that isn't contained from our atmosphere, we wouldn't be here having this lovely conversation right now. We wouldn't exist. We wouldn't form gas pressure. The gas would have fucked off.
So what do you think is the container then?
I don't know what the container is, but it must be physical.
Because we've flown rockets to space.
Yeah, I appreciate that that's what they've done.
And we have
done this, but what they claim to have done violates laws of nature. They may as well at this point say that they've been through a wardrobe and visited Narnia and spoken to a lion. They can give you pictures of a wardrobe, they can give you pictures of a talking lion, and you would buy it. When you compare the story to laws of nature, you understand the story can't be true.
So you don't believe that anything is in space, not the satellites, not space station, not SpaceX, or the Stux, or the different missiles things, or...
I get you. So we will agree there are things in the sky, but when you say things in space, that invokes that law of nature. So no, space isn't a thing for these things to be in, but they're in the sky.
And you no longer have to be afraid of asteroids crashing into your house.
Yeah. If there were gases throughout the entirety of the void of space, you would see asteroids streak across the everything. Because the asteroids receive friction from it being shot like rubbing gas.
Don't make up stuff. He already told you space doesn't exist the way you think, so stop making it up. You're just making it up as you go along, hoping that something will stick.
No, you can't just ignore the fact that the void of space is a thing and that we have the International Space Station. To say it's just all fake. And you can see live streams from it. Like, I don't... It's just... I don't even know what to...
Alright.
Dude.
You say, sorry, man. You say they're live streams. How do you know they're live streams?
Because it's on YouTube. You want to see them?
Because it's on YouTube. Is it because it says that it's a live stream with a little red box with the word live written in it? And you can talk to these people at this time and it's live. Does that mean that they're where they say they are? Just because it's live on YouTube?
You can look up and see the space station going through this. I have seen it as like a little observatory out in the middle of nowhere, Ohio. I remember looking at all the International Space Station flying by. It's possible on clear nights, so you can actually see it in the space, zipping by. A little tin can full of man, zooming through the stars. It's pretty dope.
I get it. I asked you earlier if you were a critical thinker, right? And this isn't critical thinking, what you're doing. Trying to lay this down for you as simply as you can, right? You're getting told this information and then pointing up to something in the sky, and because they're correlating, you're believing it. Now, we've done these things for like the last 70, 80, nearly 100 years now with televisual entertainment, magic tricks done on TV screens, right? David Copperfield being one of these types of people. This is what that is. You're just buying this information, saying that we've done it, even though it's not we, it's they, and you're trusting what they are saying. But the claim that they're making can't be true. Yes, they've got a stage show for you to believe in. We've tried to point out that even from the height of the International Space Station, using math and geometry, we know and we've been told that these things aren't high enough above the surface of the Earth to perceive curvature. Mathematically and geometrically speaking, you have to be more than 1,000 miles away. International Space Station, 250 miles above the surface of the Earth? A quarter of the way to that distance. You can see curvature, you can see a horizontal horizon based on the curvature of the lens. We've pointed this out to you too. So we're trying to get you to critically think about what you've been told. If you were doing critical thinking about it, you'd understand that it's a story that you can't verify for yourself. It's a story that fundamentally can't be true because of the laws of nature that apply.
You guys say that the void of space isn't real, and the International Space Station's fake. And then when I brought up the bottom of the ocean having more pressure than the top, just as our atmosphere does, without a container, it was the same thing.
Sorry, the water has the atmosphere above it. The atmosphere is pressing down on the water, but the gas is pressing in all directions. It's also going to be pressing upwards, going in that direction too. The way that we have this pressure, the gas pressing against an area, the water, is by having physical containment. If you didn't have this pressure, if there was no gas above the water would change state and turn to gas. It would bubble away. You need the pressure to have the water. You need a container to have the pressure. If you don't have a container, you're not going to have any pressure in the gas or in the water because the water wouldn't exist. There's water.
The container is just the gravity well.
No, the gravity well is a mathematical reification, a bending of space and time, a coordinate system, the passage of time over three-dimensional space, said to distort and warp because of the displacement of mass. This is a mathematical concept based upon a reification. It's not scientific.
You don't believe in gravity?
You don't believe in gravity?
What the? This is the fun of, because none of this seems to. Every time I go to make a rebuttal, that's always, instead of like, it feels like you just say no, that's just not real. And I'm like, this isn't how. That's not how science works. Like, you can see videos in space where when the liquid droplets go, they make little spheres. That's an example of a gravity well in and of itself. It's the self-formed containers, self-formed pressure wells. It stacks. The centers will have more pressure than the outsides because weight from gravity and the weirdness that is. As for seeing the lenses to excuse the roundness of the Earth, we still have trajectory from different, not even just satellites, but like the SR-72 flight paths and this and that. They go in like 5,000 miles an hour in the upper atmosphere. There are dudes that have been around the world in less than a day. Unironically, I don't. Like, I understand maybe trying to see, like, is this world a simulation? Or what about some sort of... Like, there's a lot of weird theories out there that are, like, fun to mess with. But this is one I never understood of the flat Earth thing, because, like, there's a lot of strange properties to things like different parallel dimensions, and how if matter is energy, then does this energy have different frequencies? Is that how the different, like, theoretical dimensions are stacked on top of each other? And they're messing with a lot of that quantum stuff now, but I don't really even know. When it comes to this, it's like we can literally just look up and see examples of things. I don't, this isn't like a theoretical thing to me. I think it's kind of neat that people like to do this. It seems like it's kind of fun to argue and this and that and bicker over things. I sometimes wonder if this is just like a way for people just to talk about things. It seems that to be the actual case.
Someone help him.
Yeah, man. Look, all you've done is appeal to NASA, basically, right? And if you look into NASA, right, there's countless amounts of obvious fakery being caught using harnesses, zero-G flights, hairspray, green screens, augmented reality, right? There's countless amounts of this obvious fakery, right? You probably haven't looked into it, which is fine. But if you look into it, I promise you, right, there's a lot of stuff being posted in the side chat at the moment. But yeah, we can share videos with you if you do actually want to look into it, right? You're just blindly believing, right? We're trying to tell you about things here on Earth, right? Empirical, practical demonstrations that you can actually go and repeat yourself. Right? This isn't something that is faith-based, like you're telling to NASA. NASA's the government. You know the government lies. It's no surprise. You need to look into the evidence of fakery. You need to watch the documentaries made during the moon landings were ridiculously faked. Look at the footage. Use your common sense.
You don't believe he went to the moon?
I'm guessing you haven't looked into it.
Wasn't listening about the space part either.
Hold on. Okay, because this is getting crazy. You don't believe in space? You think that everything in space was faked? You believe that the Russians and the American governments both lied about having the ability to go into space at all?
The head of the Russian space agency said that NASA faked the moon landing. Literally. He was the vice president of Russia, too. If you look at the footage, it's obviously faked. It looks ridiculous, dude. Right? The lunar lander literally looks like it's like some paper mache project made with curtain rods and gold foil. It's absolutely laughable, dude.
EJ, listen, I started noticing this trend. When the moon landing becomes fake to them and space doesn't exist, they immediately go to the Russians. What is that all about?
Yeah, because the Russian government never lies. Oh, fuck. Hold on. The thing is, we still have the lunar treks on air. I'm trying to find better photos. I still have the...
No, dude.
No more better photos. There's no such thing. I have up-close shots of the moon. No tracks on it.
No, they still... today, lunar orbit...
Yeah, look...
that kind of shit ain't going to make it happen and make it be real. That's for sure.
What, seeing literal footprints on the moon will make you believe men were there?
Not seeing footprints. What the fuck kind of camera do you have?
They sent things to go and orbit the moon with special cameras.
Oh my god. So now in order to see the footprints, we have to send something up to the moon to take pictures of a place we can't go to.
If you're willing to just
show you that. What?
If all you think is that all evidence that counteracts your points is just fake, then there's no way to actually have a scientific argument over this at all.
It's not science. It's Hollywood.
You were claiming the Richard Branson Virgin Galactic shows the curvature. Then I showed you a screenshot showing the Earth curving the wrong way. Right? Everything that you've brought up has had like really good rebuttals to it. Right? Proving that it isn't what you're claiming. Like we can show you proof that they're faking footage from the ISS as well.
Yeah, I sent a whole ton of pictures, animations, or the animated GIFs, and you can see all kinds. That's all space station shenanigans, which is just done in a studio, green screen. I have a green screen. I've done one of these similar. It was live streamed and is probably caught by YouTube, but I don't remember how long ago it was. Years ago.
And to answer that, I'm not sure if Fries is he actually in there? It's probably ablative shielding. They have heat shields on a lot of things in those different space shuttle themajigs.
Bro, why would it be rainbow pew-pews, man?
Because it looks pretty. No, I'm just joking. It's bits of metal and coating being blown away.
Stop. You're just making up shit.
No, there's actual, like, if you ever look at that. You can see it's the different bits of plasma, potentially bits of metal, and blade of shielding. It looks like a grinder going off. Pew, pew, pew.
Amazing. Isn't it just amazing?
The Earth is a triangle. What the Shanaz? Hello, Shanaz.
Hey, Rando, guess what NASA said, right? They interviewed a NASA astronaut, Don Pettit, and they asked him, how come NASA hasn't gone back to the moon in over 50 years? And he said, oh, I'd go back to the moon in a nanosecond. But we destroyed that technology, and it would be a painful process to build it back.
It just costs too much money.
No. He said, we destroyed that technology. Right? And you need to remember they went there with the computing power of a first generation Nintendo Game Boy. And they asked different astronauts, did you see stars when you were in space? Some of them said, no, I don't remember ever seeing a star. It's like the blackest void you could ever imagine. It's terrifying. And then other ones said, oh, you can see all the stars so much better than you can see them on Earth. You can see all the nebulas and galaxies, and it's amazing. Right? And there's a compilation of them asking all different astronauts this question, and they all like contradict each other like crazy.
You know, there's this black paint that doesn't reflect light, that it's really hard to be. If you paint a room, you would go nuts if you went inside the room and didn't have windows on it. It's easy to paint a screen and make a studio so that you have perfect black sky at all times in your shots. They don't put stars in.
This goes from being a flat Earth thing to being a NASA is fake thing very quickly.
Oh,
yeah, everyone appealing to NASA.
It goes from Earth not having any curve, right, to make a ball. It goes from that to it's flat because it's not a ball. You jumped into space, not us.
Okay.
Jedi has put some great videos in the side chat. You should save them and watch them if you want to sometime. It goes over all the footage that we're talking about in detail. It points everything out.
Bubbles in space. Houston.
Yeah, dude. If you look, right, so okay, NASA has mock-up ISS in a giant pool. It's one of the biggest pools in the world. Right, they say they use it for their training, but this pool also has big giant green screens that fold down around the edges. Right, if you look at NASA's spacewalk footage, countless amounts of their footage shows blatant bubbles floating around. They weren't able to remove all the bubbles, or they messed up, or something like that. Right, so there's all this footage of like bubbles in space, which is impossible to have a bubble in space. The list goes on and on and on, man. Once you stack up all the evidence, it makes it very hard to trust NASA.
Okay.
It does sound. It all sounds crazy when you first look into it, but if you do take the time to look into it, crazy at all. It's makes the outer space claims seem crazy once you look into it.
You're saying you don't believe in space and NASA?
We're saying that a lot of the evidence that we're given, right, from space is blatantly faked. Okay, and then Jedi went over why you can't scientifically have a vacuum next to a gas pressure system without a barrier.
Up in a space station in the sky.
Yeah, look, dude, when you see the space station transit the moon, it looks the same size, right? When you zoom in, you see the space station transit the moon. When you look at a plane, it looks the same size. It just looks a little bit smaller, right? Like couldn't be 250 miles away, right? No, think about it, right? The moon is the same size in each of the shots, right? The moon's the same size in the frame, and a plane is roughly the plane is like a big jumbo jet is almost as big as the ISS.
Do you know why the eclipse happens?
Yeah, at 25 minutes after the hour, I went ahead and posted for you the set of when they painted up the moon for the moon landing, the camera shots. There's the set they used, There's a design picture of it, and then there's the photographs of them doing it, and the one guy is actually painting the moon for you. So if you want to go ahead and explain why, that would be good. Go ahead.
I don't know what they're doing.
It's an artist rendering of the set that they're going to shoot. That's the camera track that rolls across the stage they had back then. You just a little dolly, it puts it on, so it always repeats itself. And then the photos of the set being built and the guy painting the moon. Now, is that clear?
Okay. Airplane transit. The airplane wouldn't cast a shadow on the moon. I don't know where they got that picture from.
No, that's a silhouette that you're seeing, right? You're just seeing a little object, right? They're saying that that's the airplane transiting the moon, right? Not a shadow. You're seeing the airplane. And then on the left one, you're seeing the ISS. Okay, the ISS is roughly the same angular size as an airplane. Big giant jumbo jet. Tiny bit bigger. Okay? But the ISS is 35 times further away. Why are they appearing the same size? It's almost as if the ISS isn't as far away as what they're telling us, right? Or the size that they're telling.
I think the ISS is huge. I'm pretty sure the ISS is like a pretty big.
No. You can look up the size.
What is it even? 73 meters? 64 meters? Is that actually?
Look, dude, hold on. The ISS is roughly the size of a football field, right? If you look at a Boeing 747 jumbo jet, it's just a little tiny bit smaller. Yeah, they're roughly the same size, right? When I was asking ChatGPT actually about this, right, and it said for them to both appear the same size like this, the ISS would have to be 1.3 miles wide, would appear the same size as a jumbo jet at the distance that they tell us that the ISS is. You just have to think about it logically. Like when the jumbo jet is just 6 or 7 miles away, it's so small you can hardly see it. Right? The ISS is roughly the same size, but it's 35 times further away. Imagine if the jumbo jet was even twice as far away. You wouldn't see it at all.
Spazzing out in text chat about the C-19 stuff. So he's not even paying attention. He's typing in chat about X. Hey, there he goes. He's just typing poison, this and that. He's going crazy.
No, they're talking about poisoning political people.
Oh, that's me. I'm the one going on.
Derailing Fry. Kick your ass, bro.
I'll just remove Fry if he wants to keep going on.
He's the one who started with the off topic.
Okay, that's it. We're going to stay focused so this guy understands. I posted a shot of the set for the moon landing, for the camera, it says right on it, the approach scene or whatever it is. That's what it looks like when you're approaching the moon. That's the shot for that. There's three different. There's a close-up, there's a moon round one, and then there's a long one for the long going around the moon shot. It's all there for you, and it's done in a time lapse. Real slow. Click, move the camera, do something. Click, all that. That's how you do that.
I don't know where that's from, but
I told you where it's from.
Are you going to answer why you believe the Earth is a ball? Or you want to answer you have the last one? What the fuck? Okay.
For our YouTube listeners, this is what it sounds like when you're going into Cogdis, where you found out the truth about something, but you want to hold the belief of the other now. So now you have hold two beliefs at the same time or whatever.
Everyone that satellites aren't real. International Space Station isn't real.
No, that one made your brain melt. That one absolutely put you over the edge.
We have satellite phones. It's literally retarded. Like, there's certain points of things where it's like you can't just say, "Oh, everything's magically not real." That just proves my point. You can't. That's not how arguments work. This doesn't. Because the Russians have been to space too.
I'll show you the satellites you're so worried about. Let me post them for you. I'll show you a launch and a crash.
What?
Yeah, look, man, we haven't even spoken about satellites or made claims about them. Nobody's denying satellites. We're just not claiming satellites in space, right? Obviously, they have technology up in the sky. NASA's first satellite was a big giant balloon. NASA has a giant satellite balloon program. They're the world's largest consumer of helium, own most of the large helium companies, right? And they probably have a lot more technology that we don't quite understand. This is the government. Same people that own the military. Obviously.
Yeah, Randall, you sound like American. Everybody has seen a satellite. Like, remember the Chinese satellite that they had to shoot down? We all have seen satellites. Nobody's denying it.
All right, I posted for you. Did you see that? The two pictures I posted for you? One is the launch, one's successful. The other one is a launch that failed and it crashed back onto the ground. Those take pictures of the ground. What do you think about that?
What?
Oh my God.
They hit the ground? They were lifting something up in a crane and they dropped it.
Occasionally satellites crash to the Earth, right? When they do, there's always a balloon attached to them.
Always.
Footage of always, yep.
Okay. Why? Is it like a safety thing?
That's how they're held up in the air. Helium.
Look, bro, you also need to remember, right, that 99% of all communications are done via undersea cables. Coaxial, big giant cables, right, that go under the oceans. That's what the internet runs on. It's not like satellites are claimed to be running the internet and all this kind of thing.
So you
Well, you still have phone lines on your house. If satellite was running everything, you wouldn't need a phone line on your house coming from the little pole in the backyard, or you know what I'm saying, bro? Come on now, use your brain. Just use it.
Well, it's not even you have a coaxial cable to get the TV and internet. You gotta have that cable.
You don't need that if it's all in wireless, brother. All you need is a box in your house and shoot me the moon. Shoot me my internet.
All right, so back to the rando. So now what do you got about satellites? Since we showed you how they're actually done, what else do you want us to show you now that you're lost in a rabbit hole of truth?
You think that all satellites are just held up purely by balloons?
I just said that thing takes a picture. Beep, beep, beep. You can pick them up with a ham radio.
You can even send your own little square satellite up there with a camera on it. Little bitty cereal box satellite with a balloon up to about, I don't know, airplane height or more maybe. But that's about it. That ain't no space.
Yeah, I remember just before Radwin gets back into it with him. I remember searching it on the internet, like how many satellites are launched every day, and then it was saying that the weather, like the national weather, they send up about 2,000 satellites every single day worldwide. Like somehow they're all friends around the world, worldwide, to get the weather. Right? So they send up these little balloon satellites every single day, 2,000 of them.
That's their helium use.
Yeah, it's because they come down. They have planes that catch those things. They have catch planes. I used to have pictures of them. I'll find them. There's a video of it.
Yeah.
How they catch them right in the air and reel them in like a fishing line right into the back end. What they got to do, grab a couple of them and they bring them down. And they get new balloons and they're relaunched. And they go, it's just a big cycle of launches over and over again. Some of them stay up for a month at a time. It got balance inside that add helium or let stuff out to raise it and lower it.
What do you think about the satellite's flight paths around the Earth?
I just told you they can control that.
Because they have a map so they don't collide, and there's crisscrosses. Because around.
They control that. There's flight paths for them.
Yeah, there's. I was gonna say that's the flight path patterns would show the globe.
You ever seen the flight path of the ISS, the supposed ISS? It's the most perfect
before
line.
we go derailing, I'm going to give them a flight path of a satellite. Go ahead and tell me what that flight path is around the ball.
It's a circle.
That's a circle? Are you even looking? It's Sirius XM satellite radio. Oh, now we're done with satellites. What else you got?
So wait, this is all being like recorded or live streamed somewhere?
You're famous.
No.
Flat earthers as we talk. People are listening to you and becoming flat earthers because now they realize what they sound like.
They realize the error of their ways, and a satellite won't help them connect.
No, all communication is done through undersea cables. They only give you that 1% for hope because if you want anything to be successful, you're going to connect with a cable.
Oh, yeah. 100% successful for the most part.
As long as the power's there and the servers stay up and switches, you're good, you're golden. And they don't have a tendency to just go down. And the internet is so redundant, you would never notice it anyway. You only notice it when your neighborhood switch is rebooted and all that shit, or the cable company is sending out router patches and things get slow for an hour, that kind of shit. That's the only time you notice it. All wired together.
That's kind of cool. So we have a live stream from. How much of a delay is there?
What? Live stream?
Apparently, this is on. I see it on YouTube. Look it up on YouTube. Oh.
Yeah, it's probably just a few seconds behind.
Yeah, it's like 10 seconds ish. Alright, that's enough of that. I was just doing. There wasn't that many people watching.
Yeah, it's shadow banned, right? All of the true flat Earth information on YouTube is shadow banned, right? So it doesn't come up in people's recommended feeds and all that sort of thing. And if you type the exact name of it into the search engine, you'll find the channel, but you won't find the names of exact like videos. It'll just come up with like a playlist of propaganda videos. So YouTube. Right, flat Earth, back in 2015, 2016, it was becoming one of the most popular search terms on all of YouTube. And then at one point, it even overtook Donald Trump during the elections. Right, and then what happened was YouTube got together with Congress, right? There's a video of them in Congress, right? And they admitted that they're going to censor flat Earth. Shadow ban, basically.
Was that because they got annoyed with this, what they thought were trolls, or because like you guys actually had points? Like, is there any of this that's actually controlled information?
Why would you ban something you call nonsense like aliens and Narnia? So you mean to tell me that all the kids and all the everybody on YouTube is talking anything just anything they want that's not like just the ultimate proven truth, right? Just gets banned? Is that what you're saying? That's what we need to do? Ban everything on the internet.
What? No.
That's what the government needs to do. Ban everything you like to talk about on the internet. Just don't talk about anything because we think it's a lie. Is that what they're supposed to do?
Well, there's things like they consider a lot of things. If you're undermining the credibility of the United States government, they will censor you, especially if you're
undermining the credibility. What does that mean exactly?
Sounds like a slave sheep talking.
If the this is how geopolitics work. Like, if you actually start something, you start getting enough anti-American sentiment going on the world stage, no matter what you are or why. Whether it be like anti-NASA or anti-anything, like you can be anti-China. If you start getting enough like presence out there, like anti-Putin or anti-whatever, people will start to come after you. Like if you're an influencer, if you have certain bits of information. I actually was curious because like if you get declared like a psyop or a misinformation campaign, or if you get declared, because you can basically be treated as a terrorist under by certain nations for simply going against their leadership.
Dude, so if you challenge the mainstream science, you can get shadow banned. Doesn't that sound like a big load of bullshit to you? Isn't the whole point of science to challenge science?
Yeah, it's kind of a problem when people are trying to silence things. I'm for free speech in this and that. I was just saying that's kind of fundamental reminder schedules.
Yeah, it is like kind of ironic, Rando. It's like if you Google what's the scientific proof that the Earth is a spinning sphere, they'll say, "Listen, we're going to demote you because what you're saying is false." But they won't put forward any scientific proof, right? They'll say, "No, you're done for asking for the proof. That's get out of here."
What evidence do you have that they've tried to restrict the flat Earth movement? Though that'd be interesting.
Well, he just said it. There is a short clip where they're in front of Congress and they're saying, "Listen, how are we going to deal with this flat Earth, content on the internet that's taking off?" And then she responds, "Well, we're gonna deprioritize it. We're going to put little tags on it, and then that'll go into the algorithm that'll then deprioritize it." And he said, "Well, what is that going to look like?" He said, "Well, when anybody says the Earth is flat, we say, nope, not true, and then put it to the depths of the internet, and nobody will be able to find it." And he said, "Okay, great, sounds good. Let's get that in motion."
I have a quick question. This was just explained to you, and then you asked the question, and it was explained to you again. Do you get it this time, or do you need it explained one more time? It was just explained to you. Real life example: Congress censoring flat Earth. You can look it up for yourself. and then you asked the question about it, and it was reiterated to you. Do you need it a fourth time?
It's right there in the box in your YouTube search underneath any flat Earth content. Flat Earth is an archaic conception. It gives you a warning tag. There's your censorship. Tells you what to think. This is untrue, it's flat Earth. I have to remind you.
Not only did they shadow ban it, they replaced the search results with a playlist of propaganda. Right? So you type in flat Earth and you get a whole bunch of pictures of discs in space, straw man arguments, and absolute bullshit that no flat earthers actually claim.
Well, what
Why would they do that?
That's what I was saying is the ironic part. Like, so when it says, it gives you that claim, it says an archaic, scientifically disproven concept, right? You would say, okay, great, you must have the scientific proof then. But they say, no, I don't, but don't ask. Because that's scientifically disproven.
So what were you just asking, Rando?
Yeah, what was that question?
Do you guys have proof that the Earth is flat? If that's what you're trying to...
Yeah. That's what we were telling you at the beginning. The Earth is measured to lay horizontal. Horizontal being an orientation. 90 degrees perpendicular to vertical, up and down. So horizontal and up and down.
Just so we're clear, sorry to interrupt, Jedi. It happened again. We just rinsed and repeated, went in a big circle, right back to what we already explained to him. This is crazy. Proceed. Sorry.
No, that was my bad. I touched back on it. He was just asking, where's the proof now?
It's measured that way. I'm trying to tell you. It's this simple, right? If you want to figure out an orientation, you measure it. Now, orientation is just as I described, right? Things that are relative to horizontal, up and down, kicking a ball at 45 degrees and then it coming back down, that angular measurement, how we navigate across the surface of the Earth using angular measurements, how we make maps using angular measurements. You have to understand that the measurements that we use determine that the surface of the Earth is horizontal. That's why we can use angles to measure it. An angle being the intersection of two straight sides that deviate from a point measured in degrees, 45 degrees, 90 degrees. That type of shit. So when we measure the Earth, we can practically measure the Earth in a straight line distance of 6,000 miles when navigating using the stars. It's a horizontal straight line distance. So for all practical purposes, when we measure the Earth, it's measured and practically used as a horizontal stationary plane. The stars, sun and moon moving above, and all measurements and references to the horizontal plane of the Earth. That 0 point is mean sea level, with elevation, altitude, and depth taken from. So it's measured flat.
What is the only shape without an edge?
Flat, not a shape.
Well, the thing is there has to be an edge somewhere if it's flat, right?
If it's a ball, there's got to be an edge.
Yeah, I mean it's a legit question like that people asked like a long time ago, like like what's his name, like the story of Columbus, right? He's saying, well, listen, I'm looking out there on the ocean, and it looks like it just ends right there. That must be like the edge, right? And then he went there, and he said, well, now there's another edge. Now there's another edge. There must be an edge. So they did give you an edge. They said, well, listen, the edge, that thing that you're seeing out there, Columbus, that's the edge of the Earth. Because the Earth's a globe. So he was saying, listen, that's the edge because the Earth's a globe. So meaning that below that horizon that he was seeing and chasing, that the water drops away from that line of sight, and that's what he thought the edge was. But flat's not a shape with an edge.
What in the hell?
Yeah, so we're not claiming to know the entirety of the Earth. Right, that's the basis of it. When we test the Earth, it can't be a globe. because we can't find any curvature, we can't find a geometric horizon, and we can see magnitudes further than you would be able to see on a globe. We have the evidence to show you, right? Tons and tons of evidence. Most people don't seem to want to see it for some reason.
No, Rando was saying he wanted to see. He said he wanted to see. And what's this edge? That's required.
No, he didn't say he wanted to see the evidence. He was asking how could there possibly not be an edge? How?
That's very edgy of you, bro.
Yeah, that would probably be the make or break with the flat Earth thing. Is there has to be an edge if it's not a sphere, because the only shape that I can think of that doesn't have an edge is a sphere. And so,
right.
Then how would you
Hold on a
know
second.
it's a sphere?
One at a time. One at a time. There you go.
Yeah, so look, we don't know if there's an edge or not. Right? You can't freely explore. You can't freely travel beyond 60 degrees south parallel due to the Antarctic Treaty that was created in the 50s.
Oh, edge of the Earth, right, so, even in the flat Earth?
Yeah, so we don't... You're still probably trying to picture the Earth as an object in outer space, which is the heliocentric model of outer space. We're not claiming that. It's incompatible with the globe model. Right? So an infinite plane, I'm not claiming it is an infinite plane, but an infinite plane doesn't have an edge. Okay, so we don't claim that. We don't claim to know exactly what it is. It could have an edge for all we know, but we don't know that.
That's very edgy,
right?
bro.
We try to stick with empirical evidence and what we can actually test here on Earth. Because we don't want to make baseless claims, because that's what the globe side does.
Yeah, Rando, if you want to get wild, man, shut up, dude. What's wrong? If you want,
what do you mean? I'm just listening. What are you talking about?
All right, go ahead and listen. But yeah, Rando, I mean, it's a little bit of like a mixed question. Like, where's the edge of what? Like, so the flat is not a shape, right? So it'd be like a horizontal line is flat, right? So now if you have two horizontal lines that are parallel to each other, right? You say, well, where's the edge of these two parallel lines? Like, where do they end, right? So geometrically, they don't end, right? So but you're kind of mixing it in with, an object known in its entirety.
So it's like an event horizon at the end of the.
You're such a loud listener. Go ahead.
That's what I said. It's like an event horizon. That's what you're describing. Correct. There's no edge to it. It continues to like.
Oh. We don't know. Yeah, we just don't know that. It's an unknown.
Unknown.
Like a D20.
Yeah. Look, if I applied the same line of questioning to the universe, it's like, okay, so. No, where's the edge of the universe? Right? What's outside of the universe? What's underneath the universe? Like all of these questions, you would have to say we don't know, right? Because that's the true answer. You can't go there, right? You don't know. Here on Earth, we don't know.
We see the farthest away thing, like, oh, that's the current edge of the universe.
Well, stick to the Earth thing, right? So they got somebody asked that question a long time ago, like these old guys in the 1000s, whatever, right? And they came up with not you, loud listener, and then they came up, Rando, with the idea that the edge, that horizon, is caused by the Earth being a sphere. So that means that the Earth, they said, well, listen, because it has an edge, like a horizon, that means it's an object, and we know it in its entirety. So they claim that they could find the total size of all of Earth using the horizon. So the horizon would never change in distance, because then that would mean that the size of the Earth, quote unquote, would be changing. So the horizon is what they claimed was the edge.
That's what I said, the event horizon.
No, this is just the water. Yeah, it's just the water on a boat.
But it would be considered an event horizon as well. You can only see as far as your perspective allows you on water level, on sea level.
So can you test that, Rando? Can you test the edge of the Earth, the horizon, to see if it's at a set distance to then extrapolate and calculate that we live on a globe?
You could use landmarks to tell you about the distance from the horizon line.
No edging. No.
Hold on a second, Rando. That's the perfect question, right? To lead into this evidence. I'm just putting in the side chat. Radwin beat me to it. Yeah, I'm going to post this particular one. Right, just under.
But I can't see side chat.
Well, that's okay. Just chuck yourself on mute, right, and listen. Or try to access the side chat somehow.
But
It's the middle part.
No. So you have to go on mute, right? If you can't see the side chat, you're not part of this particular point.
He should be able to
Rando,
see
can you? Yeah, look, you were just talking about distance markers, right? So that's what we have here. Right? This is a long distance observation off the coast of California, Santa Barbara. Okay, so the video below is in high definition, but the GIF above it is just a clip out of the video. Right, so I'll just explain this observation. Okay, so he's 8 foot off the surface of the water with his camera, and he's zooming out, right? And you can see the horizon. Okay, so if the oil platforms weren't there, we would not know the distance to that horizon, right? Luckily, we have the oil platforms, and you can check the distances from the shoreline to those particular oil platforms. And the second oil platform, the right, it's called Platform Habitat, and it is 10.1 miles away from the shoreline. And check that on Google Maps or anything like that. Okay, so we can validate that the horizon is beyond the oil platforms. Okay, so now we have to do the math, right? If the Earth's a globe with a radius of 3,959 miles, how far away should the horizon be? How far away would the horizon have to be, basically, right? That distance on a globe is 3.46 miles. That's where the horizon should be if the Earth's a globe. Everything on that horizon has to start being hidden behind the horizon.
Or
because it's like a physical...
Like, is there do they show the equation how they got 3.46 miles?
Yeah. So the equation is 1.225 times the square root of the observer's height in feet. Make it easy. They have these things called Earth curve calculators. Right, so I'm just going to post the Earth curve calculator in the side chat. So if you click into that and you put in 8 feet as the observer height, it will tell you the distance to the horizon. And it does show you the math and everything on the site, right? There's different formulas that you can use, but they'll all come up with the same answer in the end, right? So 3.46 miles from 8-foot observer height. That's the distance. Okay, so obviously there is no horizon at 3.46 miles. On globe, there would have to be a physical horizon line at that distance. Right, this is just one of countless amounts of these types of observations.
I don't think the calculation though, because
you can. What's that? Sorry.
This doesn't seem right because you can see a lot farther than that. It isn't like I don't know how they got. It's not showing me how they got it. I can't see the equations on here. I just got the website.
Yeah, look, I can show you different ways of calculating it. Right, using pi or using different types of formulas. You can double check it on ChatGPT. Is good at basic math like this, right? It will give you the same answer. But yeah, I can show you Washington University Earth curvature calculations, right? It matches up as well.
Yeah, I mean,
it's based on the radius. Yeah, it's based on the radius value of 3,959 miles. It depends on your height. Right? The height of the observer. So the horizon would be at a different distance depending on how high you are off the ground.
Yeah, like the 1.225. That's all. That's all. I mean, it's claimed to be based on the known radius, right? Like extrapolated calculation
from the
circumference. Yeah.
If you go to like a beach, I think we should be able to. Cause I don't think these are. That doesn't even sound right.
He's at the beach. That guy. That's where he is.
Hold on. Well, that's the thing is like the math here isn't working out because I don't know how they got this. I did the college algebra, but I don't know.
Math doesn't work out because the Earth is flat.
Well, it doesn't know what the true answer is. Like they should probably have someone.
Here's the easiest equation that you can use. Right, 8 inches per mile squared.
You know, we can't see that far due to like visibility, but so it works within what is the number, DJ? Like 1,000 miles, but we can't see 1,000 miles ever. So
yes.
Horizon
The geometry.
If you go to Earth,
that's all it is. It's just math and geometry. Based on these mathematical and geometric principles, it makes a prediction based on the size of the ball you're standing on, your observer height, and where your tangent from your eyes would intersect that curve at distance. That calculation is 1.225 multiplied by the square root of the observer's height in feet, but we do not observe that geometric prediction. We see a horizon well in extent of this distance, depending on the optic that you use, like binoculars, cameras, telescopes, whether it's in or out of the visible spectrum, so infrared, for example, and the atmospheric or meteorological conditions of the day. If there's a lot of heat and density, water vapor in the atmosphere compared to a clear, crisp day, it's colder. And all variables in between. But the horizon's just an optical phenomena based on those factors. It's not the curvature of the Earth. It's described and used as horizontal, measured as such. No curvature here.
yeah, the Earth curve calculator thing on what you should expect, that all begs the question. That's just like, all right, let's skip all the steps on how we would establish like a straight line in reality and all these other things. Just skip all that. Let's go to the Pythagorean theorem formula and apply it to the horizon and test it. So, like on the Earth curve calculator websites, typically you can scroll down and see whatever method they're using to whatever mathematical formula they're using to you if you want to check it. But it's all based on
computer
like a known radius. Well, they're saying, listen, I got a radius of a circle. Let's test it.
Yeah, let's test the circle on the computer screen. Yep, a circle's a circle on the computer screen. Checks out. But then what about the horizontal water that's always horizontal? Oh, in reality, Earth doesn't comport. It doesn't conform to a sphere at all. Water just doesn't do that.
What do you think, Rand? Do you think the math is wrong or the radius is wrong? What do you think?
Well, the only thing is that I don't know how to take into account the height of the object you're looking at. Because it has your height, but it doesn't have the height of the target. You know what I mean? So
that's when. Sorry,
let me explain that to you quickly. Oh, sorry, Jedi. We got some lag.
Yeah, no,
go ahead, man.
No, it's just the when you go to the calculator, it'll give you a target distance. It will give you the target height that should be obstructed because of the distance and the height of the object. The prediction is it will make this amount of that object disappear. So yeah, the height of the object is in question as well. So we're told in this that an amount of stuff should be obstructed because of the curvature. It's the prediction within the model. We're pointing out that horizon, that obstruction isn't where it should be. More often than not, it's behind the object that we're talking about.
Yeah, it's not, well, it does take into account of what should be hidden. It's to the surface of the water. Like it's from the height to the surface of the water. And then you can say, well, the reason boats disappear bottom up is because the surface of the water is higher than the bottom of the boat. And then you can get the object in there if you want.
So at 10 miles away, the obscured object part would be 28 feet.
Yeah, you're noticing the prediction, right? That prediction we don't observe.
The prediction you don't observe?
Yeah. So the curvature of the Earth blocking things at distance. So if we're going to make this mathematical principle apply to this, it makes a prediction of the distance to the horizon, the thing that's obstructing the things at distance, whether that be the boat or the building on the mountain. Now, That's a physical hump between you and the thing that you're observing on the same surface. If we use that prediction, we don't find that physical geometric horizon. The horizon moves depending on the optics that are involved in the conditions of the day and the observer's eye height. That's why it's in the formula. So the observation that was posted shows a horizon beyond the distance markers. The horizon should be in front of the distance markers if it was the curvature of the Earth. It's not. It's beyond that distance at a safe estimation of more than 10 miles. Should be at 3.5 miles. It's at more than 10.
I don't see where to put in the height of the object, though.
We're not interested in the height of the object. We're interested in the distances to the object.
But the height would also affect, because you would see part of it being blocked.
Yes, 1.22 times the square root of the observer's height. Yeah.
Sorry, blocked by what?
The water. It would look like if you saw a man 10 miles out at sea, like you might not see his shoes or something over the horizon line. Like it would be like you see his legs, but you can't see down a bit. You know what I mean?
So what we're pointing out is that horizon where the surface appears to meet the sky is beyond the objects that it should be obstructing.
Which is a problem.
Mm-hmm.
That is kind of odd. I don't know if the equation's wrong. You guys are saying it's because the Earth isn't, but you can still see that there's roundness. Like you're calculating the horizon line, which means that you're
just calculating a slope.
You don't see any roundness, right? All you see is flatness, right? But you can double check the math on any Earth curve calculator. I can give you multiple formulas. Double check it on ChatGPT if you want to, right? It will all give you the same answer.
Like you have an equation using pi, which is insinuating a roundness. Do you guys have an equation then, a theoretical equation for the flat Earth of what your horizon line should be, and then you can compare the graph?
Same thing. So pi doesn't invoke sphere; it invokes a circle. That circle being the observer at the central point of that circle. The horizon being the limitation of view of that circle around them. So that all measurements take place on that horizontal plane that is within the observer's circle of vision.
But it's not going off of your radius of vision. It's going off of your percentage of the view of target due to interruption from the ground. It would be there's I'm not even sure what function would play a role there, but I don't think pi would play a function if it wasn't a rounded. Like there would, if you want to make a horizon line equation for a flat Earth, because you're saying that the equation doesn't make sense because of what you have.
Times the square root of the observer's height in feet.
What?
1.2 times the square root of the observer's height in feet. Distance from an observer to the observed horizon in general normal atmospheric conditions.
Does that fit what you guys are seeing with the video?
Yeah, that's as far as the human eye can see. You can see further if you improve the optic, binoculars, high-powered zoom camera, telescope, because you can change the size of the aperture. You can have more resolvable angles. You can see further into the distance. The horizon isn't the curvature of the Earth. It's limited by optics.
Yep. Yeah, it's just a small angle, 1.22 optically, the smallest angle where you can until something merges.
Human eye has an angular resolution limit of 0.02 based on this and the surface that we're looking at based on the height of eye is where you mathematically end up.
Interesting.
Also, so Rando, one second, sorry to cut. I just wanted to read out the horizon definition. So this is what horizon actually is. It has absolutely nothing to do with a globe. It's the line in which the Earth's surface and the sky appear to meet. Right? A horizon is just an apparent location right? It fluctuates due to different temperature gradients, different weather conditions. It's not at a set distance. Globe, you have to have a geometric horizon at a set distance based on the height of the observer. That's what we can't find. That's what we can't validate. And that's what these demonstrations are rebutting, right? That's what we would ask you to validate after this. It's like, okay, we can't find the geometric horizon. Right? We can see magnitudes further than you would be able to see. What evidence do you have that such a thing exists? Because it has to exist if the Earth is a globe of the claimed size. It has to.
Well, the Earth isn't a perfect sphere, too. I do remember it's actually wider at the sides, the equator, than it is at the.
Get it?
Yeah, you got to have a curved surface to have that. So far we don't have that.
Even whatever. The water is deeper at the equator because of the way it's spun and slung that way. The water is deeper at the equator than it is at the North and South poles. Yeah. That's one of the reasons why Alaska's rising relative to sea level, and all these little like Caribbean and like Southeast Asian countries are sinking, is because the Earth's spinning, and then there's the water gets slung to the side due to centripetal force, and then the equator gets more water, and the North and South poles gets less water, so the weight goes from being all up on the North and South poles as ice, and all that weight's getting slung to the sides to the equator line.
Yeah. Look, we understand that. We understand that. You need to think of the grand scale of the Earth. You need to think of the scale of the Earth, right? And the images that. Who's talking?
Don't know, man. It's just.
You need to think of the scale of the Earth, right? And the images that NASA shows you, right? Of the apparently that's the Earth from space, right? Have a look in the side chat. Right? That's one of NASA's images right there. Okay, so on a grand scale, it's a negligible difference because of the oblateness of the Earth, right? So you don't have to take it into consideration when you're doing the Earth curvature measurements, right? And it's certainly not going to allow you to see 10, 20 times further than you should be able to.
If you don't believe that the water is deeper at the equator due to centripetal force, so why do you guys believe why do you guys think the water is deeper at the equator?
Deeper.
In South Pole.
Deeper. So even when you say deeper, right, that's with regards to a horizontal frame of reference. Deeper than the surface of mean sea level.
Yeah, the water gets later.
Sorry, and again, I sat here and I smiled because when you started rambling just a moment ago, it was like you were comforting yourself with the story that you had been told. I imagined that. We get that you're going to try and fight this position. But what we're telling you is we measured the surface of the Earth to be horizontal, not curving. There's not an example that you can give us where we don't measure that.
Well, you could go purely off of how the weight's being redistributed. Like, why would the equators, why would there be all this sea level rise relative to land rise at the equator versus the land rising to the water level in like Alaska, North Russia, the northern bits and the very southern bits? Like, I don't know if South Africa's far enough south. I don't know about the South Pole, to be honest. I haven't read about their stuff, but I know Alaska, the land's rising there. The different tectonic plate distortions are interesting to view. Because it doesn't really, I don't think it would make sense to have, I don't know how you would even, like, there's a lot of weirdness to that to try and see it from any other besides a sphere, you know what I'm saying? So I'm curious, if you don't believe it is a sphere, then how would you guys think that all works?
Explain.
I have a quick question, bro. You know what? Water finds its level, right? It's used in construction, like a whole bunch of applications in life, like across the board. But you're telling me right now that at the equator, the water is higher than at other parts of the world, of the so-called globe, right? doesn't that break this water finds its level thing? The fact that water has a level, like, you know, mean sea level. Are you saying that there is no level actually? That the water isn't in line with each other?
Sea level exists because it's not a sea level. Water is not always perfectly flat. No, there's a reason why there's averaging in all of that. That and just to take the plates.
That's because there's multiple stations.
Huh?
There's multiple locations where they measure it, but surely between two locations it would be level.
Well, the reason
do you have a measurement of the water being diagonal, like being lopsided?
Yeah, I have to pull up the things. It's because the way the Earth spins. That's why it gets more water slung to the sides. So you'll get more water at the equator than you will at the northern and southern bits, because there's still those kind of. It's a lot of forces at work, but
No, I didn't ask you what the cause is. I understand you're supposed to cause, right? Centrifugal force at the equator, blah 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 blah. I'm asking, do you have a measurement showing water being diagonal?
what do you mean diagonal?
Well, the level of water being different from one point to the next, meaning it's not a straight line; it's diagonal.
You could see how they calculate the mean sea level. The reason why we use the term MSL is because it's not all the same.
Measurement, not calculation, man. Measurements.
What?
Stick with me. I'm asking for a measurement showing that the level of water is it's not level with each other. That's basically what you're saying. You're saying the depth of water, the amount of water at the equator is different than other parts. I'm asking you for a measurement showing.
The equatorial bulge. That's the term.
Don't just repeat oh my goodness.
I was doing.
So you have no evidence.
In here for future.
Orlando, it's kind of like you made a claim. No big deal. You said, okay, the water is higher at the equator than at another point. So surely you've measured, right? Like somebody measured that. That's all.
Yeah.
So what's the measurement?
You should be able to show a pile of water.
Yeah, if you don't know, just say you don't know. That's fine.
I don't really know. MSL, which means sea level, calculate the average sea level at a specific location for a long period of time, usually data from a tide gauge, averaging over a 19-year cycle to account for seasonal variations and lunar gravitational effects.
Yeah, but this wouldn't be tides. This would be centrifugal force, so it would be always higher at the equator than somewhere else. So there must be a measurement of that, not tides.
Are you talking about? Wait, what are we measuring? Because the guy was asking about MSL and how we get that. I was pulling that up with the tide gauge data. What are you guys even asking for?
I believe No Tanks kind of like summarized it very concisely. Thank you, No Tanks. Yeah, just you said that the water at the equator is higher. So where's the measurement showing that?
Okay.
I live close to the equator, and we have 0 degrees mean sea level in relation to everyone else. So I don't know what he's talking about.
It's the equatorial bulge. Hold on.
So what about higher? Is it not sea level? At the equator, or at this bulge you claim?
Water appears deeper at the equator line due to the equatorial bulge, which is a slight bulge of the Earth's surface caused by the planet's rotation, resulting in higher sea levels at the equator compared to the poles. Essentially, the centrifugal force of Earth's spin pushes water outwards, creating a higher sea level along the equator.
Yeah, we know the claim.
The explanation,
right? Now we're asking you to prove that the claim matches reality. That's where we're at now. We already understood the claim. We've heard it before. Now we're looking for evidence to prove that it's nothing more than just a story or a claim, a baseless claim. Do you have any proof that that is actually something in reality?
The most direct thing would be sea level rise at the equator versus sea level shrinking towards the north and south poles as the ice caps melt. More and more water is getting slung farther and farther and farther towards the equator, because as the amount of water goes up,
You're just making shit up, and I can't take it anymore. You're just making things up.
There's Wikipedia articles on the equatorial bulge and how the water level is distorting. Alaska's rising relative to sea level because the weight's being taken off its tectonic plate. And like there's countries Caribbean that are having a lot of sea level rise because they're close to the equator, and the water gets slung there and it's deeper there, so they see a lot more of the weight.
Okay, so that's a Wikipedia answer from someone you don't know or haven't validated. Do you have a real world example of someone measuring this bulge change from 0 degrees at the equator?
There's multiple countries having a crisis over water rise.
So you don't have a direct, real world example of someone measuring this bulge.
I literally there's a bunch of countries that having. Remember anyone ever seeing on the TV or any like? There's a bunch of countries, even Florida, somewhat has issues with water rise. New Orleans is technically underwater, but they have weird pumps and like dams and things they use to keep it somehow not drowned out.
They're below. Yeah, they're below mean sea level. So maybe then, just go back to Jedi's methodology for measuring depth and elevation. Maybe just go back to that. Like you're saying, it's deeper in reference to what?
Deeper in it'd be above or below the MSL. Like you have an average sea level,
but that is the level. So you're saying that the water, in reference to the water, is deeper than the water. That wouldn't make sense, right?
It does. It's a mean. It's an average. It's like an average person. It's an average person height. You have people above and below that. There'll be average sea height or depth, and there'll be sea depths below or above that.
Yeah, mean sea level being the 0 point, the zero horizontal reference to all perpendicular verticals. So mean sea level. You're talking about rise.
Compare it to the people. Sorry, Jen. I thought
he's talking about rise above this mean horizontal average. Okay, it's still measured from horizontal.
How do you have sea level on the sphere?
People's height is a false analogy because people are distinct from each other. There's right.
So now we're talking about people's height. Okay, cool.
Well, it's still a thing. If we have the equatorial bulge and we see it being more, it's for climate change or whatever you want to call it. You could see the sea level rise is more drastic in places at the equator than elsewhere.
Okay, Rando, look, let's just grant you that. Okay, we'll grant you that because it doesn't really matter because it doesn't change magnitudes we can see further than you would be able to see on a globe. It doesn't help you find your geometric horizon at all, right? It doesn't really matter. It doesn't really matter though.
A lot of the different calculations are good because trying to work on the horizon line stuff, that's pretty interesting. I don't really know how to. I don't really mess with that too much. You're saying you only get 3 miles to the horizon line, but I think I can see farther than that normally. So I don't know if that equation's wrong, or maybe I'm just not. I never really measured. I don't know.
That's the cool part, man. It was once you kind of start to analyze the information, okay, we're on a globe, so this is what should occur, and then you start to say, well, let me compare that to my life, and you start to realize I do see the sun move in the sky. Okay. I don't feel like I'm ever moving, and I don't ever, I go back to my house. It didn't change locations. Okay. I can see pretty far. 3 miles isn't that far. I've seen things further at different heights. And then you're like, okay, well then what's the proof of this globe? Everything you're naming works out okay with the guys in here who are saying, those things aren't true, that it's just stationary, motionless, and we measure, things that are higher or lower than something, we measure it in reference to a straight horizontal, distance. That all makes sense. So yeah, you snap out of it kind of a little bit, and you say, no, it makes more sense that it's not a globe, but somehow it's still a globe.
It's so horizontal, it's somehow a ball somewhere, but not anywhere. But it's got to be a ball out there, but not anywhere you can test and measure anywhere. So you can even go out there with 100 of your friends, and none of you can find any curved water from each other. One of you are not going to drop below the other. Ever.
Yeah, now even if you're going to measure like a globe, or you're going to measure a curve of some sort within your area, you're still going to need to have a reference. Like so you're going to have some kind of tool or methodology to establish like a horizontal reference, so that you can then measure the drop or rise from that. Like rise
I'd
over
get
run,
100.
slope.
You know those guys in Italy, no tanks, that they when they go to work, they throw that little square on the water and they take the stick and they push themselves to work on their briefcase.
Okay.
Okay. Well, you get 100 dudes lined up on their briefcase that are all 6 foot tall, and then when one of the guys starts being 1 inch or anything lower than the other guy in front of him, which would have to happen on the ball, one of these guys physically has to drop below you right in front of you. It just has to happen. And if it doesn't happen from the first guy on the left to the last guy on the right, then where in the hell is bendy curb and water? Like, you should be able to stand on it and touch it, especially if people are like building rails and bridges that match that attribute. So if they match that shape, the curve, but then they can't find it, that's like a double speak. Well, these guys are building this thing to the arc curve of the earth. Well, if that's the case, then it's that easy to find and you can see it right there, and that should be what it is each time, no matter what, everywhere. Should match that very thing. So guys get on that very thing, the bridge, and they say, well, this bridge matches the curve of the, and the guys are going up above each other and down below each other, then yeah, that would be a curve. Not of Earth, of the bridge. Now Earth should do the same thing when you're on the water. So go put these same gentlemen on the lake, side view, front view. Somebody got to drop below somebody.
Yeah, I mean, Rando could test that. You know, he could test, or maybe he can go into the horizon again with DJ. I don't know where he thinks the proof is. If it's in measuring, or if it's in looking at the horizon. But Rando already said he sees further than the globe. So,
Rando, on top of these long distance observations, we have countless amounts of long distance laser tests, right? Where people get a very expensive, high powered laser and they set it up on the surface of a large body of water. And then they shoot the laser across the water to a target on the other side of the body of water. Right? Some of these tests have been conducted by teams of field engineers, PhDs, right? People that know what they're doing. Right? And the laser has been hitting the target. Right? All different locations, different weather conditions, different spectrum lasers. Right? The team of field engineers used a $30,000 laser. I think they did 17 different tests. But yeah, the lasers should have hundreds of feet of Earth curvature obstructing them from being able to reach the target. Yeah, on top of the countless amounts of long-distance observations, there's also laser tests.
yeah, that was good actually, DJ.
Yeah.
That brings both in there. That's now we got horizon and measurement.
Yep. Yeah, good video that Tanks just put in the side chat.
Another thing is like all the different perspectives you're probably not even thinking about. So all Globers, or the idea you ever get put in your head is, we're standing on the beach. Well, imagine your buddy's on the beach, and now you're the guy on the boat that's dropping down below, I don't know, 60-foot curve of water below it. Now, if you were dropping down a 60-foot curve of dirt replaced by the water, or you replace the water with dirt, and you're on a boat down that way, 60 foot below your buddy, and he's looking and can't see you now, what do you think you're going to look back and see? Do you think you're going to look back and see the beach, your buddy? No. You're going to look back at a big ass 60-foot wall of water. When does that happen? When does a person on a boat turn around and see a 60-foot hump of water in front of them, just rising up? When's that happen? About 10 foot. So you being the guy that supposedly goes down that 10-foot hump of water, when you look back, how come you're not seeing a 10-foot hump of water? That doesn't make any sense. That wouldn't make any sense at all. Because if you went down the hill in my backyard and turned around, you're gonna be looking at the hill. I could paint one side blue and one side red for you. Show you what I'm talking about.
You get a hill in your backyard, bro?
Hell yeah.
What do you use it for?
Observations of stuff behind it. And I can never see the stuff behind it. I can't refract it. I can't retract it. I can't zoom in back and bring it back. Not even beyond the first point that it disappears from my eye. So I look with my eye and see the thing go down below the hill. Now I zoom in and zoom in and zoom in and zoom in and zoom in all day. I can never see the toy below the hill again, ever. Because it's below the dirt. And in the other case, it would be water. So what people fail to recognize is they don't have a side view. A side view would be me seeing the guy, which would be your friend, and then you and the hump of water between you two. And you below said hump of water and him up on top said hump of water. Kind of. That's what a side view would be. And then from your view, you'd see the water. And then from his view, he'd see you disappeared. You see, all these perspectives are supposed to match. So he's supposed to see you disappeared. You're supposed to see a hump of water. And me, the third guy on the side, is supposed to see you down below a horizontal line of reference on that hump of water, below the hump of water. Below a horizontal line that I just draw on my screen or put on it's just on the screen. But that never happens. No one ever drops below a horizontal line. No one on a boat ever turns around and says, look, man, I'm poking this 10-inch, 5-foot, 10-foot, 20-foot high wall of water. Can't poke my stick in it. It just doesn't exist. It does not exist. Water does not stack up on hills, in hills. It just doesn't. I mean, that's the most absurd, ridiculous thing to think about in the world. A hill of water in front of you. You're going to go climb it? How do you climb water?
But D-Mog, the Earth is just so big. That's why it's all flat.
It's so big you can't climb the water hill and you can't see it when you turn around? There it is.
No, the water hill actually doesn't exist because Earth is so big, but it actually exists. Do you understand? Like the curvature doesn't really. The curvature isn't really observable, but there is curvature. It isn't really measurable, but
that sounds like a religion. It sounds like they have a belief that there's curvature, but they can't measure it, prove it, or find it physically anyway.
That's conspiracy theory.
A curve is a conspiracy theory. I agree. Where's that curve? Where's that conspiracy curve at?
No, to claim that there is no curve, that is conspiracy theory.
Oh, I thought claiming there was a curve.
You can't trust your senses, you know? Your senses are not enough. The Earth is spinning. I mean, the Earth is staying still, but it's just because it's an illusion to your senses. The Earth is actually spinning at 1,600 kilometers per hour, but you can't trust your senses. Therefore, it's just an illusion that you're standing still.
So if I take off running, I don't have to worry about the tree. I just don't pay because my senses are wrong. I just keep running, and I'll go through the. Okay.
Like when you watch TV, when you watch TV, you just eat a spoon of fluoride because don't trust your senses, and also trust everything you see on TV. Makes sense, right?
Do they have fluoride flavored ice cream?
But actually, nothing makes sense since senses cannot be trusted. Therefore, yeah, don't trust your senses. Therefore, globe.
I watched ODD TV. Should I not trust that now? I think you guys scared away the newbie.
What?
The guy, the kid.
What kid?
Exactly.
Do you watch Odd TV? I'd scratch that off my list.
I've seen it before. He's all right.
I'm just being funny because it's ODD. You down with ODD? Yeah, you know me. That's what he should have came out with, but he didn't. That was kind of crazy. But
yeah,
then,
he's like a rapper here.
Right, but I find it funny, the names of the things. FED for the feds, right? FED.
Yeah.
Feds.
Yeah, no.
And then you got ODD, DOD, Department of Defense. What the fuck is up with these boys picking these weird 3-letter, like, come on, man, pick something better. God damn it.
I'm sure they saw that when they did FED. They're like, "Oh, this would be funny," because it's like we're policing this. Yeah.
Well, my question would be, how would a senseless generation look like that denies their senses?
People that believe in they're on a ball. People that believe in space, and planets, and
exactly.
moon,
But how would that generation like act in general terms? You know, how would they look like? How would they think about themselves?
You're talking to them on here every day. All the dudes you talk to about a globe, that's how they would act and look like.
Like the dudes that come in here and just talk about sexualized things. You mean that one, or are they on the lowest end?
No, they're definitely trusting. They're following their senses too, man. They're maybe even more so.
Whoa, way more so, huh?
Like people who come in here and say flat earthers are just dumb, so and so, don't want to say the words, and then just add like the N word to it. Like these kind of sensible people.
Those are the good. I thought those were the good globers. Those aren't the good globers. Those are the bad globers. Okay.
Oh, that's the bad globers. Okay, who are the good globers? The one that, I don't know, just
the ones that just deny reality only, right?
Okay.
They're like, no, man, it's got to be a ball. It just has to be, and that's just where they stand. And then, like the guys, come on, man, can't we all just sniff globe roses and look at globe unicorns?
Do you think that the good globers would ever like argument against the, or like help, or like wanting to stand against the one people who are obviously degenerates?
They throw everybody under the bus. Anybody who doesn't agree with that individual glober will be thrown under the bus by that glober. And he's right, and he holds all the keys and the secrets that nobody else has because somebody told them to him somehow. And it's the same for each individual glober.
Although they just cherry-pick the people.
Well, they've all got their own math. They've all got their own idea of what a ball is, but couldn't draw it. They've all got their own idea on how planes do whatever. They've all got their own idea on speeds, tangent, just everything. I mean, if you actually... And then not one of them has ever got a ball and demonstrated it. They've got their ideas on Foucault's and pendulums and Cavendishes, and they've all got ideas about stuff. But none of it exists or conforms with a spherical moving object. Not even the scale at your house.
But imagine this, right? They say they have a functioning model, right? Like, or let's say you have like a model that you put on your desk or a globe, right? But essentially, what you got to realize, even if it's digital, or if it's analog, right? In order to get a globe, you gotta have a flat map. You slice the flat map up, and then you glue it to a toy ball. Like, that is the irony of it all. The only way you get to a globe is by using the flat Earth. Oh man, it's just so retarded, so stupid.
Well, The irony is we can make spheres. Why are you not printing a sphere on a sphere directly to scale? That's the weirdness. We need an actual sphere that's not wrong in any way, shape, or form at all. To the nth degree, perfect. Distances and everything that match on that ball.
The way you get a sphere, dude, no matter if it's digital, right, or if it's analog, it always requires a flat map to wrap around something. Even if you digitally, like in Blender, if you in Blender want to make a globe, you use a flat map first.
Because the screen is flat and the pictures are flat. It can only come out that way. And then when they make you that sphere, they take all those little flat squares and they pop them together of different sizes until they get what they need around the top. And then once they play, like the screens, it like plays out just like a 360, like the big building. It's like a building. It's like 50 foot tall or something. It's a ball sphere. You get inside of it and you can watch the walls on the inside.
It's like a guy who says, I'm the best baker of making gluten-free cake. I have the best gluten-free cake. And then he's like, okay, let's start making my cake. So first we're going to put some gluten. Oh, I have the best model for Earth. Well, how did you get your model? Well, first you start with a flat map. First you start with flat Earth. The irony. It's just so retarded. Sorry, guys. I mean... golly. I mean, the joke is so on you. If you buy into a ball Earth belief, you absolutely... Anyways, I gotta calm myself down. It's just amazing. The leap of faith. Like, I tell you, Demok, and I tell this to the room, I am amazed by the faith Globers have. I'm truly amazed. Like, when I read stories like, well, like all the hundreds of asteroids brought all the water to Earth, and that's how all the water on Earth got there. You know, this leap of faith. Like, I read the Bible, right? And I think that requires so much less faith than all these crazy stories from left to right about the heliocentric ape monkey fish ball. Like, I'm amazed by the faith Globers have, you know? Really. I really am. I'm way too much of a simple man that I can have the faith they have. Like, you know, distrusting your senses and making up stories and then having faith in those stories. It's amazing. Props to them.
Yeah, there's a guy in the chat that doesn't know that distances are linear, not curved. 1 foot is a straight line, a meter is a straight line, a mile is a straight line. None of it is curved, but they don't know that. They invoke miles per hour and they think it's curved.
Golly.
It's linear distances, man. You need to go back to school.
Like, but you see,
you know who the hat fits on.
You know what's funny? Everything about the ball Earth, right, about heliocentrism, everything leads back to realizing that the Earth is actually a stationary topographical planar surface. The way they got their ball, the elevation angles, whatever, it's just all based on our planar reality. The way they got maps is because Earth is a planar surface. The way they got their globe is because they wrapped a planar grid system map around a ball. And then they sliced it out, stretched it out. You know, they sliced it up so they can, you know, rip it easier.
Yeah, Haber-Stein formula to bend the horizontal lines into a sphere. Yeah.
I mean, it's just the irony, man. It's just comedy. It's pure comedy. And then you have like Longfellow, so
yeah.
even
at our level, it's comical. Yeah, you cannot have a sea level ball. You cannot have level on a ball.
But you can also not have a ball.
If our realm is actually 70% made out of water, or covered with water, 70% is called sea level. It can never turn into a ball.
But see, the irony of it all is this, right? Not even see the point is, in order to have your ball, you gotta have flat Earth. Without flat Earth, you could never have the ball in the first place.
Yeah, cartography. Flat Earth required.
Golly, like, if the Earth weren't flat, you couldn't have a heliocentric code belief system. The very reason because you have heliocentrism and a ball that you could put on your desk is because Earth is flat. I know globalists don't understand this. I know this is like, huh? What is he saying? That doesn't make any sense. Obviously, because you're slow thinking. But again, to get a toy globe or any globe, you gotta have a flat map and wrap it around it. And where's that flat map from? It's from elevation angles, which only work on a planar surface. Longitude, latitude, and meridian lines can only be measured and calculated and referred from in regards to the sky by having a planar topographical surface as a reference area. There is no other way around it. And this is so good. Anyways,
what he's saying is
very simplistic, isn't it?
In order to find the radius or circumference, you need a horizontal line from the radius to the edge of wherever you go with that straight line, and that will become the circumference.
Ding, 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 spot on, man. Exactly.
Circumference of what? Of a circle?
Of the point of a straight line.
Yeah, like if you stay on a latitude, I guess that would be a circle. So, what would that prove?
Well, these guys don't know the difference between 2D and 3D. They think a circle is a sphere.
Right. They think they're going underneath the circle instead of flying around the top of it like a dartboard, where they don't ever go under it. They don't understand. There's only one side of the dartboard that can be touched, boys. You ever seen somebody throw a dart through the dartboard? I don't think so. Oh, they actually think that Eratosthenes measured the sun coming down to hit him in his head. He had to wait. Him and his buddy had to wait in locations, and his buddy, I don't know if his buddy even existed. And then he had to wait in the location, him and his imaginary friend. And then so when he stood under the sun at high noon, he had to wait, you know what I mean, for it to come down and get close to his head so his other buddy could get the angle to it from where he was.
Now they build an obelisk.
Well, because the sun vertically drops. You know what I mean? Because globers think, hey, man, look at that sun. It's vertically dropping down. But then what's it doing when it's high noon and it's right above your head vertically? Has anybody seen it drop down? What kind of ignorance are we like? I don't understand.
Yeah, you cannot have vertical on a sphere. But they don't know that.
I mean, you got 100 observers lined up. The sun's on the middle guy. Well, in between the two middle guys, I'll say, sorry. So you got 100 people lined up. Number 50, the sun's in between them, up there in the sky, right? And they got a stick. Now, when does the sun vertically drop for which guy and get close to his head? Ever? Anywhere? Nowhere? Oh, okay. If the sun's not vertically dropping, then that means the sun is not dropping. It's going that way.
So if you have 70% of a surface leveled, that means that it's spherical. Yeah, imagine the surface of the floor in your house, 70% of it is level. How come people call it spherical? Makes no sense.
Boys are coming up about 20-something% short on your sphere. They only got 20% of a sphere. 27%, boys. That's what you get.
The 30% is what is above sea level. Obviously, there is more land underneath the sea. It's called seabed. It's what is
Well, I
covered
think
with
it's
water.
well, I
Yeah,
think it's
only
weird to know.
30% is exposed above sea level.
Well, I think it's weird to think you know the ratio in the first place. To say this much percent or that much percent, I think that's a joke too.
Obviously.
They don't though.
You never heard that percentages normally are made on the spot?
Hey, it's not true, man. It took a long time to a lot of planning went into my creation.
Yeah, good shot, boys. Good shot. Good to hear. Hey, critical. You got a critical. What's going on? Ooh. Pussies.
So, do you guys think that the universe is flat too?
Bro, with voices like these, like, at least try to hide the fact that you're an obvious glober.
What? No, I'm asking if you guys think the universe is flat. There's actually mathematical equations that might suggest so. That everything exists on a flat plane. It's a question in physics whether or not the universe is a flat plane or not.
Is it weird that I could tell someone is like a glober by their voice?
Yeah, you can.
Like they just have like they're like more nasally. They just have a higher voice on average.
I don't know what shape the Earth is. I don't really care either.
Yeah, man. We don't dabble in pseudoscience.
Oh, okay.
All right, sorry. Go ahead. What was your question, Flat?
Yeah, do you guys think that maybe the universe can also be flat?
Like what about
Define universe?
Yeah.
I guess reality, I guess, would be a better term. Whatever you think all this is.
Yeah. It's.
I think it is. Yeah.
Yeah.
Okay.
If by universe we're saying like the heaven, like that's what we observe in sky, then yeah, I would say it's flat as well. Like a ceiling, flat ceiling over a flat floor.
Yeah. So like a box.
Yeah, kind of. I don't know what the pillars would be, but yeah.
Have a flat understanding.
I know one thing that's not flat.
Oh yeah.
Yeah.
Educate me.
He's gone. I spiraled out yesterday. Heretic in India dismantled every one of his talking points over a couple of hours. He had like a demonic McToon style outburst.
What's that? Good morning, everyone.
Good morning, Leonardo.
How's everyone doing?
Wonderful, thank you. Yourself?
Oh, not bad.
How are you doing is a grammatically incorrect.
I don't know. I kind of had a rough night, I guess. I don't know.
I am doing fine. Fine is a thing that I'm doing.
You're doing fine?
Yes, I am doing fine.
That's good.
Not fine work, not fine things. I'm doing fine.
Like fine work, like you're working on a project, or?
No, I'm just doing fine. Fine alone.
Oh, okay.
See what I mean? It's kind of grammatically like weird, but it's normal for us because we've been desensitized.
Right.
What brings you to the Flat Earth channel, Leonardo?
I've been here before.
So you're a flat earther?
I talked to Krita quite a bit, lately. He's been muted the last times that I've been on here. So
you're already a flat earther?
I mean, I really don't know what to believe, to tell you the truth. Like, I'm not against it. I don't care if it...
That's good. You don't have to believe. You can just accept. Experience reality.
Yeah. I accept whoever's beliefs are their beliefs. That's all that's all that really matters, right?
Well, we're not talking about accepting beliefs here. We're talking about, let's say, for example, you go outside and the ground is obviously not spinning at 1,000 miles an hour. Just accepting it.
Yeah.
Is that a belief?
No, I know. That's what I mean, though. Like, I'm not here for confrontation, or I want to do that, man.
Yeah, I don't want to do it either. I hate all that.
I didn't come here for drama or nothing. I just, it's good to actually talk to people once in a while.
Yeah, no, we just like talking about the nature of reality and the earth.
Yeah.
That's what we're looking for. Not looking for a fight.
Right.
So what do you think about the nature of reality and the earth?
As far as conspiracies?
No, not as far as conspiracies, as far as reality and the earth.
I don't know, man. Like, I honestly believe we're in, what do you call it? Like we all visual stuff in our minds, and
people that think there is no reality and it's just all like you're a brain in a jar type of thing.
Yeah.
Not one of those, are you? Oh no. Okay. Right. Does anyone want to speak to this guy, the brain in a jar guy? I need to jump off for a minute.
Not really much you can do with the brain in the jar. You're already at the bottom. Anything can control you at this point.
I'm not saying a brain in the jar, but I'm saying like an aspiration.
Are you sure you might not be another organ in a jar? Who knows?
No.
Contents are skyrocketing.
All right. Well, I've set someone up, so someone continue the conversation. Try and keep it flat earth.
So if you're a brain in a jar, what do you believe we live on?
I don't have my brain in a jar, dude.
How do you know, bro? How do you know? Honestly.
Jesus.
I know that for a fact.
How? How do you know that you're not a brain in a jar right now and you're just imagining all of it?
I don't know, man. I mean, that's pretty deep, right? Like, I don't know.
I guess anything we present to you, anything we ask you, it's just kind of going to be like that, isn't it? You're going to say you don't know. Oh.
It's not
knows
that, man. I
what
just
the
don't. I didn't. I'm gonna forget.
know.
You know.
No,
You'll
I
never go
know that,
wrong
bro.
if you
But
say you
hey,
don't know when you don't.
what did you want to discuss, Leonardo?
I'm just kind of like, you know, like I know this is flat Earth, right? Like, so I mean, I just have a question though. So if you throw a rock in the water, why does it sink?
Why do you think it sinks? It's probably more dense than the water, right?
Possibly, yeah.
Unless it's like some pumice or something, then maybe it'll float. I don't know. Rocks probably
Yo, I could
float.
throw a rock in the water and.
Or have you ever done rock skipping, where you threw a flat rock on the surface of the water and it skips?
That's not floating.
Yeah. Not floating though. But yeah, a rock will sink, right? Because it's more dense than the water, right? If you switched that water out to liquid mercury or something that's really dense, and it would float. But if you put it in a less dense fluid, then it's going to sink through it.
But how does a rock skip above
We have
the
all
surface
these
of
different
water,
laws
though?
of the universe, all these different physical laws, and it's like if you ask them what causes entropy, right? They're like, oh, it's just a physical law of the universe, or what causes the the laws of conservation of momentum? Oh, it's just law of the universe. But then when you say, hey, law of relative density, they're like, oh, what's a yeah, I
No, I'm saying like if you
Does
take
that
a
make
flat
sense,
rock,
though, Leonardo?
you
Yeah,
take
but
a
you
flat-
understand that a rock sinks through the water because it's more dense than the water.
yeah.
Yeah.
But how does the water skip? How does a rock skip on top of the surface if you were to throw it?
Because you applied force to a rock of a particular shape, right? And because of the shape of the rock, the tension of the water, right? The viscosity of the water is able to bounce off that surface if you throw it on the right angle. It's got nothing to do with the issue. Why things rise.
No,
or
if you
sink.
throw it at a right angle, you're screwed, man. Right angle is too like vertical for it. You need to throw it at like a very acute angle, like maybe like 10 degrees or something.
Yeah, exactly.
Yeah.
Right, they say like if you jump off like a really, really high bridge, it's almost like you're hitting concrete, right? That's why you die.
Yeah.
Unless something breaks the tension of the water before you, or the surface of the water, before you land.
So technically, we don't even have gravity.
You need gravity if you want to have a globe, but in reality,
Oh, we have
things
gravity.
rise or
We don't have
sink.
flat Earth, guys. We have gravity. Gravity is the downward acceleration of heavier things, the upward acceleration of lighter things. We have gravity. It's the effect. Don't let them hijack gravity and say, oh, it's the cause. Gravity's the effect.
You could call it that, yeah. I guess gravity, gravitas. It means heavy, you know.
You guys think that we're like in a bubble, like a big ass bubble?
We don't know what we're in. Like, we just know what we can validate, right? We can validate there's no drop over, like no curvature over distance. We can't detect any motion, and we have gas pressure. So that would require some kind of containment as far as we can demonstrate on a smaller scale.
Like as far as like NASA and stuff like that, I mean it's all fake.
Well, there's a lot of evidence of fakery by NASA, yeah. Countless amounts, to the point where it makes it very difficult to trust anything from them. But then we have the problem with the gas pressure next to a container, entropy, second law of thermodynamics. So yeah, outer space, as we're told, Can't be proven, demonstrated to exist.
So, like, all the satellites and stuff we see in the sky, like, that's all NASA, right?
From like one thing to the next without any pause.
I don't know about the satellites, man. We see things in the sky. We can't validate exactly what we're seeing. If you Google images and type in like satellites in space, you're gonna see just a bunch of cartoons.
Yeah.
Yeah. Not sure exactly what's going on there, but it's interesting, and we don't know for sure. It's not something we can validate.
Well, I mean, like, they were even saying, like, the sun was, like, man-made and the moon was man-made or some shit. You know? Like, the moon doesn't actually exist.
Who said that?
I read it through some sort of documentary. It's based by, like, solar and all that shit. Apparently, like, that's why we're having all these, so-called snowstorms and hurricanes and shit, because the fucking government is literally controlling the whole entire system.
Wow. I have snow today because it's January.
Well, same here.
Oh, so it's not the government, it's because it's January.
But I'm saying, I mean, look out west, look out fucking in Texas and shit. They're getting fucking snowstorms, ice storms.
Oh, it's wintertime.
I'm saying, dude, I know it's wintertime, but Texas, we're talking Texas, okay? We're talking California, we're talking fucking everywhere. Like, everywhere there, like, there never used to be that.
Dude, you're very
I remember
excited.
where I live now. We used to have 5 feet of snow, 10 feet of snow every goddamn winter. And lately, it's just been fucking very cold, and we barely get any snow here and there.
Okay, so this is like, what does that mean? The Earth's a ball because like snow or weather?
Well, what I'm saying, Crit, is there's been it's weird, man. I remember when I was living here back in the 90s, and we used to get a shit ton of blizzards like each and every day, pretty much. You know, and now it's been like 50 below zero, but we barely have any snow on the ground. And then you look at like Arizona, you look at, anywhere else, any other state that has a very warm climate, right? Now they're starting to get snow and shit. Something's going on.
You never ever had snow before?
What?
Never ever had snow before? Shit, I remember it was about 25 years ago. I was in Florida and it was snowing.
Yeah, but it wasn't like having blizzards, right?
Yeah, it was a whiteout. People were pulled over freaking out like crazy people. But because I was from Ohio and drove there, it didn't bother me.
There's a drought too. So you guys factor like, if there's a drought, there's less snow.
Yeah.
Now they're claiming the Stellanian eclipse is now CGI. NASA must do CGI for them in the sky. That's Mark.
Yeah, Mark, that debunking flat Earth, Selenilian eclipse has nothing to do with flat Earth. So you're already fucked up there. The second thing, that doesn't explain why it's upside down. The observation's upside down either.
They always forget that part. Even when I remind and say shadow's upside down, everybody purposely just glosses over it, never says a word about it.
That's what the globe side bathes in ignorance. They gotta get it wrong. Purposely get it wrong.
If we live on a flat Earth, we will have a Selenilian eclipse with an upside down shadow. I see a Selenilian eclipse with an upside down shadow, therefore I live on a flat Earth.
The problem is that they said, hey, flat earthers, how do you explain the eclipse? And then you ask them, what the fuck you talking about? And most of the times they get it wrong. They'll be like, oh, they talk about lunar phases, or they'll talk about solar eclipse or something. And you're like, dude, are you trying to talk about lunar eclipses? And once you finally get through all the bullshit and you finally figure out what the fuck they're on about, you're like, sure, how about use all the eclipses? How about the impossible, not labeled by flat Earth, upside down eclipse? Oh, that's fake. It's CGI. Huh.
But what are the actual crescent-shaped shadows on the moon? How do you explain them?
That's lunar phases. Yeah, that's the lunar
aliens. No, but what I mean is the actual shape of the shadow.
Yeah, that's a lunar phase. Nothing to do with Earth at all.
Okay, then. So if it's like a flat Earth, shouldn't it be like a straight line on the moon?
Holy fuck!
You've got the sun. Where in between the moon?
Someone clip this. Someone clip this. Where's clip?
Yeah, look, someone's showing the picture now. Explain
Someone
that.
failed the second grade.
Because we said from 2015, man.
Why isn't it a straight line? Why isn't it a straight line? If you think it's flat, why isn't it straight?
You think lunar phases is an eclipse?
Look, mate, I look at the moon all the time. I live in out in the hills. You know what I mean? It's very dark where I live, especially at night time, and I can see the moon proper. You know what I mean? And it's never got a straight line across it. It's crescent. It's waxing. You know what I mean? It's all curved shapes.
Good for you, Mark.
And because we're in between the sun and the moon, why isn't it straight? All right, mate. If you're going to overtalk me, I'll just Hold
on, let him go because we'd like to have this clip.
Listen.
We want this clip. So continue. Mark, okay, right, dude. Okay, so the lunar phases have nothing to do with the Earth being a globe. That's not the claim. It's not the Earth's shadow on the moon in the globe model.
What globe model?
What? So what's the shadow on the moon, please? What was the shadow?
Angle of the sun, dude. It's nothing to do with
the angle of the sun. So there must be a light behind the sun to create the shadow.
No. You just thought it was.
So you can just shine a light onto something and get a shadow. You don't get light on the thing you shine on. I get you, mate. I get you.
You just thought. No. You're trying to talk over me, right? Don't do that. Okay, so you just thought that the lunar phases were caused by the shadow of the Earth. That's really, really dumb, dude. Go look it up.
Can you explain it to me then, please?
Oh my god, I'm not explaining kindergarten level knowledge.
You can't explain it. All right. No worries, mate. You can't explain it. That's
well, mate, Mark,
anyway.
you couldn't explain it because the way you just tried to explain it was a misunderstanding of what the globe claim even is. So you can't explain it. So I guess we're in the same boat.
Well, a globe's kind of roundish, and the shadows on the moon kind of
Yeah, well,
a bit roundish. So what are you saying, bro?
We're not making a claim about what's causing.
All I'm asking is why there's a crescent shadow on the moon. That's a very simple question for me.
Okay, so my question in response.
It's a very lame and used a lot of jumping through hoops to try and explain
All right,
it
so
to
I'm
me.
gonna. Let me ask a
He
question in response. Let me ask a question in response. How would you verify that?
With my eyes, right outside my back garden right now.
No, that's just looking at it. How do you verify the cause of it?
With my eyes, because I can
How do
see
you
it, mate.
verify the cause of it?
Because we see the phases going around, the different
that's just observing
crescents.
it. You're
All right,
asking
look, mate, it's not flat. It's not a straight line across the moon,
How do you
and you
verify the
can't
cause?
answer that. So I'll just leave it there, mate. I don't really say much very often.
All right, so
I just
you
like
can't
listening.
verify it.
All right,
But
thank
the point
you.
is you can't verify it. Mark, you kind of just spazzed out there.
But mate, come on! You're just trying to run me through the system, aren't you? Because I know you're all going to start attacking me in a minute, and
it's a valid
I'd rather be
question.
quiet.
Shut the fuck up for once.
Mark, it's a valid question. I asked you, how would you verify the thing that you asked us? How would you figure that out? And you just said, I just look at it and make a claim.
Yeah, you're a twat.
Why am I at SWAT? What are you talking about?
Mark, you're being a bit of a dick.
You're not listening. You're being a twat. That's what I'm saying.
Every time I pause,
if you're going to be here to shut up and just to listen, then at least listen and learn, not just to yap whenever you open your mic. Okay? Shut the fuck up and listen for once.
Yeah, Mark, you asked us, right? How can you explain what the moon is doing? We're not claiming to explain what the moon is doing. Even if you wanted to try, I asked you, how would you verify the cause of what it appears to be doing? And the answer is you can't. All you can do is observe it and guess. But I'm waiting for you to figure that out. For some reason.
All right, Cyclone. I didn't say that. I said, what is the shadow on the moon? That's all I asked. What is the shadow on the moon? Why is it crescent shaped? That's all I asked, bro.
Right. Okay. So I would ask, how do you know it's a shadow? Shadow implies it's,
because
object.
I can see shadows in my room right now. So when I go outside and see like the moon with like a bit of dark on it, I presume it's a shadow.
Okay, so you're just assuming it's a shadow.
I'm presuming it's a shadow, yeah.
Okay, well, why are you making that assumption?
Because
That looks like a shadow, bro.
I just want to know what the shadow, why the shape of the shadow on the moon is crescent
well,
shaped.
you
That's
just
all,
said
Cyclone.
you're presuming it's a shadow. Can you verify that it is a shadow?
No, because
Right. Okay.
I'm not on the moon, am I? But I can't like see gravity, so I
you
can't
don't know
see
what the
air.
darkening is.
You know.
So then you don't know what the darkening is. So then you can't say why it's doing that, other than to say that's what the light appears to do.
All right, Cyclone. So, what do you think that crescent-shaped shadow on the moon is?
Well, I've just explained to you. You couldn't verify it.
Now, I had loads of people chatting to me at once, but you're doing it.
Well, I'm just saying
Can you
can't.
explain this?
No. That's what I'm saying. It's not something we can explain.
The shadow on the moon, the dark side of the moon that is illuminated by the sun.
I'm not talking about the dark side of the moon. That's at the back.
I don't know. He's spazzing out. Ignore him.
Go on, Cyclone.
So, the point is, we're not making a claim about that because it's not something that we can test or verify, right? It's just something we observe. The moon goes through its phases, the eclipses occur. It's what they do. But we get told, right, this tells you that the Earth is a ball. It absolutely does not. It's a logical fallacy to assume anything like it. And when you start to pull it apart logically in your head, like we've just done, you realize, actually, I don't even know that it is a shadow. That's just the story I've been told. And then I've been told, because it's a curved shadow, it must be because we're a ball and we're curved. But you realize that's not logical thinking or anything you can verify.
Come on, mate.
All right,
Just
which
look,
part was
look
wrong?
at the shadow. The shadow?
No,
you can
just said
see.
you don't know
can
it's
see
a
with your
shadow.
own eyes. You
You
can
just
see.
said you don't. You just admitted you don't know that it's a shadow.
No, you kind of convinced me to say that. Agree with you.
No, I didn't. That's just what
Mate,
it is.
if I go out, Cyclone, if I go
All right, so you
outside now and look at the moon again, and It will have a crescent shadow. Well, no, we've just gone into a full moon. So in a couple of days' time, it will have a shadow on it.
Okay. So now
And
you're
why,
saying
why have we got a full moon?
verified.
Why have we got
So
a
now
full
you're
moon?
saying, right, so now are you changing your answer to you can verify that it's a shadow?
It is a shadow, mate. Come on.
Okay,
What do you think it
tell me
is?
how you verify
What do you
that.
think it
How you
is?
verify
Tell me
that.
what it is.
No, don't
If
say.
it's-
Listen,
if it's not a
you're moving the
shadow.
conversation.
Hold on.
Say
Tell
it's
me how
likely
you
that it's a shadow.
verify
You think
that then. Okay, Mark, I just want to know
Sorry,
how
mate,
you
sorry.
verify that then. If you're saying you can.
Because it just looks like all the shadows I've seen all my life. You know what I mean? I'm not on about the band. All the shadows that I see, if it's a square object, it'll have a like straight line shadow.
It's just
If it's
darkening
something
of the light.
curved, if it's like a girl's butt in a disco club, and you see the shadow on the wall, it's a curve. We know what shadows is, mate. Come on, you can't insult me
Yeah,
like
but you
that.
don't know that it's a shadow.
So all shadows are
darkening of the
different
light.
apart from the one on the moon. Is that what you were trying to say?
Well, you would say the eclipse is a shadow as well, right?
Don't know much about the eclipse, mate. I think that's when we get right in the line of the sun and the moon. We're in the middle. Yeah. That makes sense as well, doesn't it? You know,
Right,
you're at the football game and someone
appears
stands
as
in your
red.
way. You can't see what's going on, can you?
But that appears as red. Not dark like a shadow.
I don't know. I seen the eclipse in 2000. Was it? It just looked
You can
kind of
watch
like
videos of
a
eclipses,
white
you can see
light.
it. You can
A
see this
white
red.
light around the
You can see it
around
go
the
red
moon.
during the eclipse.
Around the moon.
Show me.
I don't
You've
want to
never
fall
seen
out
a
with your
girl's-
cyclone, mate. I
Have you
think
ever
you're
seen?
cool, mate.
Hold on. Have you ever seen a girl's butt in a disco cast a red shadow?
No, never.
No, exactly.
No.
So whatever
I've
it
never
is,
seen
it's
a
not
red shadow, mate. Can you explain
Yeah,
that
so
to
that's
me?
not a shadow. So there you go.
What's the red bit about? I don't know what you mean.
Yeah, you will watch some videos of some lunar eclipses, and the
I've
colours
only
of the
watched the
moon,
ones on TV, mate.
they go red.
Really?
Yeah,
Is
some
that
go
to do
red.
with like maybe it's in
Well,
the
the moon
sun?
goes all
or-
kinds of colors. You can like see images that show you different colors of the moon. And
Yeah,
almost,
look.
like, every
Oh
colour.
yeah, the wolf moon and all that. Yeah, I get it. Oh, what do you think that is then? The wolf moon?
Again, you cannot. How would you look at that? Yes, and then tell me what test you would do to verify that cause.
Oh, you'd have to go
manipulate
there, mate,
cause.
wouldn't you? You'd have to go there with your science
Well,
gear.
No, you would. You know what you would have to do? You would have to know whatever the mechanism that's causing it is, and then you would have to be able to manipulate that mechanism so you're stopping and starting it, and so you stop it midway through and see if it stops the effect.
What do you think is
right?
doing all that then? What do you think's doing all that?
Bro,
red
I don't
stuff
even.
and-
I don't even know what.
You don't know. You're going to say you don't know. Like, you don't know the shape of the earth. You don't know this.
No.
You don't know that.
Yeah,
you don't
yeah,
know that.
yeah, we're not
That's what
making
flat
claims about-
earthers do. You
Hold
don't
on,
know
Mark,
anything.
Mark, do you not think it's a good thing to not claim things you don't know, or would you rather you claim things you don't know? Is that how you go about life?
Well, when I don't know anything, I kind of like just don't really speak.
No, you're making all kinds of claims. You're saying, look.
No, all I want to know is
passed by the Earth. You're making those claims that you have no clue about, Mark.
all I want to know is why the shape on the moon is crescent, not straight line. Why isn't it a straight line? If it was a flat Earth, it'd be a straight line.
Hopefully you've realized.
But if you guys are going to
there's no
deny
way of
that, like,
verifying that. Well,
there's
no, what did we
moon,
we just denied your
and there's
ability to
nothing in
verify the cause.
between us. You won't let me talk, will you? If you're going to deny that there's nothing in between the moon, the Earth and the sun, or the moon and the sun, you know what I mean? You're kind of digging yourself into a mad hole.
What are you talking about? Deny something between what?
No, I had heretics say, someone was saying, like, why isn't there a straight line on the moon if the Earth's flat? And Heretic said to the guy, he said, there is no moon. It's just a straight line. It's just straight light from the sun. And I thought, that's not right, though.
No, you've just misunderstood what has been said.
Yeah. No, bro, look, I don't want to fall out with you, mate. All I wanted to know was, why is the moon got a, crescent shape on it? That's all I was asking.
Okay.
I don't want to...
Well, I gave you an answer, I think, which was that you can't verify that.
Look, let me explain it like one more time, Mark. Right. So in the globe model, the Earth's shape has nothing to do at all with the lunar phases. Right? With the crescent moon, the waning, all of that, it has nothing to do with it. Right? It's not claimed to be caused by the shadow of the Earth. It's claimed to be caused by the angle of the sun hitting the moon. Right? Like what Heretic said. So in your model, it has nothing to do with that.
So like it skips the Earth. The Earth kind of moves out the way, and
yeah, if you think of a ball, right, and you're holding like a ball like the moon, and you shine a light at it, it depends on which angle you shine the light at the moon, and you're going to have a different shadow on the moon, right? It's got nothing to do with the Earth creating that shadow.
so the Earth never gets in the way of the shadow. No, is that what you're telling me?
That's only during an eclipse.
How do you know?
They make that claim.
How do you know? How do you know that? Have you been there?
That's
Like
this is
like
what your model. This is.
Hang on,
Hold a
he just
second,
said
Mark.
that to me.
Hold on. No. This is what your model claims.
Have you been there?
It's what
How
the
do you know
globe
this?
model.
Cyclone
I
just said
think
to
the
me,
globe model's
I'm wrong because
Globe-
I haven't been there. I haven't been to check the
No,
shadow.
Hold
Now
on,
you're
just hold on
telling me a
second.
different thing.
Not what I said either, but
Or have you been there
Hold on a
to
second.
tell
No, I
me that
haven't
I'm
been
wrong
there.
again?
No,
Oh, so
no.
well, you're
I'm
the same
telling-
as me then, yeah?
Mark, dude, bro.
We're both
oh my
guessing.
god, man.
Oh, okay.
Hold on. Stop talking for a second, dude. Okay, just let me explain it. Okay, so this is not my claim. This is not what flat earthers claim. This is what the globe Earth model claims, not what flat earthers claim. They're not making claims about the moon. Globe Earth is making definitive claims about the moon. I'm explaining how the globe Earth describes how it works, not making claims myself about it. I haven't been there. I can't test it. I don't know. This is what the globe model says.
Okay.
Got any other questions, Mark?
What's the best sherry to put in a trifle?
Flat Earth related questions, Mark.
Oh, joking. I do have a few, you know.
Yeah, hit us with them. As long as you're chill.
The amount of, I don't know if you, obviously you guys watch YouTube. The amount of rockets getting sent up this week. I think there's one live right now. So do you reckon they're all doing it for nothing? Just for
No, they get $80 million.
shits and giggles?
They get $80 million a day, Mark. Is that nothing?
Yeah,
Damage
no,
control.
I would throw
that's
up
a
some
valid
metal
point.
rockets.
That's a valid point, mate. No, I can't.
I would throw up some metal rockets for $80 million a day, wouldn't you?
No, mate.
Mark,
Yeah. No, that's a fair point.
Mark, dude, it's damage control for just this room alone, what we do to NASA.
I agree with a lot of the things you say. You do come out with some great stuff, like, but it's just a few things. Like, I'm just moon obsessed. That's all. Sorry.
Hey, don't get me wrong. I am fascinated by the moon as well. We all are in here. We're all very interested in the luminaries. We just have to be very clear that we can't provide a story for something. Well, we could provide stories, but we're not here to do that. We're not here to say this is a new belief about them. We're dealing with what we can observe, test, measure, and accurately confirm to the best of our abilities. When it comes to the luminaries, we can only observe their motions and what they do and speculate to a degree. I mean, you can come up with some maybe more reasonable speculations than others, but our focus here is not to explain the luminaries so much as point out that there's no curvature of the Earth, so it can't be a globe. There's no motion of the Earth, so it can't be a spinning globe. And there's no way you can have gas pressure next to a vacuum without physical separation, so it can't be in a vacuum of space. That's our main points here. So yeah, NASA's full of shit. $80 million a day for CGI and chucking some rockets on a parabolic arc. Why not? It's all they have to do, and everyone's convinced. Throw up a few rockets which do a parabolic arc, not straight up into the sky, so they observably go up and then come back down, and people are convinced they live on a spinning ball. It's easy. Why wouldn't they do it? Anyway, good talk. Your ends.
Yeah, cool, man. Terrible waste of money, really. They could sort a lot of shit out, really.
Then they blew one up for you guys so that now they have a reason to do things.
Yeah, that's what we're saying,
Now
Mark.
they don't have to do shit for 5 or 10 years.
We would rather see that 80 million a day going to schools, hospitals, everything else, but
yeah,
we're
of course,
conspiracy
mate.
theorists. We're conspiracy theorists for that, apparently.
No, I agree with you.
Yeah, so Mark, you said there was like a few other things that you were still maybe a little bit unsure about in regards to flat Earth. Can you think of anything else that you wanted to bring?
Yeah. Someone posted a picture the other day of they zoomed in on a tennis ball, like microscopically close, and it was flat. You know what I mean? That section of the tennis ball, the top, it was literally flat. I thought that
You're
was.
talking about the one with a basketball. Is it a basketball?
No. It's definitely a tennis ball. It's like a yellow color. It's not like a red. Yeah. And I think us compared to this, if you took like say the measurement from the center of the Earth, this is only half the size of the Earth, to the top of what I think is a globe, and then double that again, and then try to look down on you as a person on the top of the Earth, you would not be able to see them. You'd just be you wouldn't even, non-existent. But so you're that small. How can you perceive nothing but flatness? If you were a giant.
Yeah, it's a good question. And
it's a big Earth, mate.
Yeah, I know how big it is, right? 3,959 miles, they tell us the radius is. If you do the math, right, there should be 66 foot of drop over 10 miles. Right, so...
Yeah, I'm not good at math.
Yeah, that's the... Well, 66 foot...
I'll listen.
Well,
yeah,
okay,
sorry.
Let's I'll put it this way, right? Say you've got a lake, and it's 10 miles across the lake, right? So there should be, right? Just say one person standing on one side of the lake, another person standing on the other side of the lake. Right? There should be a 6-story building size obstruction between point A and point B, blocking point A's view to point B. 6 stories.
Yeah,
right?
Yeah, I got all that.
66 foot. Yeah. So when we actually go out and test for the curvature at that lake, for example, we can see right across the lake and see the person on the other side of the lake. There isn't the 6-story building size obstruction between point A and point B. Right? So then we'll go try it at a different lake, another lake, right? Different size lakes, different locations, right? And we'll start using different methods like laser tests and things like that. And we find we can consistently shoot the lasers over these huge bodies of water and hit the target on the other side. And you would have to have a huge amount of obstruction between point A and point B. But yeah, when you have a huge accumulation of this evidence, and then when we ask the globe side to prove there is that curvature over the distance, they're unable to provide anything satisfactory.
Don't know. How long are these lakes? You got to go a
These
long.
have been done
because the Earth's so big. You got to go a long way to find curvature. Surely,
right? But over 10 miles. Yeah. Of course, it's big, right? But over a 10-mile distance, there's 66 foot of curvature.
But has any drop been recorded? You're saying there's no drops ever been recorded. But has anyone done tests where there's been, a little bit of drop? Has anyone?
No curvature has been detected.
Never, ever in the world. Never, ever.
Yep. Nope.
Wow.
Not unless anyone would like to. Yeah, if anyone has some to present. And
what about just zooming out? What about just zooming out? Looking down. Do you not agree with all that? No.
Yeah, we can see things, right? Like we'll have something that we know is 10 miles away, and we can zoom in on it, right? From just like 1 foot off the surface of the water, we can zoom in on it, and we can see it, right? And we can see it's like an oil platform, right? We can see the legs of the oil platform entering the water at 10 miles away. Countless amounts of these observations.
I don't know, mate. I just think we're too small to feel it. see it. I know you're going about like you can't feel the spin of the globe. Imagine that if you could feel it. Yeah, do you remember them? You go to the fair and you'd have them like floors that used to spin round, and you'd be trying to walk, stand up. You can't expect the world to be like that. It's a lot bigger than I think. It's a lot bigger than you guys think it is. And you are all intelligent blokes. Some proper intelligent guys in this channel. And I just can't get
the size. No, but they tell us the size. They tell us the size of the Earth, right? We're not.
Well, why don't you guys just buy a rocket? Why? Listen, mate, I'd actually chip in. I'd chip in money for you lot to get your own proper space rocket and just fire it up there with cameras all over it. The technology's there, and prove everyone wrong.
Yeah, so the highest amateur rocket launch is only around just over 300,000 feet. Right, so even the Globe scientists...
I posted a few yesterday. They were 90,000 feet.
Yeah, that's nothing, right? So Neil deGrasse Tyson said you can't even see the curvature from 350,000 feet, which is the height of the Blue Origin.
You can't.
He said you can't, right? And if you do the math, even from the height of the ISS, you would only be able to see 3% of the surface of the Earth, right? We've had quite a few people over the years, right, from the Globe side, right? Like I think Paul Larson, I think's his name, a planetarium director. He said you wouldn't be able to see the curve from that height. You can only see 3% of the horizon, the Earth, right? The surface of the Earth from that height. So, yeah, it gets interesting. I mean, there was, on the Blue Origin flight, right, there was a trained astronaut on there. And she said she was disappointed she didn't get to see the curvature of the Earth because apparently they didn't go high enough. Right? That's when Neil deGrasse Tyson came out and said, you wouldn't be able to see the curvature from that height. I've got the clips.
I've got a friend, right, a couple of months ago, right, and his name's Captain Stuart Morton. He's got like masters in space flight and all that. And what he does, he flies planes from like the UK to Australia and all that. And anyway, a couple of months ago, like we'd grown up together. You know what I mean? Used to go raving, getting drunk, sat on beaches, just chatting about everything. Not once did he ever say like, "Hey Mark, let me tell you something, mate. The air's flat, by the way." Never. Anyway, a couple of months ago, I sent him a message and I said, "Listen, mate, I've been listening to these flat earth people for a bit. Like, is it true that you don't have to like, you know, account for the curvature of the earth when you're flying?" Anyway, he sent me a message back, and if someone like Crit or yourself or whatever like want to see the evidence, I've actually still got the messages, right? I could send it to you. And he said, yeah, have to all the time, mate, otherwise I'd fly off. And then he sent me a load of photographs from the cockpit of the plane, of the Sahara Desert, America, on his way flying into America, Australia. And there is a lot of curvature going on. And if any of you, I mean, like you main guys, want to see the actual evidence of this, I can send it to you. But they were curved, the pictures, especially the Sahara Desert one, and it was 49,000 feet.
Yeah, look. So even if the Earth was a globe, you wouldn't be able to see any curvature from that height.
But
right.
Well,
also,
come on, mate, this is from a captain. This is not. Yeah, do you fly planes at 50,000 feet?
No, but we have countless interviews.
Well, this is coming from someone who does.
Hold on a second.
You don't know. You don't. You don't.
Dude.
So you don't. But this is coming from someone who does. From someone who does.
So coming from
65,000 feet and no curvature.
Yeah. Dude, I can show you footage from 120,000 feet weather balloon.
I'm just
right
telling
now
you what a
curvature.
What a captain witnesses.
Yeah. Okay, so look, I could say stories. Okay, I know this person, that person as well.
No
right?
stories.
So
no. Send me a message.
Talking over the.
And I will send you the evidence. I'll send you the actual conversation as well. So you can see it's not like set up. It was just me asking him a random question.
In the side chat.
I'm not posting
in the side chat. DM it to me. DM it to me anytime you like. Dude.
Have you ever seen an aircraft windshield being replaced? There's massive curvatures in those windshields.
I know. Yeah, I know. Yeah.
They're also multi-layered, which
But
increases
regardless,
refraction.
bro, turn your volume down. You sound like fucking Darth Vader. The thing is, he was saying that we have to account for the curvature, mate.
No.
Otherwise, we'll fly off into space.
No, he doesn't.
That's what he said to me.
He's a liar. Or stupid.
He's a liar. Okay.
He's a liar or stupid. One of the two.
He's a liar.
Well, how much? I mean, it could be true. So let's get the numbers. Let's run the numbers and let's see if it matches.
Chris, I respect you, mate. I will send you. I've been thinking about it for ages. I'll send it all to you tomorrow, mate. It's late in the UK now, but I promise I'll send it to you in the morning. I've kept it on my phone for ages, thinking I want to send it to Chris, but I didn't want to get booted off the channel or hated and all that, so I've just kept it. I'll send Chris. I promise I'll send it to you, mate.
Yeah, no worries, man.
SR-71 flies at Mach 3. That is 33 miles a minute. Do you think they had computers sophisticated enough to account for curvature at 33 miles a minute in 1964? They did not. The Concorde. They spent $39 million on the Concorde building a test rig so that it flew flat and level to conserve fuel. Yeah, so your pilot there, he's not an aeronautical engineer. He has no clue what he's talking about.
I'll tell you something to me. I had my headphones off for 1 second. Sorry. No, he's a proper pilot, mate. You know what I mean? He's got people's lives under his wings. I'll show you tomorrow, Auntie, mate. I'll send it to you tomorrow, mate. Not a problem.
Yeah, hold on a second. You need to.
I know, but it's only. Oh, sorry.
Yeah, look, okay, so sometimes it can look, if it looks like there's curvature in a particular photograph, you need to consider what type of lens is being used, because any kind of wide angle lens or lens with a low focal length, like a phone camera lens or something like that, is going to distort straight lines. This is a fact.
Granted, yeah, I'd never actually asked him what kind of lens he was using. No, granted, that is granted.
So when you take a video, a video with a lens like this and you pan the video up and down, right, you'll see the horizon will look like it's very curved, and then when you pan it down, it will look like it's curving the wrong way. Right, that's what we see in a lot of this footage from Virgin Galactic or Blue Origin, things like that. It's just like a wide-angle lens. It's a known effect. And phone cameras do that as well. Right?
Auntie, here's a question. My girlfriend asked me it, like, do you know, say like you were looking at the side of an airplane, so like you were high up, would you say like, like the window are they fish-eyed lens or?
Usually they're round, right? And they're triple layered.
Yeah, because they have to be thick. Yeah.
Yeah, so if you look at certain pictures, even from ground level, looking through a plane window, you see like a slight curvature in the runway.
I was just going to say, why don't you see everything flat when you're on the runway? But if I'm honest, I've never really thought about it when I've been staring out of a plane window. But I will do the next time I get on one.
Yeah, I've got a photo here of it. It's like a person looking out a plane window, and yeah, you can see the runway. Looks like the runway's curved.
No way. Oh,
yeah.
Show me that, mate.
Yeah, I'm just trying to find
it. The windows are curved. This guy's got a picture of when the plane's stationary, it's like curved. Yeah, that'll be funny.
Yeah, I'm just trying to file. We'll find it in a second, but I need to start naming my files so I can find them quickly. Mess.
Oh, you messy, yeah. You're messy. Stuff everywhere.
Yeah. Yeah. But I'll find it in a second.
Mark.
Yeah.
So I posted a black box data recorder that shows a flight over past a couple hours with no curvature accounted for at all, 0.
Yeah.
I want you to show your friend, the so-called pilot who lied to you, this data. This is from a black box from an airplane. I posted the PDF as well there, so you know where it comes from. Let him explain that one for you.
Okay.
And then come back to us.
That's, you know what, mate? I was thinking about this the other day. I was looking at this and I was saying, yeah, there is no drop there. And I was thinking, so now you've asked as well, I will copy that image and I'll send it to him and say, yeah, what's this mean? But I have heard other people explaining it. So,
the most important one is the pitch.
Yeah,
the
yeah,
the word pitch above the line there. That's the most important one.
Isn't it? I've heard it explained. I will do that, bro. But I mean, I've heard it explained on here that like it's built into the, the analytics of the computer. So you're not going to see it. The plane already does it. I don't know. I think that's just something I've heard.
Yeah, it's an excuse. They say that. They say it's being accounted for, but you don't see it on the data. Yeah. You don't feel it. I mean, you have to trust it. Basically, you have to trust them saying that, or trust whatever is doing whatever. But it's not showing that on the data. Yeah. You don't see it counting for coverage. I mean, like, well, what's the point?
No, I've questioned that myself.
Or are you going to go with the data?
No, mate, I've questioned that myself, and I can't remember the guy who first posted that picture. I did look at it and thought, well, hang on a sec, there's no curve there. But now you've asked as well, I'll send it to Stuart and say, yeah, mate, explain this to me.
Oh, he's probably going to say the same thing that you just said. It's already being accounted for, but we can't record it. We can't feel it. We can't see it. So remove all your senses and your reasoning, your logic. Just trust. That's basically it.
Well, if the computer's making up for it, it has to be written in code somewhere, and nobody has that yet.
Yeah, obviously, somewhere. If it's being accounted for, then that deviation has to be recorded somewhere.
Yeah,
it has to be recorded somewhere, right? But it's not.
As a layman, for me, it should be visible. It shouldn't be kind of like hidden in something, but it does it. Yeah, I agree with what you're saying. No, I'll ask him. Yeah. I will seriously ask him. Like,
yeah,
Mark, as well, I wanted to mention to you, I'm in another server called Across the Plane, right? And one of the other admins in the server, right? He's a globe earther, and he's also an aerospace engineer. He works for the government. Really, really nice guy. And yeah, he said that in their aircraft design, they treat the Earth as flat and stationary for their calculations in building the aircrafts. So if you ever wanted to come, I can send you a DM into that server. More than welcome to have a conversation with him. He's really, really nice, open, friendly guy. You could even bring your friend in sometime if you wanted to. Right? And he also shared the FAA manual or flight dynamic equations or something like that. And it also states that when designing the aircrafts, they treat the Earth as flat and stationary for their calculations.
Yeah, I've heard that before. Like, oh, mate, no point inviting me, mate. I repair medieval houses. I'm not scientific. I'm old school.
Good job.
Repair cob. It's mud houses, thatch, old medieval stuff in Devon.
Oh, awesome, man.
Yeah, it's really good. I found, honestly, I took down a cob wall, which is basically it's a mud house. And we're taking the wall down, and I found some Roman pottery in the wall. Really smart. Yeah, you found jawbones, all kinds of weird shit in them.
Do they put the walls on flat foundations, or are they curved?
Yeah, no, no, you just dig down until you hit solid rock, or, hard rock, and then just build it up with stone for the meter, and then basically just slap mud on it, wet the ground, dig it out, build it up with mud.
Vertical and perpendicular to horizontal.
Mate, none of the houses I work on are straight, low level. They're like 400 or 500 years old, They just winged it. I think they use plumb bobs. But a lot of it's just It's what the Africans used to do, innit? Technology from there, I think. Yeah, someone was showing a picture of a level, the spirit level, with a bubble in the middle. Yeah? Green water with a bubble in the middle. Shape of the bubble? What shape's the bubble? On a level? What shape is it?
Bubble.
Yeah, you know what a spirit level is, don't you? Yeah? You guys post pictures
Aren't they
of
usually
spirit
like
levels all the time.
it's like an oblate spheroid looking usually when you see those bubbles.
Yeah, they're round, aren't they?
Yeah, they're kind of like a cylinder with rounded edges.
They're not flat or.
Oh no, the Earth isn't a bubble.
Yeah, the pressure around it though. It maybe squeezed it into a round thing. I don't know. I'm just speculating, you know. Anyway, the moon. It's got me so fascinated that I'm just on the verge of splashing out on some astronomy gear. But I don't know whether to get a C-Star 50, which does all the processing and everything for you, or getting a proper rig. You know what I mean? Any of you guys ever seen the C-Star 50? It's like a little computer motorized telescope. You can see the galaxies and a lot of shit like that. Especially the moon. You can see it so close. I want to take pictures of it. Put them all around my house.
Oh,
Are any flat earthers into astronomy?
sounds so religious. I am.
You into astronomy, yeah, but you believe in flat earth?
Well, looking at the sky, what's that got to do with the ground?
So you look at everything that's spherical in the stars, but you think the earth's flat?
How do you know they're spherical?
Well, that sounds religious.
You can see them, mate. I can look at the moon now, it's round.
I've seen.
And last week you could see Jupiter. You can see Jupiter and Mars just behind the moon, and they were round as well. Everything's round. Arkan's razor.
Square
Come on.
headlights look like
I
circles.
can see the lights. I can
Everything's
see it. I
round.
can see the light.
Therefore,
Everything's round. It's all round, round. Oh, thank the heavens.
I think being like, I'm not really bothered what shape the planet is, but someone sat on the fence. I think when you guys can't tell people who are criticizing you the actual shape of what you think we're living on, when you say you don't know, I think that really kills your argument. It just breaks it. Because you've got to know your shit, haven't you? You got to know your shit before you go arguing. You can't go.
You're looking for a
can't
place
fly into an argument. Hang on, mate. You can't fly into an argument not being able to back yourself up. As soon as someone goes, "Oh, well, what shape's your planet then?"
You're looking for a
I
replacement.
don't know. I'm just saying, bro. It just, you know what I mean? In the psychology of, say, arguing, it's not a good start, is it? If you don't know what you're done.
Yeah, but you want a replacement. Since we don't have one, doesn't mean it's not it.
Mate, you can be as philosophical as you like. Like, at the end of the day...
It's not so philosophical.
Well,
It's empirical.
you're trying to do that. Like, but at the end of the day, mate, you know, if you go into a fight and you can't fight, you're going to lose. You know that, don't you?
That's a
As a man, as a man, as a man, and you got offered out in a fight and you thought, I can't fight, chances are you're going to get beat. So if you're going to a vibe where you're saying the earth is not this and it's not that, but you don't know what it is anyway, I just don't think it's a good ground basis to state your claim. That's all I'm saying. I'm not saying it as a bad thing, or I'm just being, like a devil's advocate kind of thing.
Mark, we get it. You know how many hundreds of and thousands of people that come by here over the years asking for a replacement for the globe? You're not the first. So, I don't know. You don't like it? That's on you.
No, bro, I have not said that. Yeah. Don't even go there, mate. I love being in this challenge. This is why I never really speak.
We are challenging the globe.
I'm worried about getting kicked out, you know what I mean? But you kind of like challenged me there, didn't you? I'm only asking simple questions, mate.
Well, that's cool. That's cool. You can be here and ask questions all day long if you want. No one's going to kick you out for that. It's just a little bit baffling for me. I don't know how many years you've been around for about flat Earth topic. Maybe in this piece, 24/7 community.
I think I was one of the first 3 people on this channel, in this group, on Discord. I used to be in Not Fox's group. It was crazy. Presupposition channel, so boring. And then I seen your channel 2 years ago nearly. Yeah, brilliant. Pure entertainment, mate. Some of the discussions.
When are you going to click that link in DM, Mark?
Sorry?
When are you going to click the link in DM and come and see our server properly?
Oh, where is it? Sorry, mate, I didn't realise. Sorry, bro, I'm miles away.
That's all right, mate. That's all right. We've been around for nearly 10 years. It's all right. Don't you worry about it, mate. It's in your DMs from Old Dude. Or clicking my profile picture, mate. And have you been banned already, Mark? That's not a problem.
No, mate, it's never been... Well, I've been muted once in 2 years, but I've never been banned or anything, no. No, I'm a quiet guy, mate. I just listen.
Yeah, I know. I've been watching you for a while, bro.
Yeah,
Good stuff to laugh, Mark.
Yeah, better to listen and learn than just gob off, I guess.
Yeah. Can I ask you something? You seem... Yeah. Like, you seem... I get the impression you think it's unfair that we don't have a replacement map. Yeah, you think that's a fault in our game or possible weakness on our behalf? Or?
Yeah, don't you?
Well, like, how can we map it, bro, when we're not allowed to go and actually look to see what defines the true boundaries?
No, they're sending up rockets all week. There's one going off right now. They're going to the moon.
Yeah, that's if you're part of the club, you can be involved in all that, dude. But we can't do that. We're ordinary people. We have to conform to the laws of, international travel and stuff like that. And that's why we can't go mapping stuff.
Yeah, you can watch it. It's whether you believe it or not, though, isn't it? Yeah.
Exactly, yeah, exactly. I mean,
I like to believe
you're old enough probably to remember the movements, mate. Like we've all seen things go to the moon.
Mate, I reckon we're from the same generation, 60s, mid-60s.
Gen X, baby.
Yeah, mate. Yeah. Iron Brew and all that shit.
You know it.
Hardcore, mate. Especially where you're from.
You're a bit the same.
Well, you Edinburgh or Glasgow?
These days, I'm North Edinburgh, I'm Perthshire, but yeah, I grew up in the West Coast, originally around Glasgow and then up around the islands. I'm lucky I've been rural all my life, but yeah, I know what you mean, mate. The cities are fun in this country, aren't they?
Yeah, it's beautiful. What if none of you guys, obviously not from our isles, if you want to see proper scenery, you go to Scotland. Mind blown.
I would say go to England too.
All over, mate. It's beautiful, isn't it? Especially where I live. I live in Devon. It's stunning. I live in a big valley, in the centre of a big valley. It's crazy.
Yeah, we're lucky, bro. We're lucky.
Yeah. I think everyone in this channel is lucky where we live, apart from people in California right now. Do you reckon that's going to all burn down?
But fall into the sea.
I don't even think they got a sea of California. Yeah.
Well,
Yeah,
they
they have.
say that the greater part of Cali is due to fall into the sea if they have a big old earthquake. But yeah, it's if you believe in the hype, you'll be scared all your days, man.
Yeah, it's just mad to see somewhere burning like that, isn't it? And you go on like their live feeds and you got like people going, Allah Akbar, and God is great. And I'm like, there's just people burning there. And you're saying, turn it into some religious mad shit, man. Chill out. I know they're all millionaires and shit and all that, but, you know what I mean? Fuck it. Still a bit weird, isn't it? I actually went on Google Maps, right? And because I wanted to see the scale of it. So, like, I typed in blah, 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 zoomed out. And then I was looking at it around, California. And then I zoomed out a bit more because I was kind of like, I clicked on a thing called Firewatch. And there's fires going on all around the planet. In Hawaii, there's a giant eruption from a volcano. The country's on fire all the time.
Yeah.
How crazy is that?
Well, look what happened to us when we didn't clear out all the hedgerows and all the drainage ditches. We get flooded.
Flooded? Yeah, man. I tell you what, right? People who say like climate change ain't happening, it really is. Especially in my trade as well, because I see houses getting mouldier and mouldier each year. It's definitely getting worse and worse. When it was my birthday around, like, say, August, it was always sunny when I was a kid. And like, for the last 15 years, it's always rainy now. Yeah, it's definitely something going on.
The weather's changing, man. The weather's changing. But the way we go about society and dealing with stuff, like a lot of these wildfires are down to the fact that they didn't clear out the brush. They didn't cut the fire breaks properly.
That's what I heard.
It's all the eco-terrorists having all these problems. And now we're having so-called global events. And they're claiming it's due to polar shift and all this nonsense. When in actual fact, if you look back, it's more or less engineered by man's lack of care for things.
Yeah, it could be. Even though, if you go back thousands of years, men didn't really have much technology that could cause any damage. But I think it's that 10,000 year shift, maybe. As you say, as you guys say, who knows? No one knows because no one was around back then. So.
Absolutely. Science doesn't have all of the answers for it, mate.
I think we should encourage climate change anyway, especially global warming, because it's fucking freezing in Britain at the minute. What's the point? What's the point?
Coal fires again, mate. Nothing wrong with coal fires.
Oh, mate, I've got mine. I've got a log burner blazing away now. Bought myself a new chainsaw as well. Brum, brum. Yeah. Yeah, there's no point. Apart, unless you're a polar bear or you want to go snowboarding, there's no point. No reason for snow, is there? Should be warm everywhere all the time. So what do you reckon then about them rockets going up? You guys don't believe in it, no?
They're going somewhere, man. I mean, if it is true and they're going up, yeah, of course they're going to high altitude.
I don't.
But the majority of it's a parabolic arc, and
I've
people
seen
get
that.
a little bit weightless and then fall back down again. That what's his name? The idiot that took the ping pong ball up there. He showed it. Did perfect. I let a ping pong ball go just about the point of the parabolic arch, and seen the ping pong ball go up as he started to drop down, and then he reached out and caught it as it started to drop too. That's not you're not floating around in anti-gravity. It's just parabolic free fall, mate.
I fell down in a lift once. I jumped just before the lift landed, and it felt like I floated for like about 2 inches for about a second.
We used to get thrown out of the shops for messing with the lifts and stuff like that. Yeah.
I was obsessed with it when I was a kid. Yeah, I got it right once. You get it right, you feel like you're floating. Yeah. Anyway, the Earth's a globe, so whatever.
Nah. Mark, you already know now. We've already told you, so you've got no excuse. You sound like you've got a good setup, though. Devin, that is nice. And I've even watched some videos on YouTube of these guys doing these old thatch roofs and everything like that. That's pretty sick. Sounds like you've got a good setup. So you're lucky.
Yeah, I've got a business, mate. Yeah, it's really good. Moved from Liverpool, mate, when I was 18. Didn't have no skills. All I had was a guitar and a pair of football boots. But yeah, took a while, mate. It took a while, you know.
Well, look, that's a good kind of, that's a job where you can probably feel like you're actually achieving something compared to a lot of jobs that you can get nowadays. So that's nice. And keeping up the history of these old buildings, that's important, right? Because they're trying to destroy our history. This is another part. Basically, this whole deal is trying to remove people from reality. That's what it's all about. We speak to Globers who tell us that they don't even know if they're on Discord.
Right.
So the whole globe is like a denial of your senses where you experience a flat, motionless Earth. So, but on the rockets, it's Hollywood, right? They send a rocket up on a parabolic arc, like a golf ball, goes up, comes back down. And on the part that it's coming back down, they just switch over the feed. So they swap to the video cuts. And then it's, now we're going into space. That's just Hollywood.
No, it is cut, mate. Yeah, I have noticed that, to be fair.
Oh, they've got loads of cuts. And this is like one of the very basic things. It's like, show us one rocket from start to finish, no cuts. Give us the 24-hour camera on the moon. Give us some of that shit. You would have had this decades ago. If they really went and played golf on the moon in the 60s, we should have all this a million times over. And we don't.
I concur totally, mate. I don't think, after listening to you lot for the last couple of years, that moon thing, I don't think it's real. I don't.
When you actually really
I don't think it happened. I reckon they faked it. Yeah.
Exactly. And then they did. Like, and even a load of globe believers recognize this, and they'll say, they faked it for like capitalism or like propaganda. It's like, all right, so NASA, the greatest achievement of mankind, it was just propaganda, but we're crazy for saying that these guys are full of shit.
No, I agree with you guys on that. No, they were just in the rush to get ahead of the Russians, weren't they?
No, they were just in a rush to, they're just in a rush to convince people of this spinning ball theory, which even in the 1900s, a load of people did not accept or believe. Because you have to think about it, the moon landings is the first time that they actually claimed, hey, we've gone and seen it, it's a ball. Before that, it was all speculation, right? It would have had to be, because they didn't claim to have gone far enough away to see a ball there.
No,
but at that point, it's like, right, we've seen it. So it was just a giant propaganda, because we can find newspaper articles from the 1900s, like early 1900s. In the UK, one of them, it was like the head of the education in the UK, in England. And they were talking about in this newspaper article about people wanted to take him to court for starting to teach this heliocentric globe ideology. And this is in the 1900s. So clearly, and like they've given us this history where you think people have accepted this globe idea for centuries. Not at all. Even in the UK, people were obviously kicking off because they were starting to teach it. So obviously they were not in agreement. So this is why something like the moon landing had to be staged, so that people would be like, okay, look, they've seen it, it is a ball. And that's all it ever was. And that's why it's so obviously fake, and why they're obviously like not doing it again, because they realize that if we try and fake that again, they're just going to pull it apart instantly. So they just leave it with these few little grainy clips that you see 3 seconds. That's one small step for man. Like just bullshit. Endless bullshit.
We'll see, won't we, mate? We'll see.
Yeah.
If it happens again in our life, you know what I mean, we'll know.
Oh, mate. Well, now that you're keeping track, I hope you'll hold them to account, and you'll start to notice that they say this shit every few years, like, Oh, we're going to the moon. Oh, it's going to be this. It's going to be that. We're going to have a person going up. Oh, it's been pushed back another few years, guys. Sorry, the widget's fucked. We need to really recalibrate it. And then they'll come up with another story, and they'll come up with another excuse, and they'll keep pushing it back, pushing it back, pushing it back. Meanwhile, $80 million a day, not going to poor people, not going to the homeless, not going to the schools, not going to education. Just Globers getting their hopes up, saying, one day, guys, it'll be worth it, and we'll get some more videos to watch. Like, come on, guys, wake up.
Yeah, true.
They blew up the rocket yesterday, SpaceX, so that now they can push back everything. They'll say they have to redesign stuff.
Yeah, what they're doing now is quite clever. Now what they're doing is they're focusing the Globers' attention on the rocket landing again. So they realized, right, we can't actually go into space because none of that shit's real. So what can we do to make them still pay attention to us? Let's tell them we're coming up with a new way of making it really economic, so we're re-landing the rocket back on Earth. And we'll just focus all their attention on us landing a rocket on Earth, and they'll lose their minds over it. And nowadays, everyone's like, holy shit, the rocket's landing on the Earth! It's like, right, so they've just managed to distract you into clapping for them being back on Earth, doing nothing at all. At best, going up and coming back down. Now they've got you fawning over that shit, when 50 years ago you were supposedly playing golf on the moon. Right, the whole thing was a fucking joke. Anyway, I'm gonna have to peace out, but good speaking to y'all.
Nice one, Cyclone, mate. Hey, Tibbs, I've got one thing to say to you. £2 mate. That's my last offer. Talk to me. Only Tibbs. You know what I'm talking about, bro. 1,500 quid. That's my last offer. Talk to me. Sorry, it's an Tony Tibbs. He's like an
Phone Jacker. That was classic.
Yeah, wasn't it funny? Talk to me.
He was so good.
I'll give you 2K. It's my last. Talk to me. Yeah, he's got that cock. I can't do cockney, mate. Talk to me. I'll give you £2,000. It's my last offer. Yeah. No, I 50% get what some of the stuff you guys say, if I'm honest. If I'm brutally honest, like. There's a lot of questions out there, isn't there?
Yeah, there are, mate. And that's the whole point of it. Keep asking questions and test what you can test.
Oh, you have to?
Well, I mean, we're taught from early age that science has got us covered and it's got our back. So we leave school and we think, I don't need to learn these things. And you go about your day thinking, oh, it's all sorted. But just, you scratch the surface and you think, hang on, I can learn that, or I could do that, or I could find out about that. And the more you look, the more you find, mate.
That's right, mate. I'm just going to go to the toilet, be back on the set. Not that anyone would want to talk to me, like, but just in case.
YOLO, T.
Hey, calm down, lad. That's bad. That. Do you know what? In the 90s, see the guy on the right in that clip there. That's what I look like. I had the curly hair, the mustache, and the tracksuit. Funny.
In the early 90s, bro, I got well, actually it was 80s. I got my godmother to give me a perm because I wanted the haircut.
No.
It was brushed out in the
No.
morning. Trust me, it didn't work. I
Oh,
wanted to look like Kevin.
remember he did the Scouse alphabet? A is for alright. B is for Barry. C is for calm down. D is for divvy. Yeah, I remember all that. I just moved to Devon as the Harry Enfield brought this out. I fucking mate, I cursed them.
I bet they loved you in Devon.
Oh, mate. Oh. I'm dark skinned as well, so I got all. I used to play football down here, mate. The racism because they're in Cornwall, Devon. They're a bit behind us, aren't they? So, oh, mate, I suffered it all.
It's a third world country down there, man.
Oh, it was. Yeah, they've only just got a motorway here in the last couple of years. But at the same time, you know what I mean? It's I can leave my doors open. I don't have to lock my cars or my van or, you know what I mean? The only one who wears a hoodie in my village is me. You know what I mean? So it's lovely like that. Like so, very historic. Just outside Exeter. Historic place, like. Calm down. That's funny, that. So, but you guys think you're really tiny compared to the size of the Earth to feel the movement? Don't you think that's an absurd question to expect to feel the Earth moving if
Put
you're that small?
Put an end on a basketball and spin it and see what happens.
Yeah, but an ant compared to a basketball is not the same one-to-one ratio as a human on the size of the Earth. If you scale that up, you would not feel that movement, bro. No chance. Never mind an ant. An ant on a basketball, that would make me about a mile tall. I reckon if you scaled it up properly, do the proper research, like, you know what I mean? You ain't going to feel it, an ant on a ball like a basketball.
Would you agree that if Coriolis were a real force, man would have monopolised it by now, or commercialised it?
I don't know what Coriolis is, bro. Sorry.
Earth spin.
Oh yeah, the Coriolis effect. You can't feel it, mate, can you? As a little tiny thing, you're not going to feel it, are you? No chance. You feel it on a waltzer machine or a scrambler, you know what I mean, in the fair. But you ain't going to... Never in my life have I ever felt fucking Earth moving. It's not going to happen. You're too small.
It's not moving. It's that simple.
No. Oh, bro, if it wasn't moving, everything would fly off.
If it wasn't moving, everything would fly off.
Why?
No, it's the other way around.
Fly off. We'd fly off.
If the Earth was moving, everything would fly off.
Yeah, no, if it stopped, we'd all fly off.
Why?
Because gravity's holding us down. Simple.
What?
What is his gravity you speak of?
Oh, no, look, you're going to call it density, which isn't a force anyway, but... look, I don't know. Look, I'm not taking on Jedi on this topic. He's just ruined me. All I'm saying is we're too small to feel movement.
Who said you need a force to keep you onto the Earth?
I don't know, mate.
You understand what rotational motion means, right?
Mm-hmm.
Okay, so not in a straight path. Curved. At all points along a spherical surface, the speed is different. When we're talking about rotation, we're talking about acceleration, constant acceleration around in a circle. Now, depending on where you are on this sphere that's moving, it's going to be moving at a different speed. It's just over 1,000 miles per hour around the equator. Move north or south away from the equator according to the model and the principles that apply. The rotational speed is different. Yes, it's still 15 degrees an hour, but the path that the circle is having to travel is smaller. So when you move north or south of the equator, the Earth is in all intents slowing down in its rotational speed.
Yeah, slower. Yeah, because you're less towards the outside. Yeah.
So like at 45 degrees north latitude, half the speed. So moving across this Earth that is, for all intents and purposes, changing its speed beneath our feet, we would be able to measure this difference in speed, but we don't. I get what you're saying about we wouldn't feel it. It takes 24 hours. It takes a day to go round. But we have to talk about the differentials. the path that you are taking on this sphere, not to mention that this sphere is also going in a direction. According to the laws of physics, things would fly off. It's easier and common sense to understand that the Earth doesn't feel any motion. You're coming up with excuses as to why we wouldn't feel any motion. It is simpler to understand that it isn't moving at all, because that's how we treat it, a non-rotating surface.
Okay.
Okay.
Also, I'm a little ignorant in this aspect, but would the mass of the Earth that's creating gravity, would that hold us down more than the actual rotation of the Earth itself? I know that it's a culmination of both, but like, does one hold us to Earth more than the other?
Gravity comes after the radius value of the Earth. So the ball of a definite size, its radius, diameter, circumference, composed of an amount of substance, giving us this acceleration down towards it. You'd need to have the R value before you start talking about attraction to a ball. You need a ball first. This is why people back in like the 16 and 1400s were talking about mass attracting mass. This is just conceptual. This conceptual idea has changed over time. It's distorted in space-time, but all mathematical concepts. All based upon a model that asserts that the radius of composed mass is the reason why things don't act the way that they should do according to the well-established laws of physics.
And it does seem like a weak argument to say that we know that Earth is spinning by how little evidence there is of it spinning. Right? We know Earth is a spinning globe, but we just can't feel it spinning or measure it spinning because it's so slight it may as well not be there. That's kind of a weak argument if you're a glober. I mean, has anybody been able to net out the forces and say, hey, we know this amount of force is attributed to gravity. This amount of force is attributed to your specific gravity, your weight density. And this amount of force is attributed to centripetal force. Nobody's ever been able to do any of that.
That's what I was more asking about.
Yeah, nobody's netted them out before. I mean, they can come up with calculations and guesses, but nobody's actually measured it. Like if Earth is twisting around an axis, that axial spin should have like a torque value, right? You should be able to measure the twisting power of Earth. But it's never been done.
Yeah, I feel like that was one of the things I was curious about. Like I said, I'm kind of ignorant in that fact because I know some people bring up the fact about like rotational spin that's like keeping us down, but I always figured it was more, or at least my conception was that like I had to do more with like gravity coming from like, you know, Earth itself because, you know, mass and space-time, and like I felt like that was more of the force pulling us down to Earth rather than like the rotational speed.
Yeah, it's the rotational speed that's causing the problem. Everything would fly off. According to the idea that you're pointing out, it's not the rotation of the Earth, it's the mass of the Earth and how much space it takes up, according to maybe a space-time idea. But yeah, you are right.
Yeah. Because I'm thinking like you can have something that has so much mass, so much weight in space-time that it has no spin. Would that be able to hold you down without it needing spin?
So within the paradigm of finding exoplanets, you know, other planets orbiting other stars, there are planets that tell us that sets have no rotational motion, locked in like a tidal orbit with its star, their sun. So one facing it like our moon would be. This is within that. So I don't think that within that story gravity is different. It's based upon, in this idea, interstellar stories, the amount of space time that mass is said to be able to distort. Space time fabric, right? Einstein, relativity, the bending and warping of space time. Space time being a 4-dimensional coordinate system, height, width, length, 3 dimensions, and time.
You know, the further out you move from the axis of rotation on a carousel, the more you feel like you're being flung off of it. In a similar fashion, you'd expect the same as you move towards the equator of Earth. You're moving away from the central axis of rotation, and your edge velocity is going to be faster, right? So your edge velocity at the equator at 0 degrees latitude on a globe is presumably faster, has to be from a mechanical standpoint, than being at like 45 degrees north or 45 degrees south. So the relatively uniform gravitational pull, despite a difference in edge velocity based off of latitude, is something that's very curious and flat earthers like to bring up.
It becomes worse the more of the story that you start adding. Don't forget the Earth is going in a path, an orbital path in a direction around the Sun.
Yeah.
This is going to bring up other problems as well. The Earth in one instance pushing up underneath your feet, and in another instance 180 degrees antipodal, say behind the Earth's direction of travel, the Earth leaving your feet behind. Different forces apply.
Yeah, so relative to the orbital path around the sun, you've got this at the equator, an acceleration into the direction of Earth's orbit at nighttime and away from the direction of Earth's accelerated orbit in the daytime. It's 1,037 mile per hour difference, plus and minus, over a 24-hour period relative to Earth's orbital motion around the sun. And nothing has ever measured that. You should feel like you're in a Disney ride in the teacup. You got this compound motion. You're being flung into the direction of Earth's orbit, and then away from Earth's orbit, and then into Earth's orbit, and away from Earth's orbit, nighttime to daytime to nighttime to daytime, nighttime to daytime. And yet, where's the evidence? Oh, you look at the stars. And you just can't feel it. There's not a device on Earth, guys, not a single device is capable of measuring 1,000 mile an hour acceleration in 12 hours. Really? I mean, the iPhone is pretty sensitive. Guess it's not that sensitive, huh? And neither are all these industrial sensors.
Where do the majority of like flat earthers come from?
What do you mean? Where do they come from?
Scotland, mate. We invent them here and ship them out all across the earth.
Scotland, son.
No, but like, does anybody know like the percentages wise, like where do like
I'd say Australia and America.
Well,
that's what he seems to be.
Well, everywhere that appears to speak English does. And we only speak to them. I know there's Latin, like South American communities that have flat earth communities, but we don't interact so much with those. We speak to Americans, Europeans, British, Australians, South Americans, Canadians, Mexicans, all Africans, some Asian people from time to time, some Samoans quite recently for some reason.
I mean, that's a lot of people.
A lot of people, yeah.
I think Brazil has a large number of flat earthers. Don't quote me on this, but I think it's somewhere in the region of 50%.
Wow.
50? Whoa.
Yeah.
Get out of here. 50%.
That's a crazy.
Like I said, don't quote me, but I did see that figure at one time. Yeah, they have a ton. The Brazilians do.
They have a football team as well. Flat earthers, the bunch of them.
I'm not really super into geopolitics, but how's their government?
So much about their government, it's kind of about their religion in some aspects. There's still lots of different religious groups across the earth, primarily Roman Catholic or Catholic in South America, that have these ideas. The Amish, for example, exist in America. They primarily have been taught that the earth is flat and stationary as God's described. There's other religious groups, Orthodox Christians like Russians, Greeks, different groups like Jewish groups and so on. Some Muslim groups as well. The Chinese up until the last 200, 300 years. Lots of different groups believe the earth is flat, or I thought so, for sure.
Would there happen to be, does anyone know if like the numbers about agnostic or atheist flat earthers?
I don't know about. There's a few atheists. I think that would be a low percentage. Hardly any at all. I would have thought. I would suggest that most flat earthers have some kind of intelligence creates idea, like God created, whatever they think that God is. But yeah, flat earthers come from all over the place for lots of different reasons.
I mean, I feel like in America, I feel like religious undertones have to do with it too, but I feel like it's more like, I guess, like the skepticism behind like the government and everything, right? Isn't that like the main driving force?
Yeah, I wouldn't say that religion is the primary driving force. There's still Christians that would firmly say that the earth is a spinning ball like everyone's been told. I'd say that flat earthers in America would have a slightly different, maybe westernized idea, maybe some kind of distrust in the government is where they would start, I would guess, and we all start somewhere. Some people come to this idea through like conspiracy talk or conspiracy theories, right? But coming from a distrust in organisations they can't quite point out, so just point at the government and so on. But it's a lot deeper than that. There's other flat earthers who know the earth is flat because the way it's measured, like us in here, lots of flat earthers have got lots of different ideas. But yeah, we come to this understanding through lots of different pathways, but all roads lead to the earth being measured flat. There's actually a book coming out saying titled "All Roads Lead to a Flat Earth." It kind of really does.
I tend to believe that everybody's a flat earther. That's all they've ever experienced. That's all they ever will experience, but they live under a strong delusion that sort of I don't know, compels them to deny their senses and what reality is. And they defend it like a religion, like they're part of a cult. And if you leave the cult, you sort of have to abuse those who leave the cult, right? So, anyway, I think everybody's a flat earther. They, for whatever reason, they don't want to see what's painfully obvious. We're not talking about beliefs here. It's just geometry. It's not difficult. No Earth curve. What does that mean? Well, it's flat. Okay.
I guess I hear that argument a lot, but I feel like I still don't quite understand that argument because it's like I have seen it, like I've been by the ocean and like I have seen like boats and just like disappear off in the distance, like it's not like it just like I can't see it going further away, but like I actually see the top part like actually disappearing, like it looks like it's sinking into the ocean.
Okay, so you're a victim of the power of suggestion. So someone told you the reason that you see that particular phenomena is because it's Earth curve. Did they prove it to you, or did you just believe them and move on with your life?
It's more so I'm not entirely sure if that was something like what people told me. It was just based off my assumption when I was a child. Like my assumption was that like, oh yeah, like Earth is curved because of that fact.
Where did you get the idea that the Earth was curved?
Observation.
You observe the Earth to be curving, or you observe boats to disappear in the distance?
Like boats it looked like it was sinking into the ocean.
Okay, so I guess your logical conclusion would not be that the Earth is curved, but that the boat is sinking, right? Because that's what you observed?
No, because the boats would come back.
Frank, what I'm trying to tell you is you would have never assumed that the Earth is curving just by seeing boats disappear in the distance. And I don't imagine you had that thought at 3 and 4 years old, unless someone suggested to you that the Earth was curving in the first place.
Well, I come from like a really rural part of Mexico, and like we didn't really have like that much education or anything like that. So like that's what I grew up with. No one necessarily told me like the Earth was a globe.
Did you have television?
Okay, no problem. Yeah.
Did you have television?
Oh yeah, black and white, but it was like just mainly like Mexican programs.
Yeah, no, that's fine. So television and entertainment, films and so on, where most people understand that the Earth is a ball. I understand you talking about your education, but everyone has always comes to the propaganda that the Earth is a ball, no matter if they hear it through their parents and so on. So it's possible that this is called anchor bias, what you're displaying. You have an idea and you base your observations based on that idea. That idea is something that you've been anchored to. This is your first primary understanding that's given to you. This first primary understanding is the Earth is a ball, and the reason why reality acts in the way that it does is because of this idea that you've been given. There is another way to there is another way to explain what you observe, but you have to break the anchor bias to observe what we're talking about. So you have to let go of your conditioning. It's not because of this, it's because of something else. You have to stop defending possibly this idea that you've been given.
In my case, it was more like it was observations that I made, right? Like I said, when I was a kid, and then it wasn't like I was necessarily brought up with the idea, but once I started, like once I moved, or once my parents moved us to like the United States, that's when like I guess like I was just like, oh, like I mean, it just made sense because everything that they showed us was like Earth globes, because it was mainly like shown in like American schools, and I was just like, oh, like yeah, like this always made sense. Like I was correct, I guess, in my thought. I didn't really think about that like that as a kid, but I'm just saying it as an adult. It's like looking back, it's like, oh, like yeah, like it made sense the way that I was thinking.
So, what made sense? Was it the fact that the Earth doesn't have any measurable curvature, or did it make sense that the Earth is obviously not moving? Which one of those was it that held you to the conclusion that you live on a ball, since it doesn't present itself that way, a spinning ball?
I didn't necessarily know anything about a spinning ball. It was just more so about the ball. I was just like, oh, like that made sense, because like when I saw it, it was like my head connected the two, and I was just like, yeah, like, you know, I was like, it makes sense that it's a ball.
Okay, so in your case, did you scrutinize your own analysis?
Not till later on, I guess.
Okay, so how did you affirm your analysis?
I guess in my case it was because like I don't feel like I'm necessarily smart enough to like come with my own calculations and mathematics or anything like that, but it's just more so trust in science, because it's like science has gotten us everywhere. And like I feel like I grew up in this era where it's like I pretty much had like almost basically nothing, and then moving to America, I was just like, whoa, like technology is like insane. Like how does all this stuff work? I was like so mesmerized by like everything that I saw. So I was just like, oh, like this is like just so cool. So it's like I guess that's where I gained my trust in science, was because I saw the wonders of science coming from like such a rural part of Mexico.
Well, hold on a second. You're conflating about three different particular fields here. So what does geometry, that mean Earth measurement, have to do with science?
No, like I said, like it's just one thing connecting to the other, right? It was just like me based off my observations from when I was a kid, and then learning about it from school, and then also just like seeing all the technology, and then knowing that like science is what got us to this point, you know? And it was just like, oh, like
well, that's not correct. You're like I said, you're conflating about three different fields. You have geometry, then you have science, then you have engineering. Now, two of those, or three of those, isn't science what?
Well, I was going to say, like, isn't science like intertwined with all of it, science and mathematics?
No.
When you say mathematics, you don't have the equations, you don't have the calculations. That's where you should have stopped. You then went on to describe that you trust the scientists, jumping from one category into another. We're not talking about science here. We're talking about geometry, mathematics, and measurements. The surface of.
But scientists use mathematics, right?
Yeah.
Right.
But you understand that that they give us the mathematical equations. So this is why you was asked, when you make your observation of the boat going away, what did you compare it to? How did you come to the conclusion of your analysis after you went back half the time and said that you thought about it again? So we're asking what you would compare to it. That would be the mathematics associated with the radius and circumference of the Earth being a ball, because it makes a prediction. When you're observing things over distance, you're invoking this prediction that the curvature of the Earth is obstructing your ability to see things beyond that curvature being the horizon that you see the observer based on your eye height above that curved surface. It's mathematics and geometry. We're not doing science here. Don't have to trust the scientists, but we use these equations and this mathematics. This is where you should observe and clarify your observations.
So if you saw boats disappear in the distance, or at least in your mind over a geometric horizon, did you confirm that geometric horizon was actually Earth curve, or was it an optical effect?
I'm not sure if I was able to confirm anything as a child, but as an adult, like, no, I haven't confirmed anything.
Okay. So are you aware of the mathematics dictated by an Earth sphere radius of 3,959 miles?
No.
So essentially, if you're going to go out to the ocean and see boats disappear again, you're going to need to see them disappear at roughly exactly 1.22 times the square root of the observer's height in feet. That could tell you if you're witnessing things going behind geometric Earth curve. Now, we went ahead and scrutinized this for you, but you don't have to take our word for it. This is just off the coast of Santa Barbara, California. I don't know if you're looking in the side chat, but I'm going to post an image for you, and you tell me if the horizon in this particular observation, which is a measurement because we have distance demarcations, you tell me if you see the horizon at 1.22 times the square root of the observer's height in feet at 1 minute or 13 minutes after the hour. Where do you see the horizon in that particular photograph?
Wait, sorry, I'm not entirely sure what I'm looking at.
Well, at 13 minutes after the hour, you see Bub Eyeball with a couple of oil rigs, right?
Yeah.
Okay. Can you tell me where you see the horizon in relation to those oil rigs? Is it in front of, in the middle of, or behind the oil rigs?
Behind.
Okay. Well, the Earth, if it is a sphere, and you can see that Modus Tollens logical syllogism above, if the Earth is a sphere with a radius of 3,959 miles, then every distance to the horizon can be no more than 1.22 times the square root of the observer's height in feet. This observer, this camera, is at 1 foot above sea level. So it's 1 foot above the water right there where the water's lapping up on the beach. So the horizon should be at 1.22 miles. The horizon in this particular observation is in excess of 9.41 miles. We'll make it a nice, easy round number. We'll say the horizon is at 10 miles, and that would make the radius of the Earth over 250,000 miles in radius. That's further than here to this, the supposed distance of the moon. So is the Earth a big, giant yoga ball that you can inflate and deflate? Or is it possible that the horizon is not Earth curve?
Hello, what's going on?
We're demolishing the claim that the horizon's the curvature of the Earth.
Wait, but also I got confused by what you said about the distance from the moon. That was like kind of tripped me out right there.
What I'm saying is that if the horizon is geometric Earth curve at an excess of 10 miles or 9.41 miles in this observation at this observer height, the Earth's radius would be greater than the distance from here to the moon, which is also just a made-up figure, but try to fit that into your head. The distance from here to the moon would be the radius of the Earth if in that observation the horizon was indeed geometric Earth curve. What I'm saying is that that's what is dictated by this observation. In reality, the horizon is not Earth curve because this debunks it straight away. You can just forget about all the boats you thought you saw disappearing over Earth curve. You can forget about the suggestion that that's what happens. Boats and buildings are being blocked out by physicality, because even the definition of horizon is the apparent location where the sky meets the ground or sea. So the horizon has never been Earth curve. It was never defined that way, but by the power of suggestion, and maybe even you suggesting to yourself that you saw boats disappear bottom up because of Earth curve is entirely incorrect. You don't live on a ball.
So then, what exactly is happening? Like, that's the part, I guess, where I'm getting confused, because it's like, well, what is that? That's distracting me.
Do you want to know the horizon? What do you mean, what's happening?
It's because, like, in my head, like, in my head, the way I'm thinking about it is, like, I feel like if stuff, like, if Earth was flat, and if it was really far away, like I said, I think this is, like, really difficult for me to, like, also do it, because it's, like, just based off, like, observation rather than mathematics, right? But it's just, like, I feel like if Earth was flat and stuff was getting further and further away, I would feel like the ship would be shrinking, but not necessarily sinking.
Well,
it does.
It does, and there are multiple effects. Like, first, you have to understand pretty basic perspective. You have to understand that things that are above your eye line, as they move away from you at distance, like say the top of a tree that you move back from, you notice it will get smaller and the top of it will appear to go downwards.
Yeah.
Like when you look down a corridor.
Yeah.
Right? When you look down a corridor, it looks like the ceiling and the floor are getting closer together with distance. So this is where the apparent down motion comes from. It's just the way that you, the observer, observes these things moving away from you. Your question is, why can't you see the bottom of it? We get why it's going down. It doesn't have to be a curved surface. That's just perspective. But why can't you see things that are beyond the horizon from the bottom up? The reason why that is because what the horizon is. The horizon is the limitation of the observer's view across that surface. It's just a surface. Things beyond the horizon, your eye can't angularly resolve. The eye has a diffraction limit, 0.02. So the surface that moves away up into the midpoint of the horizon, where the surface appears to meet the sky, is beyond that minimum angle. The boat that is beyond that minimum angle is on that surface, so entering with distance that minimum angle, so your eye can't resolve it. That's just a perspective. You also have to understand the amount of atmosphere and the type of atmosphere that you're observing through when you're making these observations. The atmosphere is going to play a part. The optic's going to play a part. It's going to move the horizon. All of these things are going to move the horizon. You'll notice this in the video that was posted. When you zoomed out, the horizon, you don't get to see the oil rigs. Then you zoom in, the oil rigs appear and the horizon extends beyond those. Increase the optic, the same things apply. It's just opening the angle and the horizon can appear further away. But the reason why you can't see the bottom of the boat is because it's in that angle that you can't resolve a distance through the horizon. Appears to go downwards, the bottom gets cut off. Still going downwards with distance horizontally straight in front of you, appearing to go down but getting cut off from the bottom, being cut off from the bottom because the angle is too small.
When you mention ships, I assume that you're talking about you've seen this on an ocean.
Oh yeah. I come from like I don't know if anybody's familiar with like Mexican Colima.
Okay.
Yeah, so it's a.
Is there waves in this scenario?
Yes.
So the boat that's going away from you getting smaller and smaller and smaller may be obscured by the thousands of waves overlapping? This leads us to Bedford Level. Bedford Level is the first actual scientific experiment that follows the scientific method that verifies that there is no curvature to the Earth. It is a giant, long, 20-mile canal, and there is no manipulation of the water or the atmosphere whatsoever. And when we perform this, does the boat go over the curvature? Simple observation in a scientific way. We see that we can see the boat when it's supposed to be well over the curvature. And then furthermore and furthermore, 20 miles away, we can still see things. So, that's old ancient mythology almost that you're dealing with right now. The boat goes over the curvature kind of thing. They've been using that since Socrates, I think, brought a bunch of people to the beach and said, "Look, watch the boat disappear over the curvature." And they were like, "Whoa, we don't have telescopes. I guess this is correct." So, we don't have sense enough to know that the waves are overlapping, making a false horizon. Got to consider those things.
Does anybody else have for that? Like, I never heard about the waves thing.
It's talking about the angular size of an object in front of another object, so a wave. Right? It can be maybe 3 foot tall, but because of the angular size of the object behind it, it's going to block it out. It's like putting your thumb in front of the sun. Angular size, right? Because some's small, some's big. Because it's so far away, it appears to be smaller, the size of your thumb.
There's a phenomenon known as shoaling, and it's to do with the landmass profile on the seabed. as it approaches the seashore and tidal movement. When bodies of water come in and hit this, it causes a rise in the water. An extreme event of this would be like in Hawaii, where you get the great waves for surfing. It's due to the seabed profile. And technically it causes a wall of water or a rise in the water between you and the object that is getting angularly smaller behind it. So therefore you're seeing ships going up, what you perceive as going away, being bottom up occluded after a certain point. Now that's far, far, far too far beyond the geometric horizon, even to be refraction. Refraction can only extend a 1.22 mile to about 1.3 or maybe 1.4. So it's far too far away again. And if you look into this shoaling thing, you'll start to understand that at different times of day you can see quite clearly, like the black swan observation where you can see the legs touching the shore or touching the water. And then at other times you see the legs of the rigs occluded. Now that's a body of water that's risen in your eye line. It's not actually Earth's curve. I'm trying to find oceanographic floor data for all around America and the UK. So if anybody knows where I can get hold of it, please send me a link.
NOAA?
Who?
The NOAA.
Noah?
Yeah.
Nice one, I'll try them. Cheers, bro.
No worries, man. It's my first guess.
Are there any Glovers in the house tonight?
Just you.
Oh, man. Hey, how you guys doing today, man?
Pretty well, bro. How are you?
Oh, wonderful. Thank you. Yeah.
Good
to see everybody. Yeah, of course. Good to see everyone. You know, it's just amazing to me. Every time I come in here, it's always someone explaining how flat this place is. It's wonderful.
There's always somebody asking, actually. We don't sit here and explain it to people that we know. It's
Yeah,
always
I
somebody curious about it, you know what I mean?
Yeah, I was one of those guys. I know.
You about to be one of those guys in a minute. What you talking about?
I'm just saying, listen, I've heard the whole story about how you guys believe it's flat and why you think it's flat. I get it. You know,
Are you a
the
religious?
funny
Are you
thing,
religious
huh?
dude? Are you a religious dude?
I'm a man of God. I'm a man of God.
Believe the Bible? Read the Bible?
Yeah. Yeah, of course. Well, yeah, of course. The important parts. Now, I don't know how I don't know how they fit two of each kind of animal upon the ark. And I don't know how the Jonah was swallowed by the whale and lived for 3 days. I don't know about that stuff. What I do know is God's love for the world that he sent his only son, Jesus Christ. That's what I know about.
Oh, that's interesting.
But, I mean, look, whether the place is flat or a round sphere, I mean, does it really matter as, you know, we're living here? I don't know.
Yeah, it does matter to some. Being a man of God. So I appreciate everything that you say. And I believe the same thing. Jesus Christ, salvation through his blood sacrifice. I believe in that. But if we're talking about people understanding where they are, coming to the understanding that they live within a created environment, we have to understand that the ball that spins came from nothing. That nature created itself. It expanded and caused everything to happen. Physical rocks and matter then creating sentient life, biology and information. So that idea is the wrong way round and doesn't need God. So this is one reason why those who are lying, you being a godly man, would understand why they would want to deceive the world about the creation made by God, turn it into something where God wasn't needed.
Oh, okay, I see what this is about. If they can convince us about one lie, then they can convince us about more lies.
Yeah, God's main trophy is this environment and us. So if he can Lucifer, if we're talking about it, can trick everybody that's here into thinking God ain't shit. He didn't do nothing. He didn't create this world. It was an accident. We were retarded fish monkeys. That's the ultimate slap in the face to God. So,
And I feel like this is where I'm being lost. Kessel just brought me back.
Oh man!
But you
There's
understand.
I guess it's like when Jason, Dr. Jason, the way he speaks about stuff, it just like that's what deters me away.
There's a Bible verse that
deter you away
says
from
that
what? The flat Earth or religion?
Both.
there's a Bible verse that says that creation itself gives testimony of the Creator. Therefore, if you distort creation, you can literally lie to people and tell them there is no Creator, which is what they obviously do, because it was something I was being taught in mainstream school, that there is no Creator.
Oh, it's a mix, isn't it? It's either no creator or whichever creator you'd like to think of at the time.
Yeah.
But not the true creator, right? So it's all a diversion tactic. Hide the creation, hide the creator, hide those that are lying about the creator, because they'd be hidden too. Yeah.
Exactly. And then we see the fruits, right? The fruits of this confusion. You see it on the very people that buy into it. You can call me crazy, but I think heliocentrism has contributed to the whole diversity of confusion we see parading down the streets. Whatever you interpret into this, if you interpret something into what I just said, you maybe know the truth. And if you think it's a good thing what these people are going through, then you might be arguing against yourself, because only someone who knows the truth would get angry at someone like me pointing that out. Always remember that.
No need for God, no need for salvation. So that message that you were talking about earlier, Castle, doesn't come into the equation. No need for salvation if there's no God, right?
Yeah. If your life is essentially meaningless, then why would anybody ever look for a relationship with the Creator, right?
I just don't understand how believing this place is flat would give your life meaning.
I tell you.
I tell you what.
Oh yeah, Jedi is better.
Because what we're talking about is the ontological primitive. It's a dichotomy, two choices when you ask this question. How the earth and everything was created. We understand on one hand the heliocentric idea gives us nature sprang into existence out of nothing. So nothing created everything. Nothing created the rocks and the gases and the laws of government and information and consciousness after the fact. When we ask the question again, how the earth was created, we can demonstrate that intelligence creates. Intelligence is consciousness. Intelligence is information. You need these things first before you have everything else. So the idea of when you come to the understanding that the earth is not what you were told, that it's flat and stationary with the sun moving, stars moving above us in patterns or whatever, and you ask the question, well, how did that get here then? You come up strongly on the side of, well, it was intelligently created. That invokes God.
Well, I don't believe in the Big Bang Theory or evolution.
You have to if you think you're on a ball. You have to by default.
No, I don't.
So
you don't have to believe it, but that's what your reality is if you think you live on a ball Earth.
No, I just believe that God created the heavens and the earth.
That's incorrect. Big Bang did that.
Oh, I don't believe in that.
Okay.
And even if that was the Big Bang, I believe that God was that Big Bang.
So you're rebelling against your NASA overlord?
I don't have any NASA overlords. I barely even watch those guys. Only when they send the rockets into space, that's when I check in.
Okay, Castor, real quick. When it says in Job 38, I think 14 is it, that the earth takes shape like clay under a seal. What specific shape would that be if you press clay under a seal, right?
Sphere?
A sphere?
Oh, a sphere.
No.
Really?
No. It's
You know what a stamp is, right? You know what a clay stamp is, right?
Yeah, I think.
What is that?
That's
You
where
ever see when
they take
medieval
the ring
letters
and they
and
squish the.
Yeah. Exactly. They usually have a little stamp they have custom made for their family. When they write letters, they put a wax and then they put. It's always
back in the days.
Yeah. Go ahead.
Back in the days, they even used a mixture of clay to put that seal on stuff. So and it's a planar topographical surface. That's what the Earth is. That's what it's described in biblical cosmology. You can literally, even in heliocentric mainstream science, right? If you ask a scientist what is biblical cosmology, they will tell you it is talking about a closed system where there is a firmament and the Earth is a topographical planar surface. This is the very thing you read on Wikipedia. This is not something that is made up. There's a in the heliocentric paradigm, there's a specific explanation of what biblical cosmology is. So either you accept what is in the Bible, which is biblical cosmology, or you go with heliocentrism, which is not biblical, and it's also not biblical cosmology. It's actually the opposite to the Bible. It's as if someone wrote a creation story that is completely opposite. It's anti-biblical cosmology. It's anti-Christ.
Almost as if, right?
Almost as if, right?
Yeah, that's kind of curious. Seems like. What do you think about that?
Look, man, I don't understand why it's necessary to believe the place is flat. I don't understand.
It takes God away from good people. That's what it does, man. Takes the creator out of the situation. You're retarded fish monkey versus
I serve God. I'm a man of God.
Okay, so
if you're a man of God,
you're a little reproduction of God. That's what you're supposed to believe.
If you're a man of God, then listen to what the scriptures tells you, right? Test all things and hold fast, which is good, right? So what you gotta do is, if there's some fellow brother telling you that there's biblical cosmology, you should maybe take your Bible in your hand and test all things and hold fast, which is good. Right? It's not like we are saved and we become Christians and then we're like, well, we already have it figured out. No. It's a continuous process of collecting information. So either you want to collect information, want to reprove and corrected by the Lord, or you just want to adhere to whatever the world thinks and go with it because it's just easier, I mean, if I just accept what science says and I never question anything, well, it's the easiest. This is the easiest way, right? Just don't really require much thinking. Just accept whatever is presented.
Hold on. Check it out. Just like there's flat earthers that don't really believe in God and Jesus, there's globers like me that don't believe this place is from evolution and the Big Bang.
Yeah, and that belief comes from what other people say. So yeah, there might be flat earthers who don't believe in Jesus, but that's because they're very confused about the world around them. Everything's a lie. They can't trust everyone. All religions are fake now by proxy of them finding out that everything's a lie.
Why can't we let people be ignorant?
Enough of that shit already.
Sorry, again.
People suffer. People suffer because of that.
You can't do that.
I mean, if they choose to be ignorant, why can't we just let that be?
If they choose to be ignorant after being given the information, then that's a choice that they can freely make. But most people aren't to this information, are they?
being
Yeah, I'm
denied.
saying,
Hearing this, man.
there's some information in the world that is more useful than other.
To know where you're at in the universe and where you're from, I think that's very key.
I think if you understand that you came from God Almighty, that's all you need to know. Whether the Earth is a globe or if it's flat.
Yeah.
Instead of calling your God a liar, though, that's what you're doing. You can't do that.
I'm not doing that.
If it only matters that you came from God, why would you need a shape after that sentence? God made me.
Period.
On a flat
That's
stationary
it.
Earth.
God made everything around us. Everything that we know of and we don't know of. God made it.
Including the firmament. Yeah.
Did God make you have to know, like, stuff that you don't know?
Obviously not, because I don't know it.
Okay, so if you don't know where a curve's at and you couldn't find it, do you have to know that?
If I can't find the curve, do I have to know that?
Yeah, if it doesn't exist, do you have to know it?
Say that again?
If an Earth curve doesn't exist and you can't find one, do you have to know that?
No.
Thank
I
you.
still remember. I just believe the Earth is round. I don't know for sure. I haven't been in outer space to
Right, and you don't have
observe
to
the
know it's
curve.
round either. You don't have to think it. You don't have to know it.
Castle, check this out, dude. From the logic that would follow from one of your previous statements is basically if you know that you're a creation of God, you basically don't have to know anything else. Okay, so why do you bother with arithmetic? Why do you bother with knowing how to tie your shoes? Why do you bother any bit knowing any bits of your own profession? Why bother with any of that? It's a nonsense. It's a
There's some information that's more valuable than others.
I understand that. So here's the thing, though. Here's the thing. How do you assess what is more or less valuable than others?
Exactly.
Whatever impacts my life directly.
Okay, so what if there is information about the world that impacts your life directly that you just don't know about? How would you go about evaluating whether it is worthwhile learning about?
Well, obviously, everything has a scale of value.
Right, and more often than not, these days, people measure that by means of economics. So this thing, it brings home the bacon, or it helps me bring home the bacon. Therefore, it's more valuable than others. That's often the case today. Okay, so if you're weighing it by if I maybe subliminally you might think, oh well, this bit of information it kind of allows me to meld into this world that much easier, thereby not making me look like a crazy person to other people, and thereby allowing me more economic opportunity. That's something that somebody may adhere to. Is that a valid or worthwhile pursuit?
How is believing that the place is flat gonna fill my pockets?
I'm not saying it will, sir. My point is, just because it's information that is not necessarily something that would help you bring home the bacon or fill your pockets, it does not mean that it's not worthwhile learning.
It could fill your pockets, though. Look at flat earthers that do make money, or globers that make money off flat earth, round earth. So flat earth ideas can fill your pockets. Flat earth engineering should fill your pockets more than unproducible engineering of a ball, when everything you have to do needs a reference of stationary. So you need a stationary reference for everything. So yeah, you make money off that engineering off flat earth.
That's a good point, but it's not the importance of it.
Right, it's not the end all be all.
Yeah, all I'm trying to point out to you is, stemming from what you were saying before, God created us, that's all we need to know. That's not necessarily the case.
Oh, that was the other gentleman. I was just asking him to ask questions to pull some information out of him. Yeah.
Oh, yeah. I'm talking about Castle here.
Yeah, I know.
Yeah, that's all, sir. So, if this information is imparted to you and you find yourself in this room more often than before, there might be something to it. There might be something in you that's saying, what's this all about? It could be something that's worthwhile learning, even though it doesn't necessarily fill your pockets, for example.
Yeah. This would be something like learning another language or something. Yeah, exactly like that. I'm learning the language of the flat Earth. The flat earthers. Yeah.
But maybe not, it's maybe not the same or similar at all, because in practical terms, if you want to learn Russian, it's probably because you want to speak to a Russian girl or something. Like, there's actual practicality to it. In this case, if you're learning about this just because you want to learn how to communicate with people who think like this, sure, if you entertain the practice of just speaking to people about something that you don't necessarily hold to be the case, sure. But it's like if someone came to you and says, "Oh, 1 + 1 is 2," and you're like, "Nah, it's 3. No, it's 2. No, it's 3." Well, okay. Well, how do you reconcile that? And what is it valuable to learn that? Is there something to learning 1 + 1 = 2 that could be useful? You know what I mean? Like that's a possibility. So if you come in here and learn this stuff, there might be some utility to it. Maybe not, but just knowing it to be the case, if it is, which is why I'm here, is fruitful in and of itself.
You know what's more fruitful to me? Is creating new friendships and relationships with people of this place that we live on, called Earth. That's the most
do that on a
fruitful
ball.
thing.
Can't do that on a ball. You're not allowed to get along with other countries.
Yeah.
You're not allowed to get along with countries your country doesn't like.
Listen, man.
Castle, I definitely sympathize with that. I mean, me joining this room, and coming in every, almost every day now for like the last year, I've spoken to more people in this room and, got more personal with more people in this room than I have in a long time with, in my daily life. And the practice, practice.
It's really sad, man.
Well, I mean, hey, dude, there's not a lot of people around here that, are willing to talk to random strangers.
Why not, dude? Be the change you want to see in the world, man. Start talking to strangers, bro.
Exactly, I agree.
My point is, dude, my point is, even if there are a lot of people out there, not everybody has the acumen to speak on matters as difficult or controversial and thought-provoking as this, which is something nice.
Difficult. It's just retarded. Flat Earth stuff. It's just here for
somebody might want to punch you in your face.
This is just a meme.
Yeah, this is a meme channel. I hope you know it's a meme channel.
I hope you realize
Buzz Aldrin would want to punch you if you talked about flat Earth. Buzz Aldrin would be like, I'm going to punch you.
All right. So, guys, this is the moment of pivot, I think. We have some globies in the house. Maybe Castle. I don't know if that kind of, was sufficient for you. But, if you have anything else, there are other people here.
Hey, man, like I was saying, it's all good. You believe it's flat, I believe it's round, and yet we can still get along. That's the whole point.
But one would inquire as to why.
Why?
Right?
Because it's human nature.
No, yeah, but what is it?
Why?
But what is it?
Human nature.
What is? You have a nice voice, dude. You really do. But my point is, what is it that compels you to think that? That's what this room is all about.
Well, why is because we can meet each other in real life, have conversations, sit down, eat food together, and spend time together. That's why.
No, my point is, why would you think the world is a ball versus flat?
Well, I mean, it's just a matter of preference, I think, at this point.
Well, see, that's where there's a problem. Because if I take a basketball and I try to inflate it and I convince you, hey, dude, this thing is flat, you can demonstrably prove me wrong by taking measurements and, all that stuff. So there are things in this world that are subject to preference, but others that are not.
You know what I wish sometimes? I wish that we had the ability, like Superman, to just fly out into space and take a look around from out there.
You know, that I think would seal the deal, if that's even feasible. But unfortunately, we don't. Unfortunately, we don't. I don't.
One of the recent fucking Peace Prize awards went to a few scientists that basically proved that nothing that is being anything that is not being observed is non-existent. So
Shut the hell up with that.
I'm not. I mean, bro, I'm not the one that gave him the fucking Peace Prize.
I know, but do you think that makes sense?
It kind of does.
You think it kind of makes sense that if you're not looking at the pole, it doesn't exist, and you won't run into it if you still keep going fast? What are you talking about? Come on, brother. Come on, bro. Step with us to reality, away from the what if zones of nothing. Bob, just don't worry about how fast you're going. Look at me, and the pole won't hurt us. How come they don't put their money where their mouth is and do that? Say, hey, scientists, go get in a car. Drive at an object. Look away from it. Keep driving towards it, though, but look away.
But if he's looking away from it, does it mean that it's not being observed? It could be being observed by someone else, thereby it being real.
That not the people in existence towards that thing. So if they're the only people in that area and there's no one else to observe it, it can't exist in your model and your idea.
Well, I mean, it's kind of like it's kind of like the whole if a tree falls in the forest, does it make a sound?
No, it's not. Nothing like that.
It is though.
No, it's not. No.
I mean, does
Yeah,
it
but
make
the
a
guy
sound?
still crashes into the pole, whether or not other people are watching this guy do this goofy experiment.
A bird got hurt when the tree fell. So the tree got cracked. Something physically happened when that happened.
Sound waves move through the air and
Right. So when you're physically experiencing the attribute of reality, that's what you're doing. Just because you look away in reality, being a part of all reality, you're not going to stop reality. It doesn't make any sense. You know how many bad things wouldn't happen? People would just close their eyes. You know, when you pull the blanket over your head, that's what scientists do. They're like that little kid that pulls the blanket over his head and there's no monsters no more.
Hey, that worked though. Did it not work?
No, it doesn't, because there's still people in your house dropping all your stuff. No, it's not really Santa Claus. It's a guy not in a Santa Claus outfit taking black garbage hefty bags out. No, it didn't work. The monster's still there. But he said,
like glass
shut up, little kid.
looking stuff.
And he said, shut up, little kid. If you be quiet, I'm just going to take this stuff and leave. And, you know, that's what happens. He leaves the little kid alone. He just takes the stuff and he leaves. Santa Claus, you know, backwards.
I want to take this about, I think 2 or 3 topics back, but to be a flat earther, because I heard a couple of you guys mentioning that, to be a flat earther, do I have to be a theist?
You don't have to be.
No.
You don't have to be anything. You know how to measure? Do you know how to measure and use a plumb and a level? Yeah. That's what you'll need to be a flat earther. Angles, math, flat, horizontal horizons, plumb bobs, and levels. And they all equal out to be horizontal with water. Not the dirt. You know, the dirt can do a lot of stuff. I can kick a pile of dirt and change the shape of it tomorrow. So the water, though, I can't kick the water and change the shape of the surface of water. It'll still be, it'll still be the water when I take my foot away. So water lies horizontal. So if you know about water and how it's horizontal, that's all you need to know. It doesn't matter what else you think.
Is there anybody here that is a flat earther and is also atheist or agnostic?
They don't come around often. Be honest with you.
I am a flat earther, and guess you could say closest to agnostic. I don't believe that the Christian Bible is the Word of God, but I know we were created. It's self-evident.
Same here. I think it's the most known unknown. It's something you'll never have the answer to, but you always want to. And that's same for everybody. Like it or lump it.
You don't have to be a theist, but it lends itself like this was something that was created, whereas the ball Earth was a total accident. One option is God made it. Yeah, one option is that God made it all happen, and the other option is that Big Bang, you're just an accident, retarded fish monkey. You're lucky to be alive. You're going to die any moment from an asteroid impact or some shit like that. So, or disease outbreak.
Evolution could stop working on you.
What necessarily is wrong with that line of thinking, Dr. Jason?
What's that?
Like, what exactly is wrong with that line of thinking?
Well, the thing is, if it's wrong, then it's extremely harmful, especially to teach the children.
What you're forgetting who you're asking the question to. So you're trying to shove your cosmology creation story into a now flat Earth. A flat Earth that isn't a ball, that isn't rotation around a star existing within the galaxy, the universe that's been created by this Big Bang or new creation story. So it's something different that created it. So when we start trying to understand that question, when you're asking us flat earthers who understand that the Earth is flat and not what we've been told, the creation choices become a little bit different. Nature creating itself in this system, most people don't see that as possible. So they come to understand it was definitely intelligently created because they can't explain it themselves, not the whole entirety of reality, right? So God did this. Some people, like has been said, agnostic, have a different idea. Don't lean towards the biblical cosmology or the biblical idea. Have different ideas. Muslims, same sort of thing. Lots of people have different.
Like, not to throw any shade on you or anything like that, Dr. Jason. It's nothing like that. But it's just like, I feel like that's what deters me away. Is like when when you kind of start going into that rant, because I feel like Jedi, the way he speaks is like it's more.
You know what I mean? I mean, I'm not saying whether I believe in this or not. I'm just saying this is the religious beliefs. I can't stop them from believing like this. It's just that's what happened.
Yeah.
So I'm not saying you're throwing me under the bus because I mean, I may or not believe the things I'm telling you, but these things are what everybody in the religious community generally hold to be true. See, so you can be religious and heliocentric, but people love to be atheist on a heliocentric world because they love to imagine that it all goes black when they die and you don't have to worry about anything because it's a trauma situation from day one. You're put in your crib, you look up, you see what are those, a gondola of stars with the planets and shit right above you. Those are popular. Then you go to watch the TV, the cartoons, and every cartoon has a ball Earth in it. And you watch a movie, and every Disney starts with a dome. But then it shows you a ball. It always shows you a ball, and then you go to school, and it shows you a ball Earth, and it explains to you that you're in a very dangerous place. And at a ripe age, they will tell you that they'll pull you aside and be like, "Hey, you know that an asteroid can just obliterate us in any moment? We wouldn't even know. Or there's a black hole flying through space right now. We can't detect it, and it'll just swallow the entire." And that right there makes you deal with your mortality as a child. It's a whole, and if you do that to an entire society, first of all, you just tell them, hey, there's asteroids out there. Who can protect you besides me? Me being the government now, right? So it makes these people very reliant on the government right off the bat. And that's probably why they get $50 million a day for their budget. So, yeah, I don't know where I'm going with this. It's just it's a whole web of shit, man.
I just think it's weird. Airplanes can't find the curve of Earth.
Oh.
They need to be a rocket, and they need to go up in parabolic flight, and then they need to come down, and then to find the curve, and then they got to be going 17,000 miles an hour to get down past it. Isn't that weird?
Let's go over it though.
It's just rocket surgery. That's all. So what are airplanes flying over?
Wait,
They can't.
I guess I have another question. Like, is it just Earth that's flat, or is it also all the planets in the sun?
I mean, what planets?
When you look up there, do you see people and airplanes and grass and stuff and an Earth up there? You see an Earth up there above you? I don't think so.
We don't know what those lights in the sky are.
Okay. I was like, I was waiting for an answer.
Yeah, that's all. We just don't know. We don't know what it is. You don't know what it is. Nobody is. You got a team of people that have speculated their ass off based on some optical illusions, and we have, the same speculations, but done in a different way.
Same as the UFO. It'll be a UFO light, a UFO material, a UFO ship, a UFO triangle, UFO. It's all UFOs, no matter what it is, and they have no clue what it is, whether they see it above all the streets in Texas for 15 hours or not. Nobody knows what it is. It's a UFO. But then they want to tell you they know what all the stuff in space is millions of light years away that they can't even get close to. But the stuff floating above the road, they'll never know what it is.
I guess what's the closest hypothesis that flat earthers have as to like what is like what we see, what we observe in space?
Quickly lights.
Lights in the sky we can't verify.
Yeah, everything's unverified. We're only going to be talking about a small amount of things, right? Like, are they flat? What's the surface description? But they appear in a certain way, but we could only verify it by going to it and measuring it. Not like the Earth, we can measure that. But these things we can't measure, we can just look at. They appear to be spherical, but we can't confirm it. They could just be circles, they could be concave. We don't know a lot of things about them. So it's hard to come up with a hypothesis because it's all speculation.
Mm-hmm. The truth is, they could either be what you say and very far away and huge, or they could be smaller and closer. Those are two things that can be true.
I guess if it had to be closer, though, it'd have to be like tiny, right? Like being farther away would make the most sense.
A mega star like you think they are, just a smaller light that's, smaller and closer. Bit farther away and bigger. That's what you're using our perspective as a way to do trickery on us. Damn near every reason you think you're on a ball could easily be explained with some atmospheric conditions that you didn't understand, or some science that you thought was science, but actually it's ancient fucking parlor tricks. It's made to trick the townsfolks. Like any person, like I can see what's going. Maybe this. Oh,
So
speculate on it.
So the luminaries don't play like we're completely clueless about it because during generations people have aligned landmarks, use them for navigation. The luminaries move in cycles. The sun has an effect on the medium that we're in, so people kind of follow those cycles to know, the farmers when to put the seed on the soil.
Yeah, I mean, like even like in like Mexican culture, like we were able to do like one of the most accurate calendars ever.
Yeah.
Yeah. So the luminaries work, bro.
Yeah, but didn't that calendar end on a certain date?
Yeah, it did, but that was because that was supposed to be the
So how the fuck is it accurate if it ended on a date and time continued?
No, because the way
it didn't end it.
Yeah, but the way that the years work and like in terms of like Aztec and Mayan culture is like that was supposed to be the end of that world, and then there's supposed to be a new world that's going to start. Yeah. So it still continues, but that's the end of like this year or like this human age that we have, and then that was going to be the mark of the next cycle. Yes, exactly.
Oh, okay.
Yeah. So it wasn't that they stopped because they couldn't do any more calculations. It was just in terms.
Yeah,
of
when you finish drawing a line, doesn't mean that you cannot keep going drawing the line.
Yeah.
It's just,
Yeah.
So the variables that are missing is that we cannot go up there and verify the mechanisms of the luminaries and the mediums that they're in and whatever is behind the luminaries. We can observe and see the cycles and silhouettes of things up there, and it kind it can be it can kind of be constructed almost like a like a clock, some type of clock, very complicated, that moves in, the daily, the sun, the moon is like a weekly, monthly. The wandering stars or the planets move in their cycles as well. The radiance, the north toroidal, the south toroidal, all those things are kind of like moving like gears of a clock, and they have cycles within cycles, and we can observe that, but cannot determine the actual mechanism that is actually moving. There's a lot of speculation. If you look through cultures, people, you guys spoke about God, and people say, yeah, he's a creator, he's a design clock, and God is at the center, or God created it, that kind of stuff. He's saying fuck.
Oh, my bad. I just died. I was sorry.
So, if you look through many cultures, they speak about the luminaries. And like it was being said, many landmarks and pyramids and structures are aligned to them, and many things in the ground kind of pointing that the ground is stationary, because there's so many alignments to the stars, and they have like ground positions. So yeah, it's not like we're completely clueless about them, but we're still missing a bunch of variables that then the globers are trying to tell you that they know the distances, the sizes, the makeup, all of these extra things that they claim they do know, but in reality they
because I guess like that's where I'm having like also trouble, right? Where it's like at least in the scientific field, they have like this proposed idea of like how everything works and how everything seems and everything like that, but I guess like in terms of flat Earth, like I'm still confused as to like why, if flat Earth is flat, then like what is everything else? And in terms of like how, like where Earth is exactly in like in space, it's like, is it just not moving at all? Like it's just stationary, or is it still moving? I guess
it's almost like it's a construct, and you're standing on the floor of creation. You're standing on the floor. And this is the realm we're in. We're confined. It kind of looks like we are confined based on the gas pressures and the laws of thermodynamics. It's kind of like we are kind of in a contained environment, almost like a huge terrarium of some sort. But then when we look up and we see the heavenly bodies or the celestial stuff, there is a thing of wonder. Because all generations across the world, all civilizations have wonder about that and make stories about it, just like the globers or the geocentrics or the heaven-centric or whatever cosmologies that you can look, all of the civilizations, everybody has wonder about the luminaries and how that work. So that realm up there, you could look in scripture. People, you say you're agnostic or something about religion, yeah.
Atheist.
There's many religions that talk about it, so you can look across all of the religions that still be agnostic. And but people speak about a great design, a great construct. Like it requires a great an architect, a designer to the design, a creator to the creation, and that's pretty obvious. It's just that some people give it names or give it certain human attributes and say, I know who the creator is, I know he said that, and then some people believe it and some people don't believe it. And the other guy next to that one has another idea. No, he says this and he says that, and this is the creator. That kind of stuff.
Some people say that they're God's chosen people, and crazy.
Boy. So I guess is the only way that I can really kind of put forth is like to look at different religious cultures to see what, or like different cultures, what they say about like, what they hypothesize what's out there.
When you converge it into a point, it all points out that there is a design environment, like a construct, and logically follows that if there's a construct, there has to be some architect, some designer, some creator. If there's a code, there has to be a coder. You see? So that's why, like most people for all generations, from all civilizations are kind of believers of there's a creator or a designer or a god, you can say, based on the logic that follows on a. If you're inside a car, you know there has to be an architect that created that car. Or if you have a watch, you're holding a Swiss watch, and you see the hands of the clock, the dial, the gears behind the dials. You know that you could grab all the pieces of that watch and put them inside a box and shake the box, and you will never get a watch unless you have a watchmaker that puts them all together specifically, piece by piece, and make the watch work. Make the watch what it is. You need someone to put it together. Just like the car, just like the design of your body, the design of this world, whoever created the laws of this environment, the laws of nature, or the antecedent to the container, because you're breathing air, and the force of gas pressure is the force that the gases exert on the walls of its container. The creator of the container, you can also follow to that, or the designer of the container. Because just like the watch has a bunch of pieces. Just like the watch has a bunch of pieces, different gears that make the watch work. This environment also has a bunch of variables, a bunch of things that all together make the whole machine work. And you look at the sky and you see the luminaries. Even the Swiss watch is designed after the luminaries. So the watches that you buy, to be accurate, they have to be adjusted to the movement of the wash of the sky. And that's kind of like a telling sign that there is some type of design. Go ahead, guys.
Flat Earth, pedophiles.
You scared the fuck out of me, man.
You said pedophiles? Files of bread? What did you said?
No, the guy was a troll. He just came in and said that and left. All right, guys, you have a wonderful day. I gotta go and attend a birthday party. I'll see y'all later, please.
Birthday
Take
party.
care, man.
Later, dude. I'd like to hear that guy sing "Happy Birthday." If he sings the shit out of it.
Oh, is it okay if I ask another question? I don't want it to seem like I'm the only one asking her.
No, you're fine, bro. You're breaking the silence.
Another question? You just asked one.
Hey,
So you got another one?
I'll sit back down. Sorry. So gravity, like, so that's real, or like I like what holds us down?
There is the actual phenomena that we observe. You know, we have a gradient. Things go down. Things go up. Gases go omnidirectionally, right? there is the phenomena that everybody observes and experience of. But when you say gravity, is that real? What is the actual claim? Are you saying the claim of the globe is that gravity is this warp and bending of space-time that is causing things to form into balls?
Well, no, gravity is the the theory of things that have mass.
Theory. Scientific theory?
I mean, well, it's a theory, bro, just like everything else.
Yeah, but
nothing is fact. Everything is theory.
A scientific theory will be demonstrated and verified with experiment. That's how you have scientific theories after experiments. After it has been verified and experimented with many times. And you don't have that with gravity. With the claim of the warping and bending of space-time.
Well, the whole space-time thing, I'm not buying into that, but I do believe that things that have mass attract things that have less mass towards them.
Well,
do you mean like?
Because I might be a retard for saying this, but like that's just the way I feel. It seems to make logical sense to me that if something has more mass, and it passes by an object that has less mass, that it would have a pull.
Passes by. So when you pass by and the fat lady at the store, you feel attracted to her because of she's massive.
Yes.
Or whenever she passes by the big cereal box, she feels attracted to the cereal box.
Hell yeah, bro! Shit flies off the shelves into her cart, bro.
Yeah. Do you actually see that in nature? You see rocks attracted to the rocks. Rocks. That rock is falling because it's being attracted to the other rock.
Well, I mean, the reason I was asking that question was because, like, I was wondering in terms of like flat Earth, like how do we stay here on Earth, and then how do satellites remain in space?
Well, flat earthers don't believe that we've gone to space.
Bro, is he asking you? Is he asking you the question? Do you think he's asking you?
I'm sorry, bro. I'm sorry. I was just trying to, be on your side for a second.
You're speaking for me.
No. I was trying to be on your side.
But
not speaking for you. I can't speak for you. That's not possible.
Exactly. Yeah, that's not possible. But he's asking about the side that is not the globe-centric idea, and you're trying to say, but this is how it works in a globe. This is how it works. Mass attracts mass. Even though
no, I didn't say that that's how it works. I said that that's what I believe. There's a big difference between how it works and what we believe. What you believe and what I believe might be different, but neither of us have a fucking clue on what truly is the truth.
Have you the guy that asked the question? Have you heard of this mass attracts mass? Have you heard of that?
Yes.
Okay, so he heard it already. He heard that version. Now he's asking the other side. Are you gonna give him the other side? Go ahead.
Okay, I'm sorry, bro. Look, I'll just get out of here. I'm not trying to get in on your thing, bro. It's all good.
Just tell him.
He gone.
Mass attracts mass. The massive lady at the store.
I like that one. I like the mass attracts mass argument because it's very easy to dismantle. First by asking what is mass.
That was his argument, but he's gone now. So it was like I was trying to say something, and he just derailed it to mass attracts mass, which is not a thing.
Yeah. Not sure if Pensive Blur holds that view.
Well, then what's keeping everything on the ground?
Good question.
Yeah, that's what I was just trying to like.
Everything on the ground. I see clouds. They're not on the ground.
Yeah, not everything is on the ground, dude.
Exactly.
Okay, what's keeping the things that are on the ground?
Because they're made of physical matter, and they're suspended by the surface below them.
Yeah, at best, what can be demonstrated is when you have an object that is denser than its surrounding medium, it tends to go down, and the opposite, when it's less dense, it tends to go up.
I mean, is it possible to just break out of it, like just keep going up and up and up and up to the point where, like, you are out of Earth?
Well, that presumes there is an out to begin with.
You might be able to go out, but to go up, but let's say we live in a contained environment. What if you can't get out? Go out, but what if you cannot get out because we're contained?
So like the Truman Show kind of thing.
Oh, Truman, he got out, didn't he?
No, but I'm talking about the world he like lived in. Like you're saying, like that kind of containment.
No, not like the TV show. No, I don't think so.
Do you mean like a physical sky?
I just mean like what kind of containment? Like I'm trying to like
What are we containing them from? What?
Because my question was like, can you keep going up and up and up to the point where like you go to space, right? But I forgot who it was, but someone brought up like, oh, but like break out of what exactly, and like what if we're contained? So then I'm just trying to clarify on that.
Because we don't really know. The one guy said there might be nothing outside, or how are you gonna know if you can't even get out? How are you gonna know if there's something outside? Maybe looking through the window and see things outside, but what if you cannot get out through the window? I don't know. This is a lot of speculation. You want to bring? I don't know. Go ahead, guys. You want to reply to him?
Well, I mentioned it, so maybe I can follow up there. I mean, there are clues, right? So if you have a worldview that there is an out versus there is no out, we first starting from here. What do we have, right? Well, we have, for example, the air that we breathe, and we know that gas requires containment in order to actually have pressure. We do have pressure, therefore, there's some sort of containment to that gas. Right? Or not. I mean, there are people who argue, oh, gravity keeps it in. But how has that been demonstrated? So little things like that.
I guess like I guess I'm still just confused, because then it's like I'm trying to like think in my head, like how does that, like I'm trying to think of like stuff that we can observe from space, right? So I'm like thinking about like asteroids, or just like, I guess asteroids are like the main thing that I'm really thinking about right now.
So when you think of an asteroid, what do you picture? A giant rock?
Lights is what you see.
Yeah, what do you actually see, and compare that to what is shown to you via another, like a photograph, quote unquote, or an image?
Yeah, it's like a light streaking.
Okay.
So you see a light, and then people draw a cartoon and say, that light you see up there in the heavens above, this cartoon right here, that is a rock.
No, like an actual light streaking.
Well,
yeah, but that's what I'm saying, that the idea is that when you observe the light, the natural observed phenomena, that's one thing. And then people with ideas will tell you this asteroid is this piece of rock, of ice, or whatever, and that's what you're seeing up there.
I'm trying to take that perspective out of it. Like, I'm not trying to put it as in like, I'm not trying to think of an asteroid as in like, oh, like it's a piece of rock. Maybe using asteroid
billions of miles away.
No. Like I said,
going through the vacuum of space. Yeah.
I'm
just saying that's what they say. Yeah.
Yeah. No. But I'm trying to view this in terms of like, flat Earth. So it's like, how do we explain for that phenomenon, and then also like a contained Earth?
That's a good question. There's a lot of speculation that's gonna go with that, with any reply to that.
And one thing I would. Oh, sorry. Go ahead.
Well, I said you said you had one thing. Go ahead.
I was just going to say, like, one thing that you may want to consider is, like, some people oppose this idea whereby, oh, okay, you have an explanation for this thing, whatever this thing is, whether it be true or false. If someone comes to you and says, oh, well, that can't be true because XYZ reason, right? Somebody might say, oh, well, unless you provide me an alternative explanation, my thing is true. Wherein, in the first place, it was never proven to be true to begin with. So if you can uproot yourself from that kind of thinking, right? If someone comes to you and says, oh, well, we don't actually know, it doesn't validate the prior assumption. You follow? So from there, you can say, oh, well, who knows, and be okay with that. Because I think a lot of people hold that position for a lot of things. And it is valid. So, to put it more poignantly regarding this asteroid thing, if someone tells you it can't be a rock, or it might not be a rock, are you going to hold that, oh, an asteroid is a rock because that's what we were told before and NASA must be correct? Or would you say, oh man, it's a good point. We do just see a light in the sky, and putting together a bunch of things that we do know that probably can't actually be true. Yeah, but unless you tell me what it might actually be, I'm going to cling to this rock thing, even though it goes against everything else.
Yeah, and then I think just mentioning the word asteroid was probably my mistake, because like I said, I'm just trying to put myself in the perspective of if I were to believe flat Earth, in that term. So it's how do you guys have an explanation for that streak of light? That's just pretty much it.
You can have light going through a prism or series of prisms, and when you look at an asteroid with that phenomena, because that phenomena is kind of like a specific one. There's many phenomena of the sky, right? But the asteroid ones are kind of like a specific one that are labeled that. And you can have light going through a medium of, let's say, liquid, and then glass. Like it could be like light, some type of light refracting or passing through a prism, and then you can get the phenomena that you see as an asteroid that you see. When you look at the asteroid, the photography, it's almost like it's light going through a hole, and then you see lines of light that is coming from that hole of light. Have you seen the photography of asteroids?
Photography of asteroids? No, I have not.
Yeah, actual photos of them, like real high quality ones. You see them it's almost like, when you shine light through water and a prism, like let's say you're shining water through a glass of a drink. Let's say you have like a cup, water and ice in that cup, and a glass, right? And then you shine a light through the from the top, and it goes through the liquid, the ice, and the glass, and then on the table you see like a light on the table that is the result. You see like the prism. You see the colors of the light on the table.
How far away are these asteroids?
Good question.
The high quality pictures.
I don't think there's a way to. No, high quality of the phenomena. From the ground,
okay.
People take photographs of them, and they look the way they look. Let me see. I remember looking into some photography some time ago. Let me see if I find some. It's just the asteroid phenomena is one phenomena that has explanations and claims about it, but just look at it and you're gonna.
But pretty much, I guess what you guys
about
are trying to say is right now there isn't really anything to really explain, I guess, that phenomenon, right?
Light going through mediums, and you at the ground, the observer, are looking at it. They look like lights. Like you see the colors, you see the prism, you see the colors of the rainbow in the from that light that is coming. So it looks like light.
But Pensive, the thing is, like, you bringing up, I think you bringing up asteroids was not necessarily a mistake, dude. What it does is it kind of serves as like a stepping stone into understanding how I think you perceive the world and how you would go about your worldview, you know, in discussion with people. Right? It seems like again, like I was saying before, unless somebody else shows you an explanation, as fantastical as it may be, or even equally on par in terms of phantasm or fantasticalness as the alternative, the mainstream one, how would you go about adopting it? Or how would, you know what I mean? Like, it's not an issue per se. It's just, you know, think about it and apply that to everything else that we talk about. You know what I mean?
For me, it was just more so like, what verbiage can I use to like really, like, you know, explain what it is that like you know, to explain the phenomenon that I'm talking about. So like the best word I have to use is asteroid, but I didn't mean to use asteroid as in like, oh, like it's, you know, it's a rock as like depicted, or like as like science describes it. I just meant it more as in like, how do you describe an asteroid as in like that streak of light? That's what I meant it more as.
No, those people that describe the asteroids and give you like cartoons and rock art, those are not scientists. Those are artists. They're giving you because remember, you and I from the ground with telescopes or even the observatories, huge telescopes, right? They look at the light, they observe phenomena, right? And they see what you and I see, the same thing. Okay? But then the artist tells you, oh, this is what we believe it is, and they draw you a rock. That's not a scientist, that's an artist drawing you a rock.
Yeah, and they might say something like, oh, well, this is the best explanation that we have. But in that phrase, they're omitting the fact that it might be the best explanation that they have fitting in their worldview. Right? The worldview that is of, you know, a giant ball spinning through outer space. Oh, I mean, what else could it be? You know, if we're outer space and there's things flying by, you know, what else could they be but rocks? You know, I mean, that type of reasoning. So if we were to attack that worldview from the bottom up, you know, anything's. I'm not going to say anything's possible, but you know, for all we know, like, who the fuck knows? Really, you know.
Definitely none of these globe guys. They don't know anything.
Yeah. Well, if, your original question was, how do we have like people walking on the ground while at the same time having satellites orbiting above us? And that's really what we need to examine: is what are satellites and what is an orbit alleged to be?
No, it's gravity. That's why.
It's gravity.
I think
the satellites are gravity. Okay, yeah, sure, buddy.
That's your answer.
Satellites is gravity. That was the guy's answer. Satellites is gravity.
No.
I think the gravity thing
is the reason for why there's people walking around, and gravity is also, it changes in space. Did you know?
When you say gravity, you mean like a parrot? Gravity.
Why?
What are you talking about?
Go ahead. I think Jedi wants to talk. Jedi, you're cutting out a little bit, Jedi. So I think that we're jumping on top of you.
Whatever you said. Shut up.
Socky 10 Ducky do.
Jedi wants to reply to gravity things. So, you want to try, Jedi?
I don't know what you're saying.
He jumped out for a second.
I think you're too black sounding.
In the interim, I think what Jedi was going to ask is, what do you actually mean by gravity? Because there's people that would come in here and describe the phenomena of something falling, right? The observed phenomena as being gravity versus the cause for why that thing goes down, right? So when you're using the term, which are you referring to?
When I say gravity?
Yes, sir.
Well, when I say gravity, I mean the thing that pulls something towards the planet's core.
Okay, so what would that thing be, and how do we
for example,
how do we know that?
Human.
How do we know that there's a thing that's actually pulling something down?
You're not floating.
in and of its own right, like a standalone quote unquote force.
Okay, why are you not flying right now?
That's not my question, sir. Are you gonna answer?
my question.
Okay, so are you gonna answer mine?
No, I'm answering your question with a question.
No, that's not how this works. Sir.
Yes, it is.
No, it's not. I'll tell you. I'll tell you.
This is a different guy from the other one, right?
Yeah, maybe not. But I don't care. At this point, sir, the point is you're the one in here making a claim that there's a thing called gravity. So the burden is on you to support your claim, sir.
The burden?
Yeah, if I tell you water's wet and you ask me why, and I show you what happens, it's my responsibility to do that, right? I said the thing. So you said gravity. I'm asking you what it is and how do we know it to be whatever you're claiming it is.
Are you trying to say gravity is not real?
You did, sir. Hang on. So you didn't explain jack shit. You said one word.
Hey, language.
What do you mean I didn't explain? I said it's something that pulls something towards the center of the earth.
Thank you very much. So I'm asking for, thank you. So I'm asking
exactly
for
what I said. I didn't say one word. You fucking imbecile.
You started with one word,
Listen
and
when
then I asked you for
instead of
support.
Yapping.
Dude, I'm asking you. It's effectively one word because there's no substance to that.
How
Okay, so I'm
is
asking
that one
further.
word? It's
I'm
not a
asking.
sentence.
I'm asking for. All right, can you listen, please? I'm asking for clarification.
You're obviously not listening.
I'm asking for clarification and validation to the claim. How do we know this? There is this thing to begin with, and what has been done to validate it?
Science.
Okay, what did they do?
There's that one word thing again.
Scientists are they?
Oh, okay. So what did they do, and how did they do it?
They discovered it.
How? Because you would think if there's okay. So watch this, right? If you'd think that these professionals, being scientists, would perform what they would call science, i.e., following a certain methodology, right?
I think they'd rather do experiments.
Well, thank you. So that methodology would be doing experiments. There's standards, procedure for that, and then they
We can
publish
just
their
cut to the
findings.
chase. Like, do you know or do you not know? Like, do you just have some sort of vague idea?
Sounds like it.
You're talking to me.
Yes, sir. Because you're the one that's pulling the shit out of your ass.
I'm not
He
pulling
said he
anything
pulled gravity out his ass.
Sounds like it.
Sir, the thing is,
What do you
listen, he doesn't get it yet. The thing is that you're saying these words, gravity, science, like slogan, but do you actually know what those words actually mean?
Do you know what a slogan is?
You see, okay, let's make it. Let's make it. Let's make it. Let's make it. That's not what we're talking about. Now you're gonna give us definitions about slogans when we're asking you about what you actually meant by the other
I'm
word.
trying to teach you the language.
Okay, but we're not asking about that. We're asking you about the other stuff, not the. Not...
Because you obviously don't know.
Yeah,
it very
Jordan. Hey, Jordan, do you want to be in this chat?
Oh my god.
Do you?
Say that again.
Do you want to be here or you don't want to be here? Which one?
Do you have Down syndrome? You sound.
Yeah, he doesn't want to be here. Put him on mute, someone. Yeah, he's an idiot. You're an idiot.
Yeah,
You
this is
sound like an
painful.
idiot.
Yeah, I mean, like,
come
you're sitting there,
on, family.
like, fucking with people who just boot you out of here. It's like, what do you think's going to happen?
Dude, stop speaking to me like that, man.
What?
Wait, so you believe gravity doesn't exist?
You believe gravity doesn't exist. What is gravity?
So you're just not going to answer my question.
So I need you to define it before I can tell you whether I believe in it or not. What
You
do
sound like
mean?
the other parrot. Instead of just saying gravity like a parrot, gravity, paka, you have to answer Jedi's question like an
Because he's not
actual.
answered mine.
Go ahead, Jedi.
You've claimed that it was science, or science has proven it.
I didn't say any of this. I said, do you not believe in gravity?
Yeah, no. We're going to walk you through the steps. Why?
Okay.
Okay. I mean, there's two. We can choose from either one within your paradigm, right? I'm kind of asking you to define which one you're talking about. Is it mass attracting mass? Or is it the bending of a space-time fabric? 4 dimensions. 3 dimensions.
Mass attracting mass.
Mass attracting mass. So the first one, not the second one. Newtonian physics that was debunked in 1915, replaced, superseded by Einsteinian physics, or the other reference. So you say that there's science.
Yeah.
Okay, so that would mean that there will be a hypothesis and an experiment, correct?
Mm-hmm.
Good. So what's the hypothesis?
Of what? Gravity?
Yeah.
I am.
You know what a hypothesis is, right?
He's looking it up.
He's got to consult the oracle. I mean, just tell us what we're dealing with right now. Like, are we dealing with someone who has to like look this shit up on the fly, or are we dealing with somebody who has a pretty good understanding of this already? I think I know the answer.
This is where the parrot analogy comes in. When you say a word, gravity, paka, but now he's looking for the meaning of it.
How could you guys not know gravity? Everybody knows gravity. I mean,
really?
Well, I mean, that's what he was waiting for everybody to just nod their heads and be like, "Yeah, it's gravity." Wait, let me look it up. But we're all supposed to know it. I don't know.
Well, let them tag team. Jordan brought up the gravity. Jordan, can you help your friend here? He was saying gravity.
Yeah, but Jordan's sitting with his friends in like a room right now, and he's like trying to show off. He sounds stupid.
No, I'm in a different country.
Whatever. You're still sitting with people and sound stupid.
I'm not sitting with anyone.
So can Jedi's gonna ask you again. Go ahead, Jedi. Ask Jordan because the other guy is looking to answer you, and he's taking a long time.
Okay. When we do natural science, we apply a method. That method starts with a hypothesis construction. We observe something. We can apply the scientific method. Anybody who applies the scientific method is a scientist doing science. This is what science is when you do it, following the method.
Just asked if you're a scientist. It's a yes or no question.
Yeah, when I do the method. Doesn't matter. This is what the method says. So first step of that method, understanding we're doing natural science, the study of the physical natural world, is to observe something happening. Observe a phenomena. We're then going to ask a question. Question is, what caused that? How and why? We're going to make a prediction as to what caused that. I'll presume cause, we predict, will cause the other thing to happen. The other thing happening is the dependent variable. Your presumed cause is the independent variable. You've just created your hypothesis, your prediction. Then carry your prediction forward into an experiment. So we're asking you with gravity, how are you building your hypothesis? What have you observed in the physical and natural world? And what is your presumed cause?
Well, basically, everyone in the world believes in gravity, which is part of the reason why I do as well.
Mm-hmm.
And it's what I've been taught.
Okay.
So like a religion.
Not like a religion, no.
So far, it's very much resembling a religion because you totally didn't not address Jedi's question. You missed it. You had the opportunity to show that it's not analogous to a religion, but instead you demonstrated that it is by saying what you said. I just believe it because everyone else does.
And it's still to Gemsy's. I mean, listen, it's like going to we still don't know what it is that you believe. What is it that you believe? Like this thing, gravity. It must have words to define what it is. What is it? The thing that you believe that everybody believes.
I've already told you.
Yeah, you told me it's gravity. What is that?
No, this is gonna be the third time I say it. I believe gravity is something that pulls something into a planet's core. Write that down.
Something. Is it like a spirit? Is it like, you know?
Well,
But it's something, right?
I mean, that's quite something for sure. Like, in order to now put that through Jedi's scientific method, you would need planets and cores to start pulling stuff and be like, oh yeah, I see. That's what you believe? You believe somebody grabbed planets and cores and like manipulated them to see that they pull each other?
I don't believe it.
And that's gravity now?
Yeah, we didn't ask you what you believed.
The planet.
Yeah, we didn't ask you what everybody believed. We asked you to go through the methodology of the scientific method to talk about your thing about gravity. We're asking you.
I haven't done any experiments on it.
No. Do you know any? So you don't know of any experiments that have been done?
Nope.
Nope. Okay. Would you know what an experiment was?
Like of an example of an experiment on gravity?
Any type of experiment.
What, any type of experiment?
Yeah, would you know how to formulate a hypothesis and carry that through into an experiment?
Yeah.
Okay, cool. So you do know the scientific method then?
Well, yeah, I've been taught it in school.
Cool. So when we apply the scientific method to this question about gravity, we fail using the scientific method. There is no scientific experiment that proves gravity.
How come?
Because there's no scientific experiment that proves gravity.
What if you jump?
That's the phenomena that we're all scratching our heads as to what caused that.
Well, it's gravity.
So let's apply the method. All right. Things fall to the floor. Okay.
Yeah.
It's your phenomenon.
My answer is gravity.
Yeah. So your prediction for that is gravity. Okay.
That's my answer.
What's gravity? If you're going to say it's the thing, if you're going to say it's the thing that makes everything fall to the floor, that's circular reasoning. You have to understand. Yeah. So you understand that in a hypothesis, your prediction is something that you're going to have to vary and manipulate because you're going to have to experiment on it. You've got to vary and manipulate whatever gravity is. So you have to define it. Gravity has to be a physical thing for you to physically interact with it. So
it is a physical thing.
It's even worse.
Hmm?
I was just going to say on Jedi with the circular reasoning. It's even worse if you're saying like the effect something falling, right, is gravity, and then saying, well, the cause of something falling is the effect of something falling. You're saying it's both the cause and the effect, which is definitely not science. So yeah, you already had that. No, that's why I didn't want to even go in. Go ahead, man. Go ahead, Jedi.
So you said earlier it was mass attracting mass, right?
Are you talking about gravity?
Yes. When I gave you the choice between Newtonian and Einstein, one being mass attracting mass.
That was another gentleman. That was another gentleman. Yeah, but I think that's pretty much what Jordan's saying. Yeah, he said it's like something that pulls another thing towards the center of a planet. So he's basically describing Newtonian physics.
I'm describing gravity.
Yeah, from this way of thinking, there is another way of thinking. This mass attracting mass.
Ways of thinking.
Yeah. But you've decided it's this. How much do you know about this? Maths, whatever that is. What's mass?
Mass?
Yeah.
Well, I didn't say anything about mass.
Okay. So you don't know much about it, you just say that it is, and then use words like the scientists have proved it, even though you don't really know what it is.
Yeah, he doesn't know.
I never said anything about mass.
Yeah, so he doesn't know. He's got no idea, man. He's no idea what he's talking about.
No idea. You can't just put words in my
mouth. But Jordan, the issue is it's entailed in your like belief of gravity of a planet being a mass that's attracted to a core of another planet that's another mass. It's entailed within
the word mass.
You don't have to use the word. You can use the understanding of it. Yeah? So you're saying a planet, a thing. You call it a something. It has other words.
I didn't call it a something.
Yeah, something does a something.
Yes, you did. Don't lie, Jordan. You did call it a something.
Lying.
Like, yeah, quote. We can put it in quotes, dude. This is recorded. We can go back and fucking listen to it.
No.
Yeah, dude.
You're fucking lying.
So would you rather just like, because it doesn't seem like you want to go, like you don't want to know. Is it you'd rather not know? Like not knowing is better?
No what?
Yeah, anything. Like you're like, listen, how do you guys not believe in gravity? How do you not know that gravity is this thing that's doing this thing? It's something doing something. And it's like, okay, well, let's talk about it. And you're like, no, I don't even remember. I didn't say words. Words don't mean things. And do you not want to know? You don't want to know anything?
I'd love to know.
Yeah, what?
Yeah,
love to know what? Go ahead.
What would I like to find out?
Yeah, what do you want to know on this like topic specific? You want to know why you're not floating away? Like, what's your big, groundbreaking question that's going to like help you break through to the next level? Gravity.
Correct.
Yeah, so something's pulling on you, something.
Yeah.
Okay, that thing, does it have like a volume?
It's a force.
It's a force, so it has like energy then. Like mass equals mc squared. Mass energy is at the speed of the constant speed of light. Like the energy, the mass, the thing that you said was something that you don't want to say mass, that thing. So you think that's what it is. You think you're being pulled to the ground by a force that would require motion, right? That's what's doing it for you. It's pulling you right now.
I believe something's pulling me, yes.
Yeah, and only one way, just down.
Yeah.
Okay, all things are getting pulled down then, or just you?
All things on Earth, yeah.
All things on Earth are getting pulled down. And then I let a helium balloon go, and then you say, never mind, I don't believe gravity anymore?
No, because helium is dense, and it has a different...
No, you got to remember the cause of the effect, the reason things get pulled down, right? The effect is gravity. Gravity is all things being pulled down. You're saying that the balloon has a different force acting on it?
Well, I mean, things weigh different than each other. If you have a 10 kg weight and you drop it...
Even that, yeah.
So everything being pulled down makes some things go up, is that right?
Well, if it's lighter than air, then yeah.
So everything getting pulled down makes some things go up?
If it's lighter than air, then it's going to go up.
Right. So you're avoiding the question, dude. Does everything getting pulled down, like you said, make some things go up?
Well, if something is being pulled down, and it's...
Everything. Not something, everything.
Okay, my bad. Most things.
Okay, there we go.
Hold on.
You.
You asked about the balloon, right?
Not really. I just wonder what happened to his brain.
Have you heard of Archimedes' law of buoyancy?
Yeah, buoyancy, intensity, disequilibrium. Yeah.
Because the balloon, the force going up is greater than its own weight, making it go up. That's just why it goes up. Because its force that's pushing it up, and the helium is stronger than gravity, which is why it goes up.
Stronger than that's what what's the gravity?
Because gravity is 9.81 times you know what I'm trying to say? It's like
I know what you're saying. You're saying everything.
It makes weight 9.81 times stronger. That's how on Earth. That's Earth's gravity. But that's how. But if you make something that's that can do the opposite of that, then it'll go up.
It doesn't apply to all things, dude. It doesn't apply to all things.
It doesn't apply to all things. That's why you weigh different on the moon. That's why the astronauts are able to go up and down. Because
it doesn't apply to all things here on Earth, dude. 9.8 meters per second squared downwards is not something we observe happening for all things.
I've been sitting here listening, right? I'm just trying to figure out, why do you think gravity isn't real?
Well, the thing that you're affirming
proves it. There's no scientific actual science hypothesis that's come to a conclusion for experimentation.
But that's the only thing you can say, though. That's you have no other proof.
Not a proof of what?
Like, what's your proof that gravity isn't real? What is your just saying? Oh, there's no scientific hypothesis. That is not valid and evidential proof. If you're writing an essay, you're gonna say, "Oh, the scientist said so." Is that valid? Is that valid? Like, we have yet to see a source.
Okay. Just talk
Actually, and I actually did just think about something because it was like, how do you explain the phenomenon about like when objects fall in a vacuum?
Oh my god.
Scientific method, empirical.
Because there's no air, there's still gravity though.
Yeah, but that's no. So I'm trying to say I'm trying to help. Like I'm trying to say like what Wolf is saying is that like gravity is real because like things fall at the same rate, right? In a vacuum area.
Did you hear the guy talk about not all things? You understand what we mean when we say not all things, right?
And differentiating the effect from the cause, please.
Different states of matter.
You know how an airplane flies, right?
Yes.
Bro, you're going to track with Jedi for a second. He's going to talk to you and respond before somebody fucking starts asking new questions.
What are you saying?
For fuck's sake.
You're so mad. Stop.
Oh God, why are you so mad? It's just a conversation.
Don't concern troll.
Calm it down.
You're gonna listen to me.
So not all things.
Yes.
Right. Different states
correct.
of matter.
You're gonna listen to me, baby.
Yep. Solids, liquids, and gases. You have to remember that in a vacuum chamber, we've taken the gas out. Because of the friction, we want to see how the solid objects, like feathers and bowling balls and hammers, drop within these vacuums. Understanding that the gas that was in the container before we took it out is moving in all directions.
What?
So not all things go down when gas has a infinite direction of motion potential. Can go anywhere.
Yeah, it doesn't.
Very similar to the helium balloon that fills the helium balloon in a circle. Yep.
This guy's still on about the balloon.
Yeah, I don't think balloons are that fast.
Well, I mean, that's kind of what brought it up for you. You were like, wait, the helium balloon that fills the balloon, like not just up, down, left, right, it fills the balloon, right?
The helium is significantly lighter than air.
Right, and then you went to the vacuum chamber.
Then buoyancy with force greater than its own weight, meaning it will go up because of gravity.
Oh,
yeah, and then you went to the vacuum chamber where you evacuated the gas that moves in all directions to then drop solids at what you consider to be a consistent rate at like 3 feet high. But
okay, so then why wouldn't it go down then?
Why would it not? You keep on asking for a lot of negatives. Like, why would something not be the case? Like, why is there? You got to.
No, I'm just trying to figure it out. You're asking us why it would, but you never think about the opposite. Why wouldn't it?
No, I'm not asking you why it would. Honestly, there's no. I'm not really asking you why that would happen. There's just no need to invoke something called gravity when we have other things we can manipulate in reality to cause the effect that you call up and down, which would be relative density disequilibrium.
Okay,
And
let me ask you this.
And the thing that we need, and then the other thing that we need, right, is the container. So we need a containment, right? So when you like say, well, listen, when I drop a bowling ball because it has a specific density, right, that's like a specific amount of material within a volume, right? So that's a container. And you say, when I drop another water, right, like this amount of water, that's another contained amount of material within a certain amount of volume. And then you have the gas that fills the available space. Containers. So it's a lot of containers that seem to be the antecedent for your up and down.
It says relative density is also called specific gravity.
Correct.
Yeah. It's just a very manipulate.
All right, let me ask you this. Why? What do you think holds us down on the ground then?
Yeah, we can't very manipulate that. That's why we're talking about specific gravity and relative density. The only things that we can very manipulate the relationship between the object and the medium and how they react in this vector up or down, depending on what state of matter we're talking about. In this instance, we're comparing solids to gases.
Yep, and the thing you're going to need again is like a container, right? Like lateral containment. Like let's say you have a big a lake of water, right? So you got a lake of water, and you're like, well, why is the water not moving up or down? It's because it has lateral containment. Yeah. Just sitting there. Same thing with the gas chamber when you evacuate it from the gas. So there's no need to call on this force that I don't know. People are saying this amount, whatever, this force of gravity that permeates all space and time to act on the objects. The objects act on themselves. And the objects are defined, again, by like a specific amount of volume within a space, right? And then we can call that density. Well, there's a lot of compactness of matter within a specific space. That's the density of it. So no need to call on a force anywhere else.
Yeah, see, what you're talking about is essentially environmentally specific, right? It's conditional. You'll only observe it occurring within a certain parameter of conditions. Right? Any other time, you're gonna start saying buoyancy and density, where gravity is ruled out.
What are you talking
Yeah, so and then I guess last thing for Wolf Haley, right? The difference would be that you can manipulate these things like density and volume, right? Like you could say, okay, I got 14 psi pressure in this container, and then there's a few things you do to manipulate the pressure, right? You can either add more of whatever the gas is to get a higher psi reading, right? You could make the container smaller to get a higher psi rating, right? Or you could add some heat. And those are the things that we can vary and manipulate. Nobody could vary and manipulate the thing that you're saying would be gravity in a different way.
That means it's not real.
So what's your point?
So when you say gravity, what did you mean? That gravity causes the ping pong ball to fall through the air?
Yeah.
Okay. So the next question is how?
Because of gravity.
No. How?
No.
It's just the words at this point, right? And you're just going to say, well, it's the thing that makes it go down.
Gravity is a word.
Well, it makes it go down because it's the thing that makes it go down.
Gravity is just a word.
Yeah.
Yeah, it's nothing more than
just a word isn't something that you can physically manipulate in an environment.
No,
you're trying to grab gravity.
Word is used to describe something.
Is it like some sort of spell?
Yeah, so the ping pong ball,
man.
The ping pong ball falls through the air, right? Gravity's acting on it, we're saying. Then it hits the water, and it doesn't fall anymore. So gravity stopped. I don't know what happened. Gravity stops. It's like scared of the holy water.
There's air inside the
that
ball.
That would be because the water is more dense than the ping pong ball. But
what about
the gas?
What about drowning?
What about the gas?
A gas?
Yeah.
Well, gas is less dense than water.
Okay, and what does gas do?
I mean, what do you mean? What does gas do?
Yeah, it fills space, doesn't it?
What does water do? A lot of things.
Fills crevices in the floor.
It fills bottles, it runs in sinks,
Yeah,
it does everything.
It fills containers based on
containers.
Based on its degrees of motion, yeah, it'll fill a container.
It fills people's mouths as well.
Okay. How many degrees of motion? How many degrees of motions does gas have compared to water or solid object? Well, which direction and only direction is the rock falling when we drop it?
The rock.
The rock.
Yeah, which way does it go?
If you do what if you drop it?
Yeah, which way does it go?
You drop it.
You drop it, it goes down.
Yeah, awesome. So this is 1 degree of motion, right? It's not going to go to the side unless you apply force to it. You're just dropping it, so it's going to go down. It's not going to magically jump out your hand and start going up. It's got 1 degree of motion.
Yeah,
so gases. How many degrees of motions do gases have?
Is it more than 1?
It's... Try harder.
I'm going to guess 1.
No, it's infinite.
Infinite?
There's many degrees of motion, so up, down, left, right, over there, over here. It's described as infinite degrees of motion.
But doesn't that depend on which gas it is, because some gases actually do go down because it's denser than the air.
A gas all by its little lonesome. Let's just put whatever gas you want, all by its. Shut. Don't tell me to fucking relax.
Calm down.
Relax,
Calm down.
man. Just speak calmly,
Right.
please.
I will fucking mute every single fucking one of you that are talking over the top of me.
Calm down.
Right? You? Okay, who's that? Who said that?
Me, mate.
Let's just say it was Jordan, no matter what.
Right. Now, may I continue uninterrupted? Thank you very much. Okay, so we're going to take whatever gas you want, and we're going to put it in an environment all by its lonesome. How's that?
I mean, there are some gases that is heavier than air.
Yeah, so some gases, depending on their density, the energy, like heat, hot or cold, will do something within the system. Yeah, this is the phenomena, right? And we're trying to figure out the cause. Okay.
Well, real quick, back to. Well, go ahead if you're going to still go ahead. Yeah.
No, go on, you finish, man. You're fine.
I just want to say real quick back to T-Dubs. Where he wanted us to go is a vacuum chamber and a single gas, and now air. Unless Penn, you're saying air is not a gas. That would be two gases. Like putting a gas in the air would be two gases, or well, much more than two actually. But
I mean, there is
gas.
Yeah, air is gas, though.
Yeah, and that's what we're talking about.
But there is some gases that are heavier than others.
Yeah, that's awesome. But what we're talking about is degrees of motion of gas type. Because you're saying that gravity just down. When we compare that to what gas does,
Because it does just pull down.
No, it doesn't. Gas expands. Hold on. No, it doesn't. Gas expands to fill volumes. This has been demonstrated time and again through laws of nature. Second law of thermodynamics, described as entropy. High pressure, low pressure environments when uncontained. Huh?
Gravity does pull it down.
No, it doesn't. It doesn't appear in
But there is gases that does get pulled down.
Gases don't have directional bias. The only thing that
because they're less dense.
Because they're less
dense, so they rise. Because of
That's
gravity.
why I was saying. What about a gas just all by itself? Just one gas. No other gases that it's interacting with. Pick any.
Okay.
Nitrogen.
What about nitrogen?
Okay, stick it in a container all by itself. What are the molecules doing?
I don't know. Ask them.
See, these guys don't know shit.
Well, I mean, you're asking, you know.
We just proved you wrong. So you said put nitrogen in a container on its own.
Why would I put nitrogen in a container?
And then it's going to expand to fill the available volume.
Okay.
That's what gas does. Not collecting at the bottom with a space above it that's unoccupied.
I didn't say that.
That's not what gas does. Right, so not down then. In all directions, filling all available microstates available to it. Yes, that's what it does.
It's really weird. But we're just describing well-established laws of nature, and you're going, no.
You're doing the same.
No, we're describing laws of nature.
Wait, gas does get pulled down, though, right?
No, it doesn't.
It does.
Yeah, but put
the atmosphere is
densest gas, Benson, put it in a container. Is it going to pool at the bottom of the container without any other gas in there, or is it going to fill the container?
So my line of thinking is that gas will fall down into the container and it'll heat up because of all the molecules bumping into each other. So then it has to rise, and then eventually it'll cool down. So it's like, it finds equilibrium inside, right? Isn't that how it works? Or am I wrong?
So what's the definition of gas pressure?
Just ignore him then.
No, we're talking about gas pressure. What's the definition of it?
I have no
pertinent.
Don't know off the top of my head, but I'm just assuming that's how it works, right?
Okay. So it's the force the gas exerts upon the walls of its container.
A container is the necessary antecedent to the consequence of gas pressure, the amount of that gas in that defined fixed volume. Now, the reason why this takes place is because the gas expands. If you were to remove the container, the gas will continue to expand because of the amount of collisions in a closed space over time. This is called entropy. High pressure disperses outwards into lower pressure environments. It's the second law of thermodynamics. This is a law of nature, something that happens always. It's valid without exception. And you're sitting there going, no.
No, isn't... I feel like you just explained exactly what I was saying, that, like, it falls into equilibrium.
Yeah, do you know what equilibrium is?
Like, it's like it just kind of bounces out into, like, a neutral state, right?
No,
or like
an equilibrium can only be reached within a contained system, because if there was an infinite volume to fill, you would not reach equilibrium. You would have.
But that was what we were talking about. We were talking about.
Yeah, you were talking about in a container.
Yeah, that's exactly what you guys were talking about.
Yeah, without the container, you wouldn't have equilibrium.
No. But the question was asked about in a container, and I answered the question, and you literally just
asked your question again, man.
No, like you didn't you just agree with me? Like you just.
What?
The container example was just so that you could isolate that gas that you say is denser than others. It's still going to fill the space. There's a density gradient with all things. So in a container, that gas is going to fill the empty space. As dense as it is or as light as it is, it's not going to divide into two parts.
Yeah, but I never said that.
You were saying that a dense gas will go down, and only down, it sounded like.
No. I said air, like gas will go down, right? But it'll get heated up by it bumping into each other, so it'll naturally rise. But it eventually goes into a state of equilibrium.
Oh, here it comes.
Right, so you think gravity's causing the excitement of the gases?
In a container, in a contained system, yes.
Yeah, you think gravity's what's making the gas move.
But I mean, that was our whole argument, right? Like, that's what the rock goes down, water, liquid goes down. So then when we're asking about gas in a container, like, what does that do? And I was answering.
It's not going down. It's not going down.
But it does go down.
It's not
when
going
something gets heated up, it rises up.
The only reason a gas particle is going to move in a downward direction is because of the angle at which the angle of the collision it made with another particle, with another gas particle, or the wall of the container. That's going to dictate the direction in which it will then move after the collision.
No, because like even gas, any gas that's like cooled down will go down, right? Any gas that's heated up will go up.
Yeah, relative to the exterior environment. No, we're talking about convection now. To talk about this system, you require a container. You need a physical barrier to talk about this.
That's what I'm saying. The gravity is the thing that's actually like still doing what I'm saying. Like, and then eventually it does an equilibrium. That's how that's why gas, you don't see it in a vacuum going down. Like, it doesn't pull down to the bottom.
No, it goes in all directions.
That's what you're saying.
Yes, that's what I'm saying.
Yeah, the gas goes in all directions. It doesn't go down, just down. It's not being pulled to the floor.
Yeah, but it's not like it doesn't just spread everywhere because it's just spreading everywhere. I'm saying that gravity is what's pulling it down. And it affects it, yeah. So then, like, when it rises, it gets cooled down. So then, like, in that contained vacuum, that's why it's just expanded.
So you think gas without gravity pulling on it is just going to sit there still, not doing anything? That's ridiculous, man. It's not how they.
I didn't know. I'm literally saying with gravity.
Yeah, but you're saying without that, the gas wouldn't move.
I never said anything about no gravity. I never mentioned that at all.
Yes, I am, because you're saying that the gravity is the driving force by which gas will begin to move.
Yes.
Right. So without it, gas won't move.
No, like it still moves because the molecules, depending if it's like cooled down or if it's heated up, like
Yeah,
that
because
still
that's
has
the
a
nature
factor to
of
it.
gas, period. With or without gravity, the nature of gas is for it to just fill volume, expand outwards, not attract to each other, repel each other, move away from each other in all directions. Only moving in a specific direction based on the angle of the collision with another thing, another physical particle.
But it just depends on the circumstance as well, right? Because if you cool it down, yes, it will try to like it'll actually make into a solid form. How does solid like work? Like
Yeah,
how
you're
do you
talking
make
about
something solid?
gravity. Yeah. You're talking about changing of phase states. Like if you were to take the water, right? There's a guy on here who likes to go over it. If you were to get the water, right, and put it into a container and then evacuate the air, right, and which would be the pressure, the water will start to turn into gas. Yeah,
Nice.
and then become the gas. The same thing, the same material turns into the gas that presses in all directions, not just down. The same one that was pressing down a minute ago then starts pressing in all directions when it changes states. I mean, that's just. I mean, I don't think there's an argument there. It's just what it does. Yeah.
No, they keep wanting the opposite things to happen at the same time. It just can't be. You're not going down and up at the same time because of gravity. It just doesn't make any fucking sense. So what gravity doesn't know what way it's going, up or down?
I don't understand where that like I don't feel like anybody was ever saying that part.
Well, you're saying everything goes down, but helium, clouds, hot air bubbles in water, stuff that floats, like you're
Because
saying.
some things are denser than others.
But that's not everything going down, is it?
No, but it's still being pulled down by gravity.
Yeah.
No, it's not. Not if it's going
No,
up.
it is. It is.
It is because it's being pulled up. Do you understand how absurd that sounds? You
No,
don't
I didn't say
understand.
it is because it's being pulled up.
Brother.
Well, I hope you realize when we're talking about gases, like, and the behavior of gases, we're going to be talking at a micro level. So you're going to be dealing with, basically quantum physics, right?
I don't think
and
it has
the
to be
standard
micro. It can be macro as well.
Yeah. No, it's not.
Yeah.
No, a collection of gases is only determined by the volume which it's restricted to, right?
So, like,
as one mass, but it's still not one mass. It's not a single mass of gas. It's many different tiny little masses moving around independently of each other.
No, but I'm
right?
saying, like,
only
you can
colliding,
still...
only colliding with themselves, each other, and the walls of their container.
Yeah,
right?
but I'm saying, like, you could still you can still verify this in a macro level. Like, what does gas do in water?
We're not talking, dude.
No. I'm just hold
Water
on.
is not the thing that you're trying to
No.
prove.
Hold on. I need you to guys just follow with my line of thinking.
Water
just
is
real
a
quick.
container.
Hold
You're
on.
trying to
What
prove
does
no container.
Hold on. What does gas do?
Water is
in
a
water?
physical material.
Speak, man. Just be quiet.
But when dealing with the behavior, when dealing with the behavior of
I'm
gases,
just trying to follow along a line of
physicists, when
I'm
dealing
just
with
trying
the
to prove to you
fundamental,
that this can be shown at a macro level.
Listen, when dealing with the fundamental properties and behavior of gases, physicists do not include gravity.
Why is there mice in the background? Did you hear that?
He thinks a vacuum and a glass of water are the same thing. I think we have problems here.
That's not what it is at all. I'm literally
So what
just
don't
trying
you
to show
understand
you a
about
line of
water being
thinking.
different than a vacuum? What part of these two things do you not understand?
I'm just trying to show you guys a line of thinking.
You're not showing us anything. You're showing us a container. You're showing us a container. Gravity is supposed to be space and time and mass pulling stuff, or space and time bending and warping. I don't see no space and time with that air bubble. I see water, air bubble.
Swear.
Okay, yeah,
So no
exactly.
gravity.
Okay, so the air is going up, right? No, hold on, because hold on.
Not,
This
no, it shouldn't never
you
go
just
up.
answered. Hold on.
It should never go up.
Wait. Okay,
It should never
look. You
go
answered
up.
my
Listen.
question. Hold on. Wait.
You're
You
not making
answered
any
my
sense.
question. No, hold on. Wait. You answered my question right there. So.
Oh, I did?
Yeah, you did. Because you said all you see is an air bubble in water, right? So what happens with the air bubble?
Not
it
a
goes
vacuum
up.
container.
No, hold on. It goes
No,
up.
we're looking
right?
for an air bubble in a vacuum container. What are we holding on to?
No. I'm just trying to show.
No. You're just trying to not show us what you're talking about?
Yes, how density works, and why some air actually floats up, and why some
Let me ask you a
air goes
question then.
down.
So you got the ocean sitting on top of this little air bubble, right? The whole weight of the ocean is sitting by gravity. Gravity holding that whole ocean down. So you're telling me that little air bubble outdid the whole weight and the denseness of your fucking ocean and your gravity at the same
The
time,
denseness
and
of the water,
climbed up like a
yes.
rocket?
Yes, the denseness of the water is
Because
heavier.
gravity is good and water is good, and they hold stuff down.
I don't
thought gravity held the water down too, as well as the gas.
Yeah, but the air is less dense than the water. That's why the air will go up above the
How
water.
is it going up?
Because it's less dense.
It's less dense than water.
No. That's pure
What do you mean,
potential. I don't know what you're talking about density, brother.
It's that liberal talk.
How is the bubble not popping? So what's more dense, the air bubble or the ocean? They can't blow it up. They can't stop it or crush it.
Sky and his fucking bubble.
What's
The
more dense,
water
gravity
is
or the
still
air
trying
bubble?
to crush the air. What
Gravity
do you mean?
can't
That's why it
crush the air
forms
bubble.
a bubble.
It's
That's
not
why it-
keeping it down. Why is gravity not holding it to the surface closest to the center of mass?
He needs to do a better job.
That's the fucking bubble, man.
I don't understand why people got so upset about the bubble reference. Like, I was
No, the bubble hurts you. The bubble's
How?
anti-gravity. It's anti-gravity. Every fuel, everything like that. Like when your car is sitting there, gravity's holding on to it, right? Imagine, wink, wink. And then when you fill it up with gasoline and you turn it on and press the gas, gravity lets you go wherever you want.
What
Same
are you
with
on
an
about?
airplane.
Wait, what?
Yeah, same with same with wings on a butterfly. Butterfly's held by gravity until it flaps its wings, and then the energy equals mass, and then the mass isn't it pulled down. It's let go.
What the fuck are you doing? What car has?
Well, I don't know. When you move something, doesn't it weigh more? Isn't there more force behind it?
Yeah, so the potential of the force that like you're moving forward
isn't that the
outweighs
weight
the
of it
what
now?
pulling you down. Yeah, but
Or isn't
like,
that the weight of it now? So now you're telling us something you make heavier is leaving easier. Do you understand the ignorance in what you keep saying? It's always the opposite of reality. So if I stack 52 bricks on your head, why is it easier for you to go somewhere now? That's gravity too?
because like a car has wheels and then it has potential energy and it actually uses that energy to move forward, which is like outweighing the gravity itself. And you're not trying to move up, you're trying to move side to side.
Yeah, it also has an engine that lets it drive, but you know,
wings.
Yeah, like I don't understand what you're talking about because like I'm not talking about like a car that's like moving up because that would take way more energy than it having to move side to side.
Okay.
Where's he gone?
Can we go back to the bubble?
I mean, one of you guys do eventually have to prove this thing you're saying gravity is necessary. You do at some point have to bring that up.
Sorry, you were echoing there.
I heard you double, yeah. I couldn't.
I was saying at some point you guys do, if you're going to keep on arguing for gravity, you have to again define it and then show why it's necessary. When what they have shown is necessary, the antecedent for gas pressure being containment, and then the measurement of these different things going up and down being a differential between a solid and a medium.
But what do you mean by necessary? Like, it just is. Gravity, like, we don't create gravity.
Yeah, I'm saying no. I didn't say that. Necessary, right? Would be a why. Where is it required? The thing is, you're saying is necessary. You're saying no, but we need gravity to make things go up and down. But then you can just you can show it being relative density disequilibrium.
Huh?
Wait, I got lost. Sorry.
Yeah, same. It's a bit too.
I said you were saying that gravity is necessary to make something go down. Is that true or not true?
Not necessary. It's just the explanation of what, like.
So you don't need. So now you don't need gravity to explain why things go up and down.
No, it just is. Like, gravity is a force that, like, pulls us down.
Well, that's incorrect.
So now you are saying gravity is necessary to have an up and down. When I ask you to show why gravity, the things you're invoking, you're saying, well, listen, we need gravity. You're saying it's necessary. We need it to be able to. Yeah. Otherwise, right. So otherwise, you'll float, mate. Right. And then you went through demonstrations of showing relative density. Relative density meaning that you have one
You only
thing
need
that's
gravity to go down.
So now you have one thing that's dense relative to another thing that's dense. Yeah, stop it. And so you have one thing, relative density, disequilibrium, then it's put in a state of disequilibrium. So then you have your up and down. So is gravity necessary or is it not?
As an explanation? I guess that's what you're trying to say? Like,
yeah, because I say, show me why gravity is necessary to have something to go up or down. And you're saying, well, you just take two things of different densities and relative to each other. One will go up and one will go down. I say, okay, so where's gravity? You're like, well, it just is.
So gravity is the force that's, like, pretty much, like, pulling you down, right? It pulls mass down.
Right, but then we went through the whole gas demonstration where it doesn't pull gas down. Okay.
No, but there are some gases that are lighter than the air.
Now you're going to relative. All right, so now you're going to relative density, not gravity.
Yeah,
just gravity though.
So, like, basically the density of that is able to, like, it outweighs the gravitational force.
The gravitational force is the reason that things go down and we have weight?
Yes.
Okay. And then a helium balloon, I let it go on a scale?
Yeah, because it's not as dense as air.
Yeah, because it's not as dense.
Now it's not gravity now. It's just the relative density of either an object and another object. So then it's not gravity. It's just the relative density being two. Dude, stop interrupting me while I'm halfway through my sentence, Jordan. You're an idiot. Yeah, so it's just you're just an idiot. Stop interrupting. You're being rude. You're interrupting me.
Yeah.
So it's just again to the other guy who's not interrupting me, right? So now
who's interrupting you? Do you see the name? The guy's interrupting you.
Yeah, Jordan, just settle down, man. You don't have to mute him to stop interrupting.
Jordan, mute yourself or be banned.
What's a hostile?
Mute yourself, Jordan. Don't you get it? Is it like a language barrier or something?
I think you have more of a language.
All right. He's muted. Go ahead.
Yeah, no sweat. Like, I don't mind interjections, right, to make something clear. But anyway, I just want to get to the point. So now we're saying that it's not gravity. It's just the relative density of either a solid and a liquid, or a solid and a gas, or a gas and a liquid, to get the relative density of each one and the disequilibrium, like which one is less dense or more dense than the other one. We don't need the gravity now, just like a scale.
It's just that one force is stronger than the other at that point. That's what it is. So, like, helium will go above air because helium is less dense than air.
Okay, which way is the force pushing? Like, if you were to say, like,
gravity is going down, but the helium is going to go up.
Okay, so that would be that's like a differential between the up and the down of something. So you have so a force, right, would be like the direction. So, like, if you were to say, I want to get the force vector of a liquid or an object or gas, like, for example, gas, the vector is all directions. So the force would be in all directions.
Yeah, but the reason that it'll go up, especially because you mentioned that it was going to be in a balloon, is because it's in a closed container, right? So there is nowhere else for it to expand with except within itself, and then it's going to go up because it's less dense than the air around it.
All right, so not because of
Either we had
gravity.
it- Yes.
No. It'll pretty much out. What am I trying to say? Like it'll outwin the gravity.
Yeah,
that force.
Yeah. So the forces, right? Forces are measured by an interaction between two things that are not the same. Imagine all things. Imagine the entire universe was all the same thing, just one single liquid, right? So it's all water. The whole universe, there's no planets, there's no you, there's no me. We're outside of it and we're looking in. Now, if the whole universe is just water, will there be any motion in the universe?
I guess. I mean, there would be motion, right? Because like the Earth is rotating.
No, there's no Earth, there's no sun, there's no moon, there's no skies. This is the universe, all things, right? All things. It's just one big circle, draw a big circle. Now the whole universe is just filled up with water. There's no planets, there's no nothing, just water. Will any of the water move, or will it all just stay there?
I mean, I don't know. That's like an extreme circumstance that I don't even know. Like, how the hell am I supposed to answer that?
Well, just get a pool of water. I mean, you could just get in a pool.
Yeah, but the pool of water, you can't. There's no way to like to even like think about like that as a whole, because it's like the pool of water on Earth is acting differently, being manipulated by different stuff than like what you're saying. Like if the whole entire universe was made of water.
It doesn't matter what it is, made of water, air, whatever, right? So if everything is just one thing, I'm just trying to get to you about the forces that you're saying are necessary. The force you're saying is gravity, that is just there, even when the material is not there. You're saying gravity will still exist, even if the stuff isn't there, right? So it's an emergent property of the stuff, or it exists before the stuff. So now I'm saying, listen, forget about the weird theory about gravity. You're trying to find out the force and the vector and the direction of motion of an object or a medium or a gas, right? So the way that we find out the vector of motion, or up or down, left, right, would be relative to the surrounding material. If all things were the same thing, there would be no motion. So then you have to put in another thing, right, to cause a relative density disequilibrium, aka motion up and down, left and right. So it's not that there's gravity, right? It's that there's relative density disequilibrium causing things to move relative to the other thing. If they were all the same, there would be no motion. But you're calling upon gravity as the force that drives and moves things. But they move relative to something else. No gravity necessary. But still gravity, right? It's still gravity.
I don't know. I feel like so completely lost by like by your examples that you're trying to get to. I was just like, what? I was so stuck on like the water being the universe.
Yeah, it's just to say you're looking at an experiment of like in a container, right? So the first thing you need is the container, right? So I said, all right, well, the whole universe, right? So, but whatever it is, right? Because you're going to bring in other things. You'll say, well, but we have air, we have this, we have that. So therefore, we have vectors, and we have like up and down and left and right. Those vectors, we denote by, where something is going towards or from, and the way
I guess like with your example, like if let's just say like the universe was just empty, like that's like I guess essentially what you're saying, right? Universe is empty, there's nothing there. But the moment you bring two things in gravity, those two things will start to like interact with each other because of gravity. Because those two masses will want to.
There's no gravity though. There's just the two things.
But the moment you introduce two masses in space-time, gravity will form.
As soon as you bring two masses.
Yes.
Well, there's something called like three body, like you're talking about the universe, like something called like a three body problem when you have, because you have this unequal masses, right? You can't get the orbits to work. There's like it's called the three body problem, where any three masses won't be able to maintain an orbit because they're not equal.
No, it's just that the mathematics doesn't work out with the three body problem, and no one's been able to solve it. So that's the issue with it. It's not that it's mathematically impossible, it's just that mathematically we can't solve it.
Well, prove that. To prove that it's mathematically possible, you have to show it.
I mean, there's a lot of things that like a lot of people didn't believe could be mathematically, solved, but then it took like, I don't know, like 300 years. Like Fermat's theorem took 300 years from its first inception in order for it to like actually be proven, and it took like a lot of mathematics in between those 300 years to like actually be proven. So like with the three body problem, that could be the same circumstance, right? Where like we don't know exactly how long it could take to like be mathematically solved, but just because it's not mathematically solved doesn't mean it's not ever going to be.
Yeah, I mean that wasn't really my point to bring up a three. I'm just saying, imagine a three body problem in the scenario where you start to bring bodies into, into this universe now, and then build it up from the beginning.
But I don't know. I guess I don't know why you brought up the three body problem if you were just saying like, oh, like you were introducing masses into this like universe that had nothing to begin with, and I'm telling you that like once you introduce masses into space time, gravity will form, and then they will start interacting with each other.
Yeah, right.
That's incorrect.
Yeah.
No, it's incorrect. It's one sec. It's fundamentally incorrect. All right. Two hydrogen atoms being alone in a universe will never, ever form a single object.
Well, because those two hydrogen atoms just by themselves will just be by themselves, but like once they interact with each other, then they'll combine.
No, they haven't.
Why are you bothering? These people don't have an education in like physics to know this.
Shush! Stop poisoning the well. We don't need your peanut gallery rhetoric. Listen, dude. Fundamentally, this is understood by physicists that two atoms of hydrogen will not combine. It takes millions and millions of them. You said as soon as you introduce two objects, okay, two hydrogen atoms, they will not combine, dude. Never.
I literally just Googled it. It says two hydrogen atoms can and do combine to form a hydrogen.
Yeah, it literally says that.
No.
It's easy looking.
You will
easily
need.
Look it up.
Listen, dude. You will need extreme heat and extreme pressure for that
amount of
to
energy.
occur. Now, if there is only those two things together in a universe alone, they have no reason to do that.
No, hold on. Okay, even if it requires energy to make into a new molecule, those two molecules will still interact with each other, and they'll still like go into each other.
They'll bounce off each other, and they'll bounce off each other and keep going away from each other. They'll never combine, ever.
Yeah, that was kind of my reason for bringing up the three body problem. They'll never combine. They'll never be in the same place.
But like, what are the circumstances on like what are these two hydrogen atoms doing? Are like they flying at the speed of light, like barely grazing each other? Then then they'll like kind of fling off each other and they won't combine. If they do a head-on collision, that could be like enough potential energy right there for it to combine into a molecule.
This goes
like,
back
it depends on the circumstance. You can't just say like, oh, like two hydrogen atoms that like in space-time will never ever ever interact with each other. It's like, but what are the circumstances? What's going on? What are they doing?
What put them into motion, man? That was the point of it. What put them into motion, if not an interaction of two things?
Yeah, and how fast is that motion?
No, there's nothing to put them into fucking motion. That's my point.
But you just said let's put them into motion.
No, I asked you what put them into motion. Then, if there's no interaction.
But we're just going based off like what your thought experiment is. So that's why I'm asking you to clarify on the thought experiment.
Right. It's not a thought. It's relative density disequilibrium. Right. So it's relative density to get motion vector. What we're calling a force of motion, which is just an interaction of two things that are not the same. If you put these two same things into space, you said they would just go into motion. No, you'd have to already have them in motion. There'd be no interaction, just like K-Dub just said. They would bounce off, never return. You'd have nothing.
But they would interact with each other because, like, even if they're really, 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 really small, like
Dude, they're going
they
away
still
from.
have
Is the universe a circle? Like, what's good? They're going away from each other. Why would they ever interact ever again?
Okay, so if they're going away from each other, then they're never going to interact. Then your argument is
All right.
correct in that sense.
All
But
right,
I don't. But gravity will still be there.
That's what I'm saying. You're saying yes, what I'm saying. So you're saying gravity is always when all material is gone, and gravity is all that remains. So gravity has always been here.
Gravity is only present in space-time when there's mass. That's the only time gravity is present.
So isn't an emergent? Is it an emergent property of mass, like a pseudo emergent property of mass?
Yes, in space-time, yes.
Only in space-time, nowhere else.
We literally live in space-time, so this is
Also everywhere then. So everywhere we can see little suns being made and little planets being formed in spheres and gases being made into spheres by gravity on its own. So in the air we're breathing, we're going to look around and see different spheres of air in this air. That's going to be cool.
But it's different.
Oh, so it's not that. So it's always that, but not that. But it's different than that, right? It's not exactly that. It's different.
It's because we have atmosphere. We have other stuff that's like also relative to like what's going on than like in space.
Other stuff going on in nothing, with nothing in space. Space means nothing, the absence of all things. And then there's time. So there's time sitting there with nothing. And then you're like, what's happening now with gravity again?
Yeah, space is just like a word that is like a placeholder for the thing that's going to occupy the space. To say that the space is the physical thing that is manipulating and interacting with a molecule, it is fallacious. And then time is obviously the denotation of like an angle, like the way we tell time here. Time is the angle of the sun, or you could say that, or it could just be the distance between objects, would be and the time it takes, the speed to travel from one point to another. So to say that speed or like a potential distance, So to say that distance and then space, which is the absence of anything, is manipulating the physical world is a little out there.
I mean,
all of this to
time
answer,
isn't a ruler.
Yeah, all of this to say why things go up and down seems, I don't know, unrealistic. Maybe you think it's the best answer, that the reason things go up and down is because space, the absence of all physical matter, and time, the distance between the physical, between 2 points of physical matter, is the reason that things go into motion. It seems a little nutty, and that's how you get a helium. That's how helium balloons work, children. Just so you all know.
So the gravity that he's talking about, does that gravity forms the Earth into like a sphere, like a spinning sphere?
Yes, you might know.
I'm not sure about like spinning. I think spinning has to be relative to like the
So what
sun
about
and
is
everything
gravity
else that's
forming the
interacting with it,
sphere?
which is. But like gravity itself, I think like when it collapses, it's like gonna be made into a sphere because it's collapsing into itself, right? So like that's how the Earth was formed and made. But the spinning,
why isn't the Earth? So why isn't the Earth curving for this gravity thing that you said forms things into spheres?
I mean, the Earth
into a sphere.
does have a bulge. Like it does.
A bulge?
Measure it.
Yeah. Like Earth does have a slight bulge to it because of the centrifugal force that's going on.
When you talk about Earth, do you mean the soil that you put your feet on, or do you mean like when you think about Earth, what do you see in your mind? Do you see like a sphere or a circle, or what do you see?
No.
Yes, the sphere.
You see the sphere? Is that what you think when you see Earth?
Yes.
When you think about Earth, okay. So in reality, not from like an outside perspective that you never been to. Like in reality, do you see Earth curving in accordance to that what you're claiming?
I guess you're
of the
asking
geometry of the sphere.
I guess you're asking if I've been to space?
No. The curvature that you're saying is here on Earth, or the waters across. Do you have a measurement of that?
No.
Okay. So how can you know or believe it's a sphere when it's not curving?
You can see it from a certain height.
Just as a steel man for the globalists, they say that the spin of all these things was caused from the Big Bang. It's just still spinning from that, and there's nothing there. There's friction in space to slow it down, so it just keeps spinning. The gravity is the sphere part.
Wait, the spin from what?
That doesn't. I mean, maybe it wasn't for you. The spinning of all these things is just from the Big Bang. That's just the story. Earth is just conserving its momentum from the Big Bang, still spinning due to no friction. But then the inner core, whatever. Then the inner core is slowing it down a little bit. Blah, 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 blah. It's just a story.
I was gonna say I don't think Big Bang, the theory doesn't mention anything about like how Earth is rotating.
Okay. Well, okay. Take it or leave it.
The Big Bang theory is just the explanation of like how the universe is expanding, right? And then it's also just explaining the phenomenon of like it must have come from like some central point, like, and then some cause or event happened which caused it to expand, and that's how the universe was made. So like that's the Big Bang theory, but I don't think it's explaining the centrifugal spin or the force of the Earth. I think that's something else completely different.
All right. Yeah, I mean, everybody has their own opinions, I guess. No problem. So you think they've measured the Earth? They measured what do you say, a bulge, an equatorial bulge? They measured it.
Yes. So there is a bulge on Earth due to the centrifugal force of the spin.
There would be, or there's a measured one?
But there is a measured one.
Okay, how is it measured? You're saying that the water is higher in the middle and lower somewhere else.
Yeah, but it's not like something crazy. But yes, there is.
Okay, so the water was measured to be higher in one location and lower in another, like sloped.
Yes.
Okay, so it was sloped water, no curve, just slope.
I mean, the Earth is curved because it's a sphere. I'm just saying that like there is a slight bulge where the Earth is rotating.
Well, you're saying there's a
centrifugal force. Yeah, because the centrifugal force, like you know how like.
Yeah, I know. You put it in a centrifuge. Like you could put in order to get the gas the way you guys want it, you could put it in a centrifuge. Yeah. So, like if you get a bucket of water and you spin it, or if you put you put it in a fish tank and have a center axis and spin it, and then the water will stick to the sides. The Earth is spinning, so I don't know if you're a concave earther or globe earther, but or heliocentric earther, but you're saying because of the water spinning, it's sticking to the sides of the container, centrifugal force. And that's why we're stuck to the ground. Or I'm not sure. I don't know. I can't remember the whole fantasy story.
Yeah, I don't exactly know where our conversations keep going. I feel like we're talking about like a certain topic and then like we start deviating like really hard.
But we're on the weeds now because for any of this to be true in the first instance, you would require Earth to be a sphere, and that would have the result of the surface we live on being convex and showing measurable curvature, observable and measurable curvature.
I mean, people have been doing it for like since like when like the
doing what? Observing and measuring the curvature.
Yes, like haven't people been doing it since like ancient times? Since like
show it. Give us an example.
Don't they do it with? I mean, I don't remember how they did it. Don't they do it with like also with time? So they would like track to see how far away something is, and they would also time it. Because I don't really think they have like the instruments we do now.
I'm talking about the surface. No, you're not tracking. I'm talking about the surface.
No, that's why, because like basically you piece out like small pieces of the Earth, and then eventually like you can like do calculations to like, hey, like you can see how big the Earth is, like how. Do you get what I'm saying? Like you piece it out in vectors.
So first off, we'd establish a reference by which we're going to determine a change in the surface, right? Because otherwise, if you didn't detect a change in the surface, that means it's just parallel to your reference, right? You're going to have something else in order to gauge that there's a difference, right? There's a difference between this thing and that thing. They're not the same. That's how you would determine whether the surface is curving or not.
Yeah, surely. That's, I mean, right, Pensy? Like, surely they could, somebody, it's 2025, can establish a reference.
Yeah, don't they do it with like the space stations that are up in space?
On Earth? No, on
Yeah,
Earth.
and with GPS.
That's giving you your ball. Like we haven't got there yet. For that to be true, you need Earth to be.
Yeah, I know, but it's because he just mentioned in 2025, so that's what I was saying. Like in 2025, that's how we would be able to do it.
Right, from a fundamental, basic level, right? We're talking about. We haven't got there to those other things which are derivatives of the thing that you're trying to prove in the first instance.
Yeah, so then that's what I was bringing up about like ancient times, like how they would do it.
But how did they do it?
They would walk from one location to the other and measure it.
Measure what? The distance?
Yes.
How does that determine that the surface beneath them was curving?
Actually, I'm not entirely sure how they did it back then. I know that they did do it. I just don't remember how. Didn't they like get like a triangle? Because isn't that how they really did like a lot of their calculations? Was with like piecing
you
out,
might
like,
want to learn triangles. Triangles are straight lines. So if you're going to use the surface of the Earth
that's not
as one of them
entirely
straight
true.
lines,
Because like
you're not claiming it's curved,
wait,
right?
not all triangles are straight lines. Like if you put it on a sphere, it's not a straight line.
The definition of a triangle.
Not a triangle.
No.
It's not straight. It's not a triangle.
You have an opposite, adjacent, and a hypotenuse with a triangle. Three vertex equaling interior angles equaling 180 degrees. If I take that shape and then I bend it all up, it's not a triangle.
Wait. But like a triangle on a sphere is still a triangle.
A bent triangle, like one that if I like kind of heat it up and like start hammering it down like a blacksmith onto like a sphere surface, it's not a triangle, dude.
Yeah, pensive. They aren't going to understand spherical trig.
Oh, yeah. Okay. It's because like I really like one thing I do love is like mathematics, and like the thing is like there's different definitions like in topography in mathematics, and like a triangle on a sphere is still a triangle. Like the definition.
Okay, even if we granted you that, you don't have that sphere yet upon which to place a triangle. You've got to find out if it is that first, and then apply your spherical trigonometry.
Yeah, so if you were to measure a triangle, right? So like if you were just to measure like point A to point B, then point B to point C, and then same thing from point A to point C, and then you add up the sum and like the degrees and everything like that, like it could be greater than 180 degrees, and if it's greater than 180, then that proves right there that the Earth is a sphere.
All right.
Because
who did that? Okay, who did that?
Who did do it? Hold on, I'm gonna have to Google that too, because like there must have been someone in ancient times who did prove that. Like,
right, this is going to be where we go to, right? You might want to find out.
Yeah, if you have a triangle, just got 3 points, No, you've not got the ball yet. So you're saying that they just walk from one point to the next, to the next, to the next, back into a triangle. That's just 3 straight lines.
No, but like that's okay. So like I said, in mathematics, like in topography, like a spherical triangle is still a triangle. It's just a triangle with more than 180 degrees.
Yeah, but if you just walk in a triangle, how do you know that's a sphere? A sphere.
Like I said, because if a triangle is more than 180 degrees, then it's a spherical triangle. If it's exactly 180 degrees, then it's like those are 3 straight lines.
So how far would they have to walk?
I mean, it would have to be like a pretty good distance, right? Because like as long as the math is correct, then if you have a spherical triangle, then that if you have a triangle that's more than 180 degrees, then that does prove that the Earth is a sphere.
Not necessarily. You could be measuring topography that just happens to have that formation.
Ooh, that is true. That is true. So if you were able to do it even in other locations of the Earth and still prove that like it's more than 180, then that still does prove that the Earth is a sphere, correct?
Wait. If you have a sphere and you draw what you calling is a triangle on that sphere,
yes.
How does that translate on the ground below your feet being a sphere?
Because like I said, so everyone right here has the conception of a triangle is that it has to be 3 straight lines. But in topography, and so in mathematics, if when you place a triangle on a sphere, the degrees of the angles add up to more than 180.
But when do you measure that sphere on the ground or the waters across the Earth?
Yeah. So, but that's
even if you can on the paper make this math and you say it will measure the math on the paper will give you these numbers. When do you get that on the Earth?
No. So that's why I forgot who it was. I think it was T-Dub. He brought up a good point because it's like if you only measure on one part of like the Earth, then how can you still prove that for the rest of the Earth? And I was like, that's actually a really good point. So then the best thing to do would be to like map out these distances like all over the world, right? Like, at this point, do we really have to include even the oceanic parts? Because like we should only do if we could, do we have the measurements to do it, like to do the measurements on the ocean?
Especially.
But either way, if we do it in different parts of the Earth, and if those different parts add up to over 180 degrees, then that proves that Earth is a sphere.
No, not necessarily.
Okay, so like for this whole idea, right? If somebody did these things, but then you could also say, hey, I have hundreds of examples of people seeing further than what a geometric horizon allows. And there are examples of that, and lots of people tell you about examples of that, which would technically invalidate curving Earth. Is that a valid kind of proof?
But I'm not talking about observance, I'm talking about measurements.
Well, yeah, it's still a measurement, right? Because like if you can see further than what it allows.
But
right?
like we're trying to so like in mathematics, or at least in this case, you're not trying to use your visual senses to like map out like to try to prove something true. You're just trying to use measurements and math, and that's it.
But you haven't given us any
laser beam, and then like measured a laser beam straight across with no bend. Would that like count?
I mean, I feel like it would, but probably like the best. Man, I wonder how you would be able to do it. Like, what exactly is the best way to measure? Like, how do you measure one point from one point, and like, what would be the best way to measure it?
I guess a laser would be the best, right?
I guess that still would work.
People have done that. They have taken lasers and shot it over bodies of water and didn't find any curvature.
No. But remember, we're trying to measure 3 points. Measure those 3 points, find out like the distances, and then add up the math. And as long as the as long as the degrees is 180 degrees or less, then the Earth has, well, I guess maybe not even less. Wait, I have to like remember my mathematics.
Now, what you could do is use a laser to make the side of the triangle, but then you'd have to walk the ground and see if that line is the same as the laser measurement. It would be, but on a globe it wouldn't be.
Yeah. But like I said, it wouldn't necessarily matter too much because like even if we take a laser, like that actually is better for flat Earth, right? Because that laser is going to go straight. And if you measure those 3 points from like I said, point A to point B to point C, and point C to point A, and if you add up the math and then like you form it into a triangle, like I said, if the triangle comes out to be 180 degrees, then the Earth is flat. But if it's more, then the Earth is a sphere.
An example.
But then you can take away B and C from the triangle and just do a line, and then you can still have your answer.
One sec, dude.
No, you need three.
Do you both have me muted? You both have me muted? Right, for one, you're going to have to show an example of this and detail the methodology which was involved. When you said about lasers, right, because the laser's just going to go straight, we tried that, bro. Your side said, no, it doesn't travel straight.
Also,
we get results
like I said,
using lasers. Get results using lasers showing no convexity to the surface, especially over liquid, right?
So that's what I was saying. Like, what would be the best way to like?
It just travels in conjunction with the curvature of the Earth. That's what they say.
But like, if anybody, like, I'm not saying like you shouldn't let other people do the measurements for you. Like, if you were to like, because if you do the laser yourself, then you're not under the. Like, you don't have to worry about what anybody else is thinking, right? Like, you don't have to worry about like all these people saying that like, oh, well, you can't use a laser because of the curvature of the Earth. It's like at this point, I'm saying, F them, fuck them. I don't care about that. I care about the measurements, like I said. So like, point A, point B, point C, get the measurements, and then do the mathematics and see what the degrees add up to. If it's 180 degrees, then it's flat Earth. If it's more than 180 degrees, then it's a spherical Earth.
You wouldn't need a triangle though. You just need point A to point B and a drop over distance.
No, you need 3 points. You need 3.
No,
it wouldn't matter because point A to point B, there'll be a drop over distance. It doesn't matter about point B to point C. There'll probably be another drop over distance if it was a ball. But you don't have to do it that way. Just point A to point B is all that matters here. Drop over distance from point A to point B.
Because point A to point B won't give you enough information to tell you if something is flat or curved.
But
the globe has a pre-radius already put into it, so you can test it against that radius that's been claimed.
You do the laser, that's going to be a horizontal line, take that measurement, and then you have to measure the ground itself, which should be a curve. That will be a different distance. If it's not a different distance, then flat.
So now you want to take, I guess, 4 points? Is that what you want
to? Two measurements of the same point. One is going to be the laser measurement, which is a horizontal line from point A to point B. One will be the ground. You walk the ground, get that measurement. That's going to be a curved line. Those lines will be different lengths.
Yeah, for example, right, you're gonna be a specific height above whatever surface you're measuring to begin with, right?
Okay.
And you have a level line of light, right?
Yes.
Extending outward from that point across the surface, right? At the end of that transit, the target, that the where the light reaches its target, there should be quite a significant difference in the distance between where the laser or light hit the target and the surface beneath it compared to the origin of the transit.
I mean, I guess you could do that. I'm just saying, like, honestly, the best way, like, to use mathematics, at least in everyone's favor, is to do 3 points. Because, like I said, if you can do that and then just do the math and just check out like what the degrees say, then you'll know if Earth is flat or curved. And do it in multiple different areas.
Over what sort of distance would we be talking? Because could we do this over like 5 meters?
I mean, I would say, like, why not, like, do, like, as much as you can, right? Do, like, 5 meters all the way to, like, 50, 500, and, like, see how the math, like, if the math plays out the same all the time, then you'll know that, like, Earth is flat. Or, like, if the math ends up being different, then you'll know, like, there is something wrong and there is some curvature going on Earth.
Okay, so you understand that we're given values for the Earth, right? We're given radius, diameter, and circumference, right? That's already been provided to us by someone out there. The education system says the Earth is of this size and dimension. Correct?
Yes.
Now, where did they get those values from?
I'm assuming from the same thought process that I was just having with triangles.
They didn't. No, they didn't. Nobody's ever done it. Nobody's ever shown any demonstration where somebody directly with the surface, right, directly measured the surface to have those dimensions.
I also did find out who it was that did the measurements. It was, I don't know, I'm probably going to butcher his name, Eratosthenes or something like that. He was a Greek mathematician, actually. Which is really cool. Like, that's actually awesome. Like, it was mathematics. Like, that's the way to prove all of this stuff.
You know about Eratosthenes?
I know better.
Yes, there you go.
And how did he do it?
Oh God, I'm gonna have to do so much studying. Oh, someone's.
Yeah, go find out after you make the claim. Frantically Google your evidence. Yep.
That wasn't me. That wasn't me. I don't know who that is.
Well, then just mumble and say.
No, I even just said it out loud. I was like, oh man, I'm gonna have to do so much studying.
Okay.
That's Phantom with the keyboard.
Phantom, mute your mic. We can hear your keyboard, bro.
Or just at least like lower the volume on your mechanical keyboard.
Oh, love.
But also when I'm, like I said, I don't know who that. I actually don't know how to hit here. I wasn't trying to like also, say that like I'm a genius or like I know like all the math that comes into this stuff. But like I said, I am very familiar when it comes to like in this mathematics. And like when it comes to like topography and like I said, like the measurements of 3 points would be like the best way to like really see like if Earth is flat or not. Like that really is the best way.
No, we're not claiming that you got to know everything, but do figure out what Eratosthenes has done, and then come back and explain what he's done.
Okay. My whole point wasn't about really Eratosthenes. Like now, like my whole point is about like just the pure mathematics. Like just get 3 points, and like I mentioned to T-Dub, like you should do like 5 meters, 50 meters, 500 meters, 5,000 meters, how long you can do. Do 3 points of measurements. If the degrees add up to more than 180, then the math says the Earth is a sphere. If the math adds up to 180 degrees, then the Earth is flat.
Well, I still
We
don't
need to
think
do this. Like all of us need to do this. I think that's our due diligence. All of us need to do it.
just point A to point B will be a drop over
No.
distance. On a ball, everywhere you go is going to be a drop over distance. You just need a point A to point B.
Point A to point B only gives you just one line of measurement. It just gives you point A to point B. That's it.
Yeah, and a drop over distance.
It gives you 2 points if you're measuring the ground for one and measuring the laser straight line for the other. So you need to follow that same line measuring the ground. That should be a curve. When you bend that curve to flat, it'll be a different length than the flat line.
Okay. I'll give you guys the benefit of the doubt and say like all you need is point A to point B. But at that point, what is wrong with going the extra step of measuring and adding a third point?
No, there's nothing wrong with that.
So then do it. That's what I'm saying.
I mean, against the claimed radius, you can test it with just point A and point B, with the radius that's claimed of the globe. Do you know what I mean?
That only gives you like I said, that only gives you a measurement of how far away something is from one another. At least 3 points of measure will tell you that based off that triangle, like what kind of plane you're working on. Are you working on a flat plane or are you working on a spherical plane?
Honestly, I've seen some flat earthers claim, looming refraction, which might introduce errors into this observation even on a flat earth.
Are we talking about the laser thing? Because I was saying that like maybe lasers are the best way to like measure something. I'm not entirely sure about that. Like I say whatever is the best way to measure something, like we should use that. Like maybe even like rudimentary stuff, which is like, you know, holding out like the world's longest ruler and just like one person calling out like, yeah, this is how long it is at this point, and just like, you know.
No, but like even on a flat earth, you would get a triangle more than 180 degrees is what I'm saying.
Oh, so then Earth is a sphere, or at least it doesn't necessarily have to be a sphere, but it is a curved plane.
No, it just means like
it's a curved plane.
It's not an accurate way to determine that.
But you said that flat earthers did the math and the triangles came out to more than 180, so that means it is on a curved plane.
It might give inconsistent results because of other underlying factors like the behavior of light through the medium of air.
Well, like I said, don't just use lasers. Also use other rudimentary ways. Like get like a long ruler, or get like, you know, like a piece of string that you can measure out or something like that.
Really ridiculous.
I mean, it's ridiculous, but what you want to use all the best ways, you know, and compare them.
Would introduce so many errors into the equation.
But what? How does triangles introduce errors into the equation?
I mean, you're not gonna find consistent length using a string.
Well, that's what I'm saying. Like, use different methods of measurement. Don't just stick to one and be like, oh, well, this doesn't work because of this. Like, why not use many different kinds of measurements and compare them all?
Surface of water.
But you don't have to do it over the surface of water. You can still do it on different places of the Earth, right? Because all those places of the Earth, if the measurements add up to 180, then it's flat Earth, regardless of where you are on Earth.
You're from a position where we have to defend or demonstrate something to be true when it's just already demonstrated to be true in the first instance. The surface of liquid at rest is horizontal. It shows no deviation between a horizontal.
But like I said, leave visual. Like don't use your visual senses for this. Like just use measurements.
The surface of water is a standard by which you can determine whether something is at the same height as something else in a straight line.
But like I said, you don't need to use water. You can still do it on Earth. Just use it on like flat You know, like
So
in this
then when
case, you know, just use it on any
burden,
surface.
thing that flat earthers are burdened with, this would be something that globers are burdened with having to demonstrate.
I mean, I feel like it should be like on both, right? It should be on the globers and on the flat earthers. Like, why not? This is. I feel like this is like the best way to prove. This is the best proof.
We have.
Not
We
only will
proved it.
it not give the accurate result for the radius of the Earth, it would also. The
It's
problem is like a
it's not
ruler.
about the radius of the Earth. You're just measuring out like the measurements on a certain vectors, just 3 points. That's it. You
But
don't
do you
need the
think you
radius
can
in this
measure
case.
the radius using that? Technically, you should be able to.
No, well, yeah, once you like add everything up and like, you know, if you can get the math correct and like try to get the measurements. But like I said, this isn't about the radius. This isn't about like I'm just talking about mapping out Earth on like if it's a globe, you're just mapping out the sphere, just the outside part, right? But if it's a flat Earth, then you're just measuring out Earth. That's it. 3 points will tell you if something is flat or if it's something else.
Is that possible? Can we do that? Like, could we make a level surface and measure 3 points on a plane?
Yeah, on a piece of paper, you can draw
Piece of
3
paper.
circles.
Yeah.
There'll be 3 equal altitude of elevation circles. On the sphere, can't happen.
Well, that's celestial navigation that utilizes 3 circles of equal altitude. Yeah.
Yeah, but like I said, like when you're measuring out a triangle on a sphere, it's not they're not straight lines. It's a spherical triangle.
Oh, then you won't get an angle between the 2 intersections.
Yeah,
Any
no. I mean, you always have angles, even on a flat piece of paper, right? Those are angles that'll add up to 180 degrees on a flat plane.
Between 2 lines, you're going to need those 2 lines to be straight.
Yeah, but like I said, like you could just do 2 straight lines, but I'm saying like I think the best way would be 3 points.
We make an angle between 2 straight lines on Earth, right? And we get an angle, flat Earth confirmed. Because if you didn't get an angle, then that means those lines were curved. And we're getting angles every day, all day, in many different fields.
Yeah, I get what you're saying, T-Dub. Like, if you use the horizon and your height above the horizon to get an angle, like that would mean that all the points along that straight line lie within a plane. That would be a straight line. So if you use the horizon to get an angle, like an elevation angle, it's celestial navigation, then you'd be getting an angle because all the points lie within that plane of the horizon. Otherwise, you couldn't get an angle, right? I mean, because each point would be lower and lower and lower, and you'd have to know the absolute distance to that observation.
Yeah, or get an angle to like the celestial body, like you were saying, and then find the ground position of one of them celestial bodies and make yourself a triangle that way.
Yeah, I always remember.
I guess that could work too if you use celestial bodies. Yeah, actually, that would still work as well. That would. Oh, what kind of triangle would that be? That'd be a. Oh my god! I have to like remember
Elevation.
topography and trigonometry and stuff, and it's so hard to remember this stuff.
It's an elevation angle.
Yeah, because it's not an enclosed triangle. It's not like an enclosed triangle. But
Oh, a hyperbolic triangle. That's the opposite. That's less than 180 degrees.
I guess if you're going to use the sun, then you get a triangle.
My eyes! My eyes!
I think they use that during the day, but
yeah. But so okay.
There's
so
an interesting one of I was just wanted to mention it. You could check it out. There's a place called Angkor Wat. It's like an old like whatever, like an old site, and they built a I don't know what you would call it, but it's like a decorative thing. But anyhow, it's a 1 mile by 1 mile square area of water, and what it shows is that all the points lie within a plane there. the surface on the surface of the water in Anchor Watt. You said you would like to see if that was possible in reality. But yeah, that's what when I said surely you would say that we can definitely establish 3 points at equal elevation, right? Like somewhere.
Yeah, like I think anywhere on Earth, like, and just do it in multiple different places on Earth. Like I said, just yeah.
Now, why like that? Why not just like a basketball court? What?
I mean, I feel like
can we get 3 points of equal elevation above a basketball court?
I mean, maybe. I'm not entirely sure. I mean, if it's level enough, I guess. I don't know.
Yeah.
But
I'd say we can do it.
Yeah, I just think it's such an interesting thing to like think about. Like man, I'm like almost so down to like want to do this experiment myself and like just like find out through those mathematics like exactly how it would work out.
Yeah, it's tougher than it's like. Listen, I did something. I mean, not like a mile, right? Like I have a spot where I could do a mile, but I'm going off somebody else saying it's a mile long lake, right? But I've done a little less than half a mile. But what I did was I took posts and put them in the ground. I made marks on there, and I measured the shortest distance between the two vertical posts, and then I kept on doing it over and over and over. I don't think I was a straight line, like left to right.
Yeah.
But yeah, what I was able to affirm with that was that all of those points, like the shortest distance between the 2 points of those vertical posts, was a horizontal straight line distance. Yeah. So like next to the lake, if you do that next to a lake, what would you expect to see?
I mean, honestly, not entirely sure. That's what I'm saying. Like, I feel like just like doing it on solid ground would be best. Like because as long as you do it on solid ground, like it doesn't matter where you do it. Like anywhere that you do the math, like the triangles, like
it definitely matters.
No, it wouldn't.
Listen, the ground goes up and down. It definitely matters.
I mean, but you're not. I have to think about that because you're
talking
not.
About you're talking about like trilateration, but the ground going up and down. So you'd have 1 point higher, and you'd have a kind of wobbly triangle,
But I don't think the latitude matters in this math. Hold on, let me think. I have to think about it in my head.
I'm gonna miss the latitude combo.
Yeah, I don't think the up and down matters. Or maybe it does. Hold on.
Yeah, I mean, I can't see how changing an elevation would not lengthen one leg of the line. It'd be like a hypotenuse, like getting longer and longer from the adjacent, like taller and taller. Yeah. Then the hypotenuse would obviously increase in length if you were higher up or lower down, shorten.
Man, I have to look back at my math books and everything.
Yeah, I didn't hear the latitude. So about just the very basics, a longer distance would be a longer line. So if you're higher up, that'd be a longer. That's kind of like what I was telling you about my test with the posts. Like the way I confirmed it was the shortest distance. Right, I got the laser level and I held it perpendicular to the vertical post, and then I just kind of raise it up a little bit. And if it it reads about a 1/16 of an inch. That's what it picks up and registers. A change in the distance. So I'd just raise it up a little bit and then raise it down a little bit, and I'd find the shortest distance, and the shortest distance was always perpendicular to the post. So if I had a mark, I'm just saying that to say obviously if I had a mark at the top of the post and the bottom of the post, that would be a longer distance than the perpendicular distance. And I use that that base axiom of shortest distance between two vertical points being a horizontal reference or horizontal line at the shortest possible distance. I used that as my axiom. Yeah, I don't know what
I
I don't know what
wonder
test
if
you
the
were
best
saying.
people would be to ask maybe like our surveyors, right? Because surveyors have to deal with a lot with measurements and like having to deal with like surfaces and everything like that.
Yeah, that's why I mentioned to you earlier about
Yeah,
slope.
yeah,
I was
about
like,
the
well, that would be a,
posts and the slopes. Yeah.
yeah. I was like, well, obviously that would be a slope, right? With the water being like the equatorial bulge being higher and then lower. At
I
another
just
point, yeah, that'd be a slope.
Yeah, I just feel like this would also be like another like what phrase am I trying to use? Like it'd just be another nail. It'd be another proof as to like Earth being flat, just with like 3 points of measurements. Or like vice versa for like, you know, people who believe for the globers, like, hey, like that it's actually a globe. Like it'd just be like another form of calculation to prove like one or the other.
Yeah, but in order to measure elevation of any like 2 or 3 or 4 points on the surface of the Earth, right, and for those to match, or for those to like kind of affirm that the Earth's a sphere, you'd already have to know the Earth's a sphere, you know, to get elevation. But what they do, like what the surveyors do, is they just get a like a total station and they spin it from one. They do foresight, backsight, and they just carry a straight line horizontal over distance.
But what
Like
does that do?
shortest
So when the
shortest
surveyors
distance.
do that, what does that do? Like that's actually accounting for slope, or it's just accounting for measurements between point A and point B?
Well, point A and point B, and then the elevation, the differential level, and the elevation of the
Okay,
land.
okay.
Yeah, the elevation of the land going up and down from a reference.
I guess like how would you also be able to account that like your line is straight? You know, like how do you account for that?
Yeah, well, they have a meter stick. That's kind of like the principles of what I was saying before. They have a meter stick that they can see using the principles of horizontal, vertical, and perpendicular. And then they get a stick, and then the one guy will hold the stick, another guy will sight the stick. So he'll look at the stick, and the other, to make sure it's accurate, the guy who's holding like a stick with little centimeter marks on it, he'll push it forward and backward until they get the shortest distance marked on the stick.
Interesting.
Yeah, so they'll do the same kind of thing I do with my laser, but
Then you should do it with your laser. You should do it and get 3 points and get back to us.
I did. That's what I'm saying.
The 3 points, like a triangle. You did a triangle.
No, it's just on this. What I got was that what it showed was all of those points in reference to it.
Yeah. But you're doing you're doing in a straight line. Oh, I'm telling you, like I don't know why I'm so fixated on this. I'm just like fascinated by the triangle thing, but it's because it's just so good. Like I'm telling you, like the degrees would just totally prove everything right there.
Yeah, that's what's been proven. Yeah, that's already proven.
Where? I need to see
this is what surveyors do. This is what they do every day. They're a bunch of. I mean, they might be idiots. They might be smart, right? But that's what That's just what they're not. They're not like, hey, is the Earth this or that? But that's what they do every single day.
Yeah, I know, because they're pointing out the plots and like to see like the elevations and the deviation. But like somebody else mentioned, like there's so many deviations for that. Like right, like there's so many like mountains, hills, valleys, and all that kind of stuff. So I wonder what would be the best way to like have like a level surface. And like someone pointed out lasers, but I'm assuming lasers are faulty, like to a certain point, right? Like once you get to like a certain
how far?
how far? Yeah, exactly. Yeah. So
they have like culminators and stuff that focuses the light beam, keeps it cool because it heats up and expands. It keeps it cold. And listen, it's already. I don't know. Is it like a spoiler alert? Like I could send you videos like, of long distance laser tests if you want to.
Okay. But like I said, my my brain is so fixated. Did they measure triangles? That's what I need to know. I'm just gonna be fixated on this, I think, for like the whole entire time. I should probably stop.
If you do this, and then you'll know. It's like you won't have to say, well, maybe the Earth is this, maybe the Earth is that. You'll know that level is horizontal. You'll be like, listen, I know it. Yeah. And so you have to do it yourself. You just have to. I don't even like I didn't really. I don't feel I've done it already though, like in just practical use, right? And then when the question came up, like people were saying, no, level's curved. I'm like, that's ridiculous. What are you talking about? Right? That sounds crazy, right? And I was like, all right, forget this. I'm just going to put these posts in the ground and I'm just going to just see what I measure. Then I got like whatever it was, I put in like 20 posts. And I was like, what the fuck I'm waiting. This is ridiculous. I'm not going to measure a drop of horizontal, but that's what would have to happen. Level would have to drop over the distance if level was curved. I said, but I'm not going to measure level to drop. That's crazy. I mean, isn't it crazy? Does it sound crazy to you?
No,
Level,
it really doesn't. So, like I said, like that's why I wonder, like in a sense, what would be the best? I'm barely reading the chat, by the way. I'm sorry if like I just keep mentioning triangles. If anyone needs an explanation of like how I'm trying to prove about like how different triangles work on like different planes, like let me know. But that's why I'm so fixated on the whole triangle thing, because I'm also thinking about like what is the best way to even get these measurements, you know? Like I wonder what's the best way to account, like what is the best possible straight line that we can do. And like I said, or like you said, you're mentioning about like how some lasers can be cooled down, so like it actually makes it so it's like really straight. And like I said, if we can get 3 points over like different distances and like different parts of the earth, that I feel like, for me at least, that would solidify exactly the plane of Earth. Like, what is it? Is it flat or is it curved?
Well, like the Earth goes up and down. Like when you said nothing, we got to get on really solid. Like we got to get on really solid ground. You said. Like we got to make sure it's
really
super solid.
Maybe like the desert. Would a desert be like a good? Even desert have
But all you're doing there is saying, well, it looks flat to me, so the desert must be level.
But
deserts. You were talking about this. Are you talking about compactness? Like desert sand is compact. I don't know about that.
No, but like I said, I was like, oh man, even like sand has hills and all that kind of stuff.
Right. So what you're trying to do is that's what you do, right? You can do is you can refer to surveying if you like, but what they're doing is they are establishing points of equal elevation.
So from what you're telling me, the survey only does point A to point B, and I want a point C as well.
They don't just do 2 points. No, they're making like footprints for large buildings. They're getting square mileage of land. They're not just doing 2 points. No.
Oh, someone just.
And neither did I. Like I said, I did a bunch of points. I just didn't I made sure they're all in a plane, not that they were all forming a triangle. I could have done like a 3, 4, 5. It would take a lot of effort. It would take me a long time to start doing 3, 4, 5 triangles all the way down a lake, and extending
I feel like it'd just be worth it, because then I'm telling you, like anyone that's involved with mathematics, like if you had that math, like you could just slap it in their face and be like, I did the math and the degrees came out to exactly 180. That proves that Earth is flat.
But it wouldn't prove. Well, what do you mean Earth is flat?
It would prove it, because if your measurements of that triangle with the degrees are 180, Earth is flat.
I mean, all you're proving is that level is horizontal. Is level not horizontal?
I mean, but like I said, like I'm telling you, oh my god,
I'm telling you, everybody already knows that level is horizontal. They're not going to be blown away.
I don't care about the level part.
Where are you putting a pyramid on a sphere?
A pyramid on a sphere?
Yeah, where you put it at the corners.
No, it's just no. You're just plotting 3 points on a
sphere,
on a surface. It doesn't matter
on the sphere.
In this case, it could be on a sphere.
Okay.
Yes. Like it can be.
Listen, what you got to take. Also,
hey, let's see you do it on a ball, and then let's see you do it on a flat table.
Yeah. So if it's on a ball, then it becomes a spherical. It becomes a spherical triangle.
It won't be on a ball just because you have. Listen, if you have 1 point, if you're on top of a mountain, right, at one point, and at the bottom of a valley at another point, and then at sea level at another point, that doesn't mean you're on a sphere. That just means you measured a change in elevation.
No, but you need to do it. No, but it needs to be on a horizontal measurement, not a latitude.
Okay, what tool are you going to use to establish a horizontal plane of reference in reality? What tool?
So that's all. That's all I was asking. That's also what I was asking you. Like,
Yes.
what would be the best way to do it? And then someone mentioned lasers, right? Like, is lasers not good?
Well, the laser just doesn't do things by itself. What the laser is utilizing is the same methodology that surveyors utilize, which is differential leveling.
Ah, man, no. I need measurements. That's the most important
It
part.
is a measurement.
Oh,
It
okay,
is
okay. That's what. Sorry, the way you phrased it right there.
It's the measurement in a way of the shortest distance between 2 points being in the horizontal orientation.
Okay. Okay.
So if you were to get something like a, sorry, again, yeah.
Yeah. So like pretty much you would be able to plot out measure out point A to point B, right? So then I would go over to point B, then measure out another point B to point C, and then do the same thing, point C to point A. And then, like I said, then plot it out, like write down the math. So find out the measurements and then find out the degrees. And if the degrees are exactly 180, then you are dealing with the flat Earth.
If
the degrees are more than 180,
it'll always, if you're getting 3 points of equal elevation, there'll always be 180 degrees. There's three.
No.
There's interior angles.
It doesn't have to be. If it's, like I said, that's why the mathematics is very important, because not a triangle doesn't always mean that it's a straight triangle. Like if it's plotted on a sphere, then it's a spherical triangle, and that means that the degrees add up to more than 180 degrees.
Somebody's breaking up.
It doesn't matter. If you get an angle at all, you're on a plane.
Yeah, exactly, because you're plotting 3 points. I mean, we are on a plane. Like that part's, yeah, that's like a no-brainer. What I'm trying to figure out is okay. Jordy Voyager, he just posted on the chat. That's exactly what I'm talking about.
Are not listening. If you get an angle between two lines at all, they are straight.
But like I said, like another proof would be 3 points being measured and then finding out the degrees, and then based off the degrees you would know if the plane is flat or curved. I'm saying this is another form of proof.
Dude, no, stop. We've heard you repeat this over and over and over again now. No, I'm telling you, if you get an angle between two lines, those lines are straight.
Okay, I understand what you're saying, and I'm gonna say yes, you're right. But what I'm telling you is also this is another form of proof.
I need to go beyond that. Need to go beyond that.
What do you mean?
You get an angle. If you get an angle, those lines were straight. If they were curved, you didn't get an angle. You couldn't measure an angle between two lines that aren't straight. Impossible. No such thing.
Yeah, we're not lacking in the proof department either. There's literally everything points towards a flat Earth, and
but that's what I'm saying. Has anyone ever
towards a globe?
So that's what I'm asking. Has anyone done the math? And my asking of my proof, has anyone done the math showing that they've plotted 3 points on a line, done the measurements, and then figured out the degrees? Because the degrees will tell you if a plane is either curved or if it's flat.
That'll be 180 degrees, man. That's just a line.
No, I think what people have done, and this is something that they try and claim on the globe side, is that they try and claim they've measured spherical triangles, but what they do is they just take angle measurements and then they mathematically put it into a spherical system.
Yeah, which is horrible. Like that's what I'm saying. That's horrible.
That's it. But then it's like, right, so if that hasn't already been done on the globe side, then it's not us that needs to do anything. I mean, if the globies haven't come and proven this already, then I would say by 2025, time's up.
Listen, give them one more 2026. That's draw the line.
All right, we'll give you guys one more year. Come up with some globe proof, and then we're closing the books. It's over.
Just like that, it's over. Yeah, but I don't know if anybody else is looking at it, but the picture that Jordy Voyager posted up, that's pretty much what I'm talking about.
Yeah, we've got they've got computer representations of their idea, which they can mathematically construct. But when it comes to reality, no curve, no globe, never.
But no, this isn't. This is just this is just mathematics. That's all it is.
That's what I'm saying. In theoretical math, yeah, you can do whatever you like, but in reality,
this isn't theoretical. This is actual mathematics. This is topography.
Yeah, but
no, it's theoretical because there's no curved surface to plot the triangles over. In reality,
what do you mean there is none? You could literally just get like a ping pong ball and then map out those 3 points and then do the measurements. That's exactly how you can do it.
As you're applying this to the Earth has no curvature to apply it to.
Yeah, that's why I said to you, buddy. I get what you're saying, Pensy. What I said to you again was that what you're going to remember. I said you could be at the top of a mountain and then lower, and then you'd have the trilateration of the longer hypotenuse. Yeah, but in order to get in, but that's not what surveyors do. Is they plot 3 points at equal elevation line.
Exactly, exactly. That actually still works.
So
that would absolutely still work. The math would work when everything is straight. Okay.
Yeah, but Pensive. Sorry. If you go to that picture that you sent.
Yes.
I don't know. I don't know if you sent the one with the ball and the curve and
that
the
wasn't
straight.
me. That was somebody else. But yeah.
Yeah, but the top one and the middle one, you only need one straight line for it not to be there. You don't need a full triangle.
No, because that'll only show you point
over point A and point B. You don't need a full triangle. You could do a full triangle, if you want to, but you just need the one.
Yeah, he's right. He's right, dude.
No, okay. This is
yeah, he is right. He's right.
No, it's not. The measurements.
If you measure a line across a surface of a sphere, it has to be curved. That's absolutely true. Don't say no.
No, I'm telling you, like, just
so it can be a flat. So the sphere can have no curvature and just be flat.
No, what I'm trying to tell you is that if you plot 3 points on a plane, measure the distances between the three. And then
we get what you're saying.
Yes,
we understand that. But he's saying you could just take one straight line and see if there's a curvature of that line over the surface.
And what I'm saying is that is okay, but I'm telling you that the 3 points and doing the triangle is another form of proof to prove if a plane is flat or curved. It's not
more complicated. It's more complicated and unnecessary because you agreed it yourself. The one straight line would have to be curved on a ball. Any line that you're drawing on a ball would have to be curved.
Why wouldn't you want more proof? That is not unnecessary. That's even better. That's better to your claim.
It's not that you don't want it, but I mean, it's.
But you just said it's
everything already proves it. It's unnecessary because
it wouldn't be unnecessary. It would not be.
It would. Water's already level. All the straight lines being drawn have no curvature, so there's no curvature. So we don't need to go and try and do triangles now. There's already no curvature.
Like once you put the first line straight, you know it's not that. So you don't need to do the full triangle. That's just extra work. You've already proven it after the first.
Yeah, but that would be more work as to furthering the proof and solidifying even more.
You're not getting it, dude. Every single surveyor already establishes a horizontal plane of reference to measure elevation change in the vertical from that horizontal plane of reference. It's done every single day. You're saying do it again?
I'm saying measure 3 points and measure out those, then do the math.
Well, dude, we've already established that it's not a globe and that it measures flat. But if you want to go and do this 3 point thing, be our guest. Enjoy.
Yeah, there's nothing wrong with your 3 point. But once you've got the first straight line, you don't need to do it to prove that it's not the top picture and the middle picture. Once you've got the first one,
I guess the reason I'm thinking about
that's fine if you want to do that.
No,
but you don't
hold
need
on.
to prove.
Do it in
It's
your
not
room,
guaranteed.
dude. Do it right here. Do it in your room. Go get a level.
Yeah,
Right.
yeah.
Go get a level. Draw a line on the wall. Right. Continue that straight line. Keep on doing it, and then measure between your room and square it off, and you'll have done it in reality. You'll be like, oh shit,
Yeah,
I did
but
it.
I'll just say one
can
last
get a
thing
curved
before I
line
drop
with
the
it.
subject. I'm gonna drop the subject right now, but it's because, like I said, I'm thinking about this like from a mathematical perspective. In a mathematical perspective, like you can have a proof already saying that like 1 + 1 = 1, and then you want to like even in mathematics you can still like I know it's worthless. But even in math, like we can do like, okay, but why does 1 + 1 = 1? And there's even a formula actually explaining like why certain numbers equal to or the numbers. And it's ridiculous. It's stupid. It is nonsensical. That is basically how math, like once you get into like pure mathematics, that's how it works. But all of these things are to further solidify the proof as to like why 1 + 1 = 2.
Yeah,
So that's what I'm saying. Like even though this may seem ridiculous, this would
is already
just
established. The 3, 4, 5 triangle is already established. This is what you can use in your surveying anytime to prove what you're saying. It's done all the time. We don't need you to do it again. You're just saying do it again. Do it again and again. Just keep doing it again and again and again. It's done every
See,
day.
this one, I would, yeah. I mean, I kind of get what you're saying, but I would just say try to don't be as concerned with the pure mathematics, quote unquote. Be concerned with reality, observation, measurement.
Yeah, I mean, and like I said, this is just another. Well, in mathematical terms, we call it an axiom, but this is just another axiom to the proof. So, like, even though you didn't need it because we already know the proof is the proof, it just solidifies it. That's all I'm saying. Like, I know it's nonsensical, but it's like it just solidifies.
The axioms prove themselves. Like the axioms prove themselves.
Exactly. Yeah. So that's what I'm saying. Like the 3 points.
They've already been proven. The way that you're saying that they should be proven have already been proven. That's why they're an axiom. That's why I don't understand. Listen, maybe I'm just frustrated.
Man, Jordy Voyager, I think, is also a mathematician. That's crazy.
He's just copy paste. He's a copy paste matician.
But yeah,
I mean, you can be a
math solves everything. That's all I'm saying.
Unfortunately, maths isn't going to get you Earth curvature in reality.
Yes, it does. It absolutely does. I'm telling you, it does. That is exactly how math works.
Listen. So if I do the maths to work out that Superman's top speed is 1,000 miles an hour, does that mean Superman is real and that he has a top speed?
What?
If I do the maths to work out Superman's top speed as 1,000 miles an hour, does that mean that Superman is real and that his top speed is 1,000 miles an hour?
What does that have to do with anything that I'm talking about?
Well, because the point is, maths is not necessarily describing reality just because you did the maths. Is it?
But there is math that you can apply to real life. That's why it's called applied mathematics. The applied mathematics does work.
Real life, yes. If you apply it to real life, but that's the point. When you are talking about curvature math, you are not applying it to real life because in real life there is no curvature. What would you be applying it to?
Then what's a ball?
Yeah, curvature of the Earth.
But that's oh my! But the math. That you point out the plots to prove
that this together. You think because there's a mathematical formula for a claim of curvature of the Earth, that makes it reality? Is that what you're saying?
Yes.
Wow.
You literally use math in everything. You use math when you're doing construction of buildings. Would
that maths not have to be based originally on some measurement of a curvature?
No.
So it's just theoretical then.
It's not theoretical. It's proven and true.
It's in reality then. So show us a measurement of it.
Okay, I could show you on a ball. Let me see. Like on
no, not on a ball. I'm not talking about abstract curvature on curved objects.
But that's not abstract. It's a real curvature.
A curvature of the Earth.
No, but all I'm saying is that like if you get 3 points and you plot it out on Earth, then you could actually further the proof to see like, hey, is there curvature? I'm not saying that like you're doing it.
You're defaulting back to this. No, that's
because you're bringing it up. You're telling me that the math is just like theoretical.
No, I said the curvature that's claimed, you can put it into a maths equation, does not make it real in real life.
Then
not
that
make it
pretty
a
much
physical
means that
thing.
every basis that's ever been going on is just like, then it's done. Like, also, like the measurements that you told me about earlier at the very beginning when it has to do about the ship, like how far away, then that's dumb, right? Like, that doesn't make any sense because then that mathematical
So
just
no one was
claim.
telling you that the boat was going over a physical Earth curve, except the globe Earths. We're not telling you that. We're telling you what their math says and where the horizon should be based on your observer height. And when we look in reality, it doesn't exist.
Yeah, but you're using other forms of math that you're saying you're calculating that contradicts the math of that. So you're still using mathematics.
What are you talking about, dude? You're so lost. You are so lost.
Because what it sounds like to me, right, what you said, and Cyclone got the same impression, is I could just say, Earth is a pyramid. Each side, has dimensions of X, right? That's it. I just give it a value, and that's proof, right?
What?
Because I use
No,
math.
if you wanted to prove that like Earth was a pyramid, I mean, you'd be able to use mathematics that prove that it's a pyramid.
You guys didn't understand the Superman thing, because you were making it sound like if there's maths for it, it's real. And I'm saying no. You can use maths to describe things that aren't real, like Superman, like Star Trek. You could apply maths to those things, and it wouldn't make those things real. But you seem to be disagreeing with that and saying no, it would make it real.
What? No, that's not. That's not at all how you're using the math. Like, if you're using the math just to calculate the speed of Superman, you're just calculating the speed of Superman. You're not saying that Superman is real.
So just because there's maths for it doesn't make it real, correct?
But if you plot out 3 lines, and
so
then
in
the
same way
degrees,
that if
it'll
there's
tell
maths
you if
for
it's
the
on a
globe,
flat
that
plane
doesn't
or
make it
not.
real.
That
So
is
the same
real.
way that because there's mathematics, you can mathematically describe a globe Earth. That doesn't make the Earth a globe. You understand?
But that's mathematics is the perfect way to explain it all.
Can I go through that
What
picture
are you
with you?
talking about, bro? You don't understand the difference. Like you say, that's the perfect way to explain it. We're talking about real or not real, not how best you think it can be explained in an imaginary scenario. Real or not real? That's the question. Not can we describe it?
But that would tell you if it is real.
No, it wouldn't. What? So because they've got so if I say they have a radius of 3,959 miles for the globe, does that make it real?
The radius doesn't matter in what I'm talking about.
Well, no, you're just talking about being able to describe it mathematically.
No, I'm saying we should go out and do the measurements ourselves. That's what I've been saying. That's like the whole conversation between me and No Tanks have been.
This has been going on for 10 years. People have already done it. I know you've just shown up and you're just catching up, but this has been getting done for years. The measurements have already been done.
Yeah, but the measurements have only been from point A to point B. I'm saying a triangle measurements.
So on a globe, there wouldn't be curvature from point A to point B. Is that what you're saying?
No, I'm trying to say that if you calculate...
So there would be curvature point A to point B.
Oh my lord. Okay, the mathematics in which I'm talking about measuring a triangle is not about curvature. It's about degrees.
Yeah, well, this argument is about curvature because some people are trying to argue that they're on a ball, which necessitates curvature.
Yes. Okay, but that's exactly what I'm trying to tell you. Okay.
So we can falsify that by point A to point B if there's no curvature. Simple.
Yes, but you can also...
so there you go.
But you can also further your claim with those 3 points.
Already debunked. There's no curve. Don't need to further it. That's it.
But why not?
It's binary. Well, because if there's no curve, doing a triangle is still going to have no curve.
Okay, but the that's what I'm saying. If your triangle is correct, then okay, then your triangle is a flat Earth.
Pensy, one of like you already, the KC said it to you. If one of the lines are straight, there's no curve, there's no degree change in that line. That's it.
Okay, and like I said,
if the other two are curved, are you saying that means we're on a cylinder, or if the other two are curved, what do you do? Where do you go from there?
But exactly, then like we have to further think about like what exactly is going on, right? Like if you're saying that point A to point B has no curvature, but then you plot out math and you say point A, point B, point C, and the degrees add up to more than 180 or less than 180, then there is something going wrong. There is
There
like
can't be curvature,
somebody's
though.
math
Hold
is
on.
incorrect.
Hold on. You're thinking about this wrong. Are you going to have a line of sight between point A, point B, and point C? Are there going to be lines of sight?
What does that mean?
When you do the measurement, are there going to be lines of sight between the 3 points?
Lines of
How are you going to measure the angle, dude?
I don't know. That's all I was asking
So say
before.
you're
What
at
would
point
be the
A,
best
right?
way to like measure
Say
it?
you're at point A. Hold on. Say you're at point A. You look at point B, and then you measure the angle between point B and point C, right? You use a theodolite or something.
Well, you have to add up all of the degrees, so you have to get the measurement.
But you have to. Yeah, okay, I know that part. The thing is, you're always going to have a straight line of sight. That's going to be a 180-degree triangle.
Exactly. So if you do the math and if it's 180 degrees, then yes, Earth is flat. But if the math
You don't have
comes
to
out
do
to
the
more
math
than or
because
less,
you have straight lines of sight. A triangle on a globe has curved lines of sight.
What do you measure curved
So
lines
you're
with a
confused.
field?
If I had an orange, right? If I had an orange and I drew on the surface of the orange a triangle, that triangle would add up to angles of greater than 180 degrees.
yeah, but
we're
it
not,
also
we're not
depends.
doing it on the. Hold on. We're not doing it on the surface of the orange. We're off the surface of the orange,
Yeah,
right?
you're talking about something
think
on a
if you-
massive scale.
Now, think if you took toothpicks, right, and stuck it in an orange, right? 3 toothpicks. You made a little triangle, and then you took a string and tied the tops of the toothpicks together. Now, the sticking in an orange, that's spherical. But the lines between the toothpicks are straight. That's just going to be a regular planar triangle.
Okay, but now I'm saying like expand that orange bigger and bigger and bigger and
Doesn't
bigger.
matter.
It
You're
would
always going to
matter
have straight.
because
No, it
the frame
doesn't.
of reference, depending on the vectors that you're in, like depending from that point A to point B, may seem straighter than it is when over longer distances.
Straighter. What does that even mean?
Yeah, what scale are you even talking about here? 'Cause
Okay,
now
okay.
you are just off into
You're
the
not gonna
realms
have line
of
of
No, no,
sight
no.
you
anymore.
couldn't do this.
Hold on. Okay, so like you guys were mentioning about an orange, right? Or like Indio brought up the example of an orange. If you look at it from an orange, and if you look at the angles, so if you do plot A to plot B, it may look a little bit more curved, right? That line. But if you expand it, if you expand that orange, like let's just say like you measure it on like, I don't know, like what's that big eye thing that's in Las Vegas? Like that point A to point B, depending like how far away you do it, it's gonna look like a straight line. Like it's gonna look straight, even though you're doing it over small distances. But if you do over longer distances, then you would be able to see a curve. Now, doesn't matter on which plane that you're in, it doesn't matter on the vector, on the sphere. But if you do a triangle, then you would be able to add up the degrees, and then you would be able to tell, like, oh my, like if you're on a sphere, if you're on a curved surface, or if you're on a flat surface.
Well, we can
Yeah, but
already
once
tell
you've got the
that.
first straight line, once you've got the first straight line, you haven't got a curved surface anymore. You haven't got a ball. Once you've got one straight line, that excludes it being a ball altogether.
No, but like the thing is, if you expand it out, at some point you're not going to be able to see all 3 points at the same time. So then, yeah, you're not going to have line of sight anymore.
Yeah. But like those
but-
those kinds of distances will be like insane, right? Like that'd be like ridiculous for us.
So
to be
just measure
observers.
point A to point B and see if
And then-
there's a drop
So-
over the distance.
So the thing is, it's a lot more difficult to measure the angles then, because then you have to travel along geodesics, and yeah, it's pretty difficult to do in praxis, I would say.
Yeah, that's what I was saying. Like, Paradigm's got me. Okay, I feel like Paradigm is kind of like following my train of thought here, where it's like I'm saying that like it probably is. Like,
your thing is in.
Dude, you don't understand the problem. It doesn't matter what your train of thought is. You don't understand what the problem is. You just don't understand it. I'm going to show you a picture. Give me a minute. I got to find it.
But Indio, if you don't have to have line of sight to measure the angles, but it's just going to be really difficult.
Oh, really? How are you going to do that?
What do you mean? You just travel. You have some point, and then you measure some angle, and then
You're gonna
travel
like
in a
string
straight
a,
line.
are you gonna string a rope on the surface of the earth and then measure the rope?
No, but you don't
The
have to
angle
do it
between the
all
rope.
around. You could just do point A, point B, point C, and that's it. That's all you need. Just
Yeah,
3
but it
points
has
for
to be.
references.
Listen, clown. It has to be on the surface of the earth itself.
Yes.
Yeah, but literally physically on it, meaning you need to draw a line on the surface of the earth.
I mean,
just travel in a straight path.
Yeah, you're just traveling. Yeah, you're just traveling in a
Jesus
straight path.
Christ, no.
Why not?
Oh, you mean travel in a straight path, turn 90 degrees, turn 90 degrees?
Yeah, I mean,
Just 3 points. You don't. It doesn't need to be 90 degrees. It's just
the ground
3
goes
points.
up and down if you walk and travel it. It goes up and down.
Yeah. So it will have to be
Don't
a
be
very
silly.
flat area.
Yes.
And how would you? What tools and what method would you implement to make something flat?
So we need
That's
to
what
go
I
and
was
find
asking
a
you,
very.
No Tank.
So we
That
need
was
to
the
go
whole
and-
conversation about like what.
It's surveying. That's what they do.
So we need to. So we need to go
Yes,
and
but
find
like
a
I said,
very-
they just
hold
measure.
on, hold on. Okay, so we need to go and find a very flat area, proof that it's curved. Is that the logic?
And then just say it's flat.
Yeah.
When you find it, just say this is flat.
That would
Yeah, listen
work,
to yourself.
Cyclone. I'm telling you, that would work. That actually genuinely does work.
I don't believe you.
Right.
But if you're right, go and do it, and then let us know.
Yeah.
And how you?
I think there aren't really any areas in the world that are large enough for it, to be honest. But
Oh, okay. So this is a bad argument then.
I mean, maybe you could do it over the seas, but then the flow of the
Okay,
water.
well, I'll tell you what. There's plenty of places where you could just do a straight line A to B and see if there's curvature over that. That's pretty simple. Why don't you just do that?
Well, again, that's not really what we're talking about, but
Yeah, exactly. Because for some reason, you guys are talking about something that you just admit you can't do, and we're trying to talk about reality that you can do.
No. The measurements of how to obtain it is we're saying that like that's probably the impossible part.
It's all right, bro.
But
You don't need to worry about it.
The
Listen,
actual
we've already done the
mathematics
work.
is true.
We've already done the work, guys.
Okay,
You don't have to worry about
mathematics
it.
don't prove things other than math. Now look in the chat. Now look in the chat, please. Look in the chat, please. Okay. So if you were surveyors, if you were surveying off the surface of the earth, the triangle on the left would be what you surveyed. Because you're not physically on the surface, you're not on the surface of the earth. You have a line of sight between points. You literally have to have a line physically on the surface of the earth.
Why?
Yes.
To
So the
measure
one
a
on the
greater than
right.
a true triangle.
Yeah, the one on the right is how we have to measure it.
Yeah, exactly.
Yeah, good luck with that, dude.
Yeah. So again, something you cannot do. Good stuff.
But if Earth is flat, then why is that impossible?
Because the Earth is flat, not a ball.
Why is it impossible to take a rope and string it 1,000 miles? Are you being serious?
You don't have to.
Yeah, these maths guys have like no grasp on